We welcome you to the National Museum of the United States Air Force at the DARPA Lift Challenge here in Dayton, Ohio. As we get ready for another day of competition, we are flight loaded today with 63 flights scheduled. Apologize for yesterday's thunder shower activity. It came in and it laid waste with rain and lightning, and everyone was just seeking shelter, but we kept safety paramount, so we're all good to go. Now, breaking news as we start things off on this Saturday. MTech, who you saw yesterday go into second place, it has been deemed that their flight will be disallowed because of certain infractions, which we'll get into. And we are glad to have the man, the myth, and, of course, the program manager, Philip Smith, call sign Donna, joining us, as well as our drone expert, Joshua Bardwell. I'm Todd Harris. All right, let's get right to it. MTech, you were with us when they did it. It looked great. We saw them dip above 200 a couple times. It wasn't just that, though.
Yeah, so this is always hard, right? This is in any competition when you have a did not score post-video review. I mean, we just watched the World Cup, and they were doing that all the time, right? So, but it's a part of fairness that we have to do. So every one of the flights, the scored flights, the ones that make it onto the leaderboard, is reviewed. And so we do that in the evenings. We look at those. There was also a protest about it because other people saw it. So there were two things. One is the landing. So we can go to that. We have a couple of videos of that. And so to explain the rules. So we said that in order for this, once again, to be usable for industry, it had to do a safe landing, and it had to do it in a controlled manner to a landing spot. Businesses, military, they're not going to want an aircraft that lands anywhere on a football field, right? You need to be able to control that. So in the rules, we had a 5-foot radius, 10-foot diameter circle that said you have to land in the middle. And then because of all the different designs, we started saying, well, not everybody can be inside of that, so it was the center of your system. And so now with those orbitals, that's how we have it, right? That their line where they're holding that weight is the center of their system. So that has to be inside of that 10 radius circle. It's funny, but Home Depot doesn't sell plywood in circles. So we ended up with squares out there. We made a verbal that we were going to have people land on the platform. It is a 10-foot by 10-foot square. Right. So in their particular case, they landed right on the corner.
I see.
And then they slightly moved over. You're allowed to reposition the aircraft.
All right, we're going to roll it in for you. Talk us through this.
Yeah, so there you go. They're coming down. That first landing was good, but then they bobbled off to the side. So they're on the corner, and they're off the side of that. So there's two rules. One is the weight drop-off or the payload drop-off. That has to be inside of that 5-foot radius circle. So in this case, it was outside, it was on the corner, and it was also kind of off of the board.
So just to clarify here, when we see that aircraft land on the plywood, it's not enough that it just be on the plywood. We can imagine a circle inscribed inside that square.
So this morning, my staff went out there and actually drew the circle. So now we'll be able to see it. But yeah, that's exactly it. So they have to be able to be inside. And so now what we'll be looking for is the entire weight has to be inside that circle. So we don't have, there you go, we see it live.
Look at this.
We have the circles on there. And so the entire weight now has to be inside that circle. If the edge of the weight of any part of it is on that line, then they can reposition and then come to rest. So that's the term we're using. Wherever they come to rest and drop that weight, it has to be inside.
So just to be clear, this is not a new rule. This is a clarification of the rule that was already in place.
Right. This is a clarification of the rule, and then we added the circle so that people who are visually landing can now, see where it is.
That was not their only infraction. So you went to the VAR twice yesterday after competition.
Right. So I felt like a real sports, VAR here. It was kind of crazy. We were going through all of the reviews. We just pulled some data and we did some testing this morning. So the altitude infraction, what you guys are seeing online and the Titan feed is that they can go over. You sometimes see some of these teams going over the 200 or below the 100. So in this particular case, bottom line, they broke the 200. Now, when you get into the technical details, it's actually kind of fun to talk about this and for everybody to know. So when you guys are ordering a ride share, right? An Uber or a Lyft, whatever you want to do. And sometimes it says you're on the other side of the street, or you're standing there and your dot is moving. That's called GPS drift, okay? And so in a 2D plane, you know, us earthbound humans, we're on this 2D plane. That's very minimal, actually. There's only a couple of feet in that drift. But it's enough to make your rideshare app, you know, move you around and go around. So what we have is on our 2D plane, so our left and right, forward and backwards, we are solid on that 100 feet. Now, that's called X and Y, right? Z is your altitude.
Okay.
That is actually has the most error in any system.
Oh.
And so when GPS was created and just the way that the orbits are, you know, we didn't really need it back in the day because it was mostly for ships and ground and all that sort of stuff. But for aviation, you do. And so that has the most error in it. So what we did is we actually put the limit in Titan at 212 feet. So months of testing of these systems and these trackers that we have here showed that we had about an average of 10-foot error. So what we did is we played advantage. And so we said what we don't want to do is stop a team from a good competition run because of the error in the system. We'll go to the tapes afterwards and do it. So what we did is for MTech's run, we ran the tapes and we calibrated. It was 4 feet high at takeoff and 6 feet high at landing. So we took the 6 feet high and they went to 211 feet. So they almost hit the 212 barrier, which would have canceled it. And that means they went 500 feet over the 200-foot altitude block. So it's crazy that we have to get down to that level of detail. Think about how your drift and all that. And so one more point. Also, what we have found out is that a barometric reading. So barometric is the measurement of the air density. Right? So air has weight. It's heavier on the ground than it is higher up. So inside these trackers, there's a barometric measurement. And that's actually more accurate than GPS.
You're getting altitude from two sources, from
Correct.
the GPS, which is a little bit imprecise, and the barometer.
And the barometer. Okay. So that's inside of this box. And we have little inlet holes here at the back, you know, to make sure that that pressure is there. In MTech's particular case, and where that tracker was, their prop wash was messing. It was adding and subtracting pressure inside of that box. Yep, there we go. It was adding and subtracting pressure through these vents, right? There we go. We can see it. And that was messing with the barometric reading. So you actually saw an 80-foot variance in their altitude.
Yeah, and we can see here the tracker on top of the aircraft.
Yep. So,
wait, 80-foot variance?
It was 80-foot
But
variance.
clearly the craft didn't go up and down 80
But
feet.
visually and checking their system logs, it did not go up. Now, this is the truth. So what we have done is very, very scientific here, the fix. We're using duct tape, and we're going to close the vents. And we've also actually put some foam blocks inside of the system to be able to stop that variable pressure.
Oh.
So the takeaway here, I think,
very scientific.
Tell me if you agree. We're watching the Titan feed. We're watching that altitude, and as we're watching the playback, if we see that go slightly over 200 or maybe slightly under 100, the run is going to be allowed to keep going until it goes.
Play advantage in that case.
And then there'll be a careful review to decide what actually happened.
Yep. So this morning we had some test flights with these modifications. We've also been able to disassociate the barometric from the GPS. So we've got them all set. They are flying here at the 9 o'clock window. We're excited to see them do better than they did yesterday.
Yeah. Well, and the takeaway for me is just how important it is to be collecting all this data, as I've learned, recording all this data to make sure that the competition is run fairly and for all the competitors.
Right. It's vital.
Yeah.
While we were talking, the flight window has opened officially here on day number 6, Saturday, the penultimate day here at the DARPA Lift Challenge. As we get ready to go out onto the flight line, you saw Driftless there getting up for a little bit of a check. We do have a bit of a breeze, which will be interesting. We'll see how that plays out. Right now, let's check in with the 4th member of our broadcast team, Elena Buenrostro, who is out on the flight line.
I'm here at the prep tent. I was able to talk to Luke from MTech, and while they were disappointed with their last run, they are very excited and have a lot of energy and feel more confident today. They're going to be changing up two things. Instead of landing autonomously, they're going to be landing manually to help ensure that they get in that circle. And then also they're going to be, the other thing that they're going to be doing is, I think that's actually it. They're going to be landing autonomously. Oh, actually, one thing, they're going to be flying a little lower than typically they would fly, just so that they can ensure that they're not going above that limit that they were kind of disqualified for in the last run. So those are the things that they're super confident about, and they're excited to get out there.
Well done, Elena. That was a nice mid-air adjustment by you. So there's MTech. And again, we will see them today. They had jumped up onto the top 3 of the leaderboard, but that run was deemed not qualifying, so they will be moving out. Avidrone forward to see. JB, I got to think at this point with Avidrone, who went up, what was their ratio, 3.84, something along those lines?
Very close to that 4-to-1.
Are they going 4-to-1 now?
I think at this point, especially given we have only 2 days left in the competition, I don't see why you wouldn't just go for it at this point. Like, you gotta.
So just a reminder, safety, right? Safety first. So remember that crash video when they chopped off their tail rotor?
That is true.
So our rules here are if you do have an accident and you rebuild, we need to make sure that that is a safe aircraft after you've rebuilt it, just like we did the first flights. So what they're going to do out here, I believe, is go out, do that safety check. That's why they don't have that on. If they didn't, then what we did is a safety check in the run-up earlier or yesterday. So we'll see how that plays out right now. But if we do see them just going up and flying, that's what we'll be looking for.
Donna, with your jet pilot eyes, can you tell me how much weight that is sitting on that bucket that looks like they're going to attach to that?
It looks like 245s and a 25.
245 and a 25. Okay.
That's going to be, man, math in public and on broadcast?
On broadcast, yeah, no, I don't.
No, we're not even going to try that.
It's 115 by my calculation.
There we go. So
this is MTech. So MTech's in the air, and I guess what's most impressive for me as a novice is just how smooth this craft is, JB. I mean,
Well, the craft is flying very smoothly, and we've talked about that some of these guys are flying autonomously, which means the aircraft is sort of flying itself to waypoints and altitudes that are pre-programmed into it, of course with the ability for the pilot to take over manually if necessary. Earlier, Donna, you talked about landing manually versus autonomously. It seems like if you could have the aircraft land itself right on a dot, why wouldn't you do that? Why would they choose to land manually?
Man, there's a number of reasons. So we just talked about that GPS drift, right? So there are 2 GPSs at least on these drones. The one that is in the aircraft and then the one that's on the tracker. So that is where this marrying up of technologies and figuring out the different drift between the 2 systems. So some people out there, I heard that MTech was landing autonomously. So when they put the aircraft on the platform, they marked the spot and then came back and landed on the spot. That also provided that bobble. So now the pilot is going to stay on it. So if it does bobble, he can lift the aircraft back up and put it inside the circle.
Good news is you look at the upper right corner of the screen, that is green. That means this is a competition run. We'll keep an eye on the altitude. As you see, their payload to weight ratio, 3.64. So, Joshua, that means if they complete the 4 nautical miles with weight and then the 1 nautical mile without it, they would go back into second place.
Back into second place, which I'm sure they feel like they just barely earned. And I'm sure they're feeling confident that they can earn it again.
I think that's almost, I don't say more impressive, Donna, but the fact they come out and repeat what they did yesterday, it wasn't a fluke. It wasn't like, it was just this. They came back and just laid it down.
And it's funny. We talked to the team and the CEO that's running this team or supporting them, and he was just like, that's all right. We didn't come here for second place anyway. So I love that attitude, right? If you're not first, you're last.
This is the team MTech from Sudbury, Mass., founded by MIT engineers and entrepreneurs. MTech Operations LLC develops advanced autonomous systems and technologies to push the boundaries on endurance, payload, and speed.
You know, this question about, well, should we land it autonomously or should we land it manually? And it seems like, from a certain perspective, that might be a solved question. Like, why wouldn't you already know the answer? But there are always new problems that you find when you set a goal like this and you come out to try and solve it.
So this is driftless. It's actually one of the staff favorites out here. And I was just talking to the lane coordinators, many of whom are active duty military drone pilots. And not only do they like this aircraft, but they love the team as well. And we talked about this a while ago, but when you design an aircraft that can be rapidly repairable, you get so much more data out of it. And so that team, they said they crashed, multiple times, numbers of times. What that allowed them to do is get their tuning down. And even here they've crashed, and they've been able to repair it extremely quickly.
Yeah.
So out for a military person out on the battlefield, that has a value all of its own.
Yeah.
If it crashes and I can repair it and put it back up in the air, that's valuable.
Yeah, the focus, of course, is on that 4-to-1 payload to weight ratio, but I've seen so many designs that perhaps wouldn't hit that ratio, and yet there's something else about it that jumps out.
Correct.
Some are more repairable, some are more fragile. There are just so many lessons being learned here.
There's baseline cost as well.
Yep.
Right? So some of these designs are just inherently so much cheaper than other designs, which is a factor when you actually want to go to commercialization.
Absolutely.
All right, so this is a competition run, a scoring run, we should say. It's upper right-hand corner. This is run 14 for them. It goes green. Remember, this is the team that had their prior run put them into disqualification zone, so they're back at it again, and they are 1.6 nautical miles into this one. They have to go 4 nautical miles, then drop the weight, then do a 1 nautical mile. This is H squared. They are also on a scoring run. So we got all kinds of action. As we mentioned at the top of the broadcast, we've got 63 flights scheduled. So we are with you all day long here on the penultimate day of the DARPA Lift Challenge. And then, of course, tomorrow is Super Sunday. We break it all down. And $2.5 million to the winner on the line if we can reach that 4-to-1 payload to weight ratio.
Yeah, everybody here that we're seeing today so far has broken the 2-to-1 payload to weight ratio. So they are in the running for half prize, which is certainly no small amount of money.
Donna wants to give away the whole prize, though. You want to write the big check, right?
Giving money back is just, it hurts.
Absolutely.
So it's a paperwork drill. I don't want to do that.
Well, I'm sure you want to see somebody crack that number, too.
Oh, man. That we are going to be.
I think we all do.
So excited.
Does that mean if the 4-to-1 goes, that falls, does that mean you need to come back next year, the year after, and say, you know what, we're going 5-to-1 this time?
I don't know. My boss will be on later, so you
There
can
we
ask
go.
him.
There we go.
You can ask him later. But these guys, man, they were so smooth the other days. We're excited to see them. They had, this is H squared, okay,
Yeah,
3.35.
Oh,
Oh,
I was gonna say
no.
they dipped.
So we saw them tilt backward,
Yeah.
which itself is not necessarily a problem, but unexpected. And then the rapid descent, and of course, when you see smoke coming out, that's, unless you're at an air show, that's usually not a good sign.
And to Donna's point, you look at the altitude right now, it's showing -2. Obviously, they're on the ground. It probably
Correct.
should be reading 0. It's -3. So that's the variance that you're
That's
talking
the
about.
variance,
We saw them
exactly.
dip below 100 just momentarily. I thought maybe it was just a slight little bobble, and then it became a bigger bobble.
So this is it. This is testing the limits of
Yeah.
each one of these designs.
All right, so let's look at it again. They were 0.32 nautical miles into this one.
All right, so they were doing the hockey stop. That's that extra power you need. And there you go. You saw the hockey stop. They might have hit their control limits. They
Trying to
tried
slow
to get
down,
a little bit, slow
maybe?
down. Looks like they had some controllability issues. And eventually they broke something. You can see the engine smoking before it hits.
Yeah, we've talked about that aircraft are always designed with a certain amount of headroom. They have enough power, they have enough authority to do what they need to do at normal operation. And we're pushing right past that and finding out where the headroom
Exactly.
really is.
And so some of the detractors online, they're like, okay, 4.0, you hit it here, but you don't have the safety margin. To them, I say, you know what, that's fine. We'll go 3.0 on the production model.
Sure.
That's still way better than
Yeah.
we have right now. We totally get it. We're pushing the limit. We'll have to bring it back in a production model for safety, but that is still leaps and bounds ahead of what we have.
We had a similar conversation actually in the car on the way back to the hotel last night. They say, well, if we hit these aircraft, they're not designed to be weatherproof.
Correct.
Some of them are super light and spindly,
Correct.
and they wouldn't hold up in the real world. But again, if the standard today is about a 1.0 payload to weight ratio, and we can stretch that to 4.0 in the competition, as you said, maybe that scales back to 3.0 or something
Correct.
like that in real life, but that's still a huge step forward.
Yeah, you get the weatherization, you get the safety, and then you add in all the comms and cameras that you need to be able to operate, and that'll probably naturally come down to that
Sure.
3.0. 3.1 or 3-to-1 payload to weight
So
ratio.
MTech is less than a nautical mile away from dropping off their payload. Remember, they need to get right inside that circle, which has been beautifully painted by someone with a lot of arts and crafts skills overnight, because it looks great now. They won't be able to miss that. And they are staying above the altitude of 100 feet. So this is looking very good. Remember, this payload to weight ratio of 3.64 would put them into second place if they're successful. Well, this is lane 4, power and propulsion. I'm going to go back as we were keeping our eyes on MTech, because there's lots of competitions. We said 63 flights today. And yeah, lane 4, power and propulsion.
Again. Looks like did the arm just come off? Is that what it looked like? It looked like it just came apart.
And then driftless we saw in lane 2.
Oh, I'm going to be sad if this crashes. I see
Ooh,
that
they-
blade
Yeah, see
flexing.
the blade flexing.
The
Well,
blade
they-
flexing and wobbling.
They dropped a support wire there. See that?
Is that what happened?
So there's a trailing wire, and
Oh.
that's one of their support wires that comes off the engine.
That's those fighter pilot eyes.
Exactly.
So it's very interesting how people have taken tips or pointers from different areas of engineering or different areas of the world. So suspension bridges, right?
Right.
We have found that instead of making bridges out of just straight stone and cement, you can have that suspension bridge, right? You have wires that are holding it up. Amazing engineering and architecture to be able to do that. And they've taken those concepts and brought it to aviation here. And they've said, well, instead of making, extremely strong arms that are at right angles, why don't I use a suspension bridge type concept? So you see that in MTech's design, in driftless robotics design, and that's what failed in that particular situation. It was a suspension system that was holding up the weights going to those arms. One of those wires popped, and obviously the thing does not fly well.
So keep an eye on the gentleman there in the orange vest. Now, he is the lane supervisor or lane coordinator. He will give them the nod that they have reached that 4 nautical miles and they are clear to bring it in and land, and then they'll release that payload once they're safely on the ground, 116.9 pounds. Again, this is MTech. With this run, they're almost 1 nautical mile away from going into second place.
Yeah, and if you
Joshua, that's not chump change.
No, sir. No, sir. If you look at the pilot on the left there, you can see he's holding his controller in his right hand, but now he seems to have both hands on it. Just a minute ago, he was just sort of standing there holding it, looking. I assume the craft was flying autonomously. Now both hands on and eyes on, he is bringing it in for a landing manually.
As you mentioned earlier, Todd, the winds are picking up today. This afternoon's flights are going to be dicey.
Oh,
okay.
no,
it's all right. He can pick up.
Okay.
He can pick up. There we go. All right.
Good to go.
So they are allowed to reposition
Right.
as long as the craft is
As
capable
long
of
as
doing
it comes to rest in that location, right?
Is this,
so
is
they
this
did
similar
good
like
there.
landing a Harrier?
Oh, man.
The vertical? I mean,
after all the engineering that's gone into the Harrier, so back in the day, in the 80s and 90s, it was very dicey. By the time I got to the aircraft, there were some automated systems that came on board. Now, when those automated systems fail, it can be pretty dicey. But no, what they're dealing with here with the winds, there's a lot less mass in these, even though we're going up to these crazy weights. So a gust of 5 or 10 knots hits these drastically. It's way different from a Boeing 737 or a larger aircraft where they don't even mind. They don't even feel that. These ones feel everything.
we got D Material also on the line, and this is
D
I don't
Material.
want to say it's favorite of Joshua Bardwell, but
the inflatable
so
frame.
cool.
When I first saw this frame, Don, I said there must be an internal structure.
Nope.
And then I was walking through the hangars, and the guys saw me, and they were like, "Get over here!"
Yeah.
It's not. They wanted to show it to me. It is completely inflatable. It is a some kind of a polymer. It goes into
Kevlar.
bulletproof
Yeah,
vests.
it's a Kevlar polymer.
It's rigid.
It's super cool, and we want to give thanks for them for joining us on the set yesterday. D Material coming by. This is a team that spans from Alaska to Illinois to the East Coast, back to Cal Berkeley, and so they've got all kinds of great minds going, and it's just a cool design. And I guess initially, Don, I thought this has got water landing applications written all over.
You know what? And they even have orange. So, anybody in the Coast Guard right now should be like, look, we don't even have to redesign it. It's already our colors.
Now, I spoke with them this morning, and they said that they believe this likely will be their only chance to get a competition run. And so I think we're going to see them go for it today.
Oh, I love it. You know what's great about this? In talking with them, JB, when we were over in their tent prep area, I said, how many of these do you brought? We got a whole bunch of them. We can inflate it with a generator quickly, and they can strip out all those parts that they need and put it on another frame. They said within 20 minutes.
Take a look at the left arm. You see that piece of electronics strapped to the side of the arm. That is the electronic speed controller that's part of making the motor spin. In their first run, they were grounded because they had a prop strike on their ESC. And apparently they have repositioned it to the side of the arm to prevent that.
And down on top, that's the Titan, right?
That's correct. Titan. That gray box on top. So back to your earlier comment, Josh, about the applicability, the different things we're looking at. This is a materials company. They make these inflatables, and then they came out and said, we think there's an application for this. So we are actually looking at these guys and saying, part of this community we've been talking about, let's get an engine guy and a prop and a person who develops quadcopters. Let's pair those two together, right? And join the expertise. Even though these guys may have a lower payload to weight ratio, for us, we're looking for the ideas, the concepts. And like you said before, the water landings, there's so many applications when you think about it in that respect. A lot of times we have endurance problems with quadcopters. But if you can land on the water and just sit and wait, and then when you want to fly, you pick up and you move, you're conserving that battery life in such a novel and interesting way.
See, I was thinking if I lived in Seattle on a boat, they could come and land and deliver my Captain Crunch right on the water.
There you go. That as well.
Sometimes there's people out there and they have a solution to your problem, but they don't know your problem exists. This is such a, I don't want to say perfect, but this solution fits the problem of a multi-rotor. Multi-rotors have to be very light, very stiff, and very strong. And that's a very unique material solution.
Correct.
And I imagine these guys out there going, well, we've got this great product. Who needs it? What do we do with it?
So if you read the scientific magazines, this concept of inflatable structures was actually decades ago. And a number of companies explored it. And what they ended up having a problem with was it would break under certain stresses. It would basically fracture. I know it's an inflated concept, but it would fracture. And so the idea never made it through testing. This company has figured that out now. Decades later, they said, let's fix that problem.
They dropped their weight.
Yeah, the automated release system popped it off, maybe.
This is Avidrone, and we can tell you right now they are at 4.16. They were until they ejected some weight. That was 122.4 pounds on a 29.4 pound vehicle. So their payload to weight ratio has them in the money. They would have been kings of the castle, going for broke, swinging for the fences, use every
speculated
exactly
whether they would do it.
Yeah.
They're apparently going to do it.
But if you're going to drop your weight, I mean, they kind of picked the best spot to just
Well, so very interesting on what people decided to tackle. There are many problems. This company said, I have an automated drop solution, and they used that. In this particular case, we don't know why. Maybe the automated drop system failed and it dropped it unintentionally, or maybe they started seeing a controllability issue and said, I want to save the aircraft, drop the weight, come back, fix the problem, and go again.
Well, like you said with the Harrier, you have complicated mechanisms, but then sometimes the mechanisms break, and so sometimes it's better to have a simpler mechanism.
Here we got a replay showing again. Let's look at their controllability. See if they started having issues. No, it looks like it just failed on the mechanism.
It couldn't be too much weight, right? I mean, it could be a situation where it just couldn't hold it, or do you think it just speculating, of course? Yeah. Boy, look at the difference once that weight came off it, how quickly it just
up.
I mean, if you did have controllability issues, the ability to drop that weight and potentially save the aircraft, that's an advantage of that automated system.
But on the flip side, a lot of the team said, I don't want to risk that system failing.
Right.
And having to deal with that and ruining a competition run. So every decision in the design phase has a pro and a con. For them, they have a rapid turnaround time. They don't have to worry about the 30 minutes at all. And they have this ability to drop the weight.
Yeah.
So you're seeing here that the guys are looking at that release mechanism. And so that's probably what happened. This is speculation, of course.
Could be a minor fix, right?
It could be a minor fix.
And you can get them more weight.
Oh, we have tons of weight plates out there. Yeah.
Plenty of weights.
By the way, the Dayton area will have a lot of weight plates at the end of this competition.
the used sporting goods stores. Guys,
we're not taking those home.
Donate
Carry-on
it back to the
luggage.
community.
Carry-on luggage
That's
does
great.
not allow us
But
to
you
bring
bring up
those
a good
weights back.
point, because if this was something that they needed to fly again, they couldn't go down range and retrieve and all that. They'd have to wait, right?
If we didn't have extra weights, yes, correct. But we do have extra weight plates on the line for this exact scenario.
So they're going to sort this
You
out.
know, you talk about that decision where you're going to have the automated dropper or you're going to do it manually. That's just one of probably thousands of engineering decisions being made. And if you had infinite time, you would say, well, if I had infinite time, I would solve all those. But actually, I think if you had infinite time, you would just sit there and think about all those. And it's only when you really put pressure that you actually are forced to start triaging those decisions, solving the most important ones, leaving the others for later, and actually making progress.
It's 100% correct. And yesterday we talked about all of the disciplines that combine to be able to make an aircraft. And when you go to college and you're saying, I don't know what I want to do, there are a number of disciplines here. And all of those, or a lot of them, actually bleed over into the other applications. Automobiles, airplanes, ships. There's a lot of things. Structural engineering, mechanical engineering, electrical engineering. These are all fields that you can go into. What's amazing is when you see a small team out there, that's one person that is having to deal with all of those issues, right? And it's the quality and the level of intelligence and training and education that these guys have is amazing.
Yeah, I think it's the beauty and the curse of this, the UAS or drone discipline. One is that no matter what your focus is it programming, electronics, mechanical design, CAD, you can find a way to slot that in, being a pilot.
Correct.
Also, if you're a one-man or a two-man or two-woman team, you kind of have to do it all.
That's true. And I said it the other day, but modern technology is amazing. YouTube Makerspace has all of this. So you don't have to pay a dime to go to a university and learn anymore, right?
We got Joshua Bardwell. He's got over 500,000 people following on YouTube.
It's amazing what modern technology allows that, you know, if you want to get into this sport, you can. You can.
Yeah.
A team over there just had, it was about a $1,300 aircraft, and they did it off of YouTube Makerspace.
Wow. Yeah.
And that's how much, and they're still competing today.
You know, I think that's a good point to reiterate to the audience, which if you're looking at these aircraft, and these aircraft are probably pretty expensive and out of the reach of most hobbyists, you can get into the drone or the RC flight hobby, whether that's a little multi-rotor or a little airplane, for a few $100s, and you can start experiencing this. And I wager that this is how almost everybody competing today got started. So
100%. It's a great sport, great hobby.
Before we let you go and give you a break for just a minute, please tell me that we're going to see another one of the RC derbies in the air when they go up.
Oh, yeah. The aerial combat.
Aerial combat, that's amazing.
We do have 3 of those.
Here we go.
3 every day that happen. So maybe we'll get a camera crew over there to watch it, and
My man
we'll
Scott
go
Barkey,
live.
the director, he'll get it for us.
We'll get
it is
it.
something cool to watch.
It is so cool. It's like a beehive in the air.
It's amazing. Thanks so much.
Thank
As
you.
always, appreciate
We'll
you
see
popping
you guys
in.
later.
I know you're a busy day. We'll have you back on here shortly. Our thanks to Philip Smith, call sign Donna, the program manager for the DARPA Lift Challenge. We got more guests coming along. As we said at the top of the broadcast, we are flight loaded today. 63 flights scheduled on day 6, the penultimate day of the DARPA Lift Challenge, and we've seen hints of greatness coming, JB.
Oh.
We saw someone go up breaking the 4-to-1 payload to weight ratio. Now they ejected their weight shortly into it, but you see what we're cooking.
Yeah, and we've seen other teams attempt higher payload to weight ratios, but not a team that has actually completed a competition run. So here, to have the team in #1 place on the leaderboard trying to crack that, I mean, if anybody's got a chance, you got to think it's them.
All right, let's check in with Elena, who's down near the flight line. Elena, it's all yours.
I just witnessed MTech land, and it looks like their strategy of landing manually versus autonomously actually worked out really successfully for them. They were within the circle. They're going to go up again and do their last run, and we'll see what happens.
Let me ask you this. How's the weather down there? I mean, we're getting a little gusty where we are, but how's it feeling where you are?
Yeah, it is a little windy. So when they were coming in, it was actually a little tricky, and then they went back up and positioned and landed successfully in that circle. But it was a little iffy at first, but they made it.
All right, thank you very much, Elaine, and much more from you as the day progresses on, as we are loaded with some great action today. And will history be made? Will we hit that 4-to-1 payload to weight ratio? The wind is up a little bit, but we've got the best pilots around, including my partner Joshua Bardwell as well. We've got guests coming in. We've got amazing competition throughout today, and then tomorrow, the final day, Super Sunday of the DARPA Lift Challenge, will be taking place here in Dayton, Ohio. Fantastic day. The weather's up, the wind is up, and we are so happy to see another drone going up as we welcome in our next guest here, Jonathan Bennett, the DARPA Chief of Staff. Good sir. Thank you so much. As we watch MTech go up, I got to ask you right out of that, what's been your impression so far coming to this event?
Hugely impressed with the competition itself and the competitors. Just the level of innovation that's happening in the garages and on the course has been amazing. And of course, I'm very proud of our staff as well. Like, this is a very complex event to put on, and I think they've been doing a phenomenal job. I
will second that. They have been doing a phenomenal job. They have not missed a thing. No stone has been so. Let me ask you this. Is it true that you've been to every DARPA challenge?
No, I've fostered that myth for now. So I've been at most of them, but there's 2 or 3 that I have not been to.
Why would you miss one?
Well, part of it is I'm an Army Reserve, so I got deployed. But
thank you for your service.
Thank you. Yeah, and so I missed the launch challenge and I missed the subterranean challenge, but the rest of them pretty much I've been to.
You weren't going to miss this one.
No, not for sure. Yeah, this is an amazing one. We're super excited about.
So I've been hearing people say that this is a DARPA Grand Challenge. What is a DARPA Grand Challenge? What does that mean?
Yeah, it's a question we get a lot because, big C challenge versus little c. Honestly, there's not a real definition for it. I mean, the common elements of a challenge are that it's prize-based, that it's, pay for performance, and that there's some level of head-to-head competition that occurs to do that, rather than a traditional contract where you are paying someone, you set out goals and those kind of things. But honestly, I think that the elements of what makes a challenge successful and makes it really a grand challenge really comes down to our approach with it. And there's a great quote, actually, I like to reference. It's actually from Reagan's second inaugural speech. And it said something, I'll botch it, but...
You're paraphrasing.
Yeah, exactly. But it's freedom and incentives unleash the drive and entrepreneurial genius that are the core of human progress. Have you heard that one before?
Yes, and that pretty much summarizes what this weekend.
I think that's exactly right. And I think that when you look at challenges in general, that's actually the spirit of it, right? It's from a freedom standpoint is we're not defining for you how to solve the problem. We're telling you what the problem is, and we want to give you the freedom to explore it in a way that we may not have thought of. And then the incentives of it, part of it is, hey, you're here to win. You're here to win the money and take it home. And I think that is the thing that's the real magic behind challenges and why we continue to use them at DARPA.
As the competition rolls on here on day number 6, we're visiting with Jonathan Bennett, the Chief of Staff of DARPA. There is MTech up. This is a scoring run. How about this? They are at 4.8 nautical miles. And there you see them at 3.64, so they would put them into second place. It's good to have the DARPA Chief of Staff so we can get them all the hard questions. But how does this differ from the other challenges, the DARPA Lift Challenge?
It's really, it's an apple and orange question. To look at the original Grand Challenge with the autonomous vehicles compared to this, you might be surprised. This is actually at least as complex, maybe more complex than that in a number of ways. But you love all your children, and this one's no different. But this one, I think, the speed with which we came to get this done is one that I think is really different. I mean, Donna and the team, it was less than a year ago, I think, that we came to the director and he pitched this, and Stephen was like, let's go. And they put this thing together. I think this is the fastest we've ever pulled one together, and Donna and his team deserve a lot of credit.
Donna's a pretty convincing salesman, though, right?
Yeah, for sure. Yeah, no doubt about it. Yeah.
What has been your favorite moment so far?
I love to interact with the teams and to hear kind of the innovations that they've come up with. I was talking to, I think it was the Burl team, and they were talking about their catastrophic early crash. And, they've got this very exquisite, carbon fiber wing, and them talking about having that moment where they were just like, oh, they were crushed. Right. They were like, we're out of it. And then, you go look at it now, and it's got 2x4s bolted to the bottom of it. And they say that like their solution that they came up with is actually better than the original design
with the 2x4s.
Yeah, I know it's crazy, and maybe they're saying that, but I think they seem genuine about it, and that's the kind of stuff that you just don't get in the lab. You just don't get in PowerPoint, right? Like to see that stuff get proven. And I also really love the high school and college teams that we see here. That's something that we saw in the original autonomous vehicle grand challenge with high school teams coming out, because let's be real, those are the future. Those are the guys that are going to really solve the problems in the next 20, 30 years.
Absolutely. Breaking news here. MTech has set it down. Now, this is a pending score. They're going to review a few things, but as it stands right now, MTech, JB, would go into second place if this score stands.
Wow.
So I got to ask you this question. I'll probably get in trouble for asking, but I'm going to do it anyways. What are you guys cooking up next? I know you and Don aren't rest on your laurels and say, yeah, we're good to go. Let's just go back and kick back. Is there anything you could share with us that what's the future hold?
So we actually have a challenge set up for this fall. I don't know if you've heard about it, the DARPA Triage Challenge. And that's a medical challenge that we're looking to find ways to use advanced sensors and robotics to identify ways that we can improve triage for mass casualty events or battlefield. So that's one we're really excited about. That's happening in November, and it'll be in the Disaster City complex in Texas. That's one. But I'll be honest, like we move really fast. So there are challenges that gets pitched at our tech council all the time, and not all of them are accepted. But we've got some folks that are developing some ideas that again around autonomy and those kind of things. But I don't want to
sure.
push too much.
But there could be a challenge in less than a year that you haven't even heard a pitch yet on.
That's right. That's exactly right, and that's the DARPA way, right? We don't want to get stuck into milestone-based thinking where we're like, well, this is the thing. We want to be chasing, beyond the state of the art always.
Yeah, talk about that, because certainly there are people who say, well, if only I had a little bit more time, maybe I could have done things differently. But talk about the value of that accelerated timeline and why DARPA chooses to operate that way.
Yeah, I think speed as a factor really can't be underestimated, and it is. You're like, oh, if we would have been able to develop the materials better, those kind of things. I think putting pressure on people, that's the crucible that really drives the innovation that we're looking for, and that's again part of the DARPA way. I mean, we have programs. Our programs generally last 4 to 5 years. Very, very few programs go beyond that, and we're not an agency where we have these long, ongoing programs. We want to put the pressure, and that's true for our program managers as well. Like Donna's got an expiration date. He's
Donna's off camera here.
That's right.
Not literally, but
yeah. His career at DARPA, but that's the intent. Like we don't want people that come to DARPA and build something and defend it. We want people to come in with a fire in their belly, to explore something, and then we want them to go back out into the ecosystem. And I think this is true as well for the competitors, in that, if we gave them more time, they would take more time.
Yeah.
And
exactly.
I think true innovation is driven by that crucible.
If you tell me something isn't due for 6 months, I'm not even going to start for 4 months.
That's exactly right.
We're speaking with Jonathan Bennett, the Chief of Staff for DARPA. Someone once said that fear is the energy behind doing your best work. And as we walk through the prep areas, you see these teams that have these, what you'd say, big crashes, and then they're right back in there.
Yeah. Screwdrivers
out, everything. They're just working like bees. So it's a cool vibe here. And Elena's reported on it. Joshua knows about this community very well. They're helping each other as well. This isn't just a one-off my team against your team.
I think that's a really important point, and it's one of the things that we see as one of the most powerful parts of doing challenges is it's not just about solving the problem. It's about building the community around a technology. When we originally, again, call back to the original Grand Challenge, a big part of that, the community that Google ended up pulling in for their program was all basically the performers that were on that Grand Challenge, and I think you'll see that here as well.
I think a wise person said in the prep area, JB, early in the week, it's us against the drones.
It's not us against each other, it's us against the drones. I'm curious, you've seen so many of these challenges. Have you seen that also in other communities, or is this something that's unique to the aviation community?
No, I think you see it whenever we do. Like robotics was another challenge that we did that we saw that. We saw an enormous amount of, as you were talking about, with the collaboration.
Yeah.
So they blow an actuator or something like that. They go to the next pit and they help them out. I think everybody is, yes, there's a competitive spirit here, but really people want to see the problem solved.
You picked a good time to join us, Jonathan, because this is Avidrone. They are current leaders at 3.84 payload to weight ratio. We saw them go up at over 4. So you and Donna are going to have to get ready to write a big check if they make it happen. But the weight ejected, but they're back on the line still, and they still have, by my calculations, over 45 minutes, plenty of time. MTech's run is pending scoring, so they're going to look at something else. Now, this is what we're hearing, breaking news. This is DefenTech's. Now, this is the drone, Joshua, that is, what, around 12 pounds?
Yes, 12
And I'm hearing
pounds.
crazy numbers in my ear that they're going to go and possibly go for a off-the-chart kind of payload to weight. So their tested flight was a 12.57 ratio.
And they've made an interesting choice because, of course, the minimum weight that you must lift to be qualified for a prize is 110 pounds. So by choosing to come with a 12-pound drone, they do not have the option to do less than something like a 10 or 11 to 1 payload to weight ratio. So I think of this as like they're swinging for the fences. They're either going to hit a grand slam and clear the bases and just charge ahead.
So it's a double-edged sword, really, for them.
Absolutely.
But you probably love seeing this, John.
Oh,
I mean, just like
and
more
you
the
said,
merrier.
You said, cut that check. That's a check we would love to cut, right? Like, that's not something we're unhappy about at all. So.
Yeah, the big question is like that we've seen them have a structural failure during one of their previous tests.
Right.
So they're pushing their airframe right to the limit to lift that much weight with something so light.
So this is the final preparations that they are going through, trying to make the changes or adjustments they may need with that massive payload to weight ratio.
You can see those guy wires that Donna talked about breaking on one of the previous runs, holding those arms up, supporting them.
Not to speak too much hyperbole, but there is the wind situation again. It is certainly going to be a factor, but this is a situation possibly where we could see history being made today. I mean, this is one of those deals where Joshua is closer to the ground on this one, but a lot of people in the community said this will never happen. You cannot do 4-to-1. We're on the verge of doing 4-to-1.
Yeah, absolutely. And I think that's, if you'd set this out as a traditional program, it's hard to say if that would have actually been achieved. It's this is, like that competitive spirit that we get out here is the thing that drives this. So, yeah. It's exciting.
Jonathan, thank you so much for your time. We appreciate it. We appreciate you putting this together.
Appreciate it.
Jonathan Bennett, the DARPA
really
Chief of Staff, joining us here, and he's going to go out in the flight line and take it all in. Take a pen. You might be writing a check soon. Jonathan Bennett, the DARPA Chief of Staff, joining us here on the set, and we appreciate him and all the good folks at DARPA. One thing he did say, Joshua, and I have to second it again, is the staff from DARPA, all the good folks, Donna, his team, all the people in the orange shirts.
Everybody.
Working their tails off for more than a week.
Working their tails off, for sure. And it's been inspiring to see the attitude that they bring.
Yeah.
Everybody is excited about this. Nobody seems to be just here to collect a paycheck. Yeah. Everybody wants to see this happen.
And we've got a feature on them coming up a little later on today. So from the DARPA Chief of Staff back to the Program Manager. Philip Smith, call sign Donna, back with us again. If this Chief of Staff thing for Jonathan Bennett doesn't work out, he's got a job at TV. You as well. You guys are good talkers. I mean, you guys know what you're talking about.
Some would say that's my only skill. I don't know.
Yeah, he gave us some great intel other than saying you do have a shelf life or a time of departure. What we just saw there, so we've got some great possibly breaking news here with MTech waiting for that score to go official.
Yep.
We've got two other teams that are looking like they're getting ready to spin up and go. This is DefenTech.
Yeah, today's the day. I mean, yes, tomorrow is also a competition day, but I think if you're one of these teams, I think it's time to start going big or going home.
So an interesting thing that we can talk about with the data that we've pulled from people, but especially on the personal side of things. So DefenTech's with an X there, DefenTech's is actually an Australian company. They have an arm here, DefenTech's USA. And that's where some of these guys are. But actually, when you talk to them, you'll get that Australian accent coming through. Same thing with Burl. Burl is an Australian company that's here. We have teams from everywhere, Austria, Germany. And what they've had to do to be a part of this is to partner with an American organization. And so that's where you see here, Moab, Utah. That's where this group is. Their company is affiliated in Utah.
Great place to go mountain biking.
It is.
Shameless plug. Shameless plug.
But one of the cool things about these challenges and opening it up to the world is we get talent and we get ideas, and all of that is brought here to the United States, here at Wright Pat Air Force Base. And we get to see ideas all over the world, and that's really amazing.
Would you use your jet fighter pilot Eagle Eyes? That is some massive weight. Again, this is a 12.9 pound drone.
That is correct. So we'll wait for the math to come up on Titan once they take off. But so if you look at those suspensions, once again, a number of the teams did this. A number of the teams went to the suspension concept. You see them tying those wires there. Yesterday we saw that they folded up after the crash. And if you've seen those videos of suspension bridges when they weren't built correctly
and they start
waving and everything, so actually, suspension type systems only work in one direction, and in this case, they work to keep the arms down. So yesterday or the day before, when they hit the ground and then those arms folded up, the theory here, just watching it, is that those suspensions snapped under that increased G force that happened when it hit the ground and then it popped back up. They still had power or inertia on their rotors, and once those suspension lines snapped, it just folded up on itself.
Yeah, if you look closely at that frame, there's almost nothing there except the arms.
Correct.
And then this bare minimum of a skeletal structure, but there's no big reinforcing braces in the center. And those guy wires are essentially what's holding the thing together.
Correct. And so I talked to these guys on the trailer as they were making their way out to the flight line. I said, guys, let's do this. Come on. And they're like, this is our last aircraft. We don't think we're going to be able to fix it afterwards. So if they crash here, they're done. They think maybe they can repair it and fly again tomorrow. But and I was like, come on, guys, where's the duct tape? Structure. And they were like, it's here, it's here. So actually in the middle of the aircraft, you can see some tape and everything. So they've been doing some flight test engineering repairs. When you're out in the field, that's what it is. It's amazing to see.
Speaking of tomorrow and weather permitting, what does the schedule look like as we wrap this thing up?
So we are building that schedule right now. It is difficult. We've got to see how many teams here today. We already saw a couple of crashes. We got to talk to them to see if they can repair it. We would like to give everybody another shot. We'll have to see with the schedule, today's weather, with the wind going. We might see some either increased crashes or some canceled flight windows as well. So it's a very dynamic thing. And this is actually true even in military aviation. You're always dependent on the weather and maintenance to see what you're going to do the next day.
Okay.
Carefully tensioning those lines. If they're too loose, it's not going to work right, and if they're too tight, it's not going to work right.
Correct.
And of course, when they take off and that weight gets on there, it's going to add stress. So I can only imagine they've got some kind of a method for figuring out how it needs to be. But that's just these constant adjustments that teams are making as the weight changes.
So this gets into dynamic flight controllers, automated concepts here. So if you have that tension wire and it's pulling your arm one way or another, that changes the distance between your four arms because it's very flexible. They need it to be flexible to be light. They want to try and get it as rigid as possible, but also when you go with rigid, you also go with a fracture. So the more rigid it is, when it starts bending, it just snaps instead of flexibility, which allows you to bend a little bit, but then flex back to its original position.
Don, I know you gave us a little education on the windsock and how to measure the knots that are blowing. That camera's going up and down. It's not because they're agreeing with everything that you and Joshua are saying. That is a small camera that's locked off.
I thought he liked what I was saying.
He was going, exactly. No, that is a small locked off camera that is getting buffeted by the wind. So it gives you an idea of what the wind is. My next question would be, does this design help them in these kind of conditions? Because there's less surface, obviously, for the wind to buffet.
So, once again, pros and cons to every design. They are working off of a lower RPM, and that's how they're getting such a small battery and a small motor. So their props are spinning very slow, which means the reaction time to a wind gust is also going to be a little bit more limited. You see this in those large prop-driven rotors as well.
Here we go. Avadrone out of Columbia, Maryland. They are at 4.02 on the payload to weight ratio, so history possibly being made here as we've got a scoring run underway.
Oh, no.
And I gave them the old announcer jinx.
Looks like the tail rotor stopped functioning and we lost yaw authority. And
wow.
That looks like a battery going off to me.
That's an impressive one.
Yep. They
That's
got
really
big
disappointing.
batteries.
Really
Yeah.
disappointing for that team.
So promising for the first 30 seconds, and then it all came to naught. And this is where that Titan display comes into display, because the fire folks that are going to go out there and tend to this, they'll know exactly what they're dealing with before they get out there.
Correct. So in this particular scenario, we're looking at the wind. So the wind is favoring us in this particular case because it's going away from the runway where all of the staff is. We're also looking at the color of smoke. So that color is actually not bad. There you go. There's some black smoke. So that's the carbon fiber. That's what we're worried about. And we'll be managing the lane. And our fire department has all the correct gear to go out there and put that fire out.
They were smiling.
They're smiling. They're laughing. You know, I can't speak for these teams with everything they have on the line, but I have to say, as a drone pilot, when your drone crashes and lights on fire, there's a part of you that's sad, and there's a part of you that's going, you know, I was pushing it, and that's just what happens.
Hey, they were going for it. That's all I'm going to say. They were going for it.
Yeah.
Well done, gentlemen. The good news is Aviadrone's still in first place.
Yes.
That is true.
So Donald still may have to write them a big check.
Yep.
All right, let's look at this again. And Donna, see if you can spot anything when they were starting to ascend. Looks good at this point, right? Oh, the tail.
The tail rotor stopped entirely.
So we got to be careful about that because the frames per minute on the camera will actually look like it stopped. But it did look like it slowed down. We don't know if that's the frames on the camera.
Is that savable at that point when it gets like this?
No, when you lose a tail rotor like that, that's the torque from the engine, and that starts spinning around.
Here's an interesting thing. It might not be intuitive to people that as you add weight, obviously the main rotor is working harder to lift the weight. But isn't it true that as you add weight, the tail rotor also has to work harder?
Correct.
To counteract
100%.
that yaw? So
for anybody who doesn't know about helicopters, right, there's a motor that inside that is driving a drive shaft. That drive shaft is driving the rotors. So every action has an equal and opposite reaction. If you want to spin the rotor, that means the body of the aircraft is spinning in the opposite direction. So your tail rotor is there to counteract that spin, that reactionary force. That torque is what we call it. It is torque on the mast, the rotor mast, and the tail rotor is there to stop that. So in this case, you know, armchair quarterbacking, we can do it. We can look at the screen and we can say it looks like they had a tail rotor problem. Whether it stopped, it froze up, they had an electrical issue, maybe they had a controls glitch.
Would that be related to the weight?
Definitely. Everything.
All right, this was the reaction just moments ago. Defendtech close by as they were watching. And
everybody turning to look.
Everybody looking.
WTF.
That'll get your attention quickly.
And you know, as a competitor, obviously you want to win, but it never feels good to see anybody going to the ground like that. You're always rooting for everybody else just as much as you're rooting for yourself.
So that is Aviadrone. They are down, and not sure that's going to be repairable today.
At this point, it looks like the battery has burned itself out. Now we just have this little residual fire for the fire team.
And you'll
to
send a
take care of.
hazmat crew. They'll go out there and they'll retrieve
pretty
much everything. And
we went through months of safety review boards, and we said the safest thing to do in order to keep the competition going is if that fire is not spreading, we're going to let it go.
Yeah.
One of the safety things that we had here is that you could only have that 55-pound aircraft.
Right.
So the volume of fuel and or batteries that you could put in a 55-pound aircraft is automatically limited, right?
Yeah.
You can't possibly create, I don't know. I guess you could possibly.
Never say never.
But you could have, 40 pounds of fuel. That's actually not too much. No one's done that. No one can do that, right, because of the engines and everything. So in this particular case, we are actually just leaving it. We're letting all the other competitors fly. The fire department is off camera. They're down the road. They've got a couple of different assets. So we have brought them in and stopped flights on certain conditions. But in this particular case, it was far enough down the field. Everyone else was safe from the smoke inhalation, and they just let it burn where it lies.
Of course, it's a very wet day. Rained us out yesterday.
True.
There's not much risk of this going anywhere. There we can see the relative position of the downed craft. relative to the flight line.
I'm talking to some of the staff and also seeing some of the social media feeds. Avidrone has climbed up the ladder. People have been talking about it. I see other companies that are like, oh, it looks like my design, buy mine. So it's, the energy is building, not just here on site, but I think around the world with people watching this competition. So a lot of people were rooting for them. We were as well. We're rooting for anybody and everybody that is going, but they look so solid in their previous runs.
Yeah.
And, but this is aviation. You have no idea what happened there. But there are so many different things. Going back to that multiple disciplinary and all the actions and reactions that happen inside of an aircraft, it's not like a car, right? A car, you have a problem. What happens? You start slowing down. You pull over to the side of the road. And it's a non-event in the sense that it's not very dramatic. You're living in the 2D world. When you go into that 3D world, a small error, and we talked about it yesterday with the sensors shaking, right? That's a big deal. In a car, the sensor shakes and you got your hand on the wheels and you're driving, right? But in the 3D world like we live in here in aviation, those all have massive follow-on consequences.
Yeah, and one of the things, it might seem like, well, you did it at 3.84, it was relatively drama-free, but I think the key is that we're trying to find out where the actual limit is, and sometimes when you find that limit, you end up on the ground with some flames.
We're coming up on less than 30 minutes to go in this flight window, the first one here on day 6 of the DARPA Lift Challenge here in Dayton, Ohio. Don, have you got a sense that people are playing a little strategy game, maybe waiting for a little better conditions, the wind to die down, see what other teams are doing before they launch?
There's so much going through these guys' heads, right? Just like anything, they're looking around. Yeah, they're seeing what the wind is. They're seeing what everybody else is posting. They're playing the leaderboard, right? And saying, do we really need to push it today? Do we wait because of the winds and push it tomorrow? So yeah, everybody is looking around like we saw those Defentex guys seeing, okay, that's what happened to them, right? So there's also another interesting thing is that the winds are different at altitude. So every piece of altitude, 10, 20, 30 feet, the winds can shift and they can change. So what we see here on the ground with the flags waving, which we do have a good bit of wind right now, could be drastically different at 50 or 100 or 150 feet. And so everyone is trying to learn from everyone in this case, right? We do have, the only way to actually know that, what is the wind up at altitude, is by getting up to altitude.
Yeah.
We don't have a magic sensor that looks at the wind at altitude. So an analogy here is when you're in, a commercial airline, you're flying somewhere, and the captain comes over the radio and says, we just got a pilot report that we're about to hit some turbulence. That's because someone else went through that turbulence. That's actually what is happening is some other pilot flew through some turbulent area.
It's like Waze in the sky.
Correct. Yeah, that's exactly how it is. That's exactly how it is. So some other pilot out there was like, hey, we just hit some chop around this area. Everyone else beware. Then if your plane is going through that area, the pilot comes over and says, I'm putting the seatbelt buckle on. Please stay seated because we have reports of some chop ahead.
Let's talk about strategy. Some of these teams have said that they think this window that they're going into today might be their last chance. Let's say you're in the top 3, or maybe you're a chaser, like what kind of strategy are you thinking right now?
Man, there's so many. So what you can do is try and game the weather, right? So we saw today, and everyone has it on their phones, and you can say, all right, we've got rain coming in possibly, we've got higher winds coming in. What is the weather tomorrow? Weather's kind of like a batting average, though, right? It's not very good, and especially at the micro level.
Right.
So we have a micro station, but we don't have the prediction of what tomorrow looks like here at our micro station. We rely on the macro stations, which are farther away. So the local weather versus the grander or the broader area weather. So people are looking at that. They're trying to game it. They're saying, do I risk it today, or do I risk the weather being better or worse tomorrow? And that's a big unknown. So that's one factor. Now on the flip side, it's cooler right now.
It is.
And so for the designs, remember we saw Defentex with the Mylar sheets on.
Right.
Today, you don't see that.
They're trying to keep it cool.
They were trying to keep it cool because it was a bright sunlight coming in, heating up all of their components and degrading their power. And we saw that when they took off, that they had that power settling, right? They were trying to go up, and they saw that it flattened out, and it was coming back down. So today, yes, you're fighting the wind, but you have the benefit of being a cooler and without direct sunlight. And this once again goes back to the comments we made earlier about the 4-to-1, the 3-to-1, the weatherization, all of that stuff. Of course, in a commercial or military application, you have to go up in whatever the weather is. So they'll have to design to that. But this competition is saying we now know that it's possible to go up, right? Today, or the other day with Abadrone, we know that it's possible to do 3.86.
Yeah, one of the things you talked about was that the manufacturer says the spec for a motor is so many RPM, that's
Right.
100%, and of course these guys are trying to push past that. One of the consequences of that, I suppose, is that your equipment wears out, and you may not have as good a performance on like your 5th run or your 10th run as you did on your 1st run.
Very true. So, yeah, the wear is cumulative, right? So they're taking logs of that as they are flying. They're saying, okay, I ran this engine at something, whatever it is, 300% the manufacturer's defect. Do I swap it out?
Right.
Or, and there's manufacturing variability in everything that we have. So do you swap that out, or do you say, no, I know that this engine or this motor or this battery can do it because I've tested it, so I'm going to stick with it. And that's one of those variables that teams are having to play constantly when you're pushing every single component to its very edge.
Leaders in the clubhouse, Avadrone, with a 3.84 payload to weight ratio. Unfortunately, their last run, not the way they wanted it to end, but they are packing up and heading back to the prep area. And they'll have to retrieve, or someone will retrieve that drone that's out in the field a little later on once this flight window is closed. We are getting word that 2 teams have been given extensions of 10 and 15 minutes respectively. We'll get you those team names, but this rolls on because currently looks like Extreme Aerial is going to pack up and pull it off the line.
Donna, let me ask you, we've heard about teams getting extensions to the times. What kind of conditions might cause a team to be granted an extension?
Sure. So we talked about the Titan system, and that's predominantly what we've seen at this event is the network going down. So certain tents last night or yesterday with all the, and last night, with all the thunderstorms, actually one of our towers got struck by lightning and knocked it out. So this morning, my team was rushing out early this morning, rewiring, replacing gear to get the system back up. Heat also plays the same, just like on an aircraft does. It plays the same on our sensors and our comms equipment out there. So things are getting overheated. We're telling the lane coordinators and the staff, hey, put your tablet under the shade, right? So same thing. When you have your cell phone, you put it on the dash of your car, and then you try and use it, and it says overheated. That's exactly what's happening with the systems out there.
Give you an idea of what we were dealing with yesterday on day 5. This came in early afternoon between 1 and 2 o'clock, and it continued on well into the evening. It got a little spicy out there on the flight line.
Yeah, we had a couple of TVs get knocked over in the tents. We had to pick up some flags. Luckily, none of our tents flew away. All of our personnel were under, lightning protection shelters. We had no tornado watch or warnings, so that was really good, really encouraging. But when the public saw that we had a weather delay, this is what we were dealing with. It was intense, and then we got more rain last night as well.
Heavy thunder, heavy lightning throughout the day yesterday from about 1:30 on until 6 o'clock in the evening. Then a beautiful rainbow came out, and then it started raining again. So this is day 6 of the DARPA Lift Challenge. Defend Tex is still out on the line. It looks like they are weighted and possibly getting close to making a run. The flight window unofficially closes in 20 minutes, but there have been some extensions given.
Sorry about that, Todd.
No,
you
you're
can
good.
see them taping around those batteries. I almost think I recognize those batteries. They have been assembled. You can see they do not have any sort of labels or anything. It looks like those are lab-made, let's say, not homemade cells that they have custom made for this. And when it comes down to the wire and you need to go fly, you just get some tape and tape those things on and you send it.
And see, they use that orange tape to add some suspension. So you see that they're connected to the arms. So in addition to their design with the strings that you see coming down, they've added some tape and saying, hey, I'm gonna learn from my mistakes. Yep. I'm gonna do some flight line engineering here and repair and go again.
Well, they are the tops on the Chaser leaderboard. Defend Techs out of Moab, Utah by way of Australia. And they've got to get a scoring run in, but look at the promise of that payload to weight ratio.
So here we go. We got Defend Techs. They're in at 9.63. We have M-Tech, which unfortunately we had to cancel that run. They got that 3.64. And then on down the list, we have a number of teams here, up to 10, 2.06 at the bottom there, breaking that minimum barrier and getting a qualifying score. So remember, 110 pounds is the qualifying score, and that gets your payload to weight ratio. So there, let's talk about the heaviest one on the board, Advanced Tactical Lift Aircraft Systems, 54.6. That is 0.4 away from the maximum, and then they lifted the minimum of 110 pounds, and you have the 2.4 pounds there is the tracker weight. So that is why you see an addition. When
you said there was a 55-pound limit on the aircraft, I kind of would have assumed that most people would take all of that. They'd want as much battery, they'd want as much strength and frame and so forth. And I'm surprised to see so many of the competitors coming in at less than that weight.
And that's all just an analysis of what are the engines, what are the props, what is my design and my concept, right? And this goes back to that strategy question that we were talking about earlier. What is my strategy to win this race? And you see this in sports, a lot of the technical sports, if you think about Formula One or something like that, they have strategies, and then they also play the different races and the different courses in different ways. So when they go around the world and they look at a track, they say, all right, for this track, I need to tune this design. They need to change something. All of that comes into play in the same exact way here.
So Defend Techs is sitting in a pretty good place right now. We're hoping to see them get up. They have been getting an extension on the time before the flight window closes here on the first flight window of day 6 of the DARPA Lift Challenge. We will see what they can pull off as they continue to work. So we did see M-Tech go back up. Remember there. And look at this. This is 4.02. So they are not messing around.
That's what we want to see. We want to see them going for it.
And this is a scoring run. As you can see, the top right of your screen, that is in green. Their altitude looks good. And their distance right now, 0.33 nautical miles. Remember, they need to go 4 nautical miles with that weight, drop it off, and then go for another nautical mile. So this could be the one that would not only put them on top, but basically, Josh was setting some little aviation history as far as drones.
I think that's safe to say. I mean, if you questioned whether the 4.0 payload to weight ratio was like the right place to be, the fact that we see so many teams getting just to 3 or maybe the high 2s, but struggling to break 4, just says that that's a great challenge. And that says that if they succeed, they will have done something really, really notable in the history of aviation.
Okay, so we saw there, everybody who's watching the altitude now, we did see that they dropped down to about 98 feet. So this one will be reviewed afterwards. The lane coordinators there and that visual observer are looking at the Titan tablet. They are being notified, hey, you did go below. We will check it afterwards and make sure that the error in the system is appropriate and see if they actually broke that minimum altitude.
So is this like an election? Is that margin of error? You kind of are factoring that in?
We did. And like in sports analogies, we gave them that advantage.
Right.
So we're letting them continue. It's up to them if they want to stop or they want to continue. They're notified that they went down below that, and they have the system in front of them that they're watching as well.
Yeah, and just to be clear, they do need to be on the ground and finish their run before the end of the flight window.
Correct.
So there's
They were given an
perspective-
extension, 10:40.
Yes, before the end
Eastern,
of
yep.
their flight window.
Their flight window.
So they have the choice of, do we finish this run and take a chance that it's adjudicated not valid, or do we come back down, start a new run,
Correct.
and take a risk that maybe we don't finish
Yeah.
before the end of our window?
By my calculations, they've got 25 minutes, and they're 3 minutes into this one, and they've already completed 1 nautical mile. Keep an eye on that altitude. Again, not wanting to dip below 100.
We do see them making those turns. That 5 nautical miles is not straight out and back, because of course for safety reasons we don't want them flying over populated areas and so forth. So what's the length of the lane? Do you know that off the top of your head, Don?
1,100 feet.
So they're going out less than 1,100
Less
feet,
than
turning
11.
around, coming back again.
Back.
And they do have to make that turn in a relatively narrow space.
Correct. 100 feet wide, 100 feet high. So one of the good things here is we're not seeing the altitude.
Oh, no. And I think
Looks
that-
like they had a prop failure there. And that came down.
So the fact that they dip below 100 is now moot. And they're smiling. I mean,
They are.
they're smiling in their face. They completed 1.3 nautical miles with 129.4 pounds, which gave them the payload to weight ratio that would put them at the top. But unfortunately, you just saw what happened.
Yeah, we are pushing limits here, and when you do something that you know is possible, well, you just get in your car and you go to the grocery store, no drama. And then there's a certain excitement when you do something that you're not sure is possible, and then you do something that you're pretty sure might not be possible.
Right.
And either you succeed or you fail, but you're always learning stuff along the way. And
Yeah, so these guys holding their heads high.
Yeah.
Man. Oh,
Yeah.
my goodness. They were trying for, I said earlier in another interview, somebody said, are we breaking world records? And I said to them, there are no records.
Right.
Nobody thought
Nobody
that this
thought
was
about payload to
possible,
weight
right?
ratio.
Nobody thought this was possible. Nobody focused on this specifically. So it is a world record, I guess, right? But they're out there doing what everybody said was impossible. They sent it, they flew, they were working, and they had just a failure at some point in their system. We'll probably get a replay here in a second. From the first view that we could see, it looked like they had a prop come off. We'll look at it closely here. Yep. Actually, it looks like it's separated from the arm. So if we go back there and go slowly, it looks like the connecting point onto the arm. So remember
Maybe
we
the
talked
motor
about
came off?
torque. Remember we talked about torque in a traditional design. These motors are transferring that torque directly to the engine mount or the motor mount on the arm. So here we go, real slow. It looks like it sheared right off of the end of, yep, see that? The motor and
whole
the
motor
blade came off. It sheared its engine mount because of the torque that was implemented there on the motor mount.
Wow, just ripped it off.
Once again, these are all the factors, all the minute things. And what they're going to do when they go back to their hotel or even back is they're going to say, did I tighten that screw well?
Oh, you're always asking those questions, right, too.
Did I forget?
Yeah.
Did I
Did we
forget
miss
to
something?
do something? Did I tighten it? Did I put the Loctite on the screw? Mm-hmm. And they're going to go back and be racking their brains about it. But that was an impressive, hold their heads high for that. It's
For sure.
amazing.
Yeah, we see that with full-scale aviation incidents. There's always a massive data gathering and post-mortem process where you try to answer the question, why did this fail? And we're seeing that same thing play out here in a microcosm at a very accelerated pace.
Correct.
So Defentex was spinning up, and now they've shut it down. So obviously they were getting some kind of telemetry on the pad that said maybe everything wasn't working right, or maybe we need to tighten some screws. We don't want to be at 130 feet and realize that something wasn't done right. So they've got till 10:45. So they still have 25 minutes, enough time to get a flight. And here we go. They're spinning up again.
Let's take a look as they get into the air. Do they take off stable? Do they have any oscillation or wobbles?
Got 106.11 on the payload to weight ratio.
112.
All right.
Minimum.
So this is
payload.
interesting, right? So look at their vehicle weight, 18.4 pounds. They were flying at
weight.
10 to 12 pounds. They've added enough structure there to be able to, what they think is to be able to carry that 6.1 ratio.
It doesn't look like they've added 6 pounds of tape, does it? It looks like they put a lot of tape on there.
That's either a lot of tape, a lot of wires, maybe some stiffeners in their structures. But they are up in the air.
Gosh, I love to see air. You know, you see a drone fly, you see a plane fly, and it's inspiring. But in a sense, you've seen it before, and you see stuff like this, and there's a part of your brain that just that wonder that the original area aviators must have felt
Right.
when they saw airplanes in the air. It's like, how is this thing even flying? What is it doing? And it just fills you with wonder.
How quickly, Donna, do they have to get up to elevation?
That's right. I was about to cover that. So 0.5. So
Okay.
by 0.5 or half a mile, they have to get up into their altitude
Okay.
block. So they're doing it. They're doing great. They're doing nice and slow. They're not trying to stress their motors. They're using that whole half mile to be able to get up into altitude. Depending on how far the lane is, that's 3-ish laps, or actually runs up and down. So they have time to get there. They're not quite there at 95. We got the 0.3 up there, so they still have a little ways to go. There they go. They broke above it, 100. So they still have to go 4 miles, correct? And that's where that orange bar is on the right. But they are in their altitude prior to that 0.5 total distance, half a mile.
And once you cross that 100, you cannot dip below, even if you're under the 0.50?
No, so what we did is after the 0.5, you
Okay.
can't dip below.
Okay.
We knew that people would kind of be bobbling up and down
Settle,
on their
yeah.
way up, but once
Okay.
you get into that altitude block and after the 0.5, that's when the automated geofence.
Oh, no. Oh, they were just about to hit the 0.50, and then they weren't.
So it looks like they may have had a delamination on their prop there. We'll go back into the replay. So these propellers are composite material, and they're laminated. They use glue, they use heat. There's a number of different ways. I have no idea which way they did.
Right.
But once those structures, those materials start getting the forces that we're putting onto them, they can sometimes come unglued. And it sounds funny. It sounds
Right.
like a kid's project,
Yeah,
you know,
exactly.
right? But those are all the factors, and it's amazing in these couple of runs we've seen here. We've seen a number of different types of things happen. We saw that torque on the single rotor
Right.
in the tail rotor loss. We saw the torque on the engine mount, and here we'll see that right blade. Yep, see how it starts going
yeah.
up?
Forms like a V or
Yep.
a U shape.
So
it's still going.
It either snapped there or started to, right? That's when we talk about elasticity of the structure or the composite, it looked like it bent up a little bit, and then the
coming back from
aircraft
that.
kept going, and for a minute it still maintained control.
Yeah.
The other 3 props were able to maintain the control, but afterwards it was not able to do that.
Donna, there's a quote from one of the old FPV pilots. He said, "Never fall in love with your drone." and I think
That's great.
I'm curious what that quote means to you. To me, it means the drone is a tool.
Correct.
If you fall in love with it, you won't take the risks that you need to take with it.
That is 100% true, and especially in a competition like this,
Yep.
right? You've got to be willing to go out there and do that kind of work and that kind of risk, even though you have, as you said, an emotional connection to this piece of machinery that you have
Absolutely.
poured your life into, that you've poured hours and hours. A lot of these guys were talking about, their wife and kids and how, like, hey, they haven't seen me for 2 months because every hour I've been working on this thing. So the whole family commitment to design and innovation and competition has come into this event.
So they obviously cannot go out and retrieve that while the flight window is open.
Correct.
They have had backup drones in the past. Is that something, since it it was a rotor and not something major structurally as far as the frame as we've seen. You think they can fix it and have it ready to roll tomorrow?
It depends on their spare parts, right? So actually, when it crashed, we'll call that a hard landing. When it performed a hard landing on the field, it didn't look like a lot of the structure was damaged. We'll see. The team will have to look into that. They'll look into their spare parts inventory and see if they have an extra rotor or a propeller, and we'll go with that.
And then the follow-up question I have for you would be this. Why did they go so big on that payload to weight ratio? Why not just eclipse the 4?
Here we go. It looks like maybe one of those arms snapped. We'll have to see if they have an extra arm in the inventory. So once again, this goes back to that strategy, and I love it that people looked at the rules and said, like we've talked about before, there are many ways to skin the cat. And in this particular case, they took an inventory of their idea and then the hardware that would make that idea happen. And they said, okay, we can either go to the 55 pound upper range, or we can go to the opposite direction. And I know from talking to this team, they did test at home and they flew 16-to-1 ratio. Now that's everybody says these things, and that's why we have a competition to actually come out and prove it. Maybe the environment out here, the wind, the weather, the heat is affecting them differently. But they just took that strategy. They said, okay, I'm going to go the opposite way. I'm going to look at that 110-pound limit and see how light of an aircraft I can do, because the main focus is that 4-to-1 ratio.
I feel like, though, if they had completed that run, is that a mic drop incident? Like, good luck, everybody.
Yeah.
You're not catching this.
Bye-bye.
Going back to that question of how do you set your weight, and then as they're adding weight to try to make it stronger, you've got an aircraft and it's got a given total weight, whether that's 55 pounds or in this case 18 pounds, and then you make a decision about how much of that's going to be structure versus how much of that's going to be fuel or battery. If you add too much structure, now you have weight that is not contributing to your endurance. If you add too much battery, then you have weight, but the frame is too fragile. And figuring exactly how you want to split that up. It's not like you can just arbitrarily add weight to make it stronger, and then it won't finish the course. So this is a very, very difficult engineering problem to solve.
We want to thank Philip Smith, call sign Donna, the program manager, for joining us. He got called in, so he got called to work. So they make the decision. We can't tell you. Yes, we can tell you the flight window has been closed for this first session of the day, or flight window of the day, and we are scheduled for a busy day. We've got 63 flights scheduled, and now the retrieval can begin as we are on day 6 of the DARPA Lift Challenge here at the United States Air Force Museum here in beautiful Dayton, Ohio. Todd Harris alongside Joshua Bardwell, Elena Buenarrostro also down on the flight line. Pretty exciting stuff. I mean, it's always great when you have the chief of staff and the program manager sitting right next to us getting all the questions answered, but the potential is there. We saw some amazing things go up. They came down, as Donna said, hard landings.
Yeah, I'm thrilled just as a spectator, not just a commentator, to see the teams going for that 4.0 payload to weight ratio, and it's just been such an exciting morning.
Maybe people might ask, why do they do this? Because they can. And today they really pushed the limits early on this morning. We've got quite a bit more going on. Again, 63 flights scheduled today. We'll take a look at the leaderboard as it stands right now. Avidrone, who we saw still out in front, and they are leading with a 3.84 payload to weight ratio. They tried to do 4.02. It ended spectacularly, but I have a feeling they're going to be back.
Oh, I'm sure. If they're capable of being back, I know they will be. And that 4.02, hey, that 0.02 is enough to get you into the full $2.5 million first prize. Right now, they are in first place, but because they haven't broken that threshold, they're only getting half the first prize.
Okay, Extreme Aerial Concept sits in second. H Squared sits in third. And these are the chasers. And we saw Defentex moments ago, the combo team from Australia by way of Moab. They tried a massive weight, and I guess the question is, go for 4.01. I don't know if that would have made the difference.
Well, the challenge is they're not allowed to. They wouldn't be in the money with less than 110 pounds.
Right.
So they could add weight to their craft,
which they did. They were at 18 pounds,
and that would reduce the ratio. They would have to add a lot of weight to get down to 4.0, though, and it would just seem like it would completely re-engineer their craft. So I think they don't have too many options.
Yeah,
they have to go big. But of course, if they complete a run at a 6 or even a 9, it sure seems like that would be a shoo-in.
Defentex went 6.11 on their payload to weight ratio, but they also came down with a heavy landing here in Dayton. So we've got much more still to come. Again, we are flight loaded today here on the penultimate day of the DARPA Lift Challenge. Before we take a quick break, your thoughts on that first flight window?
Yeah, well, the two things I saw novel ideas trying to swing for the fences, as I've been saying, and not making it. And then we saw the established leader with a traditional rotorcraft design just trying to turn that knob up from 10 to 11 to maybe 12, hitting these design limits. But, of course, finding these design limits is what it's all about.
All right, so we will give ourselves a chance to get some hydration, get a little shade, but we will be back in less than 30 minutes as we get things going for the next flight window here at the DARPA Lift Challenge. It's been a beautiful day so far, a little breeze coming through, clouds, but we look like we are good to go in 30 minutes. Time now for another DARPA Lift Challenge tech discussion. Let's take a look.
With the DARPA Lift Challenge, we want to rewrite the economics of flight by creating vehicles that can carry 4 times their own weight, drastically lowering the cost of transporting heavy goods by air.
The mission impact here is substantial. Achieving this means smaller, cheaper drones can do the work of massive, expensive ones, making logistics faster and more affordable for everyone.
What we're trying to do in increasing the weight ratio is being able to find a way to be able to carry more with less. Every time you can increase your weight ratio, you can do more.
The whole point here about bringing that payload to weight ratio is really focused on bringing the cost of vertical lift aviation down. If we can be 4 times more efficient, maybe it can be 4 times less to transport something, to move cargo, to move people. That's what the DARPA Lift Challenge is looking to do. We are looking to make vertical lift aviation accessible to the common man, which will then change the way that we live and improve the lives of everyone around us. Ultimately, the Lift Challenge hopes to spark a new revolution in heavy lift, making the sky a viable and affordable highway for a new generation of air cargo in virtually every sector.
You've got to stay above 100, stay below 200. If you dip below 100, the run automatically comes to an end, and that bird better stay clear.
I probably wasn't as close as it looked.
We had an excellent flight. We have been increasing the weight over our last flight. So I think right now we are carrying one of the most payload, roughly around 180 pounds. Also, we don't show the number 1 ratio right now. This is because our aircraft is 55 pounds. There's other aircraft, but I think all the competition is carrying now cargo loads around 120, 130. So we are leading in that number. But of course, what counts really at the end is the metric ratio. Right. So we work on this, and we will see. We have another flight slot tomorrow morning, and then we do our math, and maybe we will show some more.
Obviously, the hard deck is not in play. Seems like they're bringing it down.
Yeah,
Ooh, a little wobble there is
pretty
not.
quick.
Oh, they lost the weight, and it jumped back up in the air as that weight freed itself. The pilot maintained control expertly.
I don't know.
No, that wasn't on purpose. No, sorry, that was not on purpose.
But you never know, like when you start going, how the position control stuff is going to go. So, lost too much altitude in one of the far runs, and it kind of just barely breached over there. So, had to bring it back, and then wanted to do some more tuning, and you guys saw how that went. It was coming down a little too fast, and even though I was 100% throttle, I still couldn't keep it from hitting the ground. But it didn't hit the ground that hard, because all it did is really break the straps, and then as soon as the weight is gone, that thing has a lot of power, so just shot straight up. So, but we're all good. Everyone's safe. Everyone's all right. I think I'm gonna give it another try I have a second drone actually, and I have another battery. We'll try to crash it again or do it successfully.
Nice and stable, and hopefully we see it touch down right on that landing pad. Beautiful. Oh, yeah.
Oh, he's going to put it right in the center. Now you're just showing off.
Oh, yeah. Well, you got to do it. You got to do it.
So there you go.
That looks to me like a successful run and a new leader.
New leader in the clubhouse. Avidrone out of Columbia, Maryland.
So as a lieutenant colonel in the Marine Reserves, with my history of aviation and being a pilot, this challenge is more than just a breakthrough technology. There's a phrase in military parlance that says, amateurs talk tactics, professionals talk logistics. If we can democratize logistics, if we can spread that around through the ease of vertical lift aviation, if we can make it more economical, there's a military advantage there that is almost indescribable. We don't know what the limits are or what the possibilities are because we've been so constrained in our current way of thinking. When we first invented helicopters, it opened up entirely new mission sets and capabilities. What are the new mission sets that we could open up? What are the new possibilities, whether it's offense, defense, life-saving rescue missions, disaster relief, all the different mission sets that we have, what can we do next? By making this breakthrough, we open the opportunity to the military community to rethink how they fight and act in warfare. And that, for me, is what matters most for this challenge.
Imagine crashing 1 million drones to find the perfect design. Sounds incredibly expensive, right? Now, imagine doing it without breaking a single piece of real hardware. That's the power of advanced simulation and modeling for the teams competing in the DARPA Lift Challenge. To build a drone capable of lifting 4 times its own weight, you can't rely on old-school trial and error. Every fraction of a second and every ounce of material must be optimized. Teams are testing aerodynamics, pushing materials to their breaking point, and simulating weather conditions entirely in the virtual world. The ultimate flying machine doesn't start in the sky. It starts with accurate simulation.
This has been an amazing experience so far. Everyone's kind of competing against the competition and not each other. People just laughing and having fun.
Oh, you gotta stop giggling.
What just happened out there?
We're testing the limits, so we found it.
Now you're just showing off.
The camaraderie has been amazing. Coming together day after day, how do we do this? And we've got that respectful disagreement, which is what you need for a team operating at this level. People are contributing ideas, critiquing ideas, providing feedback.
I'm glad just to be here. Just being able to talk to everyone and see everyone's cool drones is really amazing. You're never bored here.
I can't emphasize enough how friendly everyone is here at this competition.
This has been a wonderful environment. People have come and talked to us about their projects and their issues, and we've gone and admired and complimented a number of those other ones.
People have been hitting us out for parts, and we're happy to share when we can.
It's really compelling just seeing everybody rolling with their own little punches, and you try and overcome it and you find the workarounds and you make it work, and you sort of see how that plays out for everybody in their own little story.
The MacGyver team shows a better ratio, but the battle goes on. So we will see. We're watching the others as well, but his team is very professional, doing straight flights, no vibration, professional loading, unloading. So I think they got a lot of experience.
Seems like everyone's doing really well and everyone's going to give us a run for their money. So
DARPA is all about pushing the boundary.
You're going to be plenty of opportunity to raise the aviation to the next level.
We push the limits, and that's one of the exciting parts about this event. We got some amazing talent, and they're all digging in right now. I'm watching one team that's 2 spinning airplanes, which is crazy.
I'm really excited to be here. This is kind of a dream come true, to be honest.
Pretty happy to be here. We have a lot of good teams that we're competing against, and it's good to learn what other people are doing and see where we fit in this landscape. Teamwork makes the dream work, and we're doing well here.
Teamwork makes the dream work.
I would not have my summer any other way. This is what I want to do right now.
Every day is a good day so far at DARPA.
All right, let's go.
So why is now the right time to tackle this? Because we are witnessing a unique convergence of technologies. Recent breakthroughs in advanced materials, open source flight controllers, and rapid computational modeling have fundamentally lowered the barriers to entry. The cutting-edge tools that once required massive traditional research facilities are now accessible to independent innovators. The technology has caught up to the ambition, making this the perfect moment to solve this challenge.
The actual reality of what you can do with a 3D printer is astounding. You can make structures that were impossible to create 10, 20 years ago. Or you can also make structures that were only able to be created at very, very large companies with a lot of money.
Now, anyone can pay for inexpensive software to use the computer to design something that just comes off of their imagination and run some simple analysis codes. It's enough to get an idea going. Pretty quickly, you could do fluid analysis, you could do structural analysis, you could do stability and control without having an incredible depth of education.
Another aspects are power plants. So whether you're going electric with battery and motors or you're going internal combustion engine, powertrain dynamics has really exploded in the last 10 years as well. So not only the designs, the different sizes, variations, and all of that sort of stuff, but the availability of it. You can jump online, buy something, and have it at your doorstep in a week or 2 weeks. That wasn't able to be done just 10, 20 years ago. So when you have all of these factors combining, you have this ability to innovate and to change the way that we have designed, built, and flown aircraft compared to the last 50 years of aviation.
Welcome to Avalon Aero's hangar, so come on in, guys. Here's Jack, team member. He is our controls and avionics expert. This is John, lead design. I'm Alec Onesin. I do most of the manufacturing, but we all work on a little bit of everything. This is Excalibur, which is our counter-rotating coaxial system. So we have two rotors stacked on top of each other that spin in opposite directions, which gives us yaw control. And if you notice, we don't have a swash plate, which is essentially kind of like the transmission and steering rack of a traditional helicopter that has this configuration. So we've completely dropped the swash plate, and we use a physics-based design. And we have encoders here that read our positional inputs, and then we change the speed of our motors using Jack's very fancy software. And that kind of allows us to pitch and yaw and roll, which gives us 6 degrees of freedom with really limited mechanical complexity. So super light, very low amount of components, and pretty easy to put together. So that's kind of our design philosophy, is keep it simple.
Welcome to Dayton, Ohio.
This is the birthplace of aviation. This is the home of Wilbur and Orville Wright. This is the place where they flew their first practical airplane in 1905. And now we're pleased to have you here as we take the next step in aviation development, the DARPA Lift Challenge. For the United States Army, Wright Field was the Army's aviation development center all the way through World War II. At this airfield, the first fully pressurized aircraft in the United States was flown by the United States Army. This is the airfield where the first woman flew a jet aircraft in 1944 off of this field. This was the Army's development center, so fitting into the DARPA development mission, easy fit.
Being here at this museum is amazing. It is filled with design innovation from brilliant minds who have thought outside of the box. For me, this journey is personal, this competition. My grandpa was a pilot, my dad's a helicopter pilot, and then I joined the Marine Corps and became a Harrier pilot. Aviation is in my blood. I have a passion for it. I love it. This challenge is not the end for me. I'm going to keep on going, keep on pushing the limits, and hopefully helping you guys push the limits as well.
I will venture a bet that in less than 5 years, this museum will have its own hangar for drones, U.S.-made drones. And I think that the DARPA Lift Challenge will have a big impact on making that happen.
What's exciting for me is to think in 20 years, how many more designs will be around these hangars? How many will be here that were inspired by this challenge, by the things that you brought, that the teams brought to this challenge? The future is being created, and it's going to be celebrated in these hangars for decades to come.
Flight Fest going on in the distance. You see the RC planes going.
Yeah.
Just.
Wow. So the event, the DARPA Lift Challenge,
so
is
cool.
co-located this year with one of the biggest RC flight festivals in America, Flight Fest. And we're looking off in the distance. It looks like they're doing some kind of a fighter jet fly-in. We got all these RC. Those are RC fighter jets, for the record. It can be hard to tell the difference on camera. And they are flying around, and it is just majestic. Just really makes you appreciate the beauty of flight.
RC radio control?
RC radio control, that's right.
Yesterday they had about, I don't want to say 50 or 60 of those up in the air, and they were literally doing a demolition derby.
Yep. They do a thing where everybody puts they'll have 70 aircraft in the air. They'll crash them into each other, and last man standing wins.
Oh, man.
Yeah.
That's cool stuff.
Yeah, it's pretty fun.
I've been to the Air Force Museum many times. I love it. This is the first time I've been to a Flight Fest. I love it. So we're going to split time between this and the museum depending on how my strength holds up. But I think this is fantastic. And to see so many sharp-eyed young people along with some older people, it really makes you feel great. And actually maybe a little intimidated. But it's great. I'm having a great time. I'm buying souvenirs and making memories of my GoPros. So if I end up in an old folks home, if they let me have my computer and my drives, I'll be a happy creature. I can just relive all this. But it is wonderful.
When they decided to have it here, I was like, oh, I got to do that. So all this stuff combined is like a massive festival kind of deal, you know. So it's really incredible. And like he said, all these kids doing this stuff is fun to watch. If I had the kind of energy they had, I'd be doing some of that stuff too again. But the gentleman in Arkansas makes these kits, and of course you just paint them up anyway, which is a simple design with a motor back here and a battery up here, and just kind of a delta wing type plane. But they fly great, they're fun, they're tough. You can go out there and crash them up with people and still fly it some more. And but they're called a wild hog, and it's kind of an interesting little flying rig, you know. Have you been out here when they're doing the combat? That is so much fun to watch. I mean, and they don't care. Those kids don't care to tear that stuff up and take it to a tent and fix it and bring it back and do it again. It's like, you know, we spend a little money on this stuff and go, ooh, I don't know if I want to tear that up or not, you know. But it doesn't bother them one iota.
So, right now, I was in combat. I don't know if you saw it, but I was doing pretty good. I took down 3 in the last combat and 2 in the first one. And the nose got pretty much obliterated. So I'm putting it back together. Last combat, I had like a few things I had to glue back together. And this one, the entire nose is kind of destroyed. So This has taken a little bit longer. He's one of our friends. We met him here a few years ago. Is this your fourth too?
I think it's my fourth. This is my fifth. This is the fourth that we've been hanging out.
Okay, this is my fourth and his fifth year. It's a lot of fun. The people here are great and really nice.
I had a monster truck just laying around in the garage. I got it for my 3rd birthday, and I decided to make it fly. Yeah, this is an old wing that we got from our neighbors last year at Flight Fest. I put ailerons on it, 3D printed a motor bracket, and a bracket to hold the tail boom. And the tail is an FT Legacy tail, scaled up 15%. And that's pretty much all I did to it. And it flew great. The first few flights weren't the best. We had to stiffen the shocks. But other than that, I mean, flew pretty good at the end. This is our 4th Flight Fest. It's just fun to be here, and it's just cool to see all the projects and just build fun stuff like this.
My favorite part about Flight Fest is building planes because I like to see like trial and error and to see which planes that I make better and better each year.
So we got these planes right here that we're working on, and it's pretty cool. It flies really good.
Your favorite thing going on here in
the plane and the ice cream. The ice cream was so good. The ice cream was so good, especially the cookie and cream.
The cookies.
And then I just made a. Wait, no! I just made a plane. It had a propeller on it.
Okay, Yash, do you want to finish? I think he lost his... So, yeah, my husband is here and we are having great fun in Flight Fest. There's so many activities for kids. They're getting really good experience, like building stuff, and it's great. All the arrangements are really good over here.
So I just made a random thing. I don't think this works. I tried it. So you just put it in here. This does not work. This thing does not work, but this thing does. This.
Kids already enrolled in that we are.
Since the beginning of aviation, once we solved the basic problem of flight, one of the early applications of aviation was to move things and people around the world. This is a continuous evolution of what aviation originally started out to be. I can't think of a more interesting challenge. Today, when a drone can lift basically its own weight, the challenge of saying, let's see if we can get somebody to have a drone lift 4 times its own weight is a massive jump forward. This is classically what DARPA does, is to ask and say, how do we take not just the next step, but the step after that?
With aircraft, you have a lot of room to have a significant impact. A small reduction in weight has a significant impact on fuel consumption, on the amount of distance that you can travel, whereas it's not as impactful on a ship or a car. Anytime we expand the capability of a vehicle system and make it better, stronger, faster, then now you have the ability to provide more food. Someone needs blood, you can provide support medically. Someone's in trouble, you can support them from air to ground. There's just so many aspects of increasing the capability of what you lift that helps every aspect in the military.
When we first invented helicopters, it opened up entirely new mission sets and capabilities. We have a new floor of performance characteristics. What are the new mission sets that we could open up? What are the new possibilities? What can we do next? By making this breakthrough, we open the opportunity to the military community to rethink how they fight and act in warfare.
I am Vaughn Newman with the TAM Air DARPA Lift projects. We are a high school team based out of the San Francisco Bay Area in California. This is mostly a project for fun because we wanted to see if we could do it, and this is our drone that we came up with. We came up with a coaxial, counter-rotating, helicopter-style drone. We have custom-made swashblades right here, which one of our teammates designed. We've got planetary transmission, and we're running off of a Desert Aircraft 170cc two-stroke engine. We weigh about 35 pounds, give or take a couple, with gas, and we are very hopeful for our lift to weight ratio being above 4-to-1 this year. Our rotors apply to our rotor heads here and down here, and they counter rotate, and they stick out about, each one is about 4 feet in length, so we have a diameter of about 8.5 feet, including these rotor heads and clamps. The drone name is Tinkerbell, because it's pretty light, pretty dainty, and it can lift a lot of weight. So that's our name we came up with. We've had a couple of issues here and there, but we've been very resilient and have overcome everything so far, and I think we will continue to overcome every challenge thrown at us. It's a pleasure to be here also. I mean, it's so nice that DARPA hosted this for us and put on this challenge so we can go out and try to prove what was previously thought impossible possible.
Through this competition, I'm hoping to find new powertrains, new aerodynamic designs, and new combinations of things that were not thought of before. So when the next aircraft designer gets up there, instead of just saying, I'm going to do what has been done for the last couple of decades and make it slightly better, they now say, well, wait, all of these other things are possible. With these ingredients, what can I do that has never been done before? And what we're seeing out here over the next couple of days is pure innovation, unbridled, and it's just amazing to be a part of.
Scientific engineering failure is a great thing. It's the way we grow. As scientists, without making mistakes, we don't learn to understand what the fault was. So the more you make the right mistakes early and learn from them, the better you are in the long run. Success for me is inspiring the community, not just the military community, but the public on trying to come out and do something that they're willing to try that's never been done before.
What I'm looking forward to once the Lift Challenge is completed is reflecting back maybe next week, a month from now, maybe a couple years from now, and knowing that I had a small part and role in making history.
What I can't wait for is the product of that. What's going to happen in a year, 2 years, 5 years, 10 years? I can't wait to see what comes out, what industries are made because we make this breakthrough, what new capabilities and companies and organizations sprout from this challenge right here. Being here at this museum is amazing. It is filled with design innovation from brilliant minds who have thought outside of the box. DARPA has been a part of many of these designs that are on the floor, on the ceiling. It's really exciting to know that the top 3 performers out of this challenge are going to be here. They're going to be displayed. They're a breakthrough. We are making history at this challenge. For me, this is just a stamp in time, this one challenge. What's exciting for me is to think in 20 years, how many more designs will be around these hangars? How many will be here that were inspired by this challenge, by the things that you brought, that the teams brought to this challenge? What does that future look like? For me, that is more exciting than this one point in time, this one challenge, and the week of flying that we are doing. The future is being created, and it's going to be celebrated in these hangars for decades to come.
I told my wife the other night, it's probably one of the best experiences I've had. It's been interesting seeing everything that could go wrong. We've been able to figure out, really satisfied with our progress to today. We achieved more than we expected coming in.
And the 11 a.m. Eastern flight window is now open here in Dayton at the National Museum of the United States Air Force. Alongside Joshua Bardwell, our drone expert and YouTube educator, coming up on 500,000 followers. Come on, now you're just showing up. I'm Todd Harris. We've also got Elena Buenrostro down on the flight line. Glad to have you with us. The sun is out. Earlier, if you're with us on the 9 a.m. flight window, we saw a lot of great stuff. We almost saw history made, JB, but we came up just short. But that means that today and then Super Sunday tomorrow, they're going to deliver.
Yeah, I sure hope they deliver. All these teams looking at how many remaining flight windows they're going to get, how many remaining attempts they're going to get, and gauging just how hard they want to go to try to either raise their standing or break that 4.0 to 1 payload to weight ratio.
You know I'm going to ask you, so I love me some weather, but these conditions look a little bit better. The wind's not as gusty as we saw about an hour or two ago.
It's shifting a lot today. We definitely had some clouds roll in and wind kick up. And that definitely makes a difference in the strategy of, do you go now and risk it, or do you try to wait for conditions to maybe or maybe not improve?
All right, remember, they're all trying to get to that 4 to 1 payload to weight ratio. If you do that, you're looking at a payday of $2.5 million, something that has never been done before, something that a lot of experts thought it would never be possible to do. But now you're a believer.
Yeah, when I first heard about this challenge, the 1 to 1 payload to weight ratio is pretty typical for everything from small drones all the way up to full-scale helicopters, and I thought 4 to 1, that's just too much to ask for. And DARPA is certainly, and these competitors are certainly proving me wrong.
Let's talk about MTech. Obviously, they had a great run yesterday. Upon further review, it was determined that it was not a scoring run. They came back out today and then matched it, and they're back in second place.
Yeah, I'd like to say if you do something once, it might be luck. And so if you do it once and somebody says do it again, you just say, all right, I'll do it again. And that's what you love to see.
And they are literally knocking on the door of that 4 to 1 ratio because they're at 3.64. So they've got the rest of today and they've got tomorrow to make the magic happen.
That is correct. That is correct. They're trying to improve.
All right. So get yourself a nice seat, settle in wherever you are around the world if you're watching from home. As again, we'll keep an eye on MTech and see if they come back out and try for a 4 to 1 payload to weight ratio to get it done. For more on the MTech story, we check in with a third member of our broadcast team. Here is Elena Buenrostro.
All right, I'm here with MTech. Luke, tell us, what was the strategy going into the run just now, and tell us what happened.
Yeah, so it was pretty crazy. Essentially, yesterday we did a run at 3.4, but it ended up getting disqualified for a couple of reasons. So today we had to rebank a run because at the moment we had nothing. So we went a little bit conservative. We went for 3.6, still a bit higher than yesterday, and all went smoothly. It looked great. It's flying solid. We think we tried as much as we can to follow all the rules possible. I think they're still reviewing it, but hopefully it goes through. And then once we did that, we decided to push it a bit because, I mean, that's what we're here for, to push these drones to the max and find the limits.
And the magic 4 to 1.
Yeah, the magic 4 to 1, which I think has led to 4 crashes now from some of the leaders. So maybe it's a 4 to 1 curse. But essentially, we just stressed our parts too much, and the motor mount, it looks like it broke off mid-flight. And if the motor mount breaks off, it's never coming back from that. So
could be fatigue from it, because this one's worked quite hard now. Yeah.
It has, yeah. So I mean, that's what happens. We had a very dramatic fire, which was quite entertaining. I'm honestly not that too fussed about it because we're used to breaking drones, and if you're not breaking them, you're not pushing them hard enough. So it's cool.
I'm very sad.
We do have another drone that's not actually finished yet that we're still working on. So hopefully we can have that ready by tomorrow to go for another run. Maybe we can hit 4-1. We will try our best. So yeah, we'll have to wait and see what happens.
All right. And what would you say has been the whole experience today, just going into it and then walking away from that crash?
Oh, if I had to put in one word, I would say it was very exciting and very stressful. I mean, overall, great experience. Like, we're here to push our drones to the limits and find these limits, and we're finding them in a very spectacular way. But overall, you know, great experience. We are very happy we're able to secure, you know, a confirmed conservative run, everything going smoothly. So we're trying to push it to the limits. We found these limits, and now, you know, it looks like it's going to be a long night for us. And you are going to hear back from us tomorrow. So we're not done just yet.
All right. Well, we're looking forward to it. Back to you, Todd.
All right, thank you very much, Elena MTech, and we can confirm since that conversation they did get certified. This was the crash earlier when they pushed it at 4.02 JB, so they literally are pushing the limits. And as they said, if you're not breaking drones, you're not pushing them hard enough.
Yeah, Luke Bell, no stranger to pushing limits. He and his father have held multiple drone world speed records with drones they built at their home. So he is right in his wheelhouse here.
And they come to us by way of South Africa. So there is the current leaderboard. Avidrone on top. 3.84 is their payload to weight ratio. Just behind them, MTech, who Elena was just speaking with. Then you have Extreme Aerial Concepts at 331. H Squared at 296. And MacGyver, top 5 at 2.51. So you've got a lot of teams out there on the flight line as we get ready for the 11 o'clock a.m. Eastern flight window here at day 6 of the DARPA Lift Challenge. Beautiful day here in Dayton, Ohio. If you were with us yesterday afternoon, it was cut short because of Mother Nature not cooperating. Heavy rains, heavy lightning, heavy thunder, to the point that even Joshua Bardwell had to shelter in place. They wouldn't even let him out to sign autographs. So we had to wait for the rain to clear. The grass is a little soggy, but other than that, a little bit of damage. As Donna said, a tower got hit by some lightning, but that was quite the electrical show.
It was quite a show. Today, of course, we're glad the ground is wet. We had a couple of drones crash, a couple batteries light off, and that stayed well contained. The fire and safety team, of course, always on it.
As we told you at the top of the broadcast, 9 o'clock, we've got 63 scheduled flights, so we are flight heavy today on the program. The penultimate day of the DARPA Lift Challenge is going on all week long. Tomorrow we'll wrap things up with Super Sunday. Hannah Monton, the team from Foster City, California, they're out on the flight line as well. And they have shown some serious promise.
Yeah, a lot of promise from a lot of these teams in the chasers category. But promise, ultimately, you can show promise all you want, but you have to get a score on the board.
So let's head over to lane 4, another team we can take a look at as they get ready. And again, one of our favorite designs. This is Skyweaver out of Menlo Park, California, in the Bay Area. Another one of those 2 fixed-wings aircraft hooked together by a cable. And if Joshua and I both fall asleep during it, it's so mesmerizing. It's like watching a lava lamp in the dark.
And Todd, I never thought I'd see the day when I would see not just one of these really just wacky off-the-wall designs, 2 airplanes tethered by a steel cable, but now we have 2.
Yeah.
So it's like
we'll see how this all plays out. We will tell you that it has been a little bit gusty, not as bad as it was this morning. The temperatures were much cooler when we came on the air at 9 o'clock. Temperature is coming up, and the wind is dying down just a bit. So this is some great flying conditions. We'll take you now over to lane 1 on the flight line. And this is Aptos Air. This is the team out of Berkeley, California. Engineering studio based in the Bay Area. Jean-Francois Clavreul is a mechanical and aerospace engineer with 25 years of experience in designing and prototyping fun vehicles. And that vehicle, I don't know if I'd say it was fun. It looks like it's up to the task. I will say that.
Oh yeah, these guys are having fun. Yeah, as we look at this, we have 2 counter-rotating rotors to counteract the torque of each other. And then the other question that I find myself asking is, how are they driven? Are they tip-driven with motors or some other form of propulsion along the edge of the rotor, or is it one central motor? We certainly don't see a central motor, so we could speculate that they are tip-driven.
Let's bust on down to 12, lane 12. That'll be Proto-Carbon. You see their team down the area from the Coeur d'Alene, Idaho area. This is a team, and I had a chance to speak with them in the prep area. They drove from Coeur d'Alene, told me all about the cross-country drive, and they were missing one part, and they're waiting for that to come in. But this is a pretty small operation. Get a chance to speak with their owner, John Brendel, there on his hands and knees trying to make the final preparation. So he's an experienced composites engineer who's contributed to multiple space vehicle programs. And now taking his chance here at the DARPA Lift Challenge. You notice, if you've been with us all week long, they've painted red circles on the plywood landing areas, and that's not just to get artsy. That has real application, real purpose.
Yeah, the landings must be within that circle. Obviously, if you can fly a craft, it doesn't really matter if you can't safely land it where you mean to land it. So for landings to count, the center of the weight must be within that circle, and just making it a little bit more clear. Well, obviously not to the adjudicators who will know what they're doing, but to the audience and to us as commentators, whether the craft has landed inside that circle or not.
So we'll keep an eye on Proto-Carbon and the rest of them down on the flight line. Remember, the flight window, roughly 90 minutes. They can be given an extension if there are some extenuating circumstances, if the RF signals are killed or something with the Wi-Fi. We were set back 10 minutes. They will give them a little extra time, but roughly around 90 minutes for this next 11 a.m. flight window here Eastern time. So busy day today, the moving day as we like to call it, because tomorrow it's all about Super Sunday and it's time to step up. I want to see someone force Donna to write a big check. I'm just saying.
Me too. I mean, the government gave him the money. Now he didn't want to have to give it back, is what he said.
Donna's boss is here, so I'm sure he would love to have both of them sign the bottom line. This is the team, again, from Central California, Hanawatan.
We've seen Hanawatan make several attempts so far, and they have struggled with various issues and haven't really been able to deliver at the level that they want to.
I know it's ease of accessibility, but in the future on a design like this, would you cable through the center of those carbon?
That's a good question. Everybody thinks that's the best idea because the carbon fiber arms protect the wires and they keep them neatly dressed. And of course, it's already a hollow tube, so why not use it? It does compromise your ability to maintain. If you break an arm, you have to take the motor off. You have to fish those wires out, disconnect them. And whereas if the wire's on the outside, it can be easier to do maintenance. Certainly, if you're building something commercial, you would want to make it as neat as possible. But for something,
and that's kind of what my thought process was. Is I have a bike, and it's wired. The component, everything's wired through the frame. It's a carbon frame, and so it just looks clean and well kept.
So we are definitely looking at something in the prototype category here, no doubt.
Pretty much everyone on the line's in the prototype category.
Well, I guess that's true. That's true. Some may be more prototypes than others. We have seen things like these loose wires affecting some of the teams. Some of the teams having issues with loose wires getting struck by the prop and having to land. And you're just always making these decisions. You go into a competition like this, and there are about 1 million things you have to do, and you just start knocking them off the top of the list. And sometimes you just I'm going to just tape the wires down. I'm going to put a rubber band on them. You think it'll be okay, and sometimes it's not.
We've seen tape. We've seen duct tape. We've seen make sure that screw is in tight enough. It has to be absolute laser focused attention to detail. The smallest rivet, screw, wire can doom the flight.
It's true, and yet there is, as I said earlier, a sort of a triage process. Which of these problems are the most important problems for me to solve that will most impact my success? Which of these problems can I just put off till later or maybe never because I've got other more important things to do? And sometimes one of those things you put off till later is the thing that knocks you out.
We've got some great teams that are supposedly going to show up here in the 11 o'clock flight window. Aptos Aero, the team from Virginia Tech University in Blacksburg, Virginia. Samara, Skyweaver, Coatless Rise out of Sandy, Utah.
Starting up that prop, you see them starting it by hand. Of course, the gas engines in our cars and trucks have starter motors, but that would be additional weight. And if you can start it by hand, well, why wouldn't you just do it that way? Like those old airplanes of yesterday.
Let's see what they can do. We have not seen, we'll see if good folks in the truck can give us a shot of this, watching them take off.
You also see he's got his feet on either side of that tail. So he's doing a spin-up test right now. He'll spin the motor up, but he doesn't want the airplane to go anywhere. So he just stands with his legs around it.
So here's my question to you, and it's probably a question that needs to go to Donna, the program manager. How does the platform landing apply to this team?
Yeah, so
they have to put one plane on each?
Yeah, so that was actually one of the problems they had to solve. Originally, they said you have to land within a 5-foot circle, but you look at some of these designs don't fit in a 5-foot circle. So the way they decided it would work is that the center of the weight has to land within the 5-foot circle.
I knew you'd have the answer. So we'll wait for Skyweaver to see if they will go up. Again, the 11 o'clock Eastern flight window is now open. Teams are on the flight line, and we hope to see some great action, possibly see some history made. We've also got the KC Space Pirates on the line. Ratio drones out of Austin, Texas are here. Somewhat Engineering out of Katy, Texas also in the house.
Todd, I can't help but notice, and I was wondering this, Do you see that they've moved those plywood squares off to the side for this? It sure looks to me like this flight system, they're calling it a flight system, is so large that if they were to put the weights on the plywood, they would be over the flight line. So I'm wondering if they have moved the landing point back to allow this system, this flight system, to stay out on the field and stay within the safe boundary.
Yeah, that'd be interesting to see Donna put together a platform with plywood to accompany and be able to facilitate their landing, but I don't think that's going to happen. So
this is just what happens when you start asking people to push the limits.
Yeah.
No one, I'm going to guess that no one from DARPA thought someone would show up with two airplanes connected by a 30-foot steel cable.
I bet if we ask really nicely to our award-winning director, Scott Barkey, he might give us a takeoff. That's what I want to see, because here's my question. Is as tall as the grass is that going to be a problem for them to get up to speed?
I bet it'll be all right.
Or do they lift right away?
I bet it'll be all right. There's an interesting question there, though. One of the requirements of the competition is that you have vertical takeoff. There's no allowance for a takeoff roll. They want straight vertical takeoff. But then how does that apply to a system like this? Well, the way they've interpreted it is that the system as a whole takes off vertically. The fact that these individual planes start rolling, you can think of this as if it was just a giant helicopter rotor spinning in a circle. And so when you see those planes start to do a takeoff roll, the system as a whole is taking off vertically, and that's how they're handling the rules.
Fixed-winged aircraft connected by that cable with the weight in the dead center. It's pretty amazing once they are up the way they move.
Oh, yeah.
As they move across the sky.
If you're just tuning in and this is the first you've seen it, it is, as you said, Scott, Todd, mesmerizing. So we'll see him.
Flight check. Here we go.
Yep, hand cranking that engine. Get it going there. Oh, not quite.
Getting word that lane 1 is also spinning up for a test flight.
You got to give it a couple flips there, get the fuel flowing. There we go. It is now spinning. And he'll now put his legs on either side of that vertical stabilizer and spin up the engine just to make sure everything stays smooth when you get up to throttle. You don't want to surprise yourself when you get in the air.
He's awfully close to a spinning prop, which makes me wonder, do you want to be that close, or is that a safety thing?
Yeah, the thing is, it's pulling away from him.
Okay, I wouldn't do it. But
so as far as safety is concerned, the sort of riskiest moment is that moment right after the motor starts spinning and you're still standing in front of it.
Correct.
A lot of times it just won't have enough throttle in order to pull the plane. You may have the plane chocked or otherwise affixed to the ground. Sometimes you'll have a second guy stand with his legs around the tail to make sure it doesn't move. There's various ways that they handle that.
So Skyweaver looks like they are set to go up. We'll see what their intentions are if this is a scoring run here in the 11 o'clock flight window of day 6, the DARPA Lift Challenge. This is Skyweaver out of Menlo Park, California, which is right around Stanford.
Yeah, we'll see
Quality University.
When they get in the air, if they've got any weight on there, this could just be a check flight. As we've said, they're required to do several check flights, one unloaded and one with half weight, again, just working up to that full weight, so that the safety coordinators will know that they are safe to fly.
So they've done their engine test, and it is now test complete. And we're bringing a table out, so maybe they're going to do something with the weight.
Well, again, I'm guessing it has something to do with marking the landing area. No, they're not going to the weight.
I don't think he's setting up for a lemonade and cookie sale.
Sir.
And selling some bazookies out on the flight line.
What do we got here? Now, Todd, I wonder if this goes back to your question about the grass.
Right.
If you turn out to be right about that, I will owe you $1. Now, a lot of times these aircraft are designed to take off from moderately tall grass.
Right.
They'll have landing gear that raise it up, and of course the propeller provides, in a pinch, the propeller will just cut the grass down.
Yeah.
Right as you go.
They can put me to work. I'll get out there and mow that down for them. Do a big circle.
The table.
I think he's put the table under that right aircraft.
It does look like it's done that. The thing is, if it's got something to do with the grass or providing a landing or takeoff surface, as soon as it starts moving, maybe he's dragging the grass down.
Maybe he's just flattening it down, yeah. He'll mat it down so nothing gets caught in the prop.
Interesting. Interesting. Todd, it does look like he's trying to mat the grass down. I think.
Don't tell me he's trying to do a crop circle in the middle of Dayton.
I think you might have been right about the grass. I knew you would be right. No surprise whatsoever.
A broken clock is right, twice a day.
Oh, look at that! Look at that fuselage! Look at that nose, that custom formed. You see some show up and it's just carbon struts.
Right.
And it barely looks like an airplane. That looks like an airplane. I'll tell you what. Of course, we're not here for looks. We're here for results, and that will ultimately matter. But it is nice to see such a cool-looking aircraft out there.
A lot of cool aircraft, especially if you go over to the United States Air Force Museum and see some amazing aircraft in those hangars, which is open to the public. There's Flight Fest going on also. Donna did promise another aerial derby.
Yeah, Flight Fest, one of the largest, perhaps the largest, although I don't want to say that without being sure, RC Radio Control Flight Festival in the United States. People come from all over the country to fly small, even large radio-controlled airplanes, and one of the things they do is a demolition derby where they put 70 or more planes in the air and try to crash them into each other on purpose. The last one standing is a winner.
Combat sessions right here in Dayton as the DARPA Lift Challenge rolls on, and it's pretty cool to see. Look at the talent.
Look at that aerobatics, flipping it around. Oh, yeah. Oh, yeah. That's one of the nice things about this kind of flying. These guys are flying line of sight, which means they're flying with their unaided visual eye as opposed to like a little camera and radio system. When you have an FPV radio system, there's a limit of how many you can get in the air because there's only so many channels you can use. Typically, you get between 3 and 8 pilots in the air at a time, which if you've got hundreds of people at a flight festival, that's not a great way to go about it.
I feel like you thought this through, like you're going to send a drone up with some radar signal jamming material on board yours and watch everyone drop out of the sky and go, yep, I'm the winner. It happened.
Oh, I'm sure nobody would do that. Yeah, but these guys flying line of sight are able to get as many as 70 or more airplanes in the air as long as they can keep their eye on it. And that is also how many of the pilots here at the DARPA Lift Challenge are flying. They're flying their aircraft by line of sight as well.
This is Aptos.
I see it creeping along.
Yeah, it's wanting to go.
Get her in the air. Get her in the air. There we go. Now she's in the air. She's shaking. We saw this the last time they flew as well. That shake is a sign that something is imbalanced.
And we're going to bring it right back down.
Yeah. You don't want to fight that out. That's not going to get better.
No.
It's probably going to get worse.
So they drop to the ground, 6-8 feet up, which is much better than 160 to 170 feet up.
Yeah.
And they will try to address that situation. Close enough, I think, to the launch area, they can go out and retrieve it.
Seems likely they'll be able to retrieve it, and they'll get her going again. And one of the things we've talked about is the challenge. You think it's hard to fly with 110 pounds of weight, and of course it is, but an aircraft that's designed to carry 4 times its own weight may struggle when it doesn't have any weight at all. And so we could be seeing that here. We could seeing them do an unweighted check flight, and if you can't get through that unweighted check flight, then you can't get in the air. But it's critical that you be able to fly unloaded. Of course, you have to drop your cargo off at some point and fly home again.
All right, so we continue to get prepped here on the 11 o'clock flight window here in Dayton at the DARPA Lift Challenge. While we have a moment, we want to give you some more insight. We want to pull back the curtains just a little bit so you can see what is going on with the fine folks at DARPA, the staff they brought out here, the number of people it takes to put on something like this. A lot of people have asked, when's the next DARPA Lift Challenge? Well, that's TBD, to be determined, but right now this is the one and only, and we had the good opportunity, I should say, Joshua Bardwell had the rare opportunity to talk with Ann Bush, the Air Ops lead here at the DARPA Lift Challenge.
Thanks for being with us, Ann. Running the command center for an event like the DARPA Lift Challenge means keeping track of an incredible number of moving parts. What kind of things is your team monitoring to keep things running safely and fairly?
So we've said this day in and day out. Safety is our main priority here. So as you can see behind me, I have multiple screens and a full staff here monitoring GPS, speeds, altitudes, everything to ensure that the aircraft are flying in a safe environment. And then, of course, the challenge is important too in maintaining that fairness. So that's making sure that we have the aircraft weights and the payload weights so that we can calculate that ratio, because that's really all we're here for.
What's the most challenging part of running the command center?
So as we've seen over the last couple of days, we have 15 active flight lanes at one flight window. So making sure that we're managing all 15 teams through our government experimental software Titan, making sure that all of the data is recorded, and teams are really supported by staff from the moment they leave their hangar to the flight line and back, and then just overall throughout the challenge. Lots of staff, lots of data, lots of flights.
Yeah. You've been watching this whole thing from the very beginning. If I remember right, you've seen every part of every run. So I don't think there's anybody better to ask. What has surprised you most about the event so far?
I think the most exciting thing for me is just the variety of designs that we've seen, and it really just emphasizes that we're here for innovation. Everyone got the same information, and they all came up with vastly different solutions to that problem. So it's really just exciting to see the pivot from quite literally lane by lane, hangar by hangar. Every team is different, and it's just really exciting to see.
And our thanks to Ann Bush, the Air Ops lead. JB, I'm surprised you got time with her because she has been so busy from the moment this thing opens to the second it closes. It's a massive operation, and anytime anyone's on the flight line or anything's in the air, she is laser focused.
Yeah, she is laser focused, and laser focused on safety, but also the scoring. She showed me the whole system that they have for tracking with the Titan system we talked about earlier. Everybody is monitoring and recording all of that data. There's just a bunch of screens up there. It's a heck of an operation.
You can see the expanse size of this thing. We're down there somewhere, center your screen. Elena Buenrostro's out on the flight line. And fortunately, we've got some really nice weather as the heavy clouds, like the darker clouds that we had yesterday around 1:30, have stayed away thus far. But that's all the prep area, the hangars, the production, the command center, all the way down to catering and the giant refrigerator, which I love to walk into. It's like 36 degrees in there.
Indeed.
All right, this is lane one trying again, and Aptos has got that same shimmy.
It hasn't gotten better.
It has not gotten better, so it's coming right back down and shutting down.
Still looks like they are a retrievable distance, and it didn't look like they took any damage to their rotors or anything like that. Anytime you've got rotating mass, and you have to balance it very, very carefully, or you get shimmy like that, and this is just a very difficult problem to solve.
I think you made a good analogy and compare it to when you have your tires and they're not balanced correctly and you hit a certain speed and it just starts wobbling.
Yep.
This isn't a situation where they could spin up the RPMs even more and lose that shimmy?
Well, it's theoretically, two things about that. One is that these large rotors are usually designed to spin at a lower speed, and that gives more efficiency, which is of course relevant to the challenge. The other thing is if you cross your fingers and speed up and it gets worse, not better, that could become catastrophic.
All right, so he has retrieved. He has placed it back center from the launch area as the 11 o'clock flight window continues on here on the penultimate day of the DARPA Lift Challenge. We will be on this flight window for at least another hour. Unless there's an extension, this will go until 12:30. But we are scheduled for 63 flights today, all trying to track down that elusive 4-to-1 payload to weight ratio. And then tomorrow, it's all on Super Sunday as we hopefully get to watch Donna hand out a $2.5 million check, plus some smaller checks, $500,000 to some of the superlatives like the most promising, most revolutionary powertrain, most revolutionary aerodynamic design. Those folks will all be voted on. Secret ballot by people smarter than me, and three of those people will be walking away with $500,000 individual investments.
Yeah, the point of those, I think, is that just because you didn't hit the 2-to-1, 4-to-1 ratio, or maybe you didn't even complete a run, you may bring a novel idea that is very, very worthy of attention and worthy of financial reward. The point of the competition is to bring all these people together, sort of shake the tree and have all these crazy ideas fall out and see which of those ideas have merit.
So you could sweep first place in all these superlatives, be the most revolutionary powertrain, most promising, and you can be looking at $4 million.
I mean, theoretically,
getting greedy, but
theoretically, there's no rule that says someone who places can't also get a superlative.
Okay, so you can get first place, 2.5, and a superlative, so you could be looking at a $3 million week in Dayton.
Yeah, I mean, obviously, the good folks at DARPA are going to make that decision. Just speaking for myself, I would hope that they spread it around a little.
Correct.
I'd love to see some of these teams who brought something really novel, really innovative, be rewarded for that.
So you can see the flight line there. It is stretched quite a way along that runway here at the United States Air Force Museum.
Look at that shadow from that cloud hanging over the field.
Okay, look at this. Skyweaver.
Getting that engine started. There's a very specific way that you flip that prop. You see he's got a glove on. There's a very specific way you flip that prop so that you don't hit your hand. The other thing is that it doesn't come up to speed immediately, so you have a fraction of a second to get your hand out of the way. But if you leave your hand out there, it'll get slapped.
All right, so we'll see if Skyweaver gets up in the air. And you'll love to watch this because it is a mesmerizing form of flight. So they got one engine fully spinning, just trying to get this second one going.
And the way he's starting it tells us that this is a liquid fuel engine, perhaps gasoline or some other liquid fuel, versus some of the teams that have come with batteries. Liquid fuel has a higher energy density, which you would think might mean it was just a shoe-in for first place. In fact, that would have been something I might have said before I got here, but we've seen a lot of teams with revolutionary battery chemistries and battery designs who are holding their own.
So Aptos back on lane 1. We're getting reports that they just spun up again. And similar results.
Yeah. And we need a lot of stability, not just in the rotor being balanced, but also stiffness in that shaft.
Yeah, still.
Oh, propeller hit the ground. I can't believe how many times they are banging this thing against the ground and it's just getting back up again. Yeah.
I'm giving Aptos the most durable award. Give them.
Yeah.
I don't know if I'll give them. I don't know if I'm going to give them $500,000, but I'm going to give them a few.
They're not giving up. They're not giving up. I mean, there's so many lessons that we're learning from this. I would have said if a helicopter rotor hits the ground, that's it. It's done. You're not taking off again. And we've seen them bounce it off the ground multiple times. Perhaps related to the large rotor and low speed, but just one of many lessons being learned here during this event.
So lane 3 is up and flying. That's the good news. We'll see they are unweighted, so this is not a scoring run. Hanumantum's up and running. This is the team from Northern California, Foster City to be exact.
The fact that they don't have any weight tells us that this is either an unweighted check flight or that they're doing some kind of testing. I would lean toward the former.
This is a team with a build by PhD scholars, engineers, and entrepreneurs. Their design targets a 4-to-1 ratio, unlocking defense, agricultural, logistics, and commercial aerial markets. So the good folks from Silicon Valley, they do know how to hover.
That's the first step. You got to be able to hover, get some weight on. So the way these safety check flights work is that before they're allowed to go out with full weight, they have to do an initial check flight to demonstrate that they're able to control the aircraft. The aircraft is stable. It stays within the geofenced area. Once they complete the unweighted check flight, they do a half-weight check flight. And then if those both pass, they will be allowed to put on full weight, as much weight as they want to, and make attempts if they choose to.
So 32 minutes has come and gone in the 11 o'clock flight window, so we are under an hour to go. Skyweaver has got the prop up and spinning. We just need them to head to the sky. Skyweaver out of Menlo Park, California. Syria, very close to Foster City, California, the same team as Hanumantum, who we just saw go up. This is lane 2, the Alpine team.
I believe we saw this aircraft lose one of its landing feet on a previous day. Looks like they got that reinstalled. Not hard. Everybody's brought spares. No weight.
So Alpine out of Fountain, Colorado.
And one of the rules that we've talked about is that if you have to repair your craft or rebuild it, you have to redo your check flights. It makes me wonder if even losing that landing foot was enough to cause the safety team to say, hey, you got to do it again. Rules are rules.
Looks like they changed it. It looked like those were black, the legs on there, and they changed it to a different material.
You can see the markers there. You've got pink or magenta on the right and blue on the left. Those are most likely orientation markers. As we've said, these pilots are flying via visual line of sight. With the unaided eye, they watch it craft, and of course with a craft like this where there's no obvious front or back, those orientation markers are key.
Well, while we have a moment, let's check on down on the flight line. And Elena Buenrostro, who talked with Skyweaver just a short time ago, got the skinny on the landing and takeoff plan. We've got our technical issues trying to get to her, so a lot of signal breakup in this area, as you can imagine. So we'll get back to Elena momentarily, but she has a report on Skyweaver and how they make this all work. Both props, though, JB, still going.
Yep, just idling those motors, doing any last-minute checks, getting ready to get in the air. Yeah, we've got a lot of wireless networks out here, of course, supporting the competitors and supporting the event. As we talk about flying with the unaided eye, you might think, well, wouldn't it be better to fly with a camera on the drone? You could see what was in front of it more easily, and that's true, but it also provides another point of failure. If anything were to mess with that radio link, you would lose orientation and have to have a contingency plan for that.
And Donna, the program manager, spoke to us about that because of that RF breakup and signal loss here and there. Every now and then they may dip momentarily below the 100-foot base threshold, the hard deck, but I don't want to say that's a gray area, but they take that into account.
Yeah, we talked about the teams being granted additional time.
Correct.
And Donna told us that one of the things that causes that would be if any of the DARPA equipment was momentarily not working, the clock would basically be paused for the team while DARPA got back in. And basically the teams shouldn't be penalized if some of DARPA's equipment prevents them from competing.
You're looking at Hanamontan in the distance there. This is just a check flight, making sure everything's good, no weight on there. As they will come back in, and then they'll do a half-weight check, if I'm not mistaken. And once that is done, then they can go up and go for real.
Yeah, go for real.
Live pitching, as we'd like to say.
Yeah, and really the clock is running out for these teams. You know, 2 days ago, if you tried to go up in the air and it didn't work, you might think, well, I got a little bit of time to breathe.
Right.
But with only 2 days, less than 2 days left in the competition, some of these teams may not get very many more flight windows, and it's do or die.
Let's cruise on down to lane 9. Somewhat Engineering, great name. This is the team out of Katy, Texas. We got 2 drones in the air right now. We're going to see a beautiful landing.
Right down in the center of that 5-foot circle, we hope. A 5-foot radius, I believe, 10-foot diameter.
There you go.
Yes,
on a
sir.
mountain now. With that flight check done, unweighted, they'll get half weight. And after that, if they clear that, then they will be on a full weight process. This is Somewhat Engineering. You got the laptop still connected. What do we got going on here?
Well, presumably they're programming and configuring the flight controller. The flight controller is the little computer that makes these aircraft fly. You know, if you think about an airplane is essentially aerodynamically stable. If you could take a little handheld glider and chuck it and it'll just fly, but if you take a handheld multi-rotor and chuck it, it'll just tumble through the air. It has no inherent stability. So there's a little computer in there that is detecting the way that the multi-rotor is moving and speeding up and slowing down the motors thousands of times a second in order to, when you see that multi-rotor just hovering stable, those motors are making little microscopic adjustments thousands of times a second, and the flight controller is in charge of that.
I love how they have given a description of their team. This Somewhat Engineering out of Katy, Texas. Somewhat Engineering is a small group of tinkerers driven by curiosity and bold problem solving. We think beyond standard playbooks and strive to explore unproven approaches when they offer a better path forward. This is the good part. Innovation isn't about following what's been done before. It's about finding what works.
That's right, and that's what we're doing here at the DARPA Lift Challenge. We are finding what works. You know, you say solve this problem, and if it's a problem that's already been solved, you know what works. And there's 2 problems with that. Number 1, if you get asked to solve a problem that no one's ever solved before, then you don't know what to do. And number 2, sometimes there are better solutions to an existing problem. When you look at that and you say, well, I know how to solve this problem, you miss out on those better solutions.
We had another JB on the desk a short time ago, Jonathan Bennett, the DARPA Chief of Staff, and he kind of echoed what you were saying about, there's a problem, fix it, and find a better way to do it. So we will see if the team from Katy, Texas, Somewhat Engineering, can live up to their credo and get this thing up in the air. Remember, we're looking for a 4-to-1 payload to weight ratio if you can do that. And if you can fly 4 nautical miles above 100 feet, bring it back, drop the payload, and then go back for another nautical mile and then set it down within the landing zone, you are walking away with potentially $2.5 million.
Yeah, $2.5 million first prize, $1.5 million second prize, and a paltry $1 million third prize. I don't know how that person is going to wipe their tears with dollar bills.
That's called Joshua Bardwell walking around money as we take you over to lane 12, Proto-Carbon. This is the team from Coeur d'Alene, Idaho. Small operation, had a chance to visit with them. Great folks. It's a cool design. We've seen similar to this, and that rotor,
yes, sir,
does not weigh anything. I mean, it is light as a feather.
Well, you want it to be as light as possible. Again, anytime you have rotating mass, it becomes hard to balance. So the less mass you have, the easier it's going to be to balance. And of course, every pound you add compromises your payload to weight ratio.
Does that need to be, I don't want to say tensile strength, but does it need to have some serious strength to it?
It does. It needs to be highly optimized to be just as strong as it can be without adding unnecessary additional weight. That's why typically it'll be made from carbon fiber composite.
This is a team, Proto-Carbon, a one-person engineering company design, analysis, development, and prototyping of advanced carbon fiber structures. So their owner, John Brendel, who made the drive from really one of the most beautiful places in this country, Coeur d'Alene, Idaho. It's fantastic. If you haven't been, I highly recommend it. And he made the drive here to Dayton, and with all his stuff packed up, and he's a one-man show. And I would love to see him drive back to Coeur d'Alene with $2.5 million in his pocket. That's a lot of stopping at gas station money.
Yeah, bringing a traditional sort of helicopter-style design. We definitely have some of those in the lead now. Of course, we're very good at lifting weight and a very established design. The key question being, how do you tweak that to beat the relatively consistent 1-to-1 payload to weight ratio that current designs are capable of?
With the conditions that we have right now, as the wind's picking up just a little bit, no rain, but with the conditions we have right now, is there a design or structure that does better than this? I mean, we've seen some other ones that don't do as well, and they struggle with that, obviously, with the wind?
Absolutely. The larger wings and the larger rotors are going to be more affected by the wind, all else being equal. Whereas you see some of these craft, and instead of having, say, 4 big rotors, they have 8 smaller rotors. They're compromising efficiency there, but they are potentially going to be less affected by the wind.
So Proto-Carbon, John Brendel's out there taking a look at this. Looks like he's got some pretty decent weight, JB, with your laser-like vision. What do you think?
Well, I see the Titan module. That gray disc on the bottom is the Titan module that's tracking the location and other stats about the craft so that the good folks at DARPA know what each competitor has done. I don't see any weight plates on there, I don't think.
Is the Titan thing on the bottom, or is it on the top?
Well, it looks like it's on the bottom to me. I think they're seeing a plate on the bottom. Maybe that's just the bottom of their stack. They have some kind of a plate that would be holding their weights on. I don't see any weight on that vertical shaft.
Well, the nice thing about the DARPA Lift Challenge is there's always a lot of smart people just walking around, and we've got one, Ed Marin, the technical advisor for the DARPA Lift Challenge. Good to see you again. You came back without toys. The other day you came in, you educated us well on your toys, and today you come with nothing but sunglasses.
I still have them. I can grab one whenever I need it. Thanks for having me back.
Ed, what's been your takeaway so far? We're on day number 6. Are you amazed? Are you shocked? Are you blown away? Or are you just like, no big deal?
Loving the innovation, loving pushing the envelope. We're starting to see some of the results of pushing that envelope and stressing out the structure and trying to get more weight and the disc loading on the vehicles, like we've seen in the last flights with some of the crashes.
What do you think about the morning run? We saw some great, I don't want to say failures, but we saw some beautiful crashes coming down, and the teams were smiling about it, obviously pushing the limits. Your takeaway from that 9 a.m. flight window?
Great learning moments. As an example, Defentex was one of the ones that's pushing the weight fraction limit, and is a perfect example where you're trying to reduce the weight to have a better fraction, but you always risk the compromise of structural integrity, right? And if you recall, the blade it buckled on top
Right.
as it folded, and that's typically when you have any structure, whether it's a beam in a building or a blade, it's composed of the top and lower layers, and those give it its stiffness. And so the way you the plies of carbon fiber and the direction of the fiber for tensile or compressive strength, they have a big impact on it. And as you start pushing the weight limit, that means that the rotor disc area has to be able to pull more thrust, and in doing so, you have a higher load on that area, which means that the blades will start to bend more, and they have to be able to manage that strength. Heavier you go, more load, and it could break.
All right. Well, we've got a segment called, and I just named it just now, it's called What Went Wrong with Ed Marin. So we're going to roll back some of the action from the 9 a.m. flight window. And Ed, tell us what went wrong. So let's take a look at Aviadrone. They were really pushing the limit here. This was their 4.02. And Ed, what went wrong?
So it looks like there was some problem with the stabilizing tail section there. And once you lose the entire control of the back end, then the whole thing starts to spin.
This is MTech. Ed, again, what went wrong?
And this one is similar, right? Extra load on the rotor system and the motor itself. Both of them separated, and as soon as you have separation, two things will happen. You compromise the structural stability, or the whole structure dissolves.
And this was Defentex.
Yeah, that was the blade. That was the blade that folded. You guys did a nice up close of the flight.
Joshua, you're around this a lot more than the rest of us, but these things happen.
Yeah, they do happen, and if you're not crashing, you're not learning, and you're not pushing limits. Ed, you talked to us when you first came on about the different types of aircraft: fixed wing, rotorcraft, multi-rotor, etc. And I've heard that referred to as like the meta. Which of those designs are in the lead? Which of the designs seem to be succeeding? What do you think of the meta of today's leaderboard?
You have a combination electric. They tend to be more reliable, easy to install and replace than the combustion system. The combustion can give you more power, and it's certainly better for endurance. But for our flight envelope that we have here in this entire range, it was designed to be kind of right in the middle, where you could use an electric propulsion system or you could use a combustion system. And so it's interesting to watch the competitors pick one versus the other.
Yeah, we're seeing several of the leaderboard entrants are using sort of a traditional helicopter-style rotorcraft. Like, what are the pros and cons of that design compared to some of the other sort of more innovative, let's say, designs we're seeing?
Well, I'd say that they have their own innovation. Typically, if you have a conventional high technical readiness level, as we call it, TRL, that means that it's a mature technology, that it has been established analytically, and the rotor systems have that. But what some of these companies have done is they've said, okay, let's use established technology and let's improve on that. So you'll see that one of them had a turbine with a built-in gearing system.
That's not typical.
That's not typical. Another one built their own magnesium gearing box for the whole thing. That's not always typical. So there always are approaches where you can take an established technology and improve on it with new aspects.
Now, this is Skyweaver out of Menlo Park, California, and they are spinning up right now. So we hope to see that. This is, I would say, Ed, this is a crazy design, but it's different in using two fixed-wing aircraft connected by a cable.
Yes. So we kind of talked about a little bit about this with rotors. If you look at any rotor as it rotates, the tips are moving at a higher velocity, so you get more lift from that aspect, as opposed to the core right in the middle. And what they're doing essentially is using, hey, let's just go fast on the tips, use that load to lift the payload. I remember they had some problems, or he had some problems with starting one of the engines a few days ago. It was getting full of fuel. He had to switch out a spark plug, and I think hopefully he's got it resolved.
It must be really frustrating to have brought an innovative design. You're going to try to push limits, and something as simple as a spark plug is what's stopping you from demonstrating the capabilities.
Yeah, and if the engine floods, right? But what was great about his earlier flight in the week was the whole time he was out there trying to start the engines, and he didn't give up. He was back and forth trying to start the engines. That's resiliency.
So we're waiting to see if Skyweaver out of Menlo Park, California will spin up. And will they go? I know everyone's kind of curious how they take off, how they land. This is a different situation. And we're going to try to head down to Elena one more time. And she's got the insight from the flight line. Elena?
Hey, so we are observing Skyweaver right now, who is about to take off. And for landing, they actually had to relocate their landing pad to accommodate their unique design. So really curious how that's going to turn out, and we'll see what happens.
All right,
Back to you, Todd.
We will see indeed if they do get up in the air. We've got Ed Marin here, the technical advisor for the DARPA Lift Challenge. Ed, give us a little background on your career, your expertise, and at this point in your career, do you think you'd be out in the middle of Dayton Field watching drones going 4 to 1?
You know, life throws things at you, and you never know where you're going to be. I call it my Forrest Gump life. I try to plan something, and the next thing I'm somewhere else, right? Actually, I did my undergrad not too far from here at Ohio State University.
The Ohio State Buckeyes.
The Ohio State University, and I came here after. So my background, I came from Columbia as a 10-year-old, and I was really good at math and science, but my English wasn't so great. So I went to community college for a few years until I got everything up to I could go into the aeronautical and astronautical engineering at OSU.
Wow!
And then I got picked up at Northrop to work on all kinds of fun stuff, and I was an aviator. So I've done a few things here and there when it comes to this aircraft.
Your Forrest Gump moment.
Yeah. So this another thing that's interesting. We've seen 2 of these type of vehicles with the aircraft, right? And the design choices are fascinating. The first competitor, they did electric aircraft. He chose combustion aircraft.
Okay.
So the pros and cons are potentially more power with this one, but starting them, as we've seen, is problematic. Whereas the electrical ones, they're easy to start, easy, ready to go.
And there's differences in energy density as well.
Very much. Yeah, so you have to pick the right battery, have the right amount of energy for the purpose of what you're doing. We have found here, in talking to a lot of the competitors, is they may have started with a really high energy density, like you mentioned, on a battery, and then as supply chain management changes and availability, and some of them are coming from overseas, suddenly they get here and they don't have enough of what they need of the one battery, and they have to change their entire scope to a different battery, different voltages, different density, very different.
I was going to ask you, and this is a question for both you and Joshua, with the pandemic that happened in 2022, whatever, are we playing catch-up still because the supply chain was disrupted, and carbon fiber is such a huge part of this?
Not just the carbon fiber, but the resin, right? When we talk about composites, it's the fiber itself and the resin, the matrix as we call it, that makes the composite. So the oldest composite is wood. Wood has a cellulose structure and it has fiber, and these composite systems have different resins. You often see polyesters and some epoxies in boats because they're more cost effective. The difficulty with some of those lower cost molecular weight systems is that they are also more vulnerable to temperature. So some competitors may find that if they're using one of those resins in the carbon fiber, then it could soften with temperature.
Wow.
That's a risk. So you ask yourself, when you see any of these carbon fiber systems, did they pre-preg it? Did they laminate themselves? Did they do a post-heat treat on it to stiffen it and make it stronger? We don't know any of those aspects of the manufacturing process here.
Yeah, you talk about supply chain and people using, for example, high energy density batteries. It's an area where a lot of innovation is going on right now. The more energy you can pack into a battery, the longer you can drive or fly for the same weight. But if that is difficult to get or limited in supply, maybe it would have been better if you'd gone with something else. And these are all the decisions that competitors have to make.
Absolutely right. But most of them are going to go for the gusto. We're going to try to do the best that they can. Yeah. But that also comes with cost.
Yeah.
You'll see a lot of them have spent a lot of their own money. This is not their job, but they're committed to this being a part of this aviation breakthrough exercise, and they're willing to spend the money to do the best they can.
Well, and if a competitor identifies a new technology as something that's very, very desirable, potentially that could shift markets, and that limited supply battery, for example, could become less limited.
Yeah, interesting you say that. We've done so many unmanned aircraft programs at DARPA, and a lot of the other agencies have as well, and we find that there are gaps in a particular product. Let's say it's a motor, combustion motor. You might have a lot of production in a certain weight categories, but maybe the warfighter needs this particular weight for this mission, and it doesn't really exist. And because of that, it's very expensive. And so now you have to try to catalyze an industry to promote this growth of this particular component, because A, there's not a lot of it in the U.S., or two, it only comes from other places because nobody else is making it.
You are looking at Skyweaver, the team that is on the flight line. They are spinning. They are waiting for clearance. They've got their pilot behind the fence. The team is looking like they are ready to go. All the checks have been made, and we will get them up hopefully in a matter of moments. This is the 11 a.m. Eastern flight window here at the DARPA Lift Challenge on day 6. One more day still to go. We are approaching just about 35 minutes left in this window. JB, we've talked to a lot of the pilots, the teams. They're giving themselves roughly between 22 and 28 minutes. Remember, there's a 30-minute time limit, so that is kind of the sweet spot to complete the 4 nautical miles plus the 1 nautical mile unweighted. They still have time. Obviously, they have to come back and get weight added to this, but I think everyone just wants to see this craft up in the air, or crafts up in the air.
Yeah, can you give us any insight into how DARPA selected the 30-minute time limit? Obviously, you don't want to be able to take forever.
Right.
Why was 30 minutes the right number?
Well, when you look at energy management with regards to the velocity of these type of vehicles and the distances, you do some analysis to back out what you think would be appropriate, right? When we ran the numbers, 30 minutes was approximately what someone could do when they accelerate towards the middle of the course to about 25 miles an hour, and then decelerate, and then be able to complete the whole course that way. If it's too fast, you make it too difficult on the G load for the aircraft.
I see.
So you're trying to make it reasonable.
A shorter time limit would have required them to fly faster. It would have stressed their airframe more.
Exactly.
And of course, a longer time limit would, well, you just wouldn't be able to get as many runs in.
Right.
Speaking of fast, when are we going to see Spitfire bat on the line again? Because that was the team that kind of got out there and got everyone's attention. It was a crazy design. It looked awesome. The promise, it had the rear jet engine. I was thinking, I just want to see this thing go up and see what it does.
Oh, we're excited. We're excited to see that. You know, initially, I don't know if Donna talked about it, but the design for that one was that we're going to use two. They were going to use two of these vehicles.
There you go.
Two, not just one, but two.
So the initial concept paper was to use two and sandwich the weights in between it, and then fly it.
Wait, so not a tether.
Not a tether.
Sandwich the weight. So we have 3 systems where there are 2 aircraft.
Look how hot it got. They melted a section of it. So, yeah, those bat wings on the back are gone.
Right. So they had originally had a carbon fiber frame on the outside, the outer mold line, and they crashed, damaged it. They had to 3D print something fast, and if anything is kind of a plastic-based system, then it has a really low melting temperature, as we saw. Right, that's a problem.
Yeah, I mean, theoretically, if they had gotten in the air and gotten moving fast enough, maybe that plastic wouldn't have melted, and they would have been able to.
That's exactly right.
Run.
That's exactly right. If it could launch immediately and get going, then it would have less emission.
Well, I've been told that Spitfire will be in the 4 p.m. Eastern flight window, so that alone is worth the price of admission. I just want to see them get up in the air and see what they can do, and the team from Florida. So we are still waiting for Skyweaver to get up. The prop's spinning. Ed, I don't know if you have a vote, but let's talk about some of the superlatives. Obviously, the most revolutionary powertrain, most promising, most revolutionary aerodynamic design. A, do you have a vote? And B, can it be bought? No, just kidding. Do you have a vote? and what have you liked so far? Is it going to be tough? I mean, is it going to be margin thin?
Oh, it's an interesting conversation. I do not have a vote.
Okay.
But we have had initial conversations about the different designs and concepts. Oh,
here we go, and we're stopping.
I did see it bobbling in the grass a little bit.
Over. There you go. So that was short-lived.
I have to hand you the win on this one. The reason it flipped over most likely,
the grass.
The grass drags on the wheels and it flips over.
We got to tell Donna next time we got to put him on a putting green. Let's see it again. This is Skyweaver. Our crack team of camera folks got this. Here it is. Watch the right.
The wheels.
And
yeah, just did not get enough speed, not get enough lift under the wings to get into the air before it snagged down in that grass. It also looks like it's getting dragged around.
Yeah.
I almost think the grass might not have been the factor.
Don't rain on my theory. Come on, don't rain on my theory.
It kind of looked like it was getting dragged around, but they didn't speed up equally,
right.
And so one of them pulled more than the other. And the grass could have caused that. Back to you being right, Todd.
Ed Marin, the technical advisor for the DARPA Lift Challenge. Let's get back to the superlatives again. Most promising, most revolutionary powertrain design, and most revolutionary aerodynamic design. You know what I was impressed most about this? This isn't just chump change. This isn't just walking away, sandwich money. This is $500,000.
Yeah, it's a decent cash, and I know you're trying to corner me on some selections here, but I really don't have one. Some of the technologies that are being implemented are approaches that have been looked at aerodynamically for a long time. Tip jets is nothing new, but we're trying to do a different way of it. We have a blade element system with the high school kids, and propulsive-driven rotors. Several different ways of approaching that angle.
Talk about the motivation behind having superlatives in addition to just giving out money to the people who actually hit the goal.
I think that if you don't have something that allows you to inspire creativity and innovation, you limit yourself in what might come up that you don't see. If a lot of times ideas come up just out of nowhere from some crazy thought process of saying, yeah, you know what if I try this? Maybe we do some analysis and it works out. Sometimes it doesn't, but we want to be surprised. We want to be surprised with technology that we haven't thought about yet.
I got a question for you, and this is serious, and I want you to be honest.
Oh, boy.
If you had a vote and you saw a team that was very promising, but they were in the maize and blue and they were from the school up north, would you give them the $500,000?
At least they're Big Ten. At least they're Big Ten.
I love the loyalty. Ed, thank you so much for being here. We appreciate you always popping in. Even if you didn't bring your toys this time, we always love having you here. Come back again. Ed Marin, the technical advisor here at the DARPA Lift Challenge. We know he's very busy, so we'll let him get about his business, but we thank him for his insight, his time, and for all he's done to make this a success. There you see the end result of Sky Weaver out of Menlo Park, California. They going to get themselves, looks like they're going to get themselves set back up. But we've said this before all day long, the people that make this go are wearing orange. And it's not just the safety vest. It's the good folks from the DARPA Lift Challenge. So it got us thinking, scratching our heads a little bit. Aren't you curious about how this thing all comes together?
My name is Ken Pankratz. I'm excited to be out here supporting the DARPA Lift Challenge. I've been supporting DARPA since 1996 after serving 10 years on active duty as an infantry officer in the Army. I've been supporting the Biological Technologies Office at DARPA for the last few years, and I have seen a lot of wonderful breakthroughs that support our warfighters. I'm looking forward to seeing some breakthroughs in technology here at the DARPA Lift Challenge.
Hi, my name is Grace Ann Flanagan. I'm enlisted in the Air Force and I work over on Wright-Patterson Air Force Base. I got the message that they were looking for volunteers for the DARPA Lift Challenge, and I've never been to any sort of drone event before, so I thought it'd be really cool to take part in this and see how everything plays out, see who wins the challenge, and I'm excited to see how everything turns out.
Hi, my name is Lun Chen. I'm an Innovation Fellow at DARPA at the Defense Science Office. An Innovation Fellow is a position for emerging professionals who wants to help drive changes and impacts for the betterment of national security. And I'm a metallurgist myself. I'm a material engineer and have a PhD in material science engineering from the University of Virginia. At the DARPA Lift Challenge, I hope to be a part of the crew to make this event successful and drive positive changes.
Hi, I'm Eric Butterbaugh, and I've been working at DARPA for about 15 years in the Public Affairs Office. Before that, I served in the Air Force as a Public Affairs Officer for 21 years. My first assignment was right here at Wright-Patt, and it's great to be back here with DARPA at the birthplace of aviation to see the next technological breakthrough, and that's what we're really excited about being here for.
Hello, my name is Natalie. I'm a 4.0 aerospace medical technician. I work right here in Wright-Patt in Area A in the medical center, and I work in PACU, so basically we're helping all of the military dependent and veterans for their surgeries. So anytime you need an IV, we're there to help you out and help you while you're recovering from surgery. Reason why I joined DARPA is I thought it was a very interesting event, and I wanted to see what advances are happening that will help us in the mission long run. Thank you.
I'm Luke Edwards. I'm a contractor at DARPA in the Defense Science Office and the Tactical Technology Office.
I'm a former submarine officer as well. I served in the Navy for 8 years and bring my experience to work on undersea systems and unmanned technology. I was really interested to join the DARPA Lift Challenge to be a part of aerial drone flight and to push the limits of the technology in this area.
Hey everybody, I'm Cam Ryder. I'm from Virginia. My company name is Chugotch. We're here assisting the DARPA Lift Challenge. My trade back home is a welder. We do a lot of shipboard work. Out here we're doing recovery and team transport for the drones and their personnel. So it's been a fun day. We've had some decent weather, and we're looking forward to what the week's going to bring from us.
Hi, I'm Phil Mraz. I'm an engineer, retired out of Wright-Patterson Air Force Base here, a retired Air Force civilian for 34 plus years, now supporting DARPA on the Sprint program. So I'm super excited to be here in Dayton, Ohio, in my own backyard, helping with the DARPA Lift Challenge. I can't wait to see all the innovative ideas that people have come up with across the country for the Lift Challenge. And so it's a pleasure to be here.
And a tip of the cap to all the good folks out here in Orange, the folks from DARPA making this all happen, putting it all together. And again, thank you for your service. As we turn our attention back to the flight line, we are getting word that the team Skyweaver from California, they have called it a day. They had some structural damage, JB, so they're going to take it back to the prep area, and it looks like they are going to do some repairs, but they could be back tomorrow. That's the key for the team from Menlo Park.
Yeah, it's a shame to see somebody get knocked out by something as simple as an airplane just flipped over trying to take off. So much promise to what these teams are trying to do.
If you're not going up today and you're in the prep area still, is tomorrow your swing for the fence, call your shot, let's go 4.02? And
I mean, it's tough because tomorrow will be the last day of the competition, but like if you think clearly the 4.0 is a very, very difficult metric to meet, and if you could maybe just shoot for the third place team, try and knock them out and get yourself in the money.
Yeah, all that would take would be a 3.32 payload to weight ratio, and you would move into third place, currently being occupied by Extreme Aerial Concepts. Second place belongs to MTech Operations, 364. They put that up today. Avidrone is at 384, and that's who everyone is chasing. MacGyver, the team, not the person, sits in fifth place with a 2.51.
Yeah, it's really interesting to see. Not to say that 3.0 is easy.
Right.
But it has been interesting to see that several teams have managed to get into the 3.0 range, and everybody is really struggling then to hit that 4.0 for the full prize.
We will see teams coming up later this afternoon. Of course, we have a 2 o'clock flight window, and hopefully the conditions here will stay the same or improve, as we will have that 2 o'clock flight window, which will be at 90 minutes. And here are the chasers, Defend Techs out of Moab, Utah. As Donna pointed out, that's a team combined of both Americans, Australians. They need to get in. They need to put a flight that is scoring, a scoring run, because if they can, look at that, aircraft weight under 12 pounds. We saw them come out and add some weight to it. They were at 18 pounds, if not mistaken, JB. And look at that payload, 112 pounds for that.
And just to clarify for anybody who's watching, the chasers, they have gone up. The numbers you see reflect an attempt, but they did not complete the requirements of the run, so it is not a scored attempt. So when you see them at 9.63 and you say, well, why aren't they at the top of the leaderboard? They got in the air at 9.63, but they didn't.
Did not complete 4 nautical miles, drop the payload, then do another nautical mile. That is what we call a scoring run, and so far we've got 5 teams that have done that. Remember, if you go 4-1 or higher and you do a complete scoring run, you are walking away with $2.5 million. So we've got another team out there. It looks like they are weighted and looks like they may be ready to go. This is lane 14.
They got a weight on there.
This is VertSolve.
It looks like it's just a single plate, so that would not be a scored run. Scored run has to be a minimum of 110 pounds, regardless of the weight of your craft, regardless of your payload to weight ratio. The idea there is, like if you think about an ant versus an elephant, well, an ant that lifts 4 times its own weight isn't very interesting from the perspective of us humans who just want to get our groceries delivered by a drone or other sort of types of practical applications. So 110 pounds, the minimum weight for a scoring run.
Yeah, you can just get an idea of just how windy it is. That windsock is almost completely horizontal. Our camera bouncing around just a little bit down on the flight line. The breeze is nice because it feels comfortable, but
it feels comfortable to us.
Not ideal for flying right now. So VertSolve looks like they're going to do a half-weight check, the team from Phoenix, Arizona. And that is lane 9 as we somewhat engineering. That was the team that we had talked about
Yeah.
out of Texas.
You see it going up. One of the things I look for as a multi-rotor first takes off is, does it go up stably or does it immediately flip over like that? In a case where it immediately flips over like that, it's likely that
Balance?
something went wrong. Not so much balance.
Okay.
You'd think balance.
Yeah.
But those, they tend to be strong enough to compensate for being slightly off balance. Usually it points to a problem with the flight controller, that little computer that runs it. It may not be configured correctly or may just got
Joshua,
confused.
it doesn't look like major damage, I mean, from my untrained eye, and now I just announcer
The
jinxed it,
announcer's
so
first.
now the smoke starts, and that might be a little more damage.
So we saw the props go flying. It could be that a prop struck the battery. When you see a fire start after the crash, so a lot of times when a battery is damaged, it won't immediately light on fire. It will take some time to get going, and to me this looks like a battery fire that was started
is this a lithium
by
fire?
damage. Yes, sir.
So on
after
Titan,
the crash.
the fire department has the information of what all that material is, and they know exactly what to address. If it's Donna told us that if it's white smoke, it's usually a fuel. If it's black smoke, it's carbon fiber. And this also looks to have a liquid fuel as well. So this is somewhat engineering, and we're watching them not up in the air. We're watching them, well,
on the ground.
On the ground.
And the safety and fire response, we were told earlier that the protocol is that as long as the fire is not spreading, you just want to let it burn itself out.
Yeah.
One of the reasons for that is that smoke that you're seeing is not good to breathe.
No.
And so you're just going to keep your distance. You're going to not be downwind, and you're just going to monitor the situation until it burns itself out. And only take action
use their
if
own
necessary.
words. The team from Katy, Texas said innovation isn't about following what's been done before. It's about finding out what works. That did not work. So they will go back to the drawing board, and that looks like, to me, in my untrained eyes, that's going to be a complete rebuild.
Yeah, there's a lot of damage there. We see motors disconnected from arms. Broken propellers are just a fact of life. If all you did was break a prop, you would just replace it. You get back in the air. But of course, you'd want to figure out what went wrong there.
And I guess that's what my thought was. We saw it flip over, we saw it land, didn't see the smoke. We're like, oh, and they're right on the landing pad. They go out there and retrieve it, replace a few parts, maybe get back up. The window closing in 20 minutes. And then the smoke started, and that was danger.
Well, and as a pilot or as a drone operator, you crash and you think, oh, okay, it's going to be all right. Then you see the flames, and of course your impulse is you want to get there, you want to stop the flames, you want to prevent additional damage, but obviously that would not be consistent with the safety protocols.
So it looks like it's going to be a long night for the good folks from Somewhat Engineering in Katy, Texas. We hopefully get them back out here tomorrow for another shot at it here on day 6 of the DARPA Lift Challenge, the penultimate day of competition. Tomorrow, Super Sunday, and then the competition will come to a conclusion here at the National Museum of the United States Air Force in Dayton, Ohio. This is, again, the 11 o'clock flight window. We've got another flight window coming up, and that will be kicking off at 2 o'clock Eastern time. So if you're watching anywhere around the world, you can check back in with us at 2 o'clock Eastern time. We've got some interesting teams. Of course, we've already teased that the Spitfire squad, JB, is going to be back out. Teams are still working frantically to try to get something up in the air here in the next 20 minutes.
Yep, 20 minutes, enough time, just about enough time to finish a complete run if you wanted to go for it, or if you haven't completed your safety check flights,
get that
certainly
done.
Enough time to get that done, and then go in another flight window if you have one.
So there you see the flags heavily fluttering, and the wind is blowing. So we will continue to monitor who's on the flight line, who is coming, who is going, and who is going to maybe try to get up into the air and see what they can do. Again, you have to travel 4 nautical miles with weight, come back, drop off the weight in the zone, then go back up another nautical mile, then put it back down, clean landing in the zone, and then you are in the money.
You know, Todd, you talk about the weight, and of course we've said the minimum weight is 110 pounds. It would normally not be legal to fly aircraft this heavy without special permission from the FAA. And of course DARPA has gotten that permission for the sake of this event. So even for competitors who maybe are not going to get a scoring run, just the ability to come here and do testing on an aircraft this heavy without having to do reams and reams of paperwork and probably get denied, there's a lot of value for these guys. And when you see them going up there flying, you know, there's a chance that the data that they're gathering is as valuable to them. Well, maybe not quite as valuable as a cash prize, but certainly there's a lot of value for them even if they don't get in the money.
Meanwhile, there is the scene back with Somewhat Engineering, and you called it. It was going to eventually have a little combustible action going on there. They are safely on grass. Hopefully it won't catch onto that platform and someone's beautiful paint job with the circle, but it's basically going to say, as we say, JB, burn itself out.
Yeah, It looks like a total loss, I think. Not a lot's going to be reasonable. Even if you had a component from that, like let's say your motor mostly survives, you wouldn't trust it.
No.
Not when it's been through that. You would save that, you would put it on a shelf somewhere, and you say, that's the flight controller that burned up at the DARPA Lift Challenge. You would commemorate it forever, but you probably wouldn't use it. I do imagine that parts of this aircraft will be highly prized by the team.
Oh, yeah.
Just for the memory of having been here and what happened.
Well, as somewhat engineering continues to burn, we want to let you know that the number of applications and the number of people, going to what you brought up, JB, that wanted to be here, the people that sent in applications, that sent in video applications, that said, hey, we're capable, this is our design, went through a rigorous process, and it was whittled down to, I think, 120 invitations, of which 80 made it here. But it was really interesting to see how people made their pitch to come to the first ever DARPA Lift Challenge.
Hello, we are Team Sherman Aeronautics.
We're Astro Systems and we're based out of Chicago, Illinois.
And we are Team SciLift.
And it's essentially a high school team with a few parents.
We are Maxway team ready for the challenge.
Well, it's whatever o'clock in the morning.
A new and improved VertSol video submission. Our flight test plan is designed to make sure that I don't get a visit from our friends at the FAA and NTSB.
We specialize in building out-of-the-box, frankly bordering on crazy machines.
You just can't buy one of these drones on Amazon.
The DARPA Lift Challenge pushed our skills and budget to the next level.
And the biggest issue is probably center of gravity. I've moved it away from the center. We have a circle.
And our answer really is to use airplanes.
I would bring them home and have my kids hang on them.
It's kind of crazy.
This was quickly shown to be infeasible.
That's exactly what we should not do.
It has been a comedy of errors for sure.
Most of the time we spend arguing.
Funny thing, I just destroyed the flyer, so I have 2 weeks to rebuild it.
It was its first flight and it took off successfully for about 2 feet and then promptly backflipped directly into the ground.
The thing shot up through the roof. I mean, it took off like a rocket.
One guy came up and showed me something cool. He pulled a possum out of his pocket.
We actually had 2 catastrophic crashes during our flight test verification.
And it was perfect. Maybe we can't say that, but it was really good.
God, the light in here is terrible. I look like I'm telling a scary story.
Okay, that one wasn't bad.
That's good.
Is that good?
And that is the spirit, that is the community, and that is what we were dealing with here. Again, 487 applications, 132 were accepted, and 81 made it here. And now the brave folks from the fire department have come out here, and they've seen enough of somewhat engineering's campfire. They're going to put this thing down.
Yeah, you know what I love about the entrance is that when DARPA was selecting the teams, they didn't just select established, aerospace contractors, the old guard. Some of those are here. Some people you would guess would have a high chance of success, but also just families, husband and wife teams, just crazy garage tinkerers. It spans the spectrum.
So they're going to safely remove this, make sure it's all, look at that. Thought he had it out, not so much.
That's a battery. You basically can't put them out. They have all the chemicals that they need to create fire inside. They will burn underwater. They will burn in the vacuum of space. You can stifle the flames. So you put sandbag on it. There are some fire extinguishers that'll put foam on it, specifically for lithium polymer batteries, but you cannot put them out. You just have to control the secondary fires and wait for them to finish burning.
So there's the shot of the flight line here at the Museum of the United States Air Force in Dayton, Ohio. There you see the smoke rising up as they are putting that fire out, as we are coming up on the final 10 to 12 minutes of this 11:30 flight window. And we will be back on the 2 o'clock flight window with much more. We are scheduled for 63, I say that again, 63 flights scheduled today. Joshua, not all of them are going to be successful. Not all of them are going to get off the ground, but that's what we are scheduled for. I'll give you a panorama view of where we are spinning around here in Dayton.
It is a jam-packed day.
Yeah,
you look out there and you see that only some of the flight lines are occupied. Every single one of those flight lines was scheduled, but for whatever reason, some teams make it out and they get up in the air. Some teams make it out, don't get in the air, and some teams, for whatever reason, don't make it out. Everyone here is trying this as hard as they can to take advantage of this opportunity.
And there is the museum. If you have a chance to go look inside there, some incredible vintage aircraft, some modern stuff. Yeah, if you're any fan of aviation, this is where you want to be.
And it is open to the public, so if you want to be here and you're in the area, you can be here. You can come to the museum, you can come to the DARPA Lift Challenge, you can watch us, you can sit out on the bleachers here, there's some folks watching us live. You can come to Flight Fest and see the RC airplanes fly in the air, smash into each other sometimes. It's a great day.
It's a great competition. There it is.
Oh, look at him go. I do not think we're currently watching one of the demolition derbies. These guys are trying not to crash into each other and just having a good time.
The first time I saw that demolition derby out, there was, 70 RC planes up there. It was just chaos.
Chaos is a great word for it. Look at them go. And it's great to see people able to enjoy aviation. Now, some people would say, well, a little toy RC aircraft is that aviation, but the thing that bonds full-scale aviators and RC hobbyists is the desire to slip the bounds of gravity and get up in the air, and I think that's really inspiring.
Can I give a movie plug?
I couldn't stop you.
Flight of the Phoenix. Have you ever seen that one?
I don't know.
Oh, you got to see that. Flight of the Phoenix. It merges RC planes and modern aviation.
It did it
in a survival. Yeah, Dennis Quaid. You got to watch this. It was great fun.
Okay.
Hugh Laurie.
I think I'm a little young for that.
Flight of the Phoenix. No, it is not in black and white. It is color. It was done in the last couple of decades.
I'm not used to being the young guy in the room, Todd.
I know.
Thank you for that.
Old Man Winter. Flight Fest continues on here, Dayton, Ohio, 2026. We're all part of the DARPA Lift Challenge. It's day 6. We've got one more day of competition. That'll be tomorrow. And then when this thing all shuts down, hopefully, Philip Smith, call sign Donna, will have to hand out a $2.5 million check. We do know one thing. There will be $500,000 superlative checks handed out. 3 of them. So $1.5 million is definitely going out the door.
That's right. That's right.
As the RC planes continue to put on a nice show for the fans here in Dayton. Looks like we're going to escape the thunder showers. Hopefully that was not an announcer jinx, knock on wood.
Yeah.
As we had yesterday around 2 o'clock, some serious weather came through the area and just put everything on hold. It was a shelter-in-place moment with thunder, lightning, and a deluge of moisture. And there is the situation. You talked about it. Here's the sand. They're going to try to depress that as much as they can.
Stifle those flames. Stifle those flames. Minimize the smoke. Spray it down. Watering, I'm guessing that looks like water, just wetting down the grass and the woods to keep it from igniting.
Gives you an idea of just how far away the Flight Fest is away from where we are. I'd say it's probably a good mile to a mile and a half down the line. Still time. Teams out on the line.
You know, in these teams, most of the people on these teams, I dare say, they started as RC hobbyists, like the folks flying those planes over at Flight Fest. So,
did you start as RC hobbyist?
Oh, absolutely. I still am. Still am an RC hobbyist, but I started as one too. and it's great. If, you know, I think of some of those kids over there flying planes right now, and wonder if 10, 15 years from now they're going to be at something like the DARPA Lift Challenge, solving these problems.
To drone. He is Joshua Bardwell. He is our drone expert and has nearly 500,000 people following him on YouTube as an educator. For the folks watching at home, if you want to get into the drone world, all that stuff, what's the best way to do it? Do you have to be licensed? What do you have to go through to just take your drone out and have some fun?
If you're talking about drones, multi-rotors instead of planes, I guess this is true for planes too. The best thing to do is to download a computer-based simulator.
Okay.
Now, I don't call them a game. I call it a training aid. It's not very much money. Many of them are even free. You get a controller. It's better to buy a radio controller, but you can use an Xbox or a PlayStation controller if you have one around. And you can start learning and experiencing this hobby without spending any additional money or putting an actual aircraft in the air and then potentially risking breaking it or potentially risking damaging it.
If you want to take it to the next level, let's say you want to get into a drone, you want to fly, you want to put the goggles on, you want to do the whole thing, what's that process? What's the cost?
The next step would be you can get these small kits. The drone is relatively small, about 65 millimeter wheelbase, and for, say, in the range of $300 to $400, you could get yourself in the air. And the nice thing about those is it is so small that it is basically impossible to damage property or cause injury, and you can take some risks with it.
Okay. So we see the team still trying to get up and make some data, try to find some analytics, see what they can learn. That was Hahnemann, the team from Foster City, California. Got up in the air with a little bit of weight on there, gave it a feel. The folks on the other end of the runway at Flight Fest.
Yep, you can see them all out there at the end of the runway with the flight lines. Of course, similar safety procedures to what you see here, although the consequences are not quite as dire because their aircraft are so much smaller and so much lighter, generally, but they're all behind that flight line, staying safely away from the flight area.
Look at that, he's getting a wind check. Vertsolve is still out on the line.
Checking the wind to see well, how it would affect their craft if it's within their safety margins. Of course, the DARPA team also has a safety margin beyond which they will say the wind is too high and they'll ground everybody. I believe DARPA's limit is 25 knots, which is pretty substantial.
Okay, yeah.
You as a competitor might say, well, I'm not going over 15 knots. I'm staying on the ground under 12 knots.
And why use knots as opposed to, I know they use knots in sailing and aeronautics. Why use knots as opposed to miles per hour?
I just assume it's cultural. I mean, they say, why use any unit of measurement? And it's just, you know, what are people used to and what language do they think in?
Copy that. All right, so we're hoping to get you some flights, hoping to get you some action, hoping to bring you, I don't say a world record, but something that's never been done before. That is a 4-to-1 payload to weight ratio by one of these crafts. And if that happens, someone is going to walk away with a title here at the DARPA Lift Challenge and $2.5 million richer.
Yeah, and I would say we're setting world records, obviously not official records, but we have done a higher payload to weight ratio than any, like I did some research going into this. Some of the highest payload to weight ratio I could find for like heavy lift helicopters was in the roughly 1-to-1 range. If you look at things like the human powered helicopter project, they get up to about a 2-to-1 payload to weight ratio. And I couldn't find much that was higher than that. I'm not saying it doesn't exist.
Yeah.
But I would argue there's a good chance we're breaking records here.
You look at the planes in the military, those Chinooks, and those things can carry tanks. They can carry
about
jeeps and things like that.
25,000 pounds roughly is their weight.
Holy
that
cow.
they can carry.
And what do they weigh?
So they weigh about 25,000 pounds and they lift about 25,000 pounds. But one of the differences is that 25,000 pounds is their dry weight. So that does not include their fuel. So they'll carry something like 7,000 pounds of fuel, and then everything left up to about 50,000 pounds is cargo. In our case, we're counting the fuel and the aircraft itself, and we're only counting the payload. So actually, that makes the Chinook have a slightly worse than 1-to-1 payload to weight ratio.
Okay, what we're hearing is because of that fire, they're going to extend the flight window by 10 to 15 minutes. It's just for lane 12. So 12:42 in lane 12, and lane 14 gets 12:35.
So Todd, let me just double check. The team that had the fire isn't getting the extension.
No, teams
your
near
fire, you own it.
Your fire, you own it. I think it's the teams that were
a nearby team.
You're
was
tight with
prevented
Ann Bush.
from
You
flying.
should ask her directly and say, Ann, what are you shelving out these extra minutes for?
Yeah, a nearby team was prevented from flying, and so they're not going to be penalized.
They didn't
for
want
that.
you in their smoke.
I got you.
No one wants that smoke. And a lot of times you make that appeal to Ann Bush, and I'm not saying she's not the nicest person in the world, but sometimes
She's
she
very
might
nice.
say...
She was so nice to me.
You might say, Ann, I got another question, and she might say... Denied.
She's...
Well, this morning's flight window at 9 o'clock, they certainly pushed the limits, and this is how it all went down. Aviadrone, who came into the day as the leaders, decided, you know what, let's go for 4:02 and do a mic drop moment. Well, what dropped wasn't the mic, it was Aviadrone itself.
Yep, we see that tail rotor seems like it stops, but certainly we lost tail authority and the aircraft began to spin, and of course that's just the end. Once it starts spinning like that, you're not coming back. And we got another, I think we have three
spectacular light show.
3 light shows today.
But they were still smiling.
Pilots, yeah, still smiling.
This
it was
close.
that close.
And this was M-Tech, also going for 4.02 payload to weight ratio, looking good. And then I announced her jinxed them.
Yep, the motor separated from the mount is what we see here from the booth. And of course, you'd think, well, if you got 8 motors and you lose one, shouldn't you still be able to fly? And sometimes it works that way, but not when you're pushing the limits like we are here.
Almost looked like it was falling. It was auto-rotating back up because several of the props were still going. That team not quite as excited or happy about their results, but again, they were going for the 4.02, and this was Defentex. They were going for a 6.11 payload to weight ratio.
We see that propeller flex and bend and break, and This one actually did a surprisingly good job of staying relatively flat as it spiraled into the ground, and that may have saved it from damage, although we didn't see it get back up again.
No. So that's what you missed from this morning. Avidrone still remains in the lead with a 3.84 payload to weight ratio. MTech sits in second. Extreme Aerial Concepts is in third. Then you have H Squared and MacGyver. That's your top 5 as it stands right now, as no one has hit the 4-to-1 power to weight ratio and payload to weight ratio, I should say. MacGyver will be going later today, so we'll see if the team in 5th place does something to move themselves up into maybe a top 3 position.
Yeah, I think if you're in the 4 to 5, you got to be thinking, can I just get into the money at all? And then if you're in the top 3, you're thinking, number 1, can I improve my standings and not get knocked out? And number 2, can I improve the position and actually increase my prize money?
So that is the current leaderboard here, day 6 of the DARPA Lift Challenge. Still have some time left. 2 teams being extended their window of competition in this 11 o'clock flight window. We'll see if they're going to do something with it.
Yeah, and worth reminding everybody that even the team in first place, you got to hit that 4.0 to 1 payload to weight ratio in order to unlock the full prize. So currently, they don't have $2.5 million. They have whatever half of $2.5 million is.
1.25.
1.25. Thank you. I know better than to do math on the air live. It's one of my hard rules.
Just freeze up.
Yeah. No.
Well, the wind continues to blow, and you can see the...
If they can get that 4.0 to 1, they'll go to the full
Yeah.
prize. It's still a lot of money, though. Nothing to sneeze at.
I don't want to be greedy. I would be happy to just take the superlative. This is Hanamanta, and they literally have under a minute to go, but they're just doing a test, so they get up about 20 feet. Looks like they're half-weighted, and they're going to bring it back down.
You see that weight swinging? You see the aircraft? Did you notice how when the weight was swinging, the aircraft was responding to it? It's not ideal. You really want to see the aircraft sort of remaining stable as it can be, and keeping that weight as steady as it can be. In a worst-case situation, the aircraft can actually amplify the oscillation, and that can get out of control really fast.
All right, so we are coming down to the final moments here of the 11 o'clock flight window here on the penultimate day of the DARPA Lift Challenge. Remember, Super Sunday kicks off tomorrow at 9 a.m. Eastern Time, and we will go into the early afternoon before we crown a champion. Will it be the big prize, $2.5 million? Will it be the half, $1.25? We'll have to wait and see.
You see that camera shaking, you can just see how strong the wind is out there.
So just 2 lanes are open in this flight window. That's 12 and 14. And don't go too far. We've got another flight window opening up at 2 o'clock unofficially. I don't know, is that enough time to go over to the museum?
Maybe. Maybe get over there, get in there, see some planes, run on back. You thinking about going?
Yeah.
So I'm going to be starting the 2 o'clock by myself.
So Joshua, let me ask you this. You're clearly not going to get a scoring run in 10 minutes, and they're not going to extend the window even more for you. But what are you getting done here? What can you accomplish in this next 10?
Well, 2 things I think mainly. Number 1 is check flights. If the organizers are requiring you to do check flights for any reason, you can certainly get that done in 10 minutes and then go into the next round ready to go. The other is testing, gathering data. Like, just because you don't complete a run, if you go up with a 4.0 to 1 payload to weight ratio, you've got metrics. You're looking at the heat of the motors. You're looking at how many amps or how much fuel you're consuming. You're looking at all these things, and you can start to get a sense of whether you have a chance of doing it or whether maybe you need to be rethinking your strategy.
So you're looking at Protocarbon right now out of Coeur d'Alene, Idaho. Does not look like they are fully weighted. Maybe they're just getting an opportunity to spin up. See what they've got. What do you think? He hasn't spun up since he's been out there in the last hour and a half.
Yeah, he's been sitting there. We haven't even seen him spin the rotor. Like, if they were trying to do check flights or something, then presumably they would have gotten in the air. There is something that is preventing them from even attempting to spin the motor. Obviously, there are a lot of checks you have to do before you start that giant rotor. You want to make sure that it is going to all be in control. The question, I guess, would be, what did they decide to come out to the flight lane for Like, because if it was just basic configuration maintenance, they could have done it in the hangars, and they, as we've seen many teams, they might not even have elected to go to the trouble of coming out.
Oh, there's no they. This is a one-man band. This is owner John Brendel. He's a one-person engineering company at Protocarbon, and made the drive, I think, solo from Coeur d'Alene, which, by the way, I think it takes about 24 hours.
That is a longer drive than I would prefer to make, but you're not fitting that thing on an airplane, are you?
That's not hand carry.
Yeah, no. So presumably he came out here with the intent of, making a flight, and either there was a safety issue perhaps that was identified by the officials and they're preventing him from taking off, or he has identified an issue that means he needs to fix it before he can spin that motor up. Oh, there it goes. Oh, the announcer's curse finally works.
The reverse announcer jinx.
So we got some motion on that rotor.
So this is Protocarbon out of Coeur d'Alene, Idaho.
And you see it flexing as he goes to lift off. Did you see the tips were kind of drooping, but then as it spins up, it flexes and lifts. Those blades move more than you would think under normal operations. And we are seeing, I'm guessing, an unweighted check flight. We do see the gray Titan module. That's the device that's used to track the aircraft's location and other stats. But we don't see any weight on there. And it looks like it's just a traditional helicopter design. I'd say traditional, but kind of looks like a low poly graphic from a video game, sort of distilling everything down to its essence. And coming back down, you notice it's coming back down tail first, and that is because the aircraft is being flown with the unaided eye. So it's always easier to control the aircraft if it's facing away from you, so that forward is forward and left is left and right is right. It's very common to see them flown that way.
I think you'd be surprised at how much data he's getting just by doing this up, down, not a whole lot forward, but just seeing what it can do.
And a lot of times when you do a check flight like this, the organizers will say, okay, go forward, go left, hover in place. They want to make sure that you are controlling it in an intentional way, and you're not just kind of like up there, just barely hanging on by the skin of your teeth and keeping a calm face and hoping nobody notices.
So Protocarbon is up in the air. This is just a test flight.
He's got to set it down back in the intended location. That's part of the protocol. And I want to really be sure that you are controlling the aircraft and it's doing, well, maybe not exactly what you intended to, but within safe margins.
Simple skeleton frame, as he's going to stay near the takeoff and landing zone. Looks pretty stable.
Looks pretty stable, I do agree.
As Donna made a good point earlier, it looks stable 10, 20 feet, but conditions are different at different elevations. He's going to bring it back down. Did not land on the pad, but again, this is just a test flight for him.
Yeah, so if that was a check flight and he did not land on the pad, I would think that would not count. I guess that just depends on exact conditions on the ground. We got a big cheer.
Success.
Whatever it was a success. I mean, heck, that was their very first flight. We've seen them on the pad. We were talking about why they weren't. I mean, they could have been struggling to solve a problem the whole time, and here in the last few minutes and overtime, really, they managed to get it in the air. That's a big win for them, no matter what else.
Protocarbon and John Brendel, very happy about that. Fists in the air, high fives for everyone as he's able to go up, get a nice little test in, get some analytics, some data off of that, and he'll take it back to the prep area and possibly, and I mean possibly, ready to do something tomorrow and show us what he can do. So we're coming to the very end of this flight window here at 11 o'clock. I want to remind you we'll be back at 2 o'clock Eastern time, and that's when the next flight window will open. And we have heard some great teams are going to be out on the line with hopefully pushing the limits that we like to see.
Yeah, continuing to push those limits.
See if the weather conditions cooperate. It's pretty stable throughout the day. Bit of a breeze. Maybe a little more than they'd like, but it hasn't stopped them from heading to the flight line and trying to make an attempt.
Yeah. Gosh, I got to think about how frustrating. He's flown this thing 1,000 times at home, and it worked every time. And he got out here, and for whatever reason, the dang thing wasn't ready to fly.
But he did look bummed.
Finally got it. No, that's what I'm saying. Finally, he got it in the air, and he's ready to go. I mean, that's just such a win.
Pushing the limits above the ground and on the ground, and that is the little definition of scorched earth.
Yeah, scorched earth, you know, they come down. We got some battery fires, some liquid fuel fires. I'm not sure which I would prefer. I'm not sure which, if I had to pick one, which is going to be more of a challenge to contain. But of course, the fire safety team here more than up to the task.
What burns hotter, liquid or battery?
You know, I don't know. So batteries burn very energetically and very quickly. Okay, so a battery will make a big ball of fire, but it'll be over relatively quickly. Whereas fuel, the problem, as I see it, not a fire professional, but it spreads and it pours and it spreads out and it ignites things in a broader area.
And it just gains traction.
Yeah.
Well, the good news is that's not an issue for Protocarbon and their owner, John Brendel. They are safely back in, and look how massive it is, but two guys just walking it across.
Yeah, you really don't have a sense of how big these aircraft, some of them are. So you see two guys carrying it, and that is under 55 pounds. Heck of a piece of engineering.
So they will check it out, probably remove the rotors to transport it back to their prep area in the hangars. Save the best for last.
Yeah.
Waited to the final moments of the 11 o'clock flight window to put that up in the air and got some good data off it.
Yeah, they've made the use of that extra time they were granted because they were delayed by fire on another lane. And that arms up moment, that cheer, that really sums the whole thing up.
Sure.
You struggle and you struggle and you struggle, and then you get your victory. And those victories just keep compounding. And at the end of the day,
so the flight window has officially closed for the 11 o'clock. 90 minutes plus a little on the back end has come and gone, which means everyone heading back to the prep area and to the hangars, and those teams that are ready for the 2 o'clock flight window will start their preparation and will be heading out to the flight line soon. But we can tell you we will be back with full coverage at 2 o'clock Eastern time as we continue on with our coverage. So for Elena Buenrostro and Joshua Bardwell, I'm Todd Harris. We'll see you back here 2 o'clock Eastern at the DARPA Lift Challenge. Welcome to the National Museum of the United States Air Force at the DARPA Lift Challenge in Dayton, Ohio, as we are set to open up the 2 o'clock Eastern flight window here as we get ready for more competition. Alongside Joshua Bardwell, I am Todd Harris. Glad to have you with us as we take a look at the current leaderboard. Now, remember on the right-hand side, that is the payload to weight ratio. So right now, Aviadrone sits on top with a 3.84 mark. MTech sits in second, Extreme Aerial Concepts in third, with H Squared and MacGyver rounding out your top 5. Well, they are pushing the limits, certainly in that first 9 o'clock flight window, JB. We saw a lot of great stuff, a lot of potential, but no one able to cross over that 4-to-1 rate ratio. Here's Aviadrone. They tried at 4.02, and this was the result. Looked promising at first.
Yeah, it looked promising, but it ultimately ended with a disappointment. We've seen several teams trying to crack that 4.0 threshold. Here we go. Oh, it's this close, just that close. Always good to see that from the team.
Then shortly thereafter, MTech went for a 4.02, and this was the result there as they were able to get to elevation, and then it all came quite literally crashing down.
Yeah, they went 1.32 nautical miles before it came apart. Looks like they lost a motor.
And then Defentex out of Moab, Utah, by way of Australia, they went for 6.11 payload to weight ratio. Looked good for a short time, and then this.
Yeah, that 6.11 ratio, not really a strategic choice. Like, why didn't they just go for 4.01 or something? The lightness of their aircraft means that with that 110-pound minimum weight, there's only so far they can push that. They got to go big or go home.
So we welcome you to day 6 of the DARPA Lift Challenge. Todd Harris alongside Joshua Bardwell. You're our drone expert. Bottom line, if people are just tuning in, what can they expect to see in the second half of today?
I think they can expect to see these teams trying as hard as they can to make the most of the limited time they have remaining. For those teams who have secured a spot, trying to secure the spot or just push that lead ever higher, that 4.0 payload to weight ratio is the key to unlocking the full prize pool, only getting half prize if you don't hit that.
So we've got a full flight window, which is 90 minutes. It can be extended, and that is by way of the Air Ops leader decide whether they get more time. This is a team out of White House Station, New Jersey, small business category. This is Burl Aero Alpha. They've got 2 drones, both very cool looking, JB. They've got Alpha and they've got Omega.
Yeah, this is a design. Looks like a spaceship.
Looks like a stealth.
Remains to be seen whether they intend to use this surface as a wing or, gosh, given the things we've seen here, I wouldn't be surprised if they turned it into some kind of a rotor. We've got this cable hanging down below it. Is that how they're going to carry the weight? Is that a tether that they're using for some kind of a safety run? We do not know.
I can't tell you a little bit about Burl Aerospace. It's a team that's a collaboration between Toby Bursack and Burl Aerospace, which has developed a unique patent-pending dual-use technology platform that provides scalable and ultra-efficient next-generation vertical lift capabilities.
Yeah, we do see the weight hanging down there below them, and we do see them beginning to spin, or are they just doing turns, little test turns to see how the aircraft responds? I'm really curious whether they will fly straight forward or whether they will try to generate lift by rotating. And honestly, Todd, the fact that I would even think to say that shows how much my mind has been expanded about what is possible.
This just opens up all kinds of questions for me, because with having to fly 4 nautical miles and then an extra nautical mile without the weight, with that weight dangling that far down, do they have to take that into account? Does the weight have to stay above 100 feet?
Well, I could not begin to guess. Could not begin to guess. I mean, I would be surprised if they tried to do a run with the weight hanging so low, although many things, as I've said, have surprised me this week. The lower the weight, the more it's going to swing and pendulum, and it's going to create a lot of stress on the flight controller, the little computer that stabilizes that drone. Wow. Reminding me of a UFO or maybe an SR-71 Blackbird. Just a crazy design.
So as they kind of sort this out, you see some heavy clouds in the distance, nothing like we had yesterday. It was about this time that the weather rolled in yesterday and kind of locked everything down and then shut everything down. We were given the shelter in place with the thunder and lightning and the heavy rain. If you're in the Dayton area, you know exactly what I'm talking about. Right now it looks good, JB, other than the wind. But this seems like it's relatively impervious to these gusty winds.
It doesn't seem to be responding very much. It's fairly thin. It has a long surface, and it does seem fairly stable. You know, there's always a question of how much power you want to give to your motors, and you know, the bigger the motor, the heavier the motor, then the less weight you have for other things. Right. And of course, the worse your payload to weight ratio is. So you really
what's the advantage of having the weight that far away from your craft? If any,
I struggle to think of an advantage. Frankly, having it mounted directly on the craft is going to give you the most predictability. That's the key. The flight controller is tuned for the specific physical characteristics of the aircraft, and if that's changing because you have a weight penduluming underneath you, it's going to struggle.
And because it's so long, it's going to utilize both landing pads, so a near perfect touchdown, splitting the difference there for Burrell Era Alpha. As their Alpha drone has gone up and has come back down. A nice little test for the team from White House Station, New Jersey.
It certainly is notable to me that this late in the competition, we're still seeing some entrants that we haven't seen before. Burrell is new to me. I don't think we've seen them before.
They're just lying in the weeds, waiting to snap, and again, trying to see if they can get something done. Another team that's in the air we have seen, this is MacGyver. They currently sit 5th overall in the overall standings, as they have completed a scoring run with weight. This is just a test flight for the team from Baltimore, Maryland.
Yeah, you see underneath there's that gray, what looks like it would be a weight plate. That is the tracker that's being used to track the location, the altitude, and for safety and scoring. That is counted towards their payload weight.
Right.
Technically, this is a 2.5-pound flight, but that certainly would not be enough to make a difference in the scoring.
MacGyver's team lead, Timothy Dunn, a former Marine with many years' experience in drone racing and robotics. Will Setzler works as a UAS pilot and expert engineer in UAS systems, and Dave Groft is an embedded engineer. They also have Martha Lopez, an expert autonomy ground station operator. So this is MacGyver out of Baltimore, Maryland. They are up. They look stable. All they're missing now is a 4-to-1 payload weight ratio, and just booking along at
looks like they're coming
4 nautical
down.
miles. Yeah. Now this looks like have we seen them with weight before, and are they able to eject that weight without having human assistance?
Well, as we saw, sometimes that weight ejects itself. We still don't know if that previous weight ejection was intentional or a failure of some kind, but sometimes that weight ejects itself without your needing to.
This is lane 4.
So it looks like they're doing some testing of the aerobatic capability. We're doing some relatively sharp turns, given what we've seen here. They do seem to be intentional. In the same way you take a car out onto a skid pad and kick the rear end out, see how the tires perform. Sometimes it makes sense to push one of these drones like this.
This is SciLift, is a M21 team at Iowa State University, Department of Aerospace Engineering, as we are looking at MacGyver still. Still looking at MacGyver.
Yeah, one of the things we talked about previously was if you're going to do testing like this, you either want to do it close enough to the ground that if you crash it won't do minimal damage, or high enough that you hopefully have time to recover. It looks like they are choosing the close to the ground approach. I have to say my read as a pilot is that this is all intentional testing. None of this looks out of control. It looks like they're just jerking it around a little to make sure it's going to remain composed.
So they do put it down on the actual platform, but it's all good. And I was beginning to give you the info details on SciLift. Again, that's a team out of Ames, Iowa. You know what's in Ames, Iowa?
What is it? Ames,
Iowa State University.
I knew it was going to be a football team. Oh my gosh. Todd, you must be thrilled.
This is their Department of Aerospace Engineering team, composed primarily of undergraduate aerospace engineering students.
Todd, tell me who that mascot is on there.
It's a mighty Hawkeye.
There you go.
No, I'm just kidding. That's a Cyclone. Hawkeyes are the University of Iowa. Iowa State is the Cyclones.
You know, am I imagining that there is one downward-facing motor? And
no, you are absolutely correct. On that right-hand side?
Yeah, so most of the time if you have a coaxial drone like this, meaning two motors in the same axis with each other in the same plane, then you'll have them on each of the motors. Here it looks like we have is it 3?
It looks
love
like
to see
is
that.
a tripod?
Love to see that more from the top, where you maybe get a better idea.
Yeah.
But it's a very interesting design.
So is that a directional thing? The way the mascot's pointing forward, that's the front end, and the
you got to
tail
assume.
has the
yeah, exactly. We've talked about how they're flying these aircraft via line of sight. The pilot is viewing it with their unaided eye, and so you sometimes need a indicator of which way is the drone is the front. It's not always obvious just from looking at it, and in this case, that may be what our little mascot there is doing.
Here's a big question I've got for you, coming from the folks out in the interspace and the social media realm. What is the difference financially and technologically between the drones we're seeing at the DARPA Lift Challenge and one that you can buy at a hobby store and you can take out and have some fun with?
Yeah, so these are obviously larger. They're designed to carry 110, 220 pounds of weight. You're not going to buy a hobby drone that can carry 220 pounds of weight. You might buy a commercial drone or an agricultural drone, but that's not your typical person. I would say these are probably in the 10x price range, and more or less around that. Well, there's a lot of range in the weights.
So a lot of teams out there frantically trying to get their craft ready to fly. Wind is picking up just a little bit. That is some cool designs. Advanced Tactical is out on the flight line. Remember, this is a 90-minute window. They can get an extension if our Air Ops lead, Ann Bush, is feeling generous. Have to have a good reason. I mean, you can't just say, hey, I'd like the extra 20 minutes.
Yeah. And only feels generous when there's a good reason.
Yeah, you wouldn't have got an interview with her.
Mainly, I think if something about the DARPA equipment, the monitoring equipment, for example, causes a delay, or weather, or we saw a situation earlier in the day where a fire on one lane meant some of the other teams couldn't operate. And if you cause a fire, then that's your clock, but it's not anyone else's.
So this is what innovation looks like. This is the Stanford OHS UAVs out of Redwood City, California.
Yeah, I talked to these guys a few days ago. Just amazing amounts of innovation coming from them. They've built CNC machines to cut the foam. They laid their own carbon, vacuum sealed it, cured it. Every bit of this was done by them with tools and materials that they built.
These are students at Stanford Online High School and at American High School in the Redwood City area. They all share a passion for drones. Guided by mentors, they formed Stanford OHS UAVs.
Yeah, we've seen in the past that they've had trouble even getting into the air. As soon as they lift off, they have stability issues.
Yeah.
Speculated it may have something to do with the rigidity of the frame, but we don't know for sure.
I mean, you look at this and you think, well, that thing is just like an albatross. It's so big, but you think about payload-wise, that thing's got a lot of potential.
Yeah, this is a stacked airfoil design. So if you look, each of those little fins going sideways is an individual airfoil, and they are joined together to make one big compound airfoil. And in fact, the front and the back elements, when the drone pitches forward into forward flight, you can imagine the back coming up and the two airfoils together. So it basically turns the entire aircraft into one gigantic airfoil.
So they've got a laptop hooked up to their drone right now. They are going through some data and some analytics. They have that hooked up as well. You see the pilot there on the right-hand side. Same thing going on here. So what can you possibly get when you're not flying?
Well, I would think that they're doing configuration. They're configuring the flight controller. They are tuning the flight controller for the specific characteristics of the drone. A lot changes. Like, surely they had it tuned and flying before they came here, but then you get here, you're different altitude, different temperature, different air density, and just sometimes you just get gremlins on the day of the flight.
You had a chance to speak with these guys. Did you get any idea of the design of this, how they came up with it? And second question is, do those slats, do they cantilever? Do they move?
They do not.
Flight? So
no,
they're fixed.
So they're fixed, and what they've done is they've estimated for the forward speed that they think they're going to have, they're going to need to go to a certain pitch angle, like 10 degrees or whatever it is, and they've angled those to be at the correct angle relative to the airstream when they are in that optimal.
I gotta think, and this is just me asking probably a dumb question, if you put this in a wind tunnel, it's not the most aerodynamic drone we're seeing out here.
No, it's not. It's not. The idea here is that we're going to generate a lot of lift by having a lot of little airfoils, and that's going to be very dependent on the airspeed and so on. There's going to be a lot of conditions where they're not facing the right direction relative to the airstream, and they're basically creating a lot of drag. But then you hit that sweet spot, and the hope is that everything comes together.
Another question I'm getting, is this thing flying face forward or with the slats going towards the direction, or is it sideways?
So you're looking at the front of the drone right now,
okay,
and it will fly in that direction.
So the more open section.
No,
side?
I'm sorry, to the right side.
Okay, to
you're
the
looking
right.
at
That's
the front.
the front. Okay.
Yeah, the slats will be facing
so
forward and moving
the air
forward.
will travel through those slats.
That is correct.
Creating some bit of a lift and then hitting the back, and as it exits,
creating more lift.
More lift. Okay.
And in fact, you don't want any overlap. You want minimal overlap between the front and the back, because of course once the air hits the front, you extract energy from the air, you gain lift, and you deflect the air downwards. And at that point, it's better to have the rear fins, the rear airfoils, getting clean air. And so the idea is that when they tilt forward, that will give more clean air to the rear airfoils.
Yeah, I was going to say, once it passes through those initial slats, you're dealing with disturbed air, correct?
Mm-hmm, that's correct. And the key here is that they've got to be able to get into the air,
yeah,
and they've got to be able to get up to speed. And so far, we haven't seen them do that. As it starts to take off, it wobbles and shakes, and they very carefully set it back down again. One of the potential problems that they could be running into is the requirement that they do an unloaded check flight before they put the weight on. You could imagine that if somebody told you had to do this very difficult task, carry 220 pounds, you'd immediately start building with 220 pounds on the drone and maybe not even think about, oh, what happens when I take that weight off? I've tuned it for 220 pounds, and now suddenly it's not right. Think about if you had a big cargo truck and the suspension's tuned for weight. The minute you take that weight out of the back, suddenly it's a harsh ride. That's a great analogy for what could be happening here.
A lot of teams out there on the flight line. Remember, at the start of the day, we were scheduled for 63 flights, so we are flight loaded today on the penultimate day here at the DARPA Lift Challenge. Well, there's a lot of people in charge of different aspects of the DARPA Lift Challenge. As you can imagine, this thing came together in less than a year, but a lot of technical people handling each and every aspect. And one of the gentlemen that's in charge of the flight lines, a very key individual for this thing to go off without a hitch, is now standing by with Elena Buenrostro.
I'm here with Drew, who is the flight ops for DARPA. Drew, you've been here on the flight line. What is your team watching and managing during every single one of these lift attempts?
Yeah, Elena, absolutely. So we're looking for teams to come out here, operate safely. We've been doing a crawl, walk, run approach, and we're asking teams, what are you planning to fly today, right? Like, how are you going to accomplish that? Or how much payload are you putting on the aircraft? They've really been receptive to it, and as you've seen, we have had crashes, but they've all been safe.
All right, and with so many aircraft in the air at the same time, what are some of the things happening out there that viewers at home wouldn't really see or know otherwise?
Yeah, absolutely. So I'll take the two airplane, the tandem planes. So I was out there when they were doing their last flight, and something that you wouldn't necessarily see that's happening is that these teams are tuning pitch angles, they're tweaking games on the fly on their GCSs, their ground control stations. So that team in particular, they did voice to text on a AI, like a chat GPT, and they found their pitch parameter within their flight controller and literally did that as they were flying. It was incredible to see.
Wow, that is awesome. And so what do the teams obsess over that viewers wouldn't actually be thinking about while watching?
Yeah, I mean, so a lot of these teams have a lot of experience flying. They know their aircraft inside and out. It's their baby, right? They want to make sure it gets back to them safely. So they've been really, really good grabbing their aircraft, getting it back. They're making repairs on the fly so that they can get out there the next day.
And it's obviously been super hot this entire week, and we've noticed you've been inching up your sleeves here and getting those guns out. How happy are you with your tan right now?
Oh man, so Monday I had a very, very nice farmer's tan. Now that it's Saturday, it's gotten better, I've been told.
Yeah,
so,
yeah. It's looking good.
Thank you.
Back to you, Todd.
Thank you, Elena. Those are some hard-hitting questions right there. You don't get those just anywhere. And Drew adopting the Suns Out, Guns Out policy here in the DARPA Lift Challenge.
Yeah, I think I'm going to start rolling my sleeves up a little extra.
Let's go.
A little extra.
Let's go. Still waiting for some action out on the line. Looks like Stanford OHS UAVs. They're spinning up. We'll see if they can get this thing off the ground. A lot of people came up and said that looks like a table that they've taken the top off of. Wait till you see it. We've also got another team back in the air. It's Burl Aero. They've got the Alpha, which is that cool long blade design.
Yeah, we saw that spinning in a circle, and
it's like a stealth wing.
It is. We've seen designs where a wing like this will rotate like a rotor blade to generate lift. We could imagine a design where it flies in a straight line, and when it starts spinning in a circle, we don't know if it's trying to start to fly or if it's just doing some test turns. And
here's a question, and I'm going to throw this out because I don't even know if you know the answer. This might be a Donna question. With the length of that cable to the weight, does that mean their margin of error staying between 100 and 200 just became a whole lot narrower?
Yeah, so like the Titan tracker is the thing that is on, well, it's on the craft. We've seen it on the top of the weight stack. I suppose the Titan tracker is the thing that's telling them what their altitude is actually technically at for the sake of the challenge. So in theory, that would mean that the Titan tracker, the weight stack, would need to stay within that range. But then again, they could have mounted the tracker on the aircraft. And we don't know for a fact that they're going to actually make their attempts with the weight hanging that low. That would surprise me if they did it with it, because with it hanging that low, it would pendulum really badly in the turns, and seems like that would be a big disadvantage.
So that is the Alpha drone for Burl Aero. Here's Stanford OHS again. And
still struggling to get in the air.
Just getting that thing off the ground.
Yeah.
I just want to see it in the air because I want to see what it'll do.
Yeah, for sure. I'm sure they do as well.
Yeah, absolutely.
You know, the tenacity of the teams who come here. I mean, imagine when you were in high school getting to come here to the DARPA Lift Challenge with a design that you build with your buddies and to compete on this level with all these other guys. This is going to be great, a great experience for them, whatever the result.
This is Advanced Technical Lift, just abbreviation of ATLAS, out of Buffalo, New York. Advanced Tactical Lift Aircraft Systems.
Now, this is a very interesting design. They have something like 32 motors. That may not be the exact number. I spoke with them a few days ago, and they said they had to reprogram their flight controller because the flight controller was not programmed to handle that. No one thought you would ever need that many motors. So they're going with a lot of motors with smaller props. That does reduce the efficiency. All else being equal, a larger prop will be more efficient. But you can imagine they've got a ton of redundancy. They said they had a situation where they lost a whole bank of motors and were still able to bring it in and land it safely.
Is there a limit to the number of motors you can have?
Well, I mean, theoretically,
weight-wise,
no. Yeah, I mean, weight and cost is a consideration. And then you think about for any given amount of thrust that you want to make, you could have one giant prop that makes that thrust, or you could have more smaller props that make that thrust. And eventually, you know, there's just like, what are the trade-offs you're making as you make that decision?
Yeah, the problem of having one giant one, if it fails, the whole thing goes south. If one of these fails, you've got plenty of backup. But that's more things to check and more things to possibly go wrong.
More things to fail. Imagine you have 30 motors. A lot of times on these aircraft, each of the motors will have an individual battery. So if you have one battery go bad, you don't lose a whole bank of motors. Well, that's 30 batteries that you have to charge, 30 batteries you have to plug in, and 30 opportunities for you to make a mistake.
And 30 batteries worth of weight. Remember, the max weight on these is 55 pounds. Still watching Advanced Tactical Lift Aircraft Systems out of Buffalo, New York.
You know, another component of this is that this is a fully modular airframe. So they've scaled it up to a certain size, but they told me they can scale it bigger, they can scale it smaller, and that's another advantage of this approach. You have one rotor, you need it to be bigger, you need a whole new aircraft. Here, they want to lift more weight, they just, bloop, 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 copy paste.
I'm being told that their margin of error is very thin because their aircraft weight is 54 pounds. So the Advanced Tactical Lift Air Systems aircraft, highly skilled. Look at this.
Those circles painted on the grass showing them where to land.
Perfect. This is a group of students from the crash lab at the University of Buffalo and State University of New York and Motovolo Drone Company.
Yeah, they also told me that originally they were over that 55-pound limit and had to do some redesigning. to get it under. So, you know, they come with what you think is going to work, but
looks like they're taking some plates of weight out there. This is Drone Smith right now in the air, doing a little bit of testing. So we'll see what they can do. They'll obviously have plenty of time. Remember, these are 90-minute windows. Could be extended if it's needed. You have a valid excuse, valid reason. Drone Smith out of Gilbert, Arizona.
And it looks like they have an unweighted, this is an unweighted test flight or check flight. We have that gray Titan tracker down there. It looks just like a weight plate, but it only weighs 2.5 pounds. That does technically count as part of your payload if you do a scored flight. Very carefully flying along here. These huge cargo planes in the background, beautiful fighters. Oh, I love that shot. Really makes you think about the relationship between what we're doing here and all of the aviation that's happened in the past, doesn't it?
Yeah, absolutely. I guess the most close comparison, and we have Philip Smith, the program manager, call sign Donna. He flew Harrier jets, and this would be the closest thing we have other than helicopters with the vertical lift.
Yeah. New types of vertical lift. You can imagine when they invented the Harrier jet, someone said, that'll never work. And of course, it didn't for a while, and then they figured out how to make it work. And now we have vertical takeoff jets like the F-35, and it's just something
amazing. Drone Smith continues to go through their test here. This is the 2 o'clock flight window on day 6 of the DARPA Lift Challenge. One more day. Tomorrow, Super Sunday, we'll close things out, and we'll see if anyone can break that 4-to-1 payload to weight ratio and claim $2.5 million. Avidrone continues to lead their ratio 384. MTech sits in second, just ahead of Extreme Aerial Concepts, and then it's H Squared and MacGyver in 5th.
Coming on down. Looks like they're bringing it in nice and stable. That's what you like to see.
Still Drone Smith making their way, going through minor testing. That's pretty stable, right?
Yeah, absolutely. And you know, there might be wind out there, but this design, a multi-rotor like this, is relatively impervious to wind. As long as you have enough headroom, like you have a thrust to weight ratio of maybe 2-to-1 or 3-to-1, and that gives you plenty of headroom and power to overcome the wind and so forth. We certainly have seen, especially as you add the weight, you run out of that headroom, but that's kind of the point of the competition, that you want to push those limits and find out just how far you can push them.
They're going to bring the platform over for Burl Alpha. Looks like they might connect the two platforms. And this is the one, if you remember, that's the big blade-looking stealth wing that has the weight hanging down below via cable. So,
yeah, we've seen this before, where they have to move the platform for some of the larger drones to keep them a safe distance away from the flight line.
Still looking at Drone Smith, the operation out of Gilbert, Arizona, suburb of Phoenix and Mesa. Is there a drone hotbed, a hot community for drones in a certain region of the country? Is it pretty evenly dispersed?
You know, there certainly are places where drone operators struggle a little more. You can imagine if you live in New York City, for example, there's so many, Washington, D.C. area, there's so many no-fly areas. Nevertheless, there is just a thriving and strong drone and RC community pretty much throughout the United States.
I was going to say, I mean, I can see
and the world.
Applications for it if you were out in the plains or farmlands, or if you were on the coast,
it's
coastal
much
region,
easier.
flying out in the ocean, up in the mountains.
Yeah, it's much easier if you're somewhere remote where there's not a lot of regulations. It's much easier where you can just go out your backyard and fly for, you know, a few thousand feet or maybe a few kilometers over nothing.
Or if you get the nice folks at the National Museum of the United States Air Force to let you come out and use their palatial estate. As we welcome you back to the DARPA Lift Challenge here for the 2 o'clock flight window. Todd Harris alongside Joshua Bardwell as we get down to some serious business. We are now half an hour into this flight window with 60 minutes still to go. Let's check in with a team that is currently in 5th place overall. This is MacGyver.
Yeah, MacGyver in 5th place overall.
That's some serious weight,
right?
Yeah,
they have some serious weight. They're probably getting ready to do another scored run and try and improve their standing. At 5th place, they are not in the money, But it's pretty clustered up there, and anything could happen.
It'll be interesting to see once they get up to elevation. We can give you an idea of just how much weight they're there. But they are doing a little bit of a test for landing. MacGyver, the squad out of Baltimore, Maryland. Ooh, came right to the edge, but they're safely on that platform, and that ratio for them is a 363, so they're carrying 182 pounds.
Yeah, and the rule is that the center of the weight has to be within that 5-foot circle, 10-foot diameter, 5-foot radius, when they set down, at least if it's a scored run. It does look like they're setting up to do a scored run based on the weight and based on the tracker that we're looking here.
So at 363, the question is got to be asked, if you're that close, why not just juice a little more and go 401?
Well, I think what we're seeing is that the distance from like 3.5 payload to weight ratio to 4.0, it's much more vast than you would think.
Yeah.
And we've seen several competitors try to hit 4.0 and have things like the rotor disc separates, the motor rips off, and that's just due to the additional stress that's being placed on the aircraft by that additional weight. So in this case, 363 would put them above Extreme Aerial Concepts and below MTech, put them in the third. This basically will put them in the money.
Yeah, but they're 0.01 from going into second.
Yeah, yeah.
I mean, isn't that a couple French fries? What are we looking at?
Well, they can't add just any amount of weight. Perhaps they might be able to strip a little weight off of their craft to
and then bring the
ratio.
ratio.
But they're adding weight based on the plates, and I'm actually not sure what the minimum plate is that they're allowed to add.
Okay. So you're looking at MacGyver right now, this team out of Baltimore, Maryland. You saw them go up there, and this would be if this was a successful flight of 4 nautical miles with weight, 1 nautical mile without weight, they would move into third place, and that would put them in the big money category. Just moments ago, back to SciLift, the team from Iowa State. They're going to spin up.
Oh, okay. Well, I did get my top-down view.
Look at that.
Probably not in the way that you would have hoped. That is a Y-copter. You can guess why it's called that. Or a tricopter. The big challenge with a tricopter is this. I'm not sure how easy it's going to be for me to explain this. How do you get yaw authority? That's looking left and right. Those motors are not facing sideways. So it's easy to imagine how that aircraft goes up and down. The motors just speed up and slow down. To get yaw authority, you use that counter torque. We've talked about how whenever you've got a spinning rotor, there's a counter torque. And by spinning those motors faster and slower, you can cause the aircraft to turn left and right. But the key is that you need a balance of torque. So those two motors that are on the tail, they're spinning opposite directions, and by speeding them up relative to each other, you can cause the aircraft to turn left and right.
Great explanation. Thank you very much, sir. So, good folks from Iowa State University. We'll get back out there. It looks like the mascot has been able to survive that relatively unscathed.
We've got that rectangular gray box on the top. That, again, is the Titan tracker. It's got 2 forms. That's what that is. We don't know why that happened. Usually when you flip over on takeoff like that, it points to some kind of a configuration or programming. Well, we'll call it a mistake. I think that's safe in the flight controller. Especially as they're unweighted, so it's not like they didn't have the power. Like if a wind gust came, they would probably have plenty of power to counteract that. The other thing I notice is look how small these props are relative to the size of the aircraft. Obviously, we've said larger props are more efficient, and efficiency is the name of the game here. Usually the limit on the size of your props is the size of your airframe. If the tips of the props would touch each other, you don't want to go any larger. But I wonder what the decision was to go with these small props. Maybe the motors would be too large and add too much weight, or maybe they just thought this was good enough to get the job done.
We'll wait and see if there was any structural damage to SciLift to see if they can keep going.
Oh,
something got their attention really quick.
I wonder what that was.
Drone Smith is back up in the air on a weighted check.
Again, these safety check flights are necessary before you're allowed to go up with 110 pounds of weight. You can imagine that comes crashing down. That's more of a safety risk. You have to demonstrate that you're able to fly with no weight, and then you have to demonstrate that you're able to fly with half of that weight, and then you're allowed to go for your scored runs. And anytime you have to do any repairs or modifications to the aircraft, you have to redo those checks.
continuing on the safety conversation, do each one of these drones have a kill switch or something like that? If they lose control, they lose contact with it, do they have a button they can just shut it down?
There are procedures for all of that.
Okay.
The most basic thing you see on hobby drones is that if the control link is lost, the drone
comes home.
Well, it either comes home, or in the case of very stripped down drones like racing drones, they don't really have a GPS. It just disarms and falls to the ground. And so you would always fly somewhere where that would be safe to do. I would think that these, well, I wouldn't speculate about the exact procedures here, but suffice it to say they definitely have a kill switch so that if control is lost, then nothing bad will happen.
So Dronesmith is up, and we've been told that they are going to run the entire course, but they do not have the sufficient weight that would really give them any kind of, I'd say, advantage, not a scoring run. So but it's good to see them up, getting some testing done. Remember, they have tomorrow as well, which will be the Super Sunday final day of the DARPA Lift Challenge.
Yeah, minimum 110 pounds of weight for a scoring run, a minimum of 2-to-1 payload to weight ratio to have half the prize money, and a minimum 4-to-1 payload to weight ratio to have the full prize money. In this case, I just said, well, we're just going to give it a go.
Have I covered every aspect of drones in the last 3 days with you?
There's
there anything
so
I've
much
missed?
more.
Have I missed anything?
So much more.
Okay.
I think you should get into it.
There you go.
You become instead of sports, you become a drone reporter.
So you're saying there's a chance. If you are not aeronautically or aviation proficient, and like me, you're aviation challenged, what would you recommend for someone that wants to get into this? What would be the first thing? You talked about going on YouTube. You talked about some different programs you can get for free.
Yeah, obviously, we all like researching things on the internet. There's a lot of YouTube content, including my content, but a lot of other great creators, some of them who are here, making content about FPV. When I got into RC flight and FPV first-person view, I just soaked that stuff up, and it gave me an idea of what was possible. I'd see a video and I'd go, I want to do that. And then I'd start researching and what I had to buy and what I had to build in order to do that. Then the next thing you might think about doing is there's lots of computer-based simulators, PC-based simulators that give you a surprisingly accurate experience of flying one of these drones. The skills really translate, and for, say less than $100 for sure, and maybe even less than that, you could be doing this on your home computer and seeing if it's really for you.
Okay. I know there's a lot of applications, not only in sports broadcasting, but now you see it in movies. The drones that they use in movies, a big major motion picture, wouldn't be anything this big.
Probably not this big. Typically, a movie drone is lifting a camera, and that camera might weigh anywhere from 5 to, let's say, 40 pounds. So if you think about the size of the drone as being roughly proportional to the size of the payload, we're lifting 110 to 220 pounds, but they're not actually that much smaller, as you can see.
Yeah. So we'll see if Martin Scorsese comes calling here at the DARPA Lift Challenge to say, I could use one of those in my next picture.
Yeah.
This is an interesting team. This team is called Rock Solid, and this is basically a parachute.
So I would say a parasail. Parachute's designed to go down.
Trying to get this up, though. We watched them the other day, and it's almost like they have to have near perfect conditions to get it up and then get it inverted.
The challenge is getting the parasail inflated. So if you think about the videos you see, the people will stand on a hill, there will be wind going over the hill, they'll lay it out behind them, they'll run forward, and it'll come up behind them and inflate. Or you think about a base jumper, they hang it down, they jump, and they go over it, and it inflates. The key is you have to get air into it, and then you have to keep it inflated. The big advantage of this approach is that the payload to weight ratio for a parasail, it's so light, and it can lift so much weight relative to its own weight. It's got a ridiculously high payload to weight ratio, but so far we have not seen them succeed at getting it inflated. They just go up in the air, it hangs below them, and they kind of come down again.
And the drone does most of the work. Well, we did see them the other day. This is Rock Solid, and this was the attempt right here. So it looks like they changed their design just a little bit.
One of the challenges is that they're not allowed to do a run-up. They have to do vertical takeoff. Now, once they're in the air, they can go forward, of course.
And we heard Donna say earlier today in one of the earlier flight windows that you have up to 1/2 nautical mile to achieve 100 feet of elevation.
The other thing I noticed from that video is before the parasail gets inflated, it is just a huge amount of drag.
Yeah.
Right, it's wasting energy. Once it gets inflated, then it provides lift, of course.
So that column section looks like that's something they've added in the last day or so. The two circular sections, the orange and white.
Looks like a guard of some kind.
Blade protector?
Maybe to try to keep the lines out of the propeller. Like you could imagine perhaps they were anticipating an issue with that. Why they have it on one side and not the other, I don't know. And it also looks to me like there is a forward-facing prop, or is that an optical illusion? Or sideways-facing prop?
There's MacGyver, and
lots of wobbling.
That was a heavy landing.
Yeah, drone's fine. Lots of wobbling there. They safely brought it back down when they saw that they were not able to have the level of control that they would have liked.
Unofficially coming up on the halfway point of the 2 o'clock flight window. Remember, it's a 90-minute window. Let's go back and look at this one more time. This was MacGyver just moments ago. This was at 3.63 payload to weight ratio.
Yeah. And the reason for that wobbling, as you add weight, you hit a point where one of the motors will, they call it reach saturation. The motor is essentially spinning as fast as it possibly can. Now let's imagine that arm is going down. The arm is going down, so the flight controller commands the motor to speed up, make more thrust, and prevent the arm from going down.
There you go, Stanford High School.
Oh, Stanford High School
got
in
it
the
up.
air.
They got it up in the air.
This is what I was hoping to see. That is not what I was hoping to see.
Not what you were hoping to see.
So the motor reaches saturation. It's now going as fast as it can go, and if the arm continues to go down, there's nothing you can do.
Right.
And so what we might get is a situation where those motors are basically bouncing off the red line, and we see that oscillation. If the aircraft was just a little bit lighter, then it would have the power to do it.
So let's take a look at the Stanford OHS UAV team out of Redwood City, California. We've got liftoff.
It looks okay at this moment. Relatively stable. Drifting backward. They start to make corrections, try to prevent that drift. Try to lean it forward just a little bit, lean it forward a little more and correct that drift, and it gets into an oscillation. We have a little bit of left, right wobbling, and again, they bring it down. But yeah.
Oh.
It's really easy to get into kind of an overcorrection loop when you're this close to the edge.
I just feel like if they could have kept it right side up, the potential for a turnaround might be there, but as it stands right now, it does not look like that's something they can just carry back and start over again. It's like some of the rotors.
We'll see. If the props broke, then they're replaceable. If something structural broke, then it may require more repairs. It's nice that they came down close enough to the flight line that they are being allowed to retrieve the drone by the lane coordinators. If it was further out, they wouldn't be allowed to go out there because there would be a risk from the other flight lanes. We're looking for parts hanging loose, broken frame elements. Just trying to assess. Honestly, the propellers look like they have folding propellers that may have saved them.
Yeah.
You can see them checking to see if that's still secure. Yeah, the fact that those propellers look bent doesn't mean they're broken. They fold up for transport and they spin out when you spin the motor up, so that's not an issue. But you definitely don't want to just go, yeah, it looks good, and jump back in the air and have something surprise you. You want to give it a thorough once-over.
I'm going to go on a limb that these guys are not taking PE and basket weaving at classes in high school.
They seem to be very interested in, CAD design and carbon fiber laying and mechanical design. Two of them are kind of the computer.
Got to be crushing
drone
in physics,
guys.
right?
One of them is the pilot. Yeah, a bright future.
These guys aren't getting C's in physics.
I was not doing the things they're doing at my age, I assure you.
I think I was getting C's in basket weaving and PE. That's why it's so good. All right, so they're fortunate enough that they can retrieve it. They're close enough to the takeoff area that they are not posing a risk to themselves or anyone else, so they will bring it back in. That was MacGyver. They spun it up for a second, didn't see the numbers they liked, so they shut it down.
Another thing to say about MacGyver is they take off, and we speculate that maybe their motors were right at the edge of the red line.
Right.
The heat of the day and the heat of the multiple temps affects that. electric motors become less efficient as they heat up. So you start the day with a cold motor, you do one attempt, you do some test flights, the motors warm up, and then you put an extra 45-pound plate on and you go for it. And it might have worked at the beginning of the day, but now because the motors have heated up, it doesn't work. So it's not as simple as just saying, I'm sure it's going to work when you're this close to the limit.
Yeah, and even Donna mentioned the other day, has seen some of the teams, I think it was Defense Tech or whoever it was that had the Mylar blankets out there to keep it cool. Didn't want to heat up their batteries and the carbon fiber on their craft. So we'll see what MacGyver decides to do. This is Advanced Tactical.
Yeah, they have a huge team.
Brought theirs in. That's not a small team. Yeah, University of Buffalo. A lot of cooks in the kitchen, or would you rather have one voice?
It's tough. You have a lot of people to help and a lot of resources, but then of course there's a lot of coordination and a lot of cooks in the kitchen, if you will. I assume this is a great team who's used to working together. When you have that many motors, and that many
everyone
joints,
take 2 or 3 and check them.
It's good to have a lot of people to help you get it going.
So MacGyver spinning up one more time. MacGyver out of Baltimore, Maryland. Again, when they take off, it doesn't get much more steady than that. I mean, that is stable.
Yeah, a little bit of movement. The key thing will be when they transition to forward flight. You can get in a situation where you have an okay hover. Now you see the oscillations getting worse, but then the situation kind of spirals out of control once you push it past a certain limit. So you might have a situation where you get in the air, but then as soon as you try to go to forward flight, it starts wobbling. You might have a situation where the wind induces a random oscillation, and that is enough to kick you out of your sort of performance area. But pushing those limits is what these guys are here to do. They have a run, they have a score on the board. They're not going to go home and say that's good enough. They're going to keep trying.
So the 2 o'clock flight window continues on. We are just about 50 minutes into it, so we're a good 40 out. This is Drone Smith once again out of Arizona. They're back up in the air. Some good elevation there. The good news is it looks like the wind has died down just a little bit, not quite as gusty as it was earlier in the day.
That wind a big factor.
Yeah.
Wind has been a big factor for some of these teams. We've seen them take off, and we've just seen them get pushed over and fall over.
It's a good look right there, huh, JB? I mean, it's stable. It's flying nice.
Yep. And we see that. Sometimes we see them take off and it's wobbly and obviously something isn't right. Sometimes we see them take off and it looks stable right up until it doesn't. And that's what it's all about, is finding those failure points. And so, when it breaks, what broke, and then you fix that and you find the next thing, and eventually you've built a better drone, built better aircraft.
Well, the man that's in charge of finding a better drone and a better aircraft is Stephen Winchell, the director of DARPA, who will join us now. Appropriately clad in the orange. Thank you very much for all you do. All your orange army, I like to call them, are doing a fantastic job. This has been fantastic. I guess the question I have to ask you right out of the gate is, can you remind us what a DARPA challenge is and some of the resulting innovations that come from that?
Yeah, absolutely. So, let's zoom out for a second,
okay.
Right? Why does DARPA exist? Right? It exists to create strategic surprise. Exists to avoid strategic surprise. We have a bunch of tools in our toolbox that we use to get there, right? This is one of them. It's one that we've used 20 times-ish in the past. Mm-hmm. We've done it with subterranean challenges. We've done it at sea. We've done it in the air. And obviously we've done it with autonomy, mm-hmm. with self-driving cars. So really, for me, it's all about right tool, right job. In this case, you've got really creative people. You've got a lot of interesting interdisciplinary problems that you want to solve. How do you get everybody together, rowing in the same direction and solving that problem?
Yeah. What do you hope comes out of this week's competition?
It's a great question. Honestly, I have a lot of hopes and dreams, right? I want the teams to get together, learn, help each other, innovate, solve problems. I want to see us building the future of heavy lift drones and their supply chains here in the United States. I want to see successful teams get resources to actually build successful companies and actually flood the market with advanced technology. I also want to see transformational capabilities that are going to be deployed to the military, that are going to be deployed for civilian missions across the board for that kind of last mile delivery and all those other problems.
For the folks that are here in attendance at Dayton, and it's been a great host city, and for the people that are watching online, can we expect to see more of these type of events from DARPA?
Absolutely.
There we go. That's what we wanted to hear.
Absolutely. No, I mean, in fact, if you tune in November, we are going to have really the largest human-machine teaming competition. It's a third version of this for the DARPA Triage Challenge. And that's all about how do you get people and these advanced robotic systems together to help in a mass casualty scenario and save as many lives as possible. So that's surgical teams, that's robotic teams, and all the autonomy associated with it.
And this is going to be down in Texas.
This is, yes, it is. That's right.
Wow, that's going to be amazing. And the dates on that again?
That's going to be in November. It's running like the first week in November.
First week in November, okay. Well, we're excited to have more competitions like this. What has impressed you the most since you've been here?
I think two things. The first one is just the creativity in some of these designs is just unbelievable, right? I mean, it's funny because I was actually out there talking with one of the teams, right? And it's kind of one of those things where about half the people thought, hey, this isn't going to be so hard. Why is this even a DARPA challenge? We can do this easily.
Yeah.
And there's another group of people that were like, this is impossible. We're never going to be able to do this, right? And it turns out we had two teams today that went out and actually, hit that 4-1, both up for about a mile each, right? Before they failed. And so it's possible, but it is really on the hairy edge of possible.
Yeah. Well, that's right where you want to be, isn't it?
Absolutely. The other thing that's really impressed me is that a lot of these teams have just, had some problem and they've gone to Home Depot, they've gone back to their barrack, they've figured it out, and they've actually been, tying things together, soldering things together, duct taping things together, and getting them back out there and learning at speed, and that's awesome.
Is there a drone out there, and I know you can't be favoring one or the other, but is there one out there that you're like, okay, that's really cool, I want to see that thing fly?
So
we won't tell anyone.
Yeah, don't tell anybody, okay? So there is a drone that has, basically jets strapped, yes, strapped to the ends of these big blades, and I'm just like, that is going to be awesome if it works.
Yeah.
I think we're all kind of waiting to see what Spitfire does.
Yeah,
worth the price of admission. Going forward, obviously, we talked about more of these activities. Is this something where you could take the DARPA Lift Challenge and say, this is the first annual. Next year, we might bump it 4.5. Next year, 5.0.
Yeah, so this is a really great question, and we've actually had a lot of dialogue about this. So a couple things come to mind, right? Maybe we could create a challenge where, either we partner with states or we partner with the military to provide test ranges for folks, before the event so they can actually get some,
interesting
sets and reps in, across the board. Another thing is small businesses, right? We want to unlock the power of these small businesses and get them the resources. So there's a possibility of maybe working with Small Business Administration or something like that to go even faster. And we're already doing that, but it's kind of on the tail end. What if we did it earlier?
Yeah.
And then obviously there's also lighter than air, right? So, hey, maybe we put some blimps in there. We figure out you got to go fast, you got to be responsive, you got to be maneuverable, but maybe you're a blimp, maybe you're a half blimp, or maybe you're something nobody's seen before. So I think that's a possibility. I've also thought a lot about how do we do competitions where you might have like sort of battle bot scenarios, but like each team gets access to each other's source code, so they know before the fight what the other team is going to do, and they and they have to dynamically adapt. There's some really creative stuff that we're thinking about. So I'll say, I don't know for sure, but DARPA is going to keep being DARPA. We're going to keep doing this kind of stuff.
Yeah. Have you written many $2.5 million checks in your day?
I've written a few.
There we go. That's what I wanted to hear.
And I'm really excited. I hope I get to write a bunch more.
Oh, that's amazing. We've been watching Flight Fest, and you were talking about the robotic war. We've got planes over there, and they put up 70 of those RCs at a time.
I watched the flight. I watched it. It was awesome.
Oh, that's good stuff. Yeah. That is good stuff. We're talking with Stephen Winchell, the director of DARPA. Thank you so much for being here. Thank you for making this happen. I know everyone that's been tuning in, people have been sending messages. They just kind of, you watch it for a few minutes, and then you get hooked. And it's pretty cool.
Yeah, well, I mean, thank you guys. I mean, you know, a big part of this is about bringing folks in, because there's all these innovators that are out on farms, out in universities, in small businesses, in their garages, and like those are the people we're seeing thrive in this sort of really challenging environment and deliver. And we're excited to see more of that and reach out to an even broader group of people.
I appreciate it,
So
Stephen.
really
Thank you so much.
it.
Appreciate
Absolutely.
you taking time to visit with us. That's awesome. Stephen Winchell, the director of DARPA, joining us here, part of the Orange Army, as they are getting things done here all week long. And we've got today and tomorrow before we wrap things up on Super Sunday here at the DARPA Lift Challenge. So there's still drones out on the flight line. And JB, as you look at this here at the beautiful National Museum of the United States Air Force in Dayton, we've still got some time left, coming up on 30 minutes plus, and then they'll wrap up the flight window for the 2 o'clock activity. And man, we're getting great information. It's good to have these smart people come in and kind of straighten us out.
I thought we were going to have to carry the whole show.
No,
and,
not a chance.
I found out we were going to have Donna, Ed.
How about Stephen Winchell? He's writing $2 million checks like it's no big deal.
Yeah.
If I wrote a $20 check, I'd be shaking a little bit. I don't want to spend that money. And he's dropping $2.5 million.
You know what though? You spend it. You drop that money on something you want. Like, well, we won't speculate about what. You're happy. You're happy to spend that money because you're getting something meaningful and valuable, and I bet that's true for him.
Well, it's a good investment into the future. It's a good investment for innovation, and I'd love to see the fact that they are supporting some of these teams that are coming up here and saying, hey, let us help you get to the next level or the next step. So we appreciate Stephen Winchell, the director of DARPA, spending a little time with us as we continue on with our coverage here in the 2 o'clock flight window. Coming up on 3 o'clock Eastern time, and we are going to have about 30 minutes plus if and when our Air Ops lead and Bush decides to give anyone extra time. I haven't seen any incidences or accidents that would cause anyone, but I'm being told there's no extra time being allotted as of now.
So 30 more minutes.
Yeah.
Theoretically, we've seen them taking about 18 to 22 minutes for their test runs.
So if anyone wants to get a scoring run in, they're going to have to do it in the next 10 minutes. Just moments ago, Rock Solid went up, and that was the team that has that, what do you call that? Parachute? Parasail?
Well, parasail is a wing that generates lift. A parachute makes drag and goes down.
So here was Rock Solid just moments ago.
We should ask them what they call it.
And they didn't even get to the parasail part.
No.
That thing
It looks like what they've done is they've added a rear-facing propeller to help get them that forward speed that they need to inflate that wing.
I was going to say it looks like they just slapped on a big box fan on the back of their drone
more
and
or
let
less.
us go. Let's look at this one more time. So there's your giant, as I call a box fan, or a circular fan.
Yeah. We got counter-rotating propellers.
And then we got spaghetti everywhere.
This looks like a pretty serious redesign.
Yeah.
I have to wonder if they rigged this up. I don't know if we could get a before and after, but if they rigged this up in the last couple of days, they were like, "What we're doing isn't working."
Yeah.
Do we go home?
Yeah.
No.
We
make a new drone. We have 1 day in the hotel to make a new drone.
Can I just say one thing that I'm grateful for?
What is that?
That I am not next door to these guys, as they were up all night, probably soldering, welding, clipping, snapping.
I have been in that hotel room. It is stressful. It is fun. It is rewarding.
Yeah.
And some of the best and the worst experiences of your life.
There you go. So it looks like they are going to possibly retrieve, because I do not think that is a airworthy craft at this moment.
And if they did rebuild it, then
so this is today. This is day 6. Let's spin back 2 days. Let's go back.
Oh yeah.
This is day 4.
That's a completely different drone.
Yeah.
Like it's probably the same parts that they. I don't know what they did, but it's a much bigger drone, a complete different design. And they've either gotten new parts or they've cobbled it together. And you might say, well, why did they test hover it? Where are they going to test hover it? You can't test hover that in the hotel parking lot.
You can't go over to the Chick-fil-A parking lot and launch that thing. Come on.
Use their flight time to figure out, you do the best you can, but then sometimes you hit go and it doesn't work out.
As we say, sometimes progress isn't always pretty.
That's right.
But it is fun to watch.
Oh, for sure.
So we are 30 minutes away from closing out the flight window for 2 o'clock here on Saturday. Remind you, tomorrow we'll be back. 9 o'clock we'll kick things off for Super Sunday, the final day of the DARPA Lift Challenge. Who knows what special guests we'll have. We will have another guest coming on the set with us. And I'll tell you this, very promising team.
A very promising team.
They're going to come and visit with us. Yeah, you'll be excited to hear about that. You want to know who it is?
I do.
It's our good friends from Proto Carbon in Coeur d'Alene, Idaho.
Oh, Coeur
John
d'Alene,
Bledell's
Idaho.
going to come over and visit with us, and we're going to get
We're
going to get the skinny on that. He can give us all the best places to visit when you visit Coeur d'Alene, Idaho.
That's
but right
what the
now,
audience wants.
Exactly. But right here in Dayton, Ohio, it is continual. A lot of teams that are off the launch pad because they're retrieving parts after a small crash. There you see the students from the Stanford High School. And it looks like, are we getting ready to spin up here?
Yeah.
That's MacGyver.
MacGyver.
So does it look, from your untrained eyes, JB, that they've got weight added to that?
Well, yeah, they're setting it on top of the weights. We've seen them make several attempts and have controllability issues.
That burly cat just picked that up like it was nothing, though. So if they've got weight on there, he's throwing that around like it was.
It looks like it wasn't attached to the weights yet. It just turned it around.
Hey, don't rain on his parade. I was trying to build him up.
Okay. Yeah, I'm all about
So
the
we
facts.
saw MacGyver, correct me if I'm wrong, MacGyver the other day was the one we saw that had the weight on it when they had the Velcro, when they made the touch and go and the weight came off. Am I thinking of the same?
It look like there's a strap. We did see one yesterday where the weight was held on with what we think was a Velcro some kind of a strap.
And when they came down and did the touch and go on the weight.
Yeah.
I think that was
the ground
MacGyver.
and the weight separated.
So many drone flights, so many incidents to remember.
Yes.
Today we're scheduled for 63, so we are flight loaded.
Yep, everybody trying to get as many flights as they possibly can in these last 2 days of the event and try and get themselves either onto the leaderboard or increase or cement their position. Last time we saw a change in the leaderboard when was the last time we saw a change in the leaderboard? Was it yesterday morning?
I can say that we are coming up just after 3 o'clock here. In less than an hour, folks, we will be back with another flight window. That'll be 4 o'clock Eastern time. We'll have 2 fixed wings, so we've got Skyweaver and the other team from California, Sherman Aeronautics, the husband and wife team. Plus we'll have, drum roll please, Spitfire will be on the line. Now, when the director of DARPA wants to see a team, Stephen Winchell, you know it's probably a team that's worth sticking around for. So stick around for the 4 o'clock window, and we will see Spitfire, and we'll see if they'll melt anything. Or will they get up in the air and put on quite a show?
I would love to see that thing get in the air
Absolutely.
and see how it flies.
Before we get to that, though, we've still got just about 25 minutes to go, and it'll be MacGyver. It looks like they are getting ready. This looks like heavier duty Velcro than we saw the other day.
Yeah.
If that is, in fact, Velcro.
Yeah, it certainly makes it easier to get those weights on and off rather than trying to lift the plates and wrangle the plates. You just set
put
them
it on that little stand, pull the
drone on
Velcro,
top
drop
of
it,
strap it on.
Yeah.
As long as it stays on, you could imagine a scenario where they intentionally tap the ground, the weights fall off, they immediately just take right back off.
And we have seen a team with an
air.
ejection button. They just hit a button and the weights just dropped.
So just to be clear, though, they are required to come in and land in the prescribed location. At that point, how they detach the weights is up to them, but they couldn't just drop the weights anywhere and keep going.
I don't know. I'm seeing 4 full plates on board MacGyver. Rock Solid looks like they are packing up. That's going into the duffel bag.
Packing up that chute. I guess they are not going to make another attempt.
Yeah.
That does not look fun, packing that thing up.
I think you'd rather be packing it up with the idea that they just went 4-1.
I've packed up a sleeping bag. I just stuff it in there. When you've got one of those airfoils, you got to fold it a specific way. You got to lay the lines a specific way.
Hey, what do they say? Pack your own parachute?
Yeah, that's right.
Just saying.
You know, the advantage, though, is that there is no human safety at risk here. If you try something radical with a human on board, you have to be a lot more careful. You try something radical with a drone, you can learn all these lessons, and all you've done is lost maybe a little bit of pride and a little bit of money, but a lot of lessons learned.
So Rock Solid will obviously break down their analytics and what they did, basically coming with 2 different designs. And this is MacGyver, so we're coming off the platform. That's 2 strong dudes that had Wheaties this morning. They're going to set that thing down. Now, I'm going to go ahead and say that could be a 4-1. What do you think?
Well, the last time we saw them go, they were not at 4-1. It was yes. So it seems like they're not going for a 4-1. They're going to try and put themselves on the leaderboard.
Dynamite. That's 3.63. I thought Donna might have gone out there and given him a pep talk.
Yeah, I know Donna wants to see somebody break that 4-1.
4-1 payload to weight ratio. MacGyver is currently at 2.51. If they can complete this one, they'd go to 3.63, which would vault them into third place, which would vault them into a nice payday if it stands.
Yeah, and knock Extreme Aerial Concepts out of the money.
Which would make them say, wait a second. Yeah, Extreme was here at the 9 o'clock flight window, but they did not fly. So they were
presumably didn't feel ready
to
do it. And we see them with a 3.63.
Correct.
They're just a tenth of a pound away from taking, or at least tying, second place. You say, well, why not just add that tiny little bit of weight? Or frankly, from my perspective, how much weight would you have to shave to change that ratio? Could you just
pull off a piece of tape?
I don't know. But I'm sure.
Or maybe they're playing the long game. Maybe they're saying, if this works, then we go for the home run hit. But at least we got ourselves into a top 3 position and we got money.
Too big of a bite, and you have a crash that takes you out of the running. You can assume that they're doing everything that they can think of to try to establish.
Here's my analogy. You're at the Olympics. You go for a jump, puts you into bronze medal position, so at least you're getting a bronze medal. And then on the last day, you say, you know what? I'm going for gold. If I don't get it, at least I'm going home with a bronze.
Well, the beauty of this competition is it's not like some of the Olympic sports where you take your run, and then that's your score and you're done, right? In this case, you get as many runs as you can fit into your flight windows. And so there is a real gamesmanship around, do we go for it now? Do we try to take a place? There's a lot of strategy there.
I still think what would be just the most epic thing, the most DARPA thing, is if someone on the last 20 minutes of the last flight window on Super Sunday went up at 4.01.
That would be great.
Booyah.
If I, the sort of scenario that would make me jump out of my seat, where we got them in the air, MacGyver's in the air, looking for that stability.
Everyone wants to see Joshua Bardwell jump out of his seat. This might be a jump out of your seat moment, good sir. 3.63.
So what we're going to look at is, as they start to put in more aggressive maneuvers, does it maintain control? Does the wobbling, whenever you see wobbling, you ask, is it getting smaller, is it staying the same, or is it getting bigger? And the best scenario is that it wobbles and it gets smaller and it stabilizes. It's okay if it wobbles and it stays the same as long as the wobbles aren't too big, but if it wobbles and it gets bigger, it means you're losing control. So right now, as a pilot, what I would be thinking is I'm going to push it a little bit and I'm going to watch those wobbles. And now see, he's slowing down, he's hitting the brakes. I'm going to push it a little more. And what I don't want to do is push it so hard that I immediately put it into that oscillation and crash it. I want to just carefully try to find that limit. And eventually, if the limit is high enough, then I'll go ahead and make an attempt.
Speaking of limits, they are getting very close to the limit of time because they're going to need probably 20 minutes plus to complete the 4 aeronautical miles with weight and the 1 aeronautical mile without weight. They've brought it back here. So they went up for 1:15 and put it right almost dead center in that circle, but did not achieve the necessary elevation at 100 feet. But they probably learned something, and maybe they come back and make 1 or 2 more little tweaks, and then...
Well, one of the things we've seen is that the time on the clock, when you get up and you do a run early, the time is not really a factor. You have 90 minutes, you take 20 or so minutes to do the run, and you're good to go. Remember, there's a 30-minute maximum time for each of the runs, which gives you about 10-ish minutes to change the weights. In this case, though, they're coming up against the end of the window, and if they said, well, heck, we're going to remove a little bit of weight or we're going to try and change things, that Velcro may be helping them out. They can do that faster and still have time potentially to get a whole run in.
So MacGyver currently in 5th place, currently on 2.51 on payload to weight ratio. We did see some other teams that had a more extensive packing or securing apparatus on the weights, and it took them 5 to 7 minutes to get that weight off, and that counts towards your overall time. Remember, 30 minutes is the max time you can take. So it looks like the team from MacGyver out of Baltimore, Maryland, has taken a long, hard look at something internally, and will they go back up again, or will they say, you know what, we got the data we need, let's go back, tweak it in the prep area, and bring it on out on Super Sunday?
You know, Todd, the other question I got to ask is they're trying to get into 3rd place, but they're just nudging by 1/10 of the pound at 2nd place.
Yeah.
Why not nudge third place by 1/10 of the pound. I mean, they're right on the edge of being flyable.
Yeah.
I wonder why they've decided to do that. Yeah.
So here's where they are, 251. So you're saying just go to like 332.
Well, we've said before that there's a certain you can't just add 1/10 of a pound, right? You have to add a plate, and so it's not 45-pound increment, but it seems like maybe there would be some combination of weights that would put them between 331 and 364, and would make it easier for them to do it. I don't know if this is just going for the gusto, or if there's some sort of logistical reason why they are choosing this weight.
All good questions, my friend, as we continue to wait and see what happens here over the next 20 minutes, as we will get them. I want to remind you, coming up at 4 o'clock Eastern time will be the next flight window. Great teams out there, including Spitfire. Stick around for that. Looks like the weather's going to hold off, so we should be in good shape.
Don't jinx it. Don't jinx it.
I know. No announcer jinx. Right now we're holding on to see MacGyver's going to go back up for the run that would put them into third place if they can get up, if they can complete it in time, and if they can complete the payload drop-off. Would you love to be out there right now and hear what they're talking about?
I mean, like they got the quarterback has a microphone.
Yeah, exactly.
I would love that. We got zip ties. Is that what we have? Is zip ties? It looks like a bag of zip ties to me. Zip ties. A lot of these are held together with zip ties. At least the wires are held down. What are they going to do with the zip tie that's going to make a difference?
Maybe they're seeing a shimmy or something.
Maybe there's a loose wire that they want to secure.
So MacGyver continues to work their magic, or try to work their magic. They're going to be up against it here unofficially. We are set to shut down in 19 minutes. So they're right on the cusp. I mean, I don't know how fast they can fly, but they're going to have to full giddy up.
Yeah, shut down this flight window.
Yep.
We've got one more coming up at 4 o'clock.
Yep. Breeze has been consistent all day, so... Still see activity down on the flight line here. The 2 o'clock flight window on day 6 of the DARPA Lift Challenge here from Dayton, Ohio. We've got another drone in the air. This is Burl. This is that kind of cool stealth wing design.
Boy, there's a lot of, it's hard. There's optical illusion about whether it's tilting or whether it's just turning. The shape of this thing is so unexpected compared to what you've seen before.
Yeah, I don't see a lot of weight on there, JB, so I don't know if this is just more testing.
More testing. Remember that weight is dangling. Yeah. Dangling with a tether.
I don't see anything. No, I don't. I'm trying to look and I do not see. Yeah, it's got
that tether was awfully long. Look at that. Look at that wing flapping in the wind. Famously, you can bend the wings of a Boeing.
But how far do you think that is below? I mean, that's got to be 50, 60 feet, if not more.
It's a lot. It's a lot. Could there possibly be a benefit to them leaving it dangling so low? It's hard to imagine.
That's a Donna question. If that's below 100 feet, that weight,
we'll have to look into that. We'll see if we can get some answers. Maybe we can get somebody out there to talk to them.
We're going to keep our eyes and ears on Burl Aero Alpha and see what they do, or if this is just more testing.
Look at that weight swinging around there. Doesn't seem to be jerking the aircraft around too much. Seems to be holding in there.
I'm ready to drop my Mission Impossible Tom Cruise analogy. Remember in that movie when he's hanging on the end of the helicopter?
Pounds, they could lift you.
Yeah, about the same.
Yeah.
Well, we continue to watch Burl Aero do their thing as, they start to get a loose, JB.
I am not convinced that that's not intentional.
I was thinking they're starting to get a little loose, but maybe not.
That is wild. You know, it swung like that and it moved a fair distance. Remember that they need to stay within their lane. Now, if they moved downrange, then that's all good, but it certainly looked like it started moving, and you might wonder whether that was intentional.
Yeah,
Now they seem to be going back to position.
You don't want to be swinging side to side if you've got someone like Proto-Carbon next to you.
The fact that it was able to accelerate like that at all is pretty impressive. Go ahead.
Well, we're going to keep an eye on that. We're happy to welcome in our good friend from Coeur d'Alene, Idaho, John Brindell. He is the man behind Proto-Carbon. John, good to see you.
Yeah, I appreciate it.
We have the benefit of having you here, and you're right behind us. So look at this. I mean, talk about good product placement. His drone is right behind us. First of all, how has the DARPA Lift Challenge been for you?
It's been really good.
Yeah,
it's been a lot of fun.
And you made the drive from Coeur d'Alene. I've been selling that all week.
I did, yep.
How long is that drive?
My dad and I drove down.
Thanks, Dad.
28 hours.
Ooh.
So, yeah,
it's
a hike.
drive.
Okay. You were out in the line earlier today. We saw you.
Yep.
The big question we have is you were out there for almost the full 90 minutes. You got to the end. You got a little up, down, and you looked like you were pretty happy about that. What were you getting? What was going on there? What data did you glean, and why were you so happy?
For sure. So I'll back up a little bit.
Okay.
On Tuesday, if you go back and look at the flight line 12 on Tuesday, one of the main rotor blades came off the vehicle during spin up, which is usually like the
catastrophic,
end, right?
Yeah.
So if you go back and you have to look at the lane view, so it's super tiny, but super violent. The blade came off. It kind of smashed into the tail. The bearing actually failed that holds that blade on. So was able to repair that. The previous 3 times I tried to spin it up, something else had failed. So on Thursday, that was the first spin up that I've had without failure in a long time, and that was the first time I had a free flight for all 5 seconds.
So
on Thursday,
you were thrilled.
Yeah, we saw you trying to get it in the air, trying to get it in the air. You're running out of time. You pick up the hover and set it down, and you were overjoyed.
Yeah, yeah. The only time before that had been on tether. So Thursday, first free flight ever. 5 glorious seconds of it. Roll and pitch felt really good. Yaw was way too hot. It was real snappy. The pilot did a fantastic job and kind of got into the wind, noticed that it was probably an unstable tune, and set it back down.
Yeah, when you say roll and pitch were good, but yaw was way too snappy. For the audience out there,
Totally.
I know what you're talking about. So
Pretend like you're talking
means.
to me.
So you got your joystick,
Yes.
right? And you're flying a 16-foot rotor blade helicopter, and you try and change its heading a little bit, and you move your stick a tiny bit, and it just goes really fast,
Really
way
drastic.
too fast. You have no the precision. It's way too sensitive.
So now you're chasing it when you're back, and then you're overcompensating, and then
exactly.
a world
So
of
he
problems.
didn't want to get into a bad position, so he did a great job kind of noticing that and bringing it down. So we were able to take that and adjust the tune, right, just kind of the settings on the controller. We go back out again today, and we get up into the air. Well, kind of the whole lead up to that is we wanted to verify that the tail was acting properly. So we were doing a spin up on the pad, and the vehicle was kind of stuck on the pad, and we're trying to yaw the vehicle over.
Copy that.
But because it was stuck a little bit more than we were expecting, it actually built up something called integral, where I want to go left, but I'm not going left. So it's almost like building up a bank of going left. And so as soon as it had the chance, it moved way too fast. And we're like, oh, what's happening? But we were running out of time. We didn't get a chance to view the log, so we just kind of had to go for it. So we kind of first we had the battery fire happen just upstream of us.
Yes.
So we had to kind of evacuate. And so last 10 minutes, right, we were kind of holding for the wind.
Ooh, MacGyver, let me interrupt you there. MacGyver has been in the air, and we just saw them touch down
landing.
hard.
Yeah, heavy
not
landing.
on the landing pad, still struggling.
And they've got less than 10 minutes. All right, John, so continue on with your story.
Yep. And so today, last 5-10 minutes, we're running out of time. We just kind of have to go for it. So we spool up, we come up, and then we're able to get up into a hover, and it just performed really well in the air. It's pretty windy.
Yes.
It's a big vehicle, but...
Let me ask you about that decision. Obviously, you want to solve all the problems. You want to be 100% certain that everything's... But obviously, that's not possible.
Yep.
Talk about that decision to just go for it. How do you balance that out?
Well, we have 2 more flight windows. We haven't done our qualifying run with no payload. So this was pretty much the last window we had if we wanted to have at least 3 runs to place a score. Like, the strategy for this competition is if the vehicle fails, the vehicle fails. Like, we are kind of pushing it all in.
Sure.
So that's a strategy. So it doesn't make sense to let that window slip by and not try to at least get that first free flight. And now we have a bunch of really rich data. We've been up in the air. We can kind of confirm the tune. And now we're ready to do that down and back checkout flight. That's going to be a ton of data, and then we'll be ready to do our scored attempts.
So the $1 million or $2.5 million question is, will we see you tomorrow going up, and will you go for the 4-1?
Probably.
You're going straight.
So you're saying there's a chance. That's all I wanted to hear.
That's right. Hey,
wow.
When we've seen a lot of cases where aircraft have crashed.
Yep.
And we've talked about, and I've talked about what might be going through the pilot's head when that crash happens.
Mm-hmm.
I think it would be easy for the audience to assume that that's the worst thing in the world and your day is ruined. Tell us what goes through your head when a crash like that happens.
I think at this point, like, my first thought would be, I'm really glad we got as far as we did, right? I put this together, in my workshop, put a lot of time and effort into it. The fact that we got it into the air and it's flown, and I got some great pictures of it up against the sky, like, that's kind of the prize for me at this point. So anything beyond that's gravy.
So what you're saying is a $500,000 thank you check would be nice, too?
I mean, I wouldn't
It'd make the trip back to Idaho a lot better, wouldn't it?
It would.
That's fantastic. Are there any other teams or designs that you've seen since you've been here and just said, that is really cool, or
Yes.
I really like
Yes.
that?
Yep.
Can you tell us?
The defense tech team.
Yep.
So as soon as I saw it, and kind of my whole reason of I'm not sure about the quad layout is the props are going too fast, they're too small. The power that a blade draws is related to the velocity but squared.
Okay.
So I have a big blade and I'm going slow, and that's kind of the whole rationale behind it. 16 feet in diameter. I tried to grab just as much area as I could and not be overweight.
I just love that it's right behind us. I mean, no one else brought their entire drone with you, but you did, and that's fantastic. Otherwise, it's carbon fiber. We were talking about this the other day, carbon fiber. You did have a strike on there, but you were able to repair it.
Yeah, yep.
Yeah, the defense tech's certainly not overweight. The 55 pounds was the limit. What's yours weigh?
I'm at 52.
You're at 52?
Yeah.
Defense tech coming in 12 to 18 pounds. What did you think of that when you first saw it?
Yeah, so I love that they have a quad, but they geared down those 4 blades. If I could do it all over again, I would probably do something pretty similar. For some reason, the thought just never entered my mind of just gear down the 4 rotor configuration. Now, there is something to be said for a single rotor, like that area is the radius squared. So 4 blades to get the same area, they're not a quarter the size, but helicopters are just really hard. So I've only done launch vehicles. I worked on New Glenn for a long time. I've worked on a couple different rockets. Never did a helicopter before, but they seem to share a similar desire to rapidly disassemble at any opportunity.
Yeah.
So I've been learning a lot about helicopters for sure.
Protocarbon is you, your dad, and your pilot. Is there any collaboration going on? Have you gone up to anyone? Has anyone approached you and said, "Hey, you know what? Between your this and my this, we could do something special"?
Yeah, there's been some of that for sure. I think one kind of advantage that I had going into this is that composites background, and I made these rotor blades. So it's funny, when I first heard about the challenge, I was like, oh, this is a composite rotor blade competition. Sounds like fun.
Yeah.
A lot of the other rotorcraft, they were kind of limited to just what blades they could buy. So I did have the advantage of I can do whatever size, shape, length, twist, what have you. So I've been talking with folks and oh, yeah, you could actually make the blade we want instead of us having to use a blade that we can only get. So I think there might be a future there.
Final question for me before we let you go, because I know you're going up in the next window or later today.
Yep.
If someone is watching this and they're like, well, I'm kind of a drone enthusiast, I'd kind of like to get involved in this, what would be your advice?
I would say just kind of start with something, off the shelf, and then get a feel for it, see what it does, and then you can think about maybe you can modify it. But I think getting to something that's flying first. For some reason, the analogy of restoring a car makes sense. Don't buy the project that you have to dump 1,000 hours into it before you get to drive it. Get something that you can drive, that you can fly, and then you can kind of wrench on it, add something to it, adjust it, and then you can kind of maybe it crashes and you just pull the guts out of it, and then you put it on a different frame that you made yourself, and you can kind of go that way.
That's great advice.
Yeah, and you're having fun.
Yeah.
and you're hanging out with your dad.
Yep.
And you're going to see a lot of America next week when you're heading back
There
to
you
Coeur
go.
d'Alene.
Yep, all the way back.
John Brindell, thank you so much. We appreciate your time.
Yeah.
We wish you the best of luck.
Yeah, thanks for having me.
I'm just telling you, knock on wood tomorrow that you guys bring it home, but it'll be fantastic if you do.
Yeah, I appreciate it.
Thanks so much for being with us. That's John Brindell from Proto Carbon, Coeur d'Alene, Idaho. They will be back out there tomorrow. We've got 5 minutes left in this flight window. Remember, we've got another one coming up at 4 o'clock. Lane 13 has brought out a new drone, and we'll see what they can do. They've got very few time. They asked to do a test flight. They said, well, okay, you can do a test flight if you can get it done in the next 5 minutes.
Yeah, the drones do need to be back on the ground by the end of the flight window. So whatever they're doing, that's the expectation from the ops team. I'm surprised you didn't ask him what his
advanced vertical from College Station, home of Texas A&M University. I like to see them out on the platform.
Yeah.
I love to see them in the air.
Oh, yeah. For your priorities are
I mean, this is
in
cool
the right
to see
place.
it, and I'm looking underneath, and it looks like something's going to drop down. It's tethered, but something's going to drop down below. You see the Titan on top. That gray box is strapped in, but not a lot to this. So I'm thinking getting to 4-to-1 ratio for this aircraft, JB, has got to be, I don't say easier, but it does not look that heavy.
Well, it's a real challenge. The lighter the aircraft, the less weight it has to carry to get to that 4-to-1 ratio. Of course, 110 pounds being the minimum weight for scoring. So the minimum weight for an aircraft to meet that 4-to-1 ratio would be 27.5 pounds. But the lighter aircraft, it's going to be more sort of spindly and potentially less strong. On the other hand, a heavier aircraft has more mass, and so there's a real balancing act in terms of the engineering, and kind of the whole point of this is to find that sweet spot.
Beautiful view of the flight area here at the National Museum of the United States Air Force for the DARPA Lift Challenge here in Dayton, Ohio, and we have liftoff.
A dangling.
Yeah, that was that.
That's probably going to carry the weight, perhaps. They're going to have it dangle below there and spread that weight out via those guy wires to
What kind of wires are those? That's not going to be
arms.
Teflon. What is that? I mean, that's got to be some pretty heavy stuff.
You would think steel would be the probably optimal. Steel cable is a very good tensile strength to weight ratio. I guess the question would be, why did they choose, if that ends up carrying the weight, why did they choose to run the weight out to the arms and put the stress on the end of that lever arm
rather than the middle?
The longer the arm, the more torque, whereas mounting it on the middle you might think would be more secure. But those are the questions they got to answer.
And constantly learning, because that would not count as an official set down because they are off the platform outside the circle. We saw that happen with MTech. They reran today and they were able to put up a good scoring run. So good little piece of advice and a good little piece of data as we're under 3 minutes to go now until this flight window closes. Next one coming up at 4 o'clock Eastern from Dayton as the penultimate day of the DARPA Lift Challenge rolls on. Will we see Spitfire? Get your popcorn, get the front row seat.
I think we're going to see them on the pad.
I say this, you guys go to the pad. I want to see something lift off.
Yeah, I've heard
You've heard rumors
about the speed that craft goes. I won't repeat it, but suffice it to say, I wonder how they're going to keep it within this little a quarter mile.
They could complete that 4 nautical miles in like 2-3 minutes.
Yeah, it's a very interesting design to have brought to a competition like this.
Yeah, when you're going that fast, I mean, are they just making big circles?
Well, there's two possibilities. If you need to turn at speed, you either slow down and turn around and accelerate again. But if you're trying to get up to a high speed in order to maximize efficiency or something, you have to just make a curving turn. And of course, the faster you're going, the more the G-forces. Think about a car going around a turn, and the airframe has to carry that stress. Remember, we have a 100-foot by 100-foot box that they have to stay in. And of course, they're going to want to give themselves some margin of error. So if it was going at a high speed with a lot of weight on it, the stress in the airframe would be pretty extreme.
I got to think that Ann Bush, our Air Ops lead, and Drew Simonson, who's also technical out there, they're going to make sure they have plenty of wide berth. Maybe they put them at the end of the flight line with a couple lanes between them and everyone else.
I think what they're going to do is they're going to make sure that they are good to go before they put the weight on. So they're going to do that unloaded check flight, and they're going to demonstrate that whatever it is they intend to do, they can do it safely with no weight. And then they're going to do the half load and then the full load, and sort of, as they said, crawl, walk, run.
So it looks like they are coming up on a minute away. Can they get this thing up? It looks like they're going to attach that weight. How quick can they get this done? This is like a NASCAR pit stop. Fellas, you got less than a minute. Let's go.
Yeah, they need to get it in the air. They need to do their check flight, and they need to get it back down again for the end of the window. It looks like they may not even get the weight attached before this clock expires on them.
We need to have a big, giant clock out there.
Oh.
And a countdown. When
they don't need the pressure. They don't need the pressure.
More stress. And they may be just getting notified that the lane coordinator, he's got it.
Yeah, got his clock in his hand. Making sure that this is run fairly for everyone.
Is he going to say, fellas, if you don't have that thing up in the air in the next 20 seconds, you are no joy. So here we go. They're going to walk back deliberately. I'd be running,
they're
but
not
that's
walking
okay.
faster. Maybe they know something we don't. Maybe they know something we don't. You know, remember, it's possible that a team could be granted additional time. We don't know whether that's happened.
Oh. So you heard it, Ann Bush, and the flight window, we just heard the flight window has now been closed for 2 o'clock. So they came up a few minutes short.
Yeah, not able to finish that check flight.
Now we'll look forward to seeing what they can do once they get up and going. All right, so that closes out the 2 o'clock flight window. We will be back at 4 o'clock. The DARPA Lift Challenge provides a springboard into the future, combining innovation from beyond traditional means. Here's how the purpose of the challenge integrates new ideas.
Used to be a very unique subset, highly trained group of people at select large companies that designed and built airplanes. Now it is open to the masses. And that is where the excitement comes in. That's where the power of outside of the box thinking has the ability to really change what we know about aviation.
It gives university students and young engineers the rare opportunity to get their hands dirty, solving a very real national security problem today, rather than waiting a decade into their careers to make an impact.
These people, they're literally out in the field right now, turning wrenches, making tweaks to their aircraft, and proving that it takes a diversity of ideas to make that breakthrough, to find that golden nugget that will take us, humanity, to the next level of innovation, the next level of capability.
If we want drones to deliver serious supplies like food, medical kits, or even repair parts, we need to break away from traditional designs and investigate what will push us to a new paradigm of heavy lift.
This breakthrough matters to everyone because it will enable faster and more efficient military logistics, transform commercial and supply chains, and allow for quicker disaster relief to hard-to-reach locations.
We've only got 4 of us here, so we've all got to do a few jobs. We are Defentex, an Australian defence research company. We've headed over to the US to compete in this challenge. So right now you're looking at our loaded check flight. So we got 55 pounds on there. Our drone weighed in at 15 pounds. So we really went for a lightweight concept with this drone. So currently you're seeing approximately a 3.5 to 1 ratio on the flight right now. We had to rebuild this drone yesterday and last night, as we unfortunately had a couple crashes, but we had enough parts to thankfully build another one. And after a few changes, we're really hoping to get a competition run of 110 pounds in today, but we'll see how it goes. So we've been working on this drone pretty much since the challenge was announced. And yeah, we've been working on it in addition to other projects at work since the competition was pretty much announced and we got the go ahead to have the funding and the resources to put a drone together for it. We went for the concept of we're aiming to do the minimum payload and we attempted to minimize our drone mass. It's been one of the most enjoyable parts of the competition so far is meeting all the incredible engineers and concepts that they brought to this competition. So that's 55 pounds on there. It's our loaded check flight. But in addition to the regular check flight of just up and back, we're also doing some tuning of the controller at the moment.
So We don't see the green mark at the top right saying that they're going for a run, but there you go.
And a big set down.
Big, hard set down. Those motors were pulling hard to lift. Perhaps it was overweight. It was maybe one of the motors got hot.
First run was good. We were just checking it. It wasn't an official run, but we were trying to work our way up to the full 110 pounds because our strategy is a bit weird where we have to lift 110 pounds to score. Like, our ratio is already very high, but everything's a bit hotter than expected, and also we haven't had much time to test stuff, so we're kind of learning on the fly. The second flight, I don't know, lost power. I'm not sure why. Yeah, it still had control and stuff, but I pretty much went to full throttle and it was just sinking. So we'll have to investigate what it was and build another one.
Imagine carrying 4 times your own body weight. Crazy, right? We want a drone doing exactly that. That's the challenge we here at DARPA are throwing at inventors across America. And if they succeed, we could see a whole new generation of propulsion systems. Today's drones are limited by how much thrust they can generate for their weight. Some drones can carry a lot of weight, but they are very heavy and cumbersome themselves. But what if the teams competing in the DARPA Lift Challenge create ultra-efficient motors, revolutionary propellers, or entirely new and previously unimaginable ways to generate thrust? Suddenly, a compact drone could carry equipment that today requires something much larger and way heavier. More efficient propulsion could influence cargo, emergency response, and future air transportation systems. More lift, less weight, better performance. Sometimes when engineers chase an impossible sounding challenge, they end up reinventing the future.
History shows us something fascinating. A technology doesn't necessarily change the world when it is invented. It changes the world when it becomes affordable enough for widespread adoption. Take the automobile. For its first 20 years, the car was a toy for the rich. It didn't change how the world operated. But when Henry Ford brought the cost of production down, it completely restructured human civilization. We also saw it with computers. They were around for decades, but until the personal computer was created, they didn't have a significant effect on how we lived our lives. And today we're seeing it in space. Space used to be a domain exclusively for superpowers and the exquisitely funded. But by transitioning to reusable rockets, the cost plummeted, and suddenly a massive commercial space economy is emerging that we previously thought was impossible. Today we're standing at the edge of the next great technological inflection point, heavy vertical flight that is economical for widespread adoption. Right now, if a company needs to move cargo, they run a cost-benefit analysis, they look at trucks, trains, and ships. Helicopters and drones almost never make the cut. Why? Because the cost per pound per mile transported is just too high. Vertical lift is reserved only for the most critical missions or the most well-funded industries. At DARPA, we want to shatter that cost barrier. That is why we launched the DARPA Lift Challenge. Our goal is audacious. We are challenging innovators to build a heavy lift drone that can lift 4 times its own weight. Let me put that into perspective. Today, a highly specialized helicopter has about a 1-to-1 payload to weight ratio. A 1,000-pound aircraft carries 1,000 pounds of payload. And commercial drones are often much worse. As you scale up the size of the drone to carry more weight, the cost just explodes. We want a 4-to-1 ratio. If we achieve that, we flip the math. Instead of a massive expensive vehicle, you can carry the same heavy payload with an aircraft that is a fraction of the size and a fraction of the cost. If we can drastically decrease that cost per pound per mile metric, we open the floodgates We can envision moving heavy construction materials to remote mountainsides or rapidly deploying medical infrastructure. But the most exciting part, it's the unknown. Just like no one in 1908 could have predicted the drive-through window or the modern suburban neighborhood, we don't know exactly what new industries will emerge from this. But history guarantees that when you unlock this level of economic efficiency, transformative innovation inevitably follows. And of course, at DARPA, our core mission is national security. Today's battlefields are dominated by small drones. But because they don't scale well, they're limited to tiny payloads. Breaking this weight barrier will revolutionize military missions, allowing us to supply our warfighters anywhere on Earth at a fraction of the cost. In 2004, the DARPA Grand Challenge sparked the self-driving car revolution. The communities that formed in the desert that day went on to build an entirely new global industry. This is exactly what we are doing with the DARPA Lift Challenge. We are building the community, proving the hardware, and giving America the jumpstart it needs to dominate the multi-billion-dollar aerial economy of the future. This isn't just about building a better drone. It's about redefining how human civilization operates.
I figured for something like this, actually, like a very small team was actually the best thing because you can move very fast. So I actually built the first drone before I was even accepted as a team in this. I like just assumed that, you know, if I tried my best, I'd probably be accepted. And so I built the first one, you know, like less than a month after the challenge was announced. And then I've been test flying since then. So this is actually the fourth drone basically that I've built. So but in terms of, you know, I went for very simple. Like, I've built a lot of drones. I know that stuff that works and the stuff that doesn't work typically, and so I wanted to keep it, you know, as simple as possible and like realistic. And so I did a lot of simulation work on what is, you know, the least amount of structure I can use to still lift reasonable. This thing is actually like rated for up to like 250 pounds. So hopefully I don't eat my words out there, you know, with less than that, but it is rated for a decent amount in this iteration of the design. And there's a lot of small things with the design to optimize wiring and how the motors communicate. We were able to get away with not having certain components because of how I did things. But the main innovation with this is the battery. It's a custom battery that I made that allowed me to maximize my energy density for, you know, the weight that I had left over in the budget, basically. I'm definitely willing to crash it, so, you know, we'll see. Oh, I just bought like a $3,000, you know, pretty junky Sprinter van, like an 05 Sprinter that's pretty much fallen apart, and that's what I use to transport everything for flight testing, and you know, did the bare minimum to fix it up to drive, and that's what I got here. Drove all the way out here, had to go 50 miles an hour the whole time because it basically can't do more than that. So yeah, so that's what I'm working out of, you know, self-funding. I spent all the money on the drone, I didn't spend it on the transportation, you know.
Obviously, the hard deck is not in play. Seems like they're bringing it down.
Yeah,
Ooh, a little wobble there.
Pretty quick.
Oh, they lost the weight, and it jumped back up in the air as that weight freed itself. The pilot maintained control expertly.
I don't know.
No, that wasn't on purpose. No, sorry, that was not on purpose.
But you never know, like when you start going, how the position control stuff is going to go. So, yeah, lost too much altitude in one of the, you know, far runs, and it kind of just barely breached over there. So, had to bring it back, and then wanted to do some more tuning, and you guys saw how that went. You know, it was coming down a little too fast, and even though, you know, I was 100% throttle, I still couldn't keep it from, you know, hitting the ground. But it didn't hit the ground that hard because, you know, all it did is really break the straps, and then as soon as the weight is gone, that, you know, that thing has a lot of power, so just shot straight up. So, but we're all good. Everyone's safe. Everyone's all right. I think I'm gonna give it another try. I have a second drone actually, and I have another battery. We'll try to crash it again or do it successfully.
With the DARPA Lift Challenge, we want to rewrite the economics of flight by creating vehicles that can carry 4 times their own weight, drastically lowering the cost of transporting heavy goods by air.
The mission impact here is substantial. Achieving this means smaller, cheaper drones can do the work of massive, expensive ones, making logistics faster and more affordable for everyone.
What we're trying to do in increasing the weight ratio is being able to find a way to be able to carry more with less. Every time you can increase your weight ratio, you can do more.
The whole point here about bringing that payload to weight ratio is really focused on bringing the cost of vertical lift aviation down. If we can be 4 times more efficient, maybe it can be 4 times less to transport something, to move cargo, to move people. That's what the DARPA Lift Challenge is looking to do. We are looking to make vertical lift aviation accessible to the common man, which will then change the way that we live and improve the lives of everyone around us. Ultimately, the Lift Challenge hopes to spark a new revolution in heavy lift, making the sky a viable and affordable highway for a new generation of air cargo in virtually every sector.
And even if you're not necessarily prepared to win, you go there to meet the other people, see what everyone's doing. There's vendors. We've just found out that there's another competition very similar to this one that now we're going to go and enter into as well. So it's a huge social event. And then starting, I think, tomorrow is going to be like the Flight Fest stuff. And so, I mean, this is just going to be huge. And so it was obvious we needed to come to this.
So there's more to it than just, I'm going to compete for the DARPA Lift Challenge prize.
That's correct. Yeah. And in all honesty, you know, a solution like this, we didn't really think it would win that 4-to-1 ratio, but we do think there's like a future in this design.
Very interesting. How's your experience been with the other teams?
Oh, fantastic. Everyone is very excited about their products or designs. They're very excited about our designs. There's also very helpful. There's a forum, and so I've been watching the forum. Someone said, oh, they need batteries. Another team steps up. Our pick had to leave. That's their pilot. And so someone else says, I can help you guys. And so it's just a very fun, collaborative environment. Yeah, we're competing for money, but it's all about the spirit of competition.
It's fantastic. It's such a great culture, isn't it? Mm-hmm. You know, I was thinking about the event and thinking, I wish we had done it differently. So we've done something differently. I'll do it better again next year. And then I realized there isn't going to be a next year. Would you, if this was like a repeating event, would that be something you'd be interested in?
Oh, absolutely. Yeah. And if it was, I don't know, if they change the rules, you know, this solution might actually be a little more competitive. The problem for us is that the distance is so short, we don't get enough lift off of our wings.
The distance is too short.
Yes.
That's not what I thought you were going to say.
Well, it's legs, right? You're doing 30 passes back and forth, whereas if it was like a mile or 2 miles long, we would be able to pivot all the way to 90 degrees.
Oh, you're not even getting the full pivot because you would just blow out the end of the course.
Yeah, if you take a look at the simulation, this is our tilt angle here. So as you can see, it's about 30 degrees, and so a lot of that's going to be in drag.
So the faster you're going, the more you get the advantage of the wings.
Yep.
I see. Interesting. So your full scale, what did you expect it to lift?
Our full scale, we expect it to lift about 150, 165 pounds.
Yeah.
And
what kind of payload to weight ratio does that give you?
Oh, it's going to be less than 3. So
less than 3.
Yeah, we're already seeing people doing their early numbers at probably what our maximum would have been. So definitely not competitive in that space, I think.
Well, I mean, but there's pros and cons to every design.
Yes.
Right? There's certainly pros to this exact design.
Right.
And, you know, everybody sort of shoots for that goal, right?
Yep.
Some people hit that goal, some people exceed it, but, you know, everybody sort of advances. And I think that's the spirit of the competition. Awesome. Thank you so much.
Thank you.
I just love building drones, and I want everyone to build drones. It's just so fun and rewarding. And so when I saw this challenge open about building like a massive drone, I was like, this is my one opportunity. I will never get the chance to build like, you know, a 150-pound drone. Never. So I was like, okay, let me get on this. And then I was like, what am I going to do? I don't have the most resources, so I wanted something that's kind of like off the shelf. accessible, and I tried to find engines that would produce 200 pounds of thrust, and that's how I came up with a paramotor.
Yeah, a paramotor. So this engine, it's made to put on your back and fly up like a parasail.
Yeah.
And instead you've just got it blowing down and pushing up.
Yep, that's the plan.
Okay, so it makes thrust.
200 pounds, so that should be enough.
Should be enough.
Yep.
Why does it have extra motors on the outside?
Well, my original plan was just to use these little vanes over here. I wanted these vanes to just tilt and control the drone, so I could use the airflow of this and I would save a lot of weight elsewhere. Partway through my development process, I realized, like, with these drones, like with our FPV drones, we can toss them in our backyard, arm it, fly, if it crashes, whatever.
Right.
With something that weighs 55 pounds without any weight, you can't do that. If you crash, it's over, you know?
Yeah.
So I need to come up with a series of test stands and stuff to try and test the drone on a static stand before actually attempting. And in the end, vanes would be a little bit too difficult for me to engineer a test stand. So not only do I have to engineer a drone, I have to engineer a whole bunch of supporting equipment to test it. And I pivoted to using quadcopter style controls to and then control the drone, because that's what I'm most familiar with.
Yeah.
I've learned a lot about quadcopter stuff. So you know what? I'm in a time crunch.
Stick with what you know.
Stick with what I know. So that's why quad motors.
Everybody's been really open and friendly. You know, we were kind of concerned about whether everybody was going to have a tarp over their machine and whether we should have one too. And this has been really a wonderful environment. People have come and talked to us about their projects and their issues, and we've gone and admired and complimented a number of those other ones. So yeah, I think it's been great.
Awesome. So are you able to go do a run even though you're overweight? It just wouldn't count? Are you going to?
Well, we have some mechanical issues too. Like you'll notice that there's two different sizes of centrifugal clutches on this.
I hadn't noticed that. I see that now.
Yeah, and that one's too small. It gets red hot when we
run golly.
And this one is too heavy.
Okay. Okay.
And we just have several sort of mechanical issues like that we can overcome in the next few weeks. It's not like they're showstoppers.
No.
We're just not there.
You know, it's interesting though, because I'm stealing this from one of the other teams. They say you could spend months and months designing and thinking and planning, and then when somebody says, okay, now here's a deadline, suddenly you got all the problems to solve and you start actually moving forward.
The deadline really was a gift.
Yeah.
I think it was. It hadn't been that much fun, to be honest, but it's really been a gift because it got us moving. It really did. Yes.
Yeah. Awesome. Well, it's good to meet you, and thanks for showing me your aircraft.
Thank you so much.
Yeah.
Here at the DARPA Lift Challenge, safety is paramount, and that is why we have partnered with the Federal Aviation Administration. From the outset, we designed this competition to uphold the highest standards of aviation safety while pushing the boundaries of innovation. Every operation is conducted within a structured flight environment that enforces clear boundaries, layered safety zones, and strict response protocols. All remote pilots participating in the challenge are certified under Part 107, meaning they have demonstrated a comprehensive understanding of airspace rules, emergency procedures, and safe unmanned flight operations. But beyond certification, these pilots bring something even more critical. They and their teams have intimate, hands-on knowledge of the aircraft they are flying. They have designed, built, tested, and refined these systems, giving them a deep understanding of performance limits, failure modes, and recovery actions. This combination of regulatory compliance and engineering ownership ensures that every flight is conducted with discipline, accountability, and precision. At DARPA, advancing technology never comes at the expense of safety. It is the foundation that enables innovation to move forward responsibly and ultimately transition into real-world use. Imagine balancing a broomstick on your hand. Now imagine doing it while carrying a refrigerator, in the wind, while flying. That's basically the control problem DARPA Lift challenge teams are trying to solve. As aircraft lift heavier payloads, controlling them becomes dramatically harder. Tiny shifts in weight can change everything. That's where advanced control systems come in. Future drones may use smarter sensors, faster computers, and advanced algorithms to constantly adjust their flight hundreds of times every second. What is that result? Drones that are safer, more stable, and potentially more autonomous. In the DARPA Lift Challenge, the aircraft may get the headlines, but the real magic could be the software acting as the brain behind the machine.
Hello. We are Team Sherman Aeronautics.
We're Astro Systems and we're based out of Chicago, Illinois.
And we are Team SciLift.
And it's essentially a high school team with a few parents.
And we are max weight team ready for the challenge.
Well, it's whatever o'clock in the morning.
A new and improved VertSol video submission. Our flight test plan is designed to make sure that I don't get a visit from our friends at the FAA and NTSB.
We specialize in building out-of-the-box, frankly bordering on crazy machines.
You just can't buy one of these drones on Amazon.
The DARPA Lift Challenge pushed our skills and budget to the next level.
And the biggest issue is probably center of gravity. I've moved it away from the center. We have a circle.
And our answer really is to use airplanes.
I would bring them home and have my kids hang on them.
It's kind of crazy.
This was quickly shown to be infeasible.
That's exactly what we should not do.
It has been a comedy of errors for sure.
Most of the time we spend arguing.
Funny thing, I just destroyed the flyer, so I have 2 weeks to rebuild it.
It was its first flight and it took off successfully for about 2 feet and then promptly backflipped directly into the ground.
The thing shot out through the roof. I mean, it took off like a rocket.
One guy came up and showed me something cool. He pulled a possum out of his pocket.
We actually had 2 catastrophic crashes during our flight test verification.
And it was perfect. Maybe we can't say that, but it was really good.
God, the lighting here is terrible. I look like I'm telling a scary story.
Okay. That one wasn't bad. That's good. Is that good?
The course is not arbitrary. It is intentionally engineered to represent a real-world logistics breakpoint that exists in both military and commercial operations. At 5 nautical miles, you move beyond demonstration and into operational relevance. It stresses endurance, energy management, and thermal limits. It also introduces communications and control challenges that mirror real-world deployment. The flight lane is a compressed representation of a much larger mission corridor. It allows us to evaluate precision, repeatability, and safety in a controlled environment while still scaling to that 5 nautical mile operational concept. By combining a 5 nautical mile mission driver, a precision constrained flight lane, and a tiered geofenced safety architecture, we're forcing competitors to solve the same problems that exist in contested logistics, autonomous resupply, and commercial heavy lift transport. The DARPA Lift Challenge course is not just a test, it's a proxy for the real world. If a system can succeed here, it's not just impressive, it's operationally relevant. What if something could be incredibly strong without being incredibly heavy? That's one of the biggest opportunities for innovation at the DARPA Lift Challenge. To carry 4 times your own weight, every ounce matters. That means innovators will have to develop advanced materials that are lighter, stronger, and smarter than what many aircraft use today. Think of ultralight frames, new composite materials, maybe even 3D printed structures influenced by nature that use material only where it's needed. And here's the really exciting part. The same breakthroughs in materials that could win the DARPA Lift Challenge could eventually show up in everything from automobiles to disaster response robots to even tennis rackets. The DARPA Lift Challenge isn't just asking innovators to build a better drone, it's pushing them to rethink what things should be made of in the first place.
You know, it's been a long 8 months in general, but especially the last 2-3 weeks building this frame. We're glad that we showed what it can do. I think we've had a lot of people that were excited about it and thought it was a very cool design. And yeah, we're excited to see where that interest goes and if we can potentially make a product out of it or something like that.
Day 6 of the DARPA Lift Challenge from the National Museum of the United States Air Force rolls on from Dayton, Ohio. Todd Harris alongside Joshua Bardwell and Elena Buenrostro. And we are getting ready to open things up here for the 4 p.m. Eastern flight window. There's your current leaderboard. Avadrone out of Columbia, Maryland sits on top with a 3.84 payload to weight ratio. Remember, everyone's looking for the 4-to-1. MTech sits in second. Extreme Aerial Concepts out of San Jose, California in third. Then you have H Squared out of Boston, and MacGyver out of Baltimore, Maryland sits in fifth. So, JB, as we look at day 6 and we come up on this next flight window, we've got some teams in there that look like they have some promise. Again, no one has hit the 4. We've seen teams go up with a 4.02 ratio, but they have not been able to complete the 4 nautical miles.
Yeah, that's right. And it's not enough to just take off. You have to complete the 5 nautical mile course. So when you see some of those teams, they've tried to break that 4.0, but no one has yet succeeded.
Flight line, be advised, the flight window is now open. I repeat, the flight window is now open.
So it is official. The flight window for the 4 o'clock Eastern time is up and ready to go as the teams will make their way out to the launch sites. And they will now have 90 minutes to get up in the air, do some testing, possibly do the half-weight check, light check, or go for a full scoring run.
That's right. They can do whatever they want with that 90 minutes as long as they stay within their flight lane and, of course, follow all the safety procedures. And you might wish, from a broadcast perspective, to see a whole bunch of people making attempts.
Sure.
But obviously there's this procedure that's got to be followed. And if you're not sure that your aircraft, well, we've seen some cases where people made a big attempt and the aircraft did not survive the attempt. And so you don't want to do that.
So this is Max Waits out of Richmond Hill, Georgia. It's a Georgia-based aerospace startup developing heavy-lift unmanned aircraft systems for defense, emergency response, logistics, and commercial missions. They were founded by aerospace engineers and entrepreneurs. Max Weight is advancing American-made UAS technology through lightweight design, rapid innovation, and the MWV-1 heavy-lift platform.
And what I noticed most about this is that sling that they've got underneath. A sling is a classic way of carrying weight. You look at the full-scale helicopters, they will often carry weight slung underneath, and it certainly seems like that has a lot of potential to make it easier and faster to unload. You just disconnect that sling and unload the weight. Again, you do have to unload that weight as part of your run.
But you look at that mesh webbing, that stuff, as you know, is probably super strong, so you're going to be able to put as much weight as they probably can do or max out on, and it's not going to be an issue for holding it. It's going to be how stable it's going to be. I mean, you throw a few hoagie sandwiches in there, no problems, legs, all that stuff, but we're going to talk about the plates they put in and why they chose those metal weight plates. It's easier to transport.
Yeah, easy to transport, but most importantly, easy to acquire. DARPA didn't want teams to have to buy something weird or proprietary in order to test this. Of course, these teams have had 7 to 11 months to test this out, so they could go down to their local sporting goods store, buy these 45-pound plates, and test basically the exact same thing that they were going to use when they got here. Oh, and also
across the board.
We're hearing that they're going to be selling them to the local community when this is over.
If you need weight plates of any type or weight, reach out to the folks at DARPA because they have a load that they want to get rid of. They've got quite a few.
They're going to be in your local...
get a pallet of weights.
If DARPA was... Now, far be it from me to presume, but if DARPA was smart, they would mark these plates in some way.
So this one went up with...
If people scavenged them, you keep that as a souvenir.
Absolutely. Would you want one if you took it up and your drone came down and crashed?
I would want if my drone came down and crashed, I would want all the broken parts of the drone. I would want the weight plates. I mean, you offer them to the teams first just as a thank you and a souvenir.
It would be a cool trophy, although except when you go through check-in.
I'd ship it home.
So you got a 40-pound trophy. You sure you want to carry that on?
Get it signed.
Max Waits is rapidly trying to get this lower section solved, and there you see the webbing that they've got. We haven't seen anything like that before. Raging Cajuns also out on the flight line. That's the students from University of Louisiana Lafayette.
Yep, a large bicopter design, large rotors. 2 of them, we've seen them have stability issues in previous runs. We've seen them have some shaking and other problems. We'll see if they've got those problems solved if they get up in the air during this run.
Talk about superlatives for some of these other really unique designs. Most likely to be confused as a Chinook helicopter. I would put Raging Cajuns in that category.
I've seen a couple, but yeah, they're up there for sure. We're just checking it out, making sure everything is good to go. I can't help but notice it's not on the platform. I wonder if does it even fit on the platform. That platform is 10 foot square, and there is a 5-foot circle, 5-foot radius circle inscribed on that platform within which they have to land.
We also have the team Skyweaver from Menlo Park. We saw them earlier today, a fixed-wing aircraft, so they will start those props up manually, those propellers, and then they are attached with a weight in the middle.
Yeah, a steel cable between those planes. There's 2 designs similar to that. And then the last attempt, they either the plane got caught in the grass and flipped over, or maybe the planes weren't moving at the same speed.
Yeah, I think that was more of a non-synced issue.
Yeah,
because you saw that they had slack in the wire, and then
we heard reports that there was some damage to one of the plane's tails. I suppose they've got that worked out, and they're trying to get it back up in the air.
Everyone working a little quicker, trying to get as much in as they can, because yesterday everything was shut down around 2 o'clock. A big front came through, and we had thunder, we had lightning, we had instructions to shelter in place. The rain basically was here for 6 hours, and that pretty much brought everything to a halt. These drones are pretty amazing. They're pretty durable, but what they can't do is fly in heavy rain, heavy wind, and of course thunder and lightning.
Well,
no bueno.
Especially because these are experimental aircraft. We're trying to push the limits, and so never mind that the rain yesterday was pretty extreme, maybe even for a full-scale aircraft. But these ones, you solve the problems of payload to weight ratio, and then you figure out the weatherproofing later.
Speaking of weatherproofing, this is a situation in the Dayton area yesterday. The skies got really dark, the winds picked up, and then the precipitation came down, and we had lightning, we had thunder, we had heavy winds. The good news is nothing was severely damaged, although Donna did tell us that one of their towers was struck by lightning. But it was a pretty serious weather event that came through, and it wasn't just a quick hitter. It lasted. It just kept wanting to stick around.
Ooh. When you say a tower was struck, that's one of the radio towers that's got the wireless infrastructure that's supporting the event.
So we were basically locked in place, shelter in place for 2 to 3 hours. And
well, you say shelter in place, locked. I mean, they just basically said go inside and don't go outside.
True.
Out here in the flat area, you don't want to be a target for lightning.
Raging Cajuns, looks like they are, am I seeing spinning? I think I am.
Okay. Spinning up those rotors. We'll see if they get into the air. I'm looking to see if they have any weight on the bottom. It's one of the first things we look for.
Yep.
If there's no weight, that can indicate this is a test run or maybe a safety run. And if there's weight, then maybe going for a qualifying run. Here we see the rotors are slowing down again. Yep. So that may have just been a spin-up check.
If you're just joining us, and all I have to say is, where have you been? You've missed 6 great days of competition. Tomorrow's the final day of the DARPA Lift Challenge, but the rules are pretty simple. You have to go 4 to 1. That's 4 to 1 on the payload to weight ratio. You have to cover 4 nautical miles on this course. It's basically down and back. Then you have to set the weight down, detach, go back up, stay above 100 feet for the entire time, and do another nautical mile, bring it back, and put it down on the platform. If you can do that, if you can go 4 to 1 on the ratio, if you're the only one to do it, and if you do it under 30 minutes, guess what? You are entitled to $2.5 million as the top prize.
$2.5 million for that first prize, $1.5 million for the second, and $1 million for the third. And I think these guys, what we're hearing from them is, obviously the money is nice, but everybody is just happy to be here, experiencing this, getting to participate. and that's what it's all about.
And then if you don't make it in the top 3 as far as distance covered or successful scoring run, you got the most revolutionary aerodynamic design. That's worth $500,000. Most revolutionary powertrain design, also worth a cool $500,000. And then the most promising, and I already know where I'm putting my most promising vote. That's $500,000 if, and that's a big if I had a vote, which I do not. But I've seen some pretty cool stuff.
We got an idea for most promising?
Yeah, I do. I'll just say this. Well, maybe if I say this, it'll give it all away.
Don't jinx it.
Okay.
Don't jinx it. I'll tell you some of the companies that I think might be in consideration if I was choosing superlatives. The inflatable drone frame.
D-material.
I don't know what category that fits in, but boy,
Yeah.
I've never seen anything like that.
It's cool.
And it feels like it deserves a superlative of some kind.
Yeah, agreed. If you were wondering what we're talking about, if we've lost our marbles here in the heat, this is D-material, and this is their... That's got to be the lightest frame going.
Yeah, well, it's mostly air, and then it is a polymer used in bulletproof vests, they say, and they basically made this structure out of it. They inflate it to 15 to 25 psi, and what surprises me is just how rigid it is. Look at it jerking. Well, it's not good that it's jerking around there, but it's not bending, and you would think if it was a balloon, balloons are squishy, but it's not squishy at all. I got to lay my hands on it, and it's remarkable just how light it is for how strong it is.
We were lucky enough to have the good folks from D-Material come on the set yesterday, give us some insight as the teams continue to make their way down to the flight line. Remember, it's a 90-minute window here in the 4 o'clock hour Eastern time, and got another team coming down. I can't exactly tell who that is. We have seen teams come down with completely different designs. If you do that, that's fine. More the merrier, but you will have to do flight checks with no weight and with half weight.
Yep. Any change to the aircraft, you have to rerun the safety protocols.
So this is actually not a team coming in. This is Advanced Tactical, who we saw earlier in the 2 o'clock flight window, and it looks like they are heading home, so their work is done for the day.
Now they're driving out of there nice and slow. Could be they're trying to keep that drone safe. Obviously got the people riding on the back of the trailer, keeping them safe. And that is the word of the day. You know, we're going to push limits, and anytime you push limits, there's a chance that things can go wrong. You want to do that in a safe manner.
So we got the liquid fuel being put in to the receptacle. Looks like they've got 3 tanks.
You can tell from that red color. It doesn't look like gasoline, does it? So it's nitro fuel. Nitro fuel.
Nitrous?
Nitro fuel is a different kind of liquid fuel that's used in hobby aircraft, smaller engines.
That's not what Vin Diesel uses in Fast and the Furious?
Don't believe it is.
Okay.
I don't believe
checking.
it is. I believe that's nitrous oxide, but I'm not exactly a motorhead. I'm certainly not an expert on Vin Diesel. I look like him a little bit with his haircut.
All right, so they are going to make their way to the launch pad as they've got the fuel in the tanks. And cap that thing off, and then we could be good to go. There you see the flight line. It is a beast. Long ways all the way down, 14 lanes. We're in the upper right corner of your picture there, nowhere near the flight line, but we got a great view. We've got a lot of cameras covering all the action, and we will be with you for the next 90 minutes until this flight window closes, or if someone's given an extra 10, 15 minutes, that's always a possibility.
Yeah.
They've had problems.
You don't want teams to be penalized if, for example, the trackers that they use to know how high everybody is, how far they got, and basically keep the whole thing safe and fair. If any of those tracker system goes down, or maybe another team crashes and you can't go out in the field because of their drone, well, you're not going to be penalized for that. They could be granted additional time.
We have seen some scorched earth here at Wright-Patterson, and we apologize for that, but it's all in the name of progression, as it looks like we've got... Do we have a drone in the air? Is that on the... Oh, that's on the ground. My apologies.
Yeah, you can see some scorch marks there. Well, you know, sometimes batteries are flammable. Sometimes liquid fuel is flammable. We had some examples of that this morning.
Drone happens.
Yeah, that's what you could say. You could definitely say that. Of course, everything handled by the fire safety
Yeah, they
team.
did a great job. They were out there pretty quick. Usually if it's that liquid fuel, you say they'll just let it burn out and then they'll shut it down.
I mean, if you have to pick a kind of fire, I mean, as a firefighter, you think if you have to pick a kind of fire, a little battery fire in the middle of a big open field the day after it had torrential rains is probably a pretty light day.
It wasn't going anywhere.
No.
So we've seen max weights, and we have seen who else has been out there that's been up? We've got the hovering owls are supposed to be out here. APRAD. I'm trying to think. Raging Cajuns, we've seen them. Sherman Aeronautics is also out on the line. Skyweaver. How about Spitfire? The word is Spitfire's en route.
Yeah, Spitfire that almost, it looks jet-powered almost. Looks like the bat.
It's Batman's drone.
Yeah.
If Batman had a drone, it would be Spitfire.
Yeah, of course, they came out to the pad and they put it down on its tail and they fired up the engine.
And they melted the
and
tail.
It melted. They had a crash. Their original carbon fiber frame was damaged in the crash, and instead of saying, well, we give up, we're going home, they 3D printed one. And 3D printing is plastic, and plastic famously melts, but my guess is they thought, well, if we get in the air fast enough, we'll be moving so fast that it won't melt. Now, I don't know if that's true, but they sat there long enough for it to melt, and once again, they're coming back out. I think we're glad that they are.
Oh, 100%. Spitfire, the team from Daytona Beach, Florida. They've only been around for a year, founded in 2025. And they are going to try to put on not only a show for us, but the folks at DARPA, give them an opportunity to take notice. Max Weight's now spinning up, so it looks like they've got that lower webbing catch area all sorted out.
Yeah, we call that a sling, maybe?
I don't see weight in there, do you?
Oh, it's really hard to tell. I mean, something is weighing down the sling. You can see it's not quite blowing in the breeze.
Something's in there.
But we don't know how much weight might be in there, unlike some of them where we can count the plates in this case. And we don't even know for sure that they intend to take off. A lot of times you'll do a power-up test. It does look like that drone is getting light on the launch pad. Throttle up slowly and see what happens.
So there's no weight, as we're being told, on max weight. So they are actually minimum weight, and they're going to shut the blades down. So Max Weight out of Richmond Hill, Georgia, just spun it up, see what it would do. Got light there for a second. Maybe they didn't like what was happening or the numbers they were getting.
Well, we saw it drifting forward a little bit, and that's normal that you get a lot of deflection, a lot of air bouncing off the ground, and it can make it bobble and float a little bit.
This is Raging Cajuns. They aren't necessarily on the launch pad, but then again, we're not sure if they would fit on the launch pad. They're a little big, but that gives you an idea of just how light it is.
Yeah.
I mean, look at that.
Him picking up that big thing, carrying it like it's nothing at all.
He did that, or that's one of Arnold Schwarzenegger's kids, because he just picked that up like it was nothing.
Yeah. And you can see him adjusting the rotor blade there. It does look like this is a collective pitch rotor system, which means that those blades will tilt depending on where they are in their rotation. The blade might tilt up at 6 o'clock and down at 9 o'clock, and it causes the whole rotor head to tilt in a given direction.
Is that how they get their turning?
And that is how they get their turning. That is exactly right. With two blades like that, you can see that by speeding one up and slowing the other down, you could tilt in one direction. But how do you tilt in any other direction? And that collective pitch is how you do it. So
will it fly with one of the rotors pointed in the right direction that it wants to go, or will it fly horizontally against with it?
That's a great question.
Side by side.
If we're flying sort of the long ways with the rotors front to back, one of the consequences of that will be that the back rotor will be getting dirty air from the front rotor. So like if I had to guess, I would say that you would fly sideways and both rotors will get clean air. But of course, there may be other considerations.
This is InSky out of Miami, Florida. They develop advanced aerial mobility systems, electric propulsion technologies, and autonomous flight capabilities with experience spanning fixed-wing aircraft, eVTOL platforms, and heavy-lift VTOL platforms. They focus on expanding performance, accessibility, and the utility of vertical flight.
Look at those carbon fiber props, so beautiful and so expensive.
So teams continue as the flight window is now 20 minutes old, which means they are 1 hour and 10 minutes away from this being shut down. So making their opportunities to make a flight, possibly get a scoring run in. There's a lot of busyness out on the flight line, as well as the command center. And we were lucky enough to give you a little quick peek on what happens there during the day.
All staff be advised, CP is now closed for flight ops. I repeat, CP is now closed for flight ops.
Hands on 3, 8, 11, and 14 start, please.
Getting hold of ground knots for 13 and 15 to see if they're going to make their window, but everyone else should be out there.
Stand by.
range is hot and it is start of your flight command.
Copy. Ops. Range is hot. Can I have a leaderboard check, please?
Leaderboard here.
Stand by 60 seconds. Quiet NCP. 10 o'clock flight window is now open.
2 has been cleared for check, so they could fish straight into competition.
I'm showing 2, 4, and 10 online. 2 marked as unofficial loaded.
It is loaded at 112 payload weight.
2 top left.
Copy.
Yeah, 2.14 ratio for lane 2.
Eric, confirm 3 unofficial or official.
Is labeled as official.
162 pounds.
Official 2.96, lane 3. Standing by for comp run.
Official run should be coming off the lane 11.
3.31.
182 pounds at 3.31.
Stand by for launch.
12 will be an unloaded check.
Copy. Brad, confirm prep 1 is on 2 and 3.
Prep 1's on 2 and 3, confirm.
Copy. 11, comp run.
Yeah, we're watching it.
Eyes on 11, starting comp run. Pending success, goes to second.
Here, 11.
Launch. Launch on 2.
Launch on 2. Suit. All close.
10 crash.
Copy crash.
Crash or hardly in
Lane 10 was reported as fixable.
Lane 3 ops, confirm comp run on 3.
Lane 12 increasing altitude.
Breach. Breach on 12. Here, Prince Breach. Launch on 3. Prep 1 to 3. Lane 4 going cold. Can I have eyes on 11?
Lane 11's descending. All right, come on in for landing on 11.
Dropping.
Lane 3s should be about complete transport.
Looks like 12 safely landing.
They're descending now.
Yeah, they're 40 feet.
Lane 12 grounded.
Lane 3's in last month.
Copy.
And 11.
Stay by 11 for landing. Comp run.
3's coming in.
Stay by.
I'll hold on.
3 top left.
11 successful landing. Run complete. All right, Brad, I want eyes on 3 descending. Competition run. Stay by. Successful landing.
That's 2 on the board in the first batch of runs. Pretty good.
All right, new third place.
We still birds in the air. Lane 10.
1000 flight window is now closed.
We have a cold range
Cold range.
for recovery and transport.
So that is the scene at Air Ops. That is Ann Bush, the lead of that, and she does a great job. Very tense situation in there. You want to go in there and start yapping. You got to go in there and just keep your mouth shut.
No, and you saw at the very beginning, she said CP is closed for flight ops. It sounds like that once flight ops begin, you do not go in or out of there.
Yeah.
Which is, entirely appropriate.
Absolutely. As we see teams continue to make their way out to the flight line for this flight window. Remember, it's a 90-minute flight window, or these are teams that are coming up for the next round. But busy day today. We said we came on the air, it was going to be 63 flights scheduled. We are flight heavy on this Saturday, the day before the final A.
Yeah, everybody trying to get their flights in, get their opportunities to get on the board in these last few opportunities before the event closes tomorrow.
Your aerial view of what we're looking at here. If you're just joining us at the National Museum of the United States Air Force here for the DARPA Lift Challenge in Dayton, Ohio.
Yeah, the space is truly massive. You see the museum there in the background, and the flight field here in the foreground. Just hard to imagine another place where you could have an event like this, not just because of the space, but because of the regulatory requirements. Flying drones this heavy is normally not legal, but DARPA's made it possible for these teams to come here and stretch their legs.
So doing test flying with a drone like this, is it possible?
Well, you could test fly it. So here's how I see it. You can test fly it with no weight. That's the point of the 55-pound limit. Now, 55 pounds is generally the upper end of what a normal person can fly without doing a lot of paperwork.
Yeah.
The other thing to keep in mind is that the FAA controls the national airspace. So if you think about it, if I'm inside a giant hangar, well, I'm not in the national airspace. So I could imagine theoretically you could test it that way. Also, if the drone is tethered to the ground, technically it's not flying. And so theoretically you could connect it to the ground with a tether, add the weight, and lift off, and you would not be breaking any rules. But that's a lot of hoops to jump through, and there's no substitute for actually putting on the weight, putting it in the air, and finding out what happens. And these teams today are finding out some of them to their detriment.
Yeah, and then we look at Skyweaver here. It's one of two fixed-wing aircrafts that'll be tethered together. Sherman Aeronautics is the other one.
He's having a good time. Looked like he was pumping fuel there, just hand pumping, just turning that crank as fast as he can.
Skyweaver out of Menlo Park, California. Solo entry of Ben Barry, a freelance aerospace engineer in the San Francisco Bay Area, whose past work includes the University of Maryland's human-powered helicopter, Connie's airborne wind turbine, and numerous civilian and military drones.
I don't know, get a bungee, or bungeeing something. I wonder, it looks like he might have bungeed to maybe a stake in the ground. We were talking earlier about when they spin the motors, you don't want the plane to come forward. You spin the prop starts spinning, and then theoretically it could pull the plane forward and you're standing in front of the prop for a small period of time. You'll often have another person hold the back of the plane. We didn't see that happen in the previous run, and it sure looked to me like he had a bungee cord of some kind. Maybe he's got a stake in the ground or something. They bungeed it down to keep it from going anywhere. Is that a green bungee cord going over the tail of the plane? I think it might just be.
We got a new craft. I don't think we've seen this one. This is Energetic Flying Nuisance out of Claremont, New Hampshire.
New contender for my favorite team name.
Here you go, EFN. Just two professional grade weekend warriors in a garage who thought this challenge looked interesting and wanted to give it a go.
Yeah, the number of props they have is something we've seen before, but for a craft this large to have such small props is a little bit of a surprise to me, given the weight that they're going to have to try to lift.
I'm trying to think about those props and what they're mounted to, and what is that mounted on?
I mean, it certainly looks at least a little bit cosmetic. It's hard to imagine what functionally might require that shape and color.
Looks like something they may have 3D printed too.
Perhaps.
Super lightweight.
Yep. So smaller props have to spin faster, and energy increases, as we learned from one of our guests, is the square of the RPM. So we're going to have much more efficiency at a larger, lower RPM.
So this is max weights again. They keep kind of doing the same thing. They get this point and they're back into the grass. So hopefully
thinking about getting up.
Yeah,
not getting up.
Really addicted to that grass.
Yeah, they may be, well, obviously they're trying to get in the air, but there's, you don't want to just hit the throttle and climb into the air, have something go wrong, and then have your aircraft crash. So, you know.
We've seen this movie before. This is the third time they've come out. Put it. So this time, look at this. He's going to put it at the very far end of that launch area. So if they do have that sliding takeoff, give themselves a little more space.
Yeah, you can see that red circle there. That is the area they must take off and land in within that circle. You know, there's a very tense moment just after takeoff with a drone. You're close to the ground, you're being buffeted by that prop wash hitting the ground, and if anything goes wrong, it can be dramatic. So there's a conflict of you want to get out of that ground effect and get into the air as quickly as possible, but at the same time, you also don't want to rush it, have something go wrong, and then have it tip over or crash. So it's, in that moment after you take off, you're really highly attuned to what the drone is doing. You're feeling it out. And if it's doing anything that isn't what you expect it to do, you're going to set it back down again. And we could speculate that that's what's going on here. Whatever the pilot intends it to be doing, it isn't doing it, and he's setting it back down. The way they picked it up tells us there's not any weight here, and they're going to keep testing it and refining it until it does what they want, and then hopefully we'll see them put some weight in and actually go for a run. But
this is advanced vertical now up in the air, and they do have some weight. I don't think that is a 4-to-1 ratio.
One plate being held underneath with these guy wires, and it's a real question as to why they decided to guy to the outside versus having it a single connection point on the inside. It does look pretty stable, though. It's not tilting. Those guy wires are very effectively distributing this weight. So that's nice. Oh,
maybe a little half weight check with 1.22 of a payload to weight ratio.
A lot of tilt, a lot of speed, at least for the size.
42 miles an hour.
We've seen. Yeah, that's faster than most of the ones we've seen. Of course, with a lot of speed, you get through the course faster, but potentially you expend more energy. It may speak to some confidence if they're willing to go this fast during their check ride. We'll see if they do that when they've actually got weight on there. Nice, confident check ride, though.
So as they bring it down now, gusty wind, they'll come into the landing area, and we'll see how smooth this is with the weight hanging below. A little half-weight check for them. Boy, descending nice, good hover, good touch, and we've got touchdown. So a good start for them, and they come up on the 30-minute mark of this 90-minute flight window here at the DARPA Lift Challenge. Good to have another guest, Tyler McQuaid, the Deputy Director of DARPA. Tyler, good to have you with us.
Hey, thank you very much for having me. And I'm so glad that we're watching the video here. It was hard for me to come down. I mean, I love being with you guys, but I was missing out on some action on the flight line.
Oh, you don't have to miss any of the action while you're here. We got it all.
Outstanding.
Well, let's talk about what is in this for DARPA. Why do this? I mean, you guys probably could have other things you could be involved in, other things you put your resources toward, but why do this?
Oh, there's really three reasons, and the technology piece is certainly one of them, right? If we can get to the point where we can carry a 4-to-1 ratio, it really opens up a lot of different con ops for us. That means we can change the way that we deliver food and materials into the battlefield. It's the way we can move people out of the battlefield. It really changes a lot of the dimensions of what we could do with that equipment. So number one, the technology. We really need to get new ideas in this trade space. The other piece of the puzzle is really sharing this opportunity with a broader public and getting more ideas to the table. It's really important for us to engage with new participants, get them involved. We have really tough problems, and if you do not get that kind of creativity, that really American garage style, like we can do this into the ecosystem, we're leaving stuff on the table. So that's something that's really exciting for us.
The DARPA Lift Challenge is probably some people's first exposure to DARPA. How can they learn more about DARPA in general?
Oh yeah, I mean, there's lots of different ways that we can do it. So number one, like I said, we would love it if we could get more people to be performers. Now, some people think of DARPA and they think of like big defense tech, but we really have quite a few performers. And what I mean by performers are people who are actually living up to the challenge of creating the new technology for us. So bottom line is, one of the biggest ways that they can get in touch with us if they want to be a performer is through DARPA Connect. This is a program that we've developed. It's an extremely well-run program. It introduces you to DARPA in a number of steps, gets you involved, helps you get through that proposal process, gets you integrated pretty quickly, and that's something that's a great way to get with us. The other way is just to reach out to us, and there's a number of different ways to do that. My favorite way is for you to pay attention to what's going on at DARPA and come in to one of our proposers days. And this is where we're going to engage with people, share the new ideas that we want them to come help us solve. That does require people to pay attention. Now, you don't have to come to Arlington to get that. We have it all online most of the time, so you can engage that way. The other way that I would really love it if we could get people out in the ecosystem to engage us is actually come work for us. We have different ways that you can be a program manager. That's like the best job in the agency. You get to, Donna created all of this. I mean, look at it. He gets to be this superstar. We're going to lose him to Hollywood because he's so good at this. So that's one way. But there's all kinds of other ways that you can work with DARPA. Number one, we have all kinds of, roles in the organization. Like, for example, we have the business financial manager. So you might think about, how did Donna get all of this spun up and know how to allocate resources? He has a dedicated person who's basically his CFO who does that. So there's a lot of different ways to participate in the agency. What I'd really love it is if we could get just everybody either wanting to be a performer or wanting to come work for us, because getting American ingenuity into the place is really the thing that we're always excited about.
Tyler, I got to ask you, what kind of data do you expect to come out of this competition at the end of Sunday when everything starts to shut down and hopefully big checks are being written to some good folks?
Yeah,
what kind of data analysis do you expect to come out of this come Monday?
Yeah. So I think there's going to be two sets of data that I think are going to be really important. On one hand, I'm hoping we actually have people who can make the drones to potentially go out into the field, do some field tests, really push this technology forward. So I think we're going to get a cohort of people who are ready to do that. We've seen some pretty refined drones that look like they could be based on chassis that we already know can be mass produced. So I think we're going to get that kind of information. But the other information that I'm particularly excited about is all of these unique flying machines that are just totally atypical. Now, we've had different versions of them at various times attempted, but without the control systems, without the batteries, without the material science, and now we're putting it all together. So I think we're actually going to see that we have a whole data set that says, you know what, we ought to make an investment in really getting these drones pushed forward. So that's something that I think we're going to get out of this experience.
What is it like to be a program manager at DARPA? You know, we get to see Donna, and he comes here and he talks to us, and then he runs away, and I'm sure he's doing something. What is he doing?
Oh, it's the best job in the world. So Stephen and I, we have, you know, the best job under the PMs. We get to help pick some of the PMs with the tech offices, but a PM is really getting to be almost like a professor, a venture capitalist, and like a motivator. So they are learning as much as they can about a new technology, and they may know like a piece of it, but then they have to broaden themselves and really understand it. They go out to the community. So it used to be called a program manager was a travel agent with a budget. That's how they used to describe program managers. And that's really true because they're going out, they're canvassing the world, they're learning all of this. Like, Donna knew a lot about flight. Don't get me wrong. Like, he was really a world's expert, but he really needed to broaden his understanding of different types of control systems, different types of flight strategies to really be able to analyze this. So he's going to be able to go out and learn all that stuff, which is really fun. And then he's going to figure out how to bundle that into a program. And when he was thinking about this application, he was thinking, you know, okay, we could do it through a challenge, which is really fun. This is a great way to bring it to the community. We get to connect with Flight Fest, which is really a great idea. But there were other considerations. We almost thought about just going with it as a normal program. Normal programs are where we make investments in companies to build technology for us. But the program manager gets to make those types of decisions about how to go about allocating the resources to get maximum benefit for DARPA. So that's the VC side. And then the motivation side that's really fun is it's really two dimensions. You get to motivate this core team that's employed at DARPA, these experts who come in. We have all kinds of, we call them CETAs. They're working with Donna. But Donna then also gets to work with all of these people who are in the ecosystem, the people who are actually performing the work. And that's one of the most gratifying pieces. That's the piece that I've really enjoyed working with people today.
Other than Donna, who you've always said is going to be off to Hollywood soon, what's next for program managers at DARPA? Where do they go after they do something like this?
Oh, well, I mean, it could be that they go off and become a CTO of a company. That definitely happens quite a bit. They could go back to their academic lives. We have a lot of people who we share with academic institutions for short periods. There's a lot of different places that people will go after they are program managers. But typically somebody, you know, like Donna is going to come back to DARPA. He's going to pitch another program after he, you know, gets a couple of nights sleep and gets raring to go. So we'll probably see, my prediction is we'll probably see Donna pitching something else before he pops smoke and leaves. But that's something I want to make absolutely clear. One of the best parts of DARPA is just wait a few years and it'll be totally different because all the people turn over. 29% a year turnover, and that's by design. We want people to come in, give us their best ideas. We want to squeeze out all their energy. We want them to grow as people and then just get the heck out and go do something else, and we'll bring new people in.
And then let me get you down here on this one. Why was it so important to you guys to achieve that community feel? With Flight Fest being here, obviously Dayton seems like an obvious choice to be here. The facility's fantastic. The folks of Dayton have been fantastic. The museum's here. But why was that important to do something like this? A lot of people might think, oh, you're going to go do this somewhere secretive where no one can see it.
Yeah, I would love to say that it was totally the idea of the upper echelon of DARPA, but it really wasn't. Donna and his team had the insight that coming to the place where flight was really sort of, it began to blossom quite a bit, and it's got one of the best museums in the world. And there was this opportunity to connect with this Flight Fest organization that is really wonderful. And the piece that I think is the best part, the part that just gets me really excited, is we have a whole bunch of families and young people who are over there doing some crazy stuff already. They're really pushing the envelope of their flight, right? This is all, you know, remote control manned flight, but they're still pushing it really hard. They're getting intersection with us. And I'm hoping that we're just seeing, like, we just planted like 400 seeds, and they're going to blossom up, and they're going to become program managers, or they're going to become professors, or they're going to become people who work in the defense industrial base and can help us solve those really critical problems that we have in the future.
Tyler, thank you so much for taking some time.
Thank you very much.
He is Tyler McQuaid, the Deputy Director for DARPA, giving us all the inside scoop, so thank you very much, and we can't wait for what's next, because we know it's going to be something big.
Thank you both for being the voice. It's been very enjoyable. Before we came here, we were listening to you guys, watching you on TV. It got us really stoked up to get here, and you guys have not disappointed, so thank you.
Thank you so much, Tyler. Appreciate it.
Cheers.
We'll go back out on the flight line and see what's going on here. It's been a grand day today. As we said, 63 flights scheduled today, and we've got some teams that look like they are moving day. It's like heading down to the flight line, JB, and looks like we might see some action.
Moving in.
Let's put some people up in the air. What do you think?
Yeah, I'd love to see some people get in the air. Obviously, they're going to make the call, but just me as a spectator and a commentator, I'm like, let's do it.
I see some weight on this craft.
Oh,
They've taken off the Titan module, which will have to go back on before they can fly, obviously, so we can get all the data.
Yep. Taking the
weight
plates off. We're just adjusting. Taking the aircraft. Please don't take it away. No, bring it back.
Stay.
Oh.
Stay. This is In Sky, the team out of Miami, Florida. Meanwhile, Skyweavers got their planes out on the, I guess you can call it the tarmac.
It's not really a tarmac.
The grassy tarmac.
Grassy field.
Some people have been asking a lot of questions on internet and that. People are saying, why aren't they doing this before they get out there? How come they're coming out to the flight line and now doing all this tweaking and pulling and wires and stuff? Why haven't they done that before they get there?
There's various rules about when and how you're allowed to fuel. Of course, liquid fuel is a flammable risk.
Right.
And so it looks like what they're doing is they are fueling the planes once they're out there. You can think about it, if you put the fuel in the plane and then you drove it to the field, if you had a spill or you had an accident, it could create a hazard.
Spark, yeah.
Yeah, or God forbid, a spark.
And they make that stop before they get to the flight line, correct?
Yeah, they pick up that fuel before they get to the flight line, so the fuel is stored in hazmat containers, fireproof containers. And this is, of course, one of the pros and cons of electric versus liquid fuel. Electric, it doesn't have the same energy density, and it's in some ways less temperamental. So liquid fuel, a lot more temperamental. We heard the story about this very team. They couldn't get the engine started because he had something wrong with a spark plug or something. And he spent his whole 90-minute flight window out there going, turn, come on, like cranking his car.
I think we've all been there before, trying to get a lawnmower started.
Yeah, same thing. Yeah, chainsaw for me. I can't help but notice that the weight is not centered.
No.
That's interesting.
This is Raging Cajuns, I believe, and they are spinning.
We've been seeing them trying to get up.
We like spinning. We love flying.
That is right. But even here on the ground, you can be assessing the rotor speed, the RPM of the rotor. You can be assessing the vibrations. You have the gyroscope inside there on the flight controller telling you, even though it looks like nothing's happening, the guys who are evaluating this telemetry are doing a lot of thinking, and they're not just doing this for fun.
So the Raging Cajuns spin up, and then they spin back down.
It looks like he's going out to tweak something, maybe. These are collective pitch helicopter blades, and collective pitch mechanism is incredibly complex and mechanically challenging to maintain, let's say. It's one of the advantages of electric motors. There's very little to them to go wrong until you push them too hard, and then the smoke comes out, and then they don't work anymore. But in terms of mechanical complexity, there's just a bearing, a shaft, and goes around, and that's about all there is to it. Yeah,
that does look like it's favoring the left aircraft with a little more distance than the right.
Yeah, seems like that would need to be centered up if these guys are going to go in the air. Of course, last time they tried to take off, we saw one of the aircraft get sort of jerked around. And if the weight was not centered, then perhaps it could cause that, although that seems like the kind of thing these guys would account for.
So they're not ready to get airborne just yet with the pilot, his assistant, out there on the modified launch pad area in the grass. Give you another good look from way up top, looking down on the flight line.
We haven't seen them start those motors either. That's one of the advantages, I guess, for us and the spectators of the fuel, the liquid fuel, is that he has to go out there, he has to flip the prop, and it has to start spinning. It's not going to surprise you. Whereas the electric ones, as soon as they decide to raise the throttle, they just go.
Well, as we wait for someone to go airborne here in this 4 o'clock flight window, as we are just about halfway through it, 45 minutes in, I want to give you an opportunity to get to know some of the people that are working here. If you have an orange shirt on here, not an orange vest, but an orange shirt, that means you are part of the staff here at DARPA, and they do so many great things. And we thought it'd be kind of interesting to find out what they do outside of here, what their background's about, and maybe think, aren't you wondering what they're doing?
Aren't you wondering? That'll never get old.
Hi, my name is Carlos Embry, and I am the lead cybersecurity CETA for ITD. My job primarily consists of making sure that our enterprise applications and performer sites are secure so that when it goes out the door, all that cybersecurity is kind of checked off and it's safe enough to be fielded to our warfighters. What I'm most excited about here at this DARPA Lift Challenge is being part of history in the making.
Hi, I am Stephen Lavenstein. I am a scientific advisor at DARPA. I'm here to see all the mom and pop innovators. You got people, making stuff that they made in their garage, people that, the real tinkerers of the world. This kind of event really draws those kind of people.
Hey, my name is Cole Canals. I'm a student at the University of Florida. I'm here working as a lane tech for the DARPA Lift Challenge. I'm really excited to see if anyone can actually get that 4-to-1 ratio, because that'd be awesome for future, all types of different fields and different technologies. So I'm just excited to see what happens.
My name is Ryan Pippin. I'm an aviation management student at Auburn University. I'm currently working as a lane tech, and I'm excited to see us push the boundaries of aviation.
Hello, I'm Harry Twazan. My background is in bioengineering, looking into entangled drones. So I'm also an innovation fellow at DARPA, and today I'm supporting the DARPA Lift Challenge. As part of being a fellow, we are emboldened to participate in some of these events to see what the overall DARPA is all about. And why I'm so interested in this is because being in the military as well, it is vitally important that we develop future drones that are capable of performing more things other than just for warfare. So lifting objects is one of them.
Hello, everyone. My name is Dr. Robert Brown. I work for the Naval Surface Warfare Center Carter Rock Division in Bethesda, Maryland. I work at the Sea-Based Aviation and Aeromechanics branch there. So our branch analyzes aircraft configurations for the Navy. We operate the Navy's largest subsonic wind tunnel, and we also do fleet support for various ships and UAS integration activities. I've been working alongside DARPA for quite a while, providing SME support. And I'm very excited to see all of the aircraft configurations here. So if you see me around, have any questions about anything, please flag me down.
And our thanks to all the good folks in the orange shirts here, part of the DARPA team that have been here for more than 10 days, putting this together, getting it ready, getting everything in place so that we could parachute in and watch some of the great action. So, Skyweaver, here's the situation. We were just alerted that they are maybe aware of that this is not even, so he's doing it with his feet. We've heard about duct tape, we've heard about 2x4s.
Pacing it off.
Pacing it off.
And it's obvious to us from this drone view that it is too far to the right, but it's probably not as obvious when you're down there on the ground. A lot of sort of optical effects, skewing, parallax, etc. And he's just decided to walk it off.
So I'm wondering if he's going to walk to the left and the right and then get the measurements off of that.
I noticed that he's walking from, let's say, the 6 o'clock position, but it looks like it's off to the right on the 9 o'clock, 3 o'clock axis. Makes me wonder if he's trying to inscribe a circle and figure out where the planes are gonna be. Of course, one of the disadvantages of this kind of complex system. Oh, now he's walking it off. Yeah, he's gonna figure it out.
You get a laser pointer for this, or one of those golf things where you can measure distance to the pin.
Well, next time you do it, you'll think to bring one.
Bring one of those.
That's one of the lessons learned.
Yeah, I mean, if you're rocking a size 10.5 like me, as opposed to some guy that's rocking a Shaquille O'Neal 21, that's going to be a different measurement.
Well, what matters not is the absolute amount, but the relative amount. So if you go toe to heel, you'll count the number of steps, and then you'll be able to see if it's the same in each direction. But of course, you won't know how many exact feet it is unless you know your exact shoe size. But yeah, one of the complexities of this kind of design, there's a lot of variables you have to control for. We noticed that there's a lot more distance between these two aircraft compared to some of the other examples we've seen. I say one other example, really.
I would think that would be a fixed cable between them that had the distance perfectly matched off with the hook or the fulcrum right in the middle, dead center.
You would say that, but
I'm just going full devil's advocate.
See, you and me, who's out there doing it, I'm sure that there's a reason they've ended up where they are, and they've already solved hundreds and hundreds of other problems that would have sidelined definitely you and maybe even me.
Well, if you're just finding us, where have you been? This is day 6 of the DARPA Lift Challenge. Here we are at the National Museum of the United States Air Force at the Dayton, Ohio campus, and there you get a look at this beautiful setup here. If you're wondering what DARPA stands for, it's Defense Advanced Research Projects Agency, and there is our current leaderboard. We're all trying to shoot for, the teams are all trying to shoot for a 4-to-1 payload to weight ratio if they can get that done. And if they can travel a distance of 4 nautical miles with weight and then 1 nautical mile without the weight, they will claim top prize. That would be $2.5 million. Down to $1 million for third place, plus we have 3 superlative prizes worth $500,000. We also have a team of chasers that right now are outside that top 5, but they are still with an opportunity because we've got another day of competition when this day wraps up. JB, and there's some talent out there. You look at Defend Techs, you look at InSky, who's on the flight line right now, Dronesmith we saw in the previous flight window, and then Phoenix Drone LLC currently sitting in that 10th position. But they need to get what is called a scoring run.
That's right. The reason these are chasers, even though some of these numbers are higher than some of our winners, actually only one of them, is that they did not complete a scoring run. They got in the air, and in fact for that 9 payload to weight ratio, they were barely in the air for a minute before they set back down again. Nevertheless, they are a chaser. They did get off the ground, and as you can see here, just getting off the ground is no small hurdle to clear for some of these designs.
Well, this is a good sign. I see both props are spinning, but they will not take off until those 2 individuals depart from the grassy area.
Yep, they will need to be behind the safety barrier. It's worth thinking, even though that weight looks like it's off to the side from our perspective, we don't know if there's some other rope or attachment that is actually centered up. It does, as you said, Todd, seem like the kind of thing they would have thought of. Maybe they did. So we'll see them as you start up an aircraft like this with a liquid fuel engine. You'll start it, then you'll do a power-up test. You'll run the engine up to high RPMs, make sure the motor doesn't stutter, make sure everything is smooth and happy. You'll bring it back down to idle. You'll walk to a safe distance, and then you'll begin your takeoff roll.
Look at the flags in the distance there. You see how the wind does seem to be picking up just a little bit as we approach the 5 o'clock hour here in Dayton Eastern Standard Time, as the gust is up to 11 knots currently right now. So that is something we'll want to keep our eyes on, as will the teams as they make their way to the flight line.
Yeah, and that's 11 knots as measured by the weather station here on the ground, but of course they have to maintain a minimum altitude of 100 feet and a maximum altitude of 200 feet, and you can have a lot of difference in the wind between the ground and 100 feet. So who knows what's going on up there? You know who knows? The pilots who are flying. They can feel that air pushing their aircraft around and respond to it.
I thought it was an interesting term, and you've heard it before, but until he said it in context, I'm talking about Philip Smith, call sign Donna, our program manager. He said, it's kind of like flying by the seat of your pants.
Yeah.
You have feel when you're in an aircraft and you're doing it by hand. You can feel, the turbulence, every part of how the plane is reacting.
Yeah.
Does it have a shimmy? Does it have a vibration? Anything going on?
Yeah.
This is totally different. It's all line of sight.
Yeah, it is, and it's line of sight. So you have to just visually view, and using the data telemetry, what the aircraft is doing. It's one of the things that I hear from full-scale pilots who transition to RC aircraft or drones, is they're so used to feeling, you think about being in a car, you go around a turn and you can feel it pulling to the side. You hit the brakes and you feel yourself being pulled forward against the seatbelt, and that tells you, even subconsciously, what the car is doing. And of course, those airplane pilots are used to that.
Right.
You put them in a drone, and suddenly they just have to use their eyes. And of course, as a drone pilot, I look at the video and I can see what the drone is doing, and I'm not feeling it. It's probably a good thing. It probably would not be good for my stomach.
Yeah, agreed. So with the props spinning, it looks like they are going to extricate themselves from a grassy area, possibly get behind the safety barriers, and we may be looking at some flying.
Certainly would hope so. The last time they spun up, they started their takeoff roll, the planes started to go in a circle, and one of them tipped over, whether that was from hitting the grass as you proposed, or because something with the strength between them, the strength of the pull. You can think if those airplanes are both pulling against that cord, if one of them doesn't move at the same speed as the other, it'll just send the whole system off flying. It has to be very, very carefully balanced.
This is Energetic Flying Nuisance out of Claremont, New Hampshire, and they had a full cadre of people working on that earlier. So now it's been down to, looks like 4 individuals, with one person working primarily and the others observing.
Yeah, certainly one of the more interesting aircraft we've seen here. And nobody's backing out. You know, although we're coming to the end.
Yeah.
And here we've got an aircraft that is, still has check flights to go, doesn't have a score on the board, doesn't even really have an attempted run. It's not like they're going to say, well, I guess we'll just go home. Everybody, just to get up in the air, here is an honor and a point of pride for these guys.
Don't want to rush anybody, but we are coming up on the 5 o'clock hour. This flight window should close at 5:30 with still another flight window to go. So, and most of the scoring runs that we have seen come in, they've been between 19, 22, 23 minutes. So you're coming up on about T-minus, what do you think, 8 to 10 minutes,
yeah,
if you want to try to get a scoring run. Otherwise, this is just practice / testing /
data
halfway
gathering.
Data gathering.
Yeah, gathering data. Everybody would like to score, but there are things you got to do first. You have to do that unloaded check flight, a check flight with half weight, and then you will be allowed to go up with the actual weight on and make a competition attempt. And these teams we're looking at here are not to that point yet. It looks more even from here, from this view. It still looks like it's a little off to the right. We'll see if they get up in the air what actually happens.
Take up the slack.
Yeah. I mean, maybe they'll surprise us and it'll just fly with it being uneven.
Maybe they'll surprise us and they'll fire up those props and they'll go around, they'll mow the grass while they're sitting there, and then they'll spin around. Meanwhile, we're keeping an eye on that, Raging Cajuns, they've gone back up in the air. They're in a full hover mode.
Yeah, looks like a decent hover. No drama is what you want to see. No wobbling, no oscillation. They're going straight up in the air. They're not transitioning to forward flight yet. If you look carefully, you can see those rotor discs tilting forward and back to cause the aircraft to move the way the pilot's commanding it to move. Right now, the left one is lower, and it's tilted slightly toward the center.
So this is not a scoring run. This is more testing.
No weight. Hovering up there in the sky, that little ribbon hanging down, we've decided that is an orientation marker that lets the pilot know which side of the aircraft is the front, so that when they're flying it, and they are flying it with their unaided eye, there's no camera on the drone. There could be, some may have chosen to do that, but we believe that they didn't, so that when he's flying it, he can see what it's doing. Yeah, there he is, with his unaided eye, controlling the drone. And yeah, you might think, well, surely a camera would be better. Like, you could just virtual reality fly the drone. But two things about that. Number one is, it's one more system to fail. You have a virtual camera, you lose radio link, now you can't see where you're going anymore. And then there also are challenges with the radio systems. The number of those you can get in the air at a time becomes a limitation. So a lot of these guys just said, hey, we're going to get one of these awesome pilots who can fly line of sight, and we're going to have them do the work.
It's got to be trial and error. I mean, you just start with a smaller craft and then build your way up, get a touch to it.
Yeah, well, what you would do is you could start in a simulator, which is always good. But what you would do is you would start with a smaller, safer craft, and you have it facing nose out away from you, so its butt is facing you, and you basically just lift into the air just a little bit, and then when it starts to drift, you make tiny little movements to keep it, in a box, basically. And that's how you start learning to fly line of sight. Soon you get the ability to do it in a box, and then you start practicing nose in. And of course, when the nose of the drone is facing you, left and right are reversed, front and back is reversed. And then once you've got that, you'll do sideways facing. And then eventually, and this is about where my skill with line of sight flying, I'm an FPV pilot primarily, you'll actually just do figure eights and loops and flying around. And it's a real challenge, especially as it gets farther and farther from you, to see which way it's facing and so forth. But these guys are experts at it. Even when that drone is a tiny dot in the sky a quarter mile away, they still know how to keep it within that safe box.
All right. So if you're a kid and you want to go out there and you want to get some line of sight training in, you talk about a simulator. Is it more of a video game, or you just pop into your local arcade and say, hook me up with the simulator?
Well, a lot of them are available on Steam or for download from the internet. You would just look for a RC flight simulator or an FPV drone simulator. There's various ones out there that you can pick up. Some of them are even free. Most of them are less than, say, $50, so it's not too much of an investment. And the key distinction there would be whether you wanted to start learning to fly line of sight, like these folks here and like the folks over at Flight Fest flying their planes, or whether you want to fly FPV with a camera on the plane. It's a very different perspective, whether you're looking from quote-unquote inside the vehicle versus from the ground.
And I'm wondering if that can be done on your phone, because it seems like nowadays most kids are doing everything on their phone.
Yeah, there are simulators that you can use on your phone. There's two things about that. One is the processing power of the phone is slower, although there's some of those sims are pretty good. And the other is that you really want to have a controller. You don't want to be using a touch screen, because a controller is going to simulate the actual process of flying the real aircraft. And if you're flying in the sim, you want to be building skills that you can transition to a real aircraft. I mean, probably.
Look at this. The students from Stanford Online High School are back out on the line. We saw them in the last flight window. They got it up, and then they pitched it forward, and it flipped upside down. But maybe they've made some repairs, and they've given the green light. There are some open lanes, so there is the space.
Yeah, and we don't know the exact process that's being used to determine which teams get which slots. But, as the event goes on and some teams are no longer able to compete and drop out, you can imagine that opens up slots for other teams who want to keep trying.
Yeah, we did talk to a few of teams as they were actually packing up and saying, we're done. We could do no more. We're heading out, but maybe that's opening up these flight windows for these teams that pop back out there.
And they're not going to waste it. I mean, the ability to be here, as we said, and keep testing and keep trying. We've seen them try to take off multiple times. They're having some kind of stability issues. The craft will kind of hover, it'll wobble, it'll tap the ground and flip over. And I'm pretty sure these folks would still be here, in the middle of the night if it was possible for them to do it.
So this is Stanford OHS, or Stanford Online High School. They're taking off the rotors, kids from Redwood City, California, so that's not trending in the right direction. The other day, though, they were kind enough to pop a GoPro on and give us a first-person account of what it's like to be on the flight line, what it's like to get your drone ready, give us an inside view, or at least a little peek behind the curtain.
Well, we see him here with the laptop doing some configuration here. We're checking the motor mounts. That may have been, I saw them doing that after the crash. You can see there the folding propellers. They fold up for transport. He's checking each of those airfoils to see if any of them have been knocked loose or broken. It does look like the post-crash inspection. Checking the motor mounts, maybe checking the wiring going to the motor to make sure it's intact. Nothing has come unplugged. The worst thing you can do after a crash is go, yeah, it looks fine, and try and put it up again, and then do even more damage because there's something that you missed.
So they are out there MacGyvering their rig, not to be confused with the Team MacGyver that's currently in 5th place. They're going to try to figure this out, get some possible airtime, but they are coming up against under 30 minutes before this flight window closes, and we get to the final flight window of the day on the second to last day of the DARPA Lift Challenge.
Yeah, let's talk about why they might have taken those props off, because obviously you're not going to fly if the props are off. And it doesn't look like they're packing up to go home, at least not yet. You might do that if you were going to test the motors. Like, let's say you've got a question of if a motor is spinning at the right RPM. You take the props off, and then you can arm those motors, and there's no safety issue. By arm the motors, I mean spin the
them
motors.
up, yeah. So you've got a lane coordinator, you've got 3 members of the Stanford OHS team out there having a nice discussion. This is Energetic Flying Nuisance out of Claremont, New Hampshire. They are continuing to work. They've been in the same position pretty much for the entire time this window has been open, so over an hour they've got it out there. They're making changes, picking things up, and Elena Buenrostro spoke with them on the flight line a little bit earlier.
While we're waiting, Todd, I was able to talk to one of the moms, actually, of Energetic Flying Nuisance, and she was just telling us their journey, how they were going back and forth for 8 months between New Hampshire to Saratoga Springs to build this drone in their garage. They had 7 3D printers to bring it to life, and it's been a journey for them. So we're just excited to see them go up, and hopefully we see that soon.
there as our roving reporter out on the flight line, getting great access to all the teams out there. We mentioned at the top of the show today we had scheduled for 63 flights. Those are scheduled, but doesn't mean they're going to actually go up. And right now this is kind of one of the same situations, as we are lucky to have back the program manager of the DARPA Lift Challenge, Philip Smith call sign Donna. Welcome back.
Thank you.
I mean, when you're gone, we're like, where's Donna? What are we doing? I know you got things to do.
I got, running the place. I'm trying. I'm trying to be here. But
all your bosses came in. They
did.
Singing your praises. It's just all nothing but good.
It's that behind closed doors. Maybe it's a little different.
There you
but,
go.
No, it's great to have them here. It was awesome to see them up. I was here in the background for JB. I saw a little bit of Stevens before I had to run, and it's really great to have this support, which is awesome about DARPA.
This is a long day today. We're already on the fourth flight window with one more scheduled to go. This obviously to make up for yesterday when we lost 4 or 5 hours.
Correct. Yep. So we have a couple of people who were very late, or they showed up early in the competition. They did everything right, and then they just ran into problems. So is that live right now?
Yep.
Boy.
This is actually
a save. That was a save.
They just dropped below. Oh wait, they haven't hit. Oh yeah,
they're at 116, so I didn't see where it went, but 94.
They dropped down to 80.
Yeah,
so
that'll do it. And the light, the green.
Yeah,
they're going fast. We saw them going 40 miles an hour.
That's going to be hard to hockey stop like that.
No kidding.
Stop.
Yeah.
That's a good
kidding.
term.
Yeah.
Anyways, you were saying we're going to put 5 sessions in today.
That's right.
And just,
But this is all about just trying to get the teams as many runs as possible, right? We want to see success. We wanted to be able to do it. My staff is being good sports, staying late and working the times. The winds are a little bit rough, but people seem to be wanting to risk it and give it a go.
Yeah.
Talk to us a little bit more about the thought process you use. Obviously you book out the lanes, and then maybe a team drops out or can't compete or can't make it. How do you decide how to allocate those slots? Because everybody wants as many slots as they can get, of course.
Yeah. So it is actually very difficult to do that, to be fair, but then also just say, like, the goal of us being here is for people to fly to try and break these records, right? So we have a process. In general, we have tried to get everybody, one a day. Tomorrow it looks like we will only have the 9, 11, and 2 slots. So we won't be doing the 1600 and the 1800 or the 4 o'clock and 6 o'clock runs. And that's just due to a number of factors of, the end of the week and all this sort of stuff. So we will be looking at that. We will have to figure out how we mash people into those spots. But throughout the week, it's been, you guys had a video of inside the command post. Mm-hmm. So one of the staff in there is constantly on Discourse, which is our Teams communication chat. And then we have another one with the staff working through that. Our hangar managers are going up and down talking to the different teams and asking them, when they're going to be ready and not. And as you know, people are rebuilding. They're trying to tune their aircraft. So it's like, I think I can be ready for the 4 o'clock. So that's really how it works. And then once we have those, we look at the schedule. We see what was pre-scheduled. We're not bumping any of them.
Sure.
But if we have some open slots, then we're going to try and put them in there.
Because there definitely have been some questions of like, well, we have 3 teams out there. Couldn't somebody have taken their slot? But it's not as simple as just going up to somebody and saying, hey, we're bumping you up 2 hours.
Right. So if we already gave them a scheduled time, we try and keep that. And that's a try. If we need to move lanes left and right, then that's easier. But at least we gave the team and we said, hey, this is your opportunity. Get up there, and all the hard work that you guys have put into it, we're going to try and let you get out there and shine. So that's difficult, like I said before, but it's an ever-rolling process. For me in aviation, military aviation, I'm used to that flight schedule roll.
Sure.
Just like we had yesterday, a thunderstorm comes through, whatever you have rolls to the next day. But for us, it's even more dynamic because you have that added pressure of trying to fix and maintain your aircraft all along.
All right, so we will look forward to yet another flight window coming up after this one concludes, and looks like it's under 20 minutes until that will be shut down. Then it'll be a 30-minute gap time to get the teams out there, get them prepped and ready to go, and then we will close out the penultimate day of the DARPA Lift Challenge here in Dayton as everything turns towards Super Sunday. How do you feel about Super Sunday?
Man, I'm excited. So the 3 teams that crashed this morning who all tried for that 4.0 have said that they're going to rebuild, right? You guys, I think, have heard that. So they are going to be working and building another aircraft. So we have one more shot tomorrow. And we've already made the decision that the schedule that is tomorrow that we'll put out later on, it's not going to move. You know, if somebody can't make the 9 o'clock, the 11 o'clock, we're not going to play that game on the last day. So it's all or nothing. I mean, it's coming down to the last day here of this challenge, and I never thought that, right? I never thought that, okay, on Sunday everybody's going to get this close, or a number of teams are going to get this close, and we're going to see that 4.0 or that 4-1, and get there, right? So we're gonna replay here. We're gonna look at some of these videos from this morning. A couple of the guys that are actually trying to do.
This is Avidron, the current leaders, as they went 4.02 until they didn't.
So talking to these 3 teams, they are so pumped. They see that light at the end of the tunnel. They're like, this is it. I can do it. It was a little thing that happened. Let's put it up and try again. And this goes back to, you know, I keep on talking about strategy, right? So obviously something went wrong with all of these aircraft. Where you go now is how much do you change?
Right.
So with this one, where we talked about the motor shear, which we think it is the problem here. Do you put just a little bit more Loctite on there? Do you put, you know, another screw, maybe tape like we had before? For shearing forces, that's difficult, but this is the thing. Do you change much? You know that you just flew a mile, maybe half a mile, whatever it was. Do you change much, or do you just put up the same configuration and cross your fingers, right?
You're so close to getting it, and you only have to do it once.
Right.
So everything has to go right one time.
And
you'll have that 4-to-1 payload to weight ratio. That, let's be reminded, unlocks the full cash prize. They're only at half prizes so far.
For that team that makes it.
Right.
Yep. So if one person makes it, they'll get the full, and then the other 2, if they don't make it to that 4, they'll get the half prize as well.
Right.
We're all looking forward to that Super Sunday, but we still have the rest of this flight window, about 20 minutes to go, and then we'll have a half an hour gap, and then we're on to the final flight window of the penultimate day here at the DARPA Lift Challenge. Thank you so much for taking time and chatting with us. Is there anything else? And I know I'm going to bring this up, and people are like, stop bringing up Spitfire. Is Spitfire coming out today?
I was out on the flight line today, and I talked to them. They are essentially running out of time. And this is a challenge that has a finite amount of days. So they should be on this flight window. They should have some cinder blocks out there, and they're testing half of their system. So their system, as a reminder, is 2 of these jets that they sandwich together with the weight in between. So they are going to flight test one of them just to show that their modifications and changes and everything is good. We did put some cinder blocks out there, as you can see in the feed. That's just to help prevent any of the heat coming out. We know that they know as well that that's not a competition run. That's not how they're going to do it. But for this test flight that we see today, we're going to look for them to hover. We're going to look for them to slowly increase their speed and show us that they can control the aircraft throughout that envelope. And then I don't think they're going to have enough time to be able to finish that second aircraft, put them together, get through the safety flights, especially with our short window tomorrow.
Yeah, I mean, I'm sure you would rather not burn another hole in your nice plywood.
You know, nice plywood. No, no, we're not worried about the plywood. Not worried about it. And that's a good marker. You know, it's just like the marker on the grass. It shows, shows effort. It shows that we tried.
If you think these guys are taking home souvenirs? Do you think they're going to be like, hey, can we have that plywood? We're going to frame it.
Actually, some of my staff, one of the drones crashed on the taxiway, the one that's out farther. So it was something like 120 feet, and the weight plates shattered. And so a couple of those pieces people have already grabbed up, and it's like, this is going to be my souvenir.
I'm going to throw you a suggestion since you're here. You talked about taking these weight plates after the event and sort of, just selling them to local, we play it again, sports or whatever. You should mark them, stamp them, or paint them so that when people find them, they'll go, oh, it's from the DARPA Lift Challenge. They'll become collectibles.
Especially if they're partially scorched.
Scorch
on them. Oh, here we go.
Oh, man.
Wow, that came together quick.
Literally.
All right, so you saw those.
That was Raging Cajuns.
Vibrations that they had, which ended up loosening probably their joint in the middle of the aircraft, and then you saw it fold up in there.
Let's watch this.
Oh,
again.
they do have weight.
Yeah, they do.
That weight may have
Was the weight too much?
The joint.
So they started here. You'll start to see that oscillations, right?
Oof.
And now you've got harmonics. So in harmonics, just like in music, you have resonant frequencies. So when your blades hit those resonant frequencies, they marry up and start to shake the entire aircraft. This is a very common problem in rotorcraft. It's a difficult thing to do because you can only figure that out. Well, there's math behind it as well, but you can figure it out. And then also what a lot of aircraft do is they pass through that resonant frequency. So as they're powering up, they'll know that this is where that resonance is happening, and they'll quickly try and pass through it. With them, this is the first time I've seen them with weight. That may have been, may not be true. That looks like their half-loaded flight. If I can see there, two plates of 50, 55 pounds.
Yeah, it was 1.31. Yeah.
So that was their unloaded test flight, and it just showed that they hit some of those harmonics and cracked.
Is it possible we get to that point? Is there a kill switch that they can just shut everything down to save the craft? Or?
Right, that was a requirement. Well, at that altitude, you kind of want to just hold on. So if you were to drop that from that altitude, it would break as well.
Yeah.
Now, we have a kill switch. All of the aircraft are required. That's tested out in the run-up area prior to, and then in the prep area and also the lane tent as well. When they get up there, everybody knows that there's a how to activate it and what it does when you hit the kill switch. But in that particular case, it wouldn't have saved them. They were.
Speaking about that resonant frequency, one of the characteristics there that might come into play, isn't it true that rotorcraft have a more consistent blade speed than like a drone?
Correct. Right. So the different control theories with rotors, essentially, let's break it up into two. You have your variable speed. So you're controlling your lift. You can have a fixed pitch. You can also go with a variable pitch, and then there's also the swash plate mechanism, right? So standard helicopters that we see flying around, what they do is they spool up and they maintain their RPM.
Right.
And then all they do is just twist their rotor blades, and that's how they maintain that control. So as it's going around, they twist. That's how they get that instantaneous reaction that allows them to do very finite maneuvers. With these drones, and you can see it with the propeller-driven rotors, they don't have that capability. They're going directly into a very, very slow disc that's moving around, and they're also, most of those are fixed pitch. Mm-hmm. So they're using the speed of that blade to go up and down. That's why we're seeing those controllability problems from some companies, from some teams, and other teams have figured that out. And that's, extremely interesting to us of which one figured it out and which one didn't.
Yeah.
We saw the Raging Cajuns just moments ago have their incident. Just prior to that, In Sky, the team from Miami, Florida, also spun up and actually got off the ground, and then this happened. So Donna's going to tell us exactly what went wrong.
I don't know about exactly.
Dead on.
So, what could happen here? You saw them settle a little bit, but that might have been because they noticed that they didn't have the controls, so the pilot may have brought it down. These are variable speed propellers on here. So you can get into a pilot-induced oscillation, a PIO is what that's called. What that means is, when kids are learning to drive a car for the first time, they oversteer.
Yeah.
Right? And you got to tell them, hey, back off. Like, don't oversteer on this. And that's what happens here sometimes. This may have been under automated control. It might have been under pilot. So for this instance, let's say it was under the pilot. What he was doing is he saw the left. He implemented a control. And just like when you're driving, he didn't take it out in time. So he oversteered. And that brings that rocking motion that you see. And eventually, it's uncontrollable, and then, then crashes.
We've seen a lot of cases where it seems like one of the arms dips and it kind of flips upside down.
Right.
What causes that?
So there are a number of things, but essentially, once you get to a point, that rotor disc, in order to have max thrust, it needs to be pointed straight down towards the ground, right? So perpendicular to the rotor disc, or the propeller disc in this particular case. As you start tilting, that lower rotor disc, obviously all of them, start tilting and you losing that thrust. So that's immediately when you start losing altitude, because your thrust vector is not pointed against the earth, right? It's not pointing straight to the sky. Now, the control mechanisms that make it flip instantly, don't know what that is, don't know exactly what that is, but we do see that a lot, that once it starts gaining that momentum and then you go past the point of no return, you just can't catch it.
Kind of like chasing your tail. You go left, you chase it left, then you chase it right. You're late, and you're always constantly, as you said, overturning or oversteering. So, it's collection time. And this is Steve from Raging Cages. Look at this. You talk about a souvenir, JB. Why not get a picture of yourself out in the field with your destroyed drone? But you came, you saw, and you flew.
Heck yeah. They're super proud to be here.
Made it. It's awesome.
They're going to collect the pieces and take it back. I don't know. Here we go.
Oh, this is the first time that they've gotten up in the air.
And bouncy landing.
Yeah.
Oh. Bouncy, quote-unquote, landing. As you said earlier, a hard landing.
Hard landing.
Yeah, that's a heavy one.
Yeah, but crashes have paperwork, right? But hard landings,
that's fine.
There's no paperwork.
This is Sky Weaver, and they spent, the better part of an hour and 15 minutes trying to get this sorted out.
Yep.
From our eyes, it looked like they had the weight, or whatever, the fulcrum in the middle, was off to one side. So one side had more cable than the other, and they set it up. So here, we just missed the start of this. Here's the moment of truth. See, we think the weight's too far to the right.
One of the planes is, there they go. They are going so much faster.
Yeah.
Right? And just having trouble with their altitude control. You know, the other team, I'm blanking on the name, Todd. The other team who
Sherman Aeronautics.
Sherman
Aeronautics.
They said that they have automated the control, but originally him and his father were flying the aircraft manually. I wonder if we know.
Yeah.
I wonder if we know whether that's the case here. Have these guys automated this, or maybe they have two pilots flying manually? I don't even know if that would be allowed within the rules.
No. It does have to be controlled by a single individual. That's a Part 107 requirement, an FAA requirement. So what they had there in the middle was just the tracker on there. So they only had that 2.4 or 2.5 pounds on that tracker. Being the first flight, they need to do that safety flight, which is why we do it in the least dangerous. Also for this one, if you notice, there was no one next to them in the lane. So we do that on purpose for some of these. When you go up for the first time and you have something that is so out of the box like this that you don't know what it's going to do, we clear the lanes next to them. We also push the teams back, just out of an abundance of caution for these types of events.
So when Spitfire goes out there, do we give them their own lane or two?
It's going to be well monitored. Well monitored.
Well said. So we will see what happens here. If they are done for the day, their flight window is closing in under 7 minutes.
And like you said before, Todd, just giving props to these guys. You know, like these were the guys that, remember, for a full 90 minutes they were out there turning their props, trying to get it going.
Yeah.
And I think a couple of people came over and helped afterwards, and engine experts or whatever, and started helping them. And then today they spent most of their flight window out there just trying to get it started. But just this goes back to those design choices. So it looks like Sherman built their own aircraft and just had probably electric. I think it was an electric aircraft.
Yes, I agree.
So they decided to just go a different route, right? They said, I'll take risk on building my own aircraft because it's a very simple design, but I'll make it simple so I don't have to focus on that.
Yeah.
These guys took commercial off-the-shelf drones. As you can see, these are some that you could probably buy from a hobby shop or online, and they said, okay, I know what these can do. They have solid performance, so I'm going to accept less risk there. But then they ended up accepting a little more, right? Because they went with a gas engine, and then they had starting problems there. So just very interesting, especially when you can do these apples-to-apples comparisons of the same types of designs, of seeing the strategy that they had coming into the competition and how they were going to do it.
Yeah. So there's 7 minutes unofficially left in this flight window. the 4 o'clock flight window. We'll see what happens if anyone else is able to spin up, but it gives us an opportunity once again to tip of the cap to the good folks in the orange t-shirts from DARPA who are putting in so much work, and want to introduce you to them. And we're wondering, aren't you curious just exactly who they are?
My name is Ken Pankratz. I'm excited to be out here supporting the DARPA Lift Challenge. I've been supporting DARPA since 1996 after serving 10 years on active duty as an infantry officer in the Army. I've been supporting the Biological Technologies Office at DARPA for the last few years, and I have seen a lot of wonderful breakthroughs that support our warfighters. I'm looking forward to seeing some breakthroughs in technology here at the DARPA Lift Challenge.
Hi, my name is Grace Ann Flanagan. I'm enlisted in the Air Force and I work over on Wright-Patterson Air Force Base. I got the message that they were looking for volunteers for the DARPA Lift Challenge, and I've never been to any sort of drone event before, so I thought it'd be really cool to take part in this and see how everything plays out, see who wins the challenge, and I'm excited to see how everything turns out.
Hi, my name is Lun Chen. I'm an Innovation Fellow at DARPA at the Defense Science Office. An Innovation Fellow is a position for emerging professionals who wants to help drive changes and impacts for the betterment of national security. And I'm a metallurgist myself. I'm a material engineer and have a PhD in material science engineering from the University of Virginia. At the DARPA Lift Challenge, I hope to be a part of the crew to make this event successful and drive positive changes.
Hi, I'm Eric Butterbaugh, and I've been working at DARPA for about 15 years in the Public Affairs Office. Before that, I served in the Air Force as a Public Affairs Officer for 21 years. My first assignment was right here at Wright-Patt, and it's great to be back here with DARPA at the birthplace of aviation to see the next technological breakthrough, and that's what we're really excited about being here for.
Hello, my name is Natalie. I'm a 4.0 aerospace medical technician. I work right here in Wright-Patt in Area A in the medical center, and I work in PACU, so basically we're helping all of the military dependent and veterans for their surgeries. So anytime you need an IV, we're there to help you out and help you while you're recovering from surgery. Reason why I joined DARPA is I thought it was a very interesting event, and I wanted to see what advances are happening that will help us in the mission long run. Thank you.
I'm Luke Edwards. I'm a contractor at DARPA in the Defense Science Office and the Tactical Technology Office. I'm a former submarine officer as well. I served in the Navy for 8 years and bring my experience to work on undersea systems and unmanned technology. I was really interested to join the DARPA Lift Challenge to be a part of aerial drone flight and to push the limits of the technology in this area.
Hey everybody, I'm Cam Ryder. I'm from Virginia. My company name is Chugotch. We're here assisting the DARPA Lift Challenge. My trade back home is a welder. We do a lot of shipboard work. Out here, we're doing recovery and team transport for the drones and their personnel. So it's been a fun day. We've had some decent weather, and we're looking forward to what the week's going to bring from us.
Hi, I'm Phil Mraz. I'm an engineer, retired out of Wright-Patterson Air Force Base here, a retired Air Force civilian for 34 plus years, now supporting DARPA on the Sprint program. So I'm super excited to be here in Dayton, Ohio, in my own backyard, helping with the DARPA Lift Challenge. I can't wait to see all the innovative ideas that people have come up with across the country for the Lift Challenge. And so it's a pleasure to be here.
So, Donald, those are your people. Go ahead and brag on them because they've been fantastic all week long.
They've been ridiculously awesome. We put out the call months ago saying, hey, just traditional challenges, you need, hundreds, 200. I think we had about 280 people all take time away from their jobs, the things that they actually do for a living, and say, yeah, I'm going to go out and, sit at a hazmat locker for 8 hours and just, collect batteries and fuel and everything. But it's both. Like I'm so happy for them to be out here. I'm so happy for them to experience it, but also just we can't do it without them, right? And we had a number, as you just saw from that montage, of people that that volunteered to help. So we have people from Wright-Patt just next door. That's where they work, and they said, yeah, sure, I'll walk over. We had people come in from DARPA that are amazingly talented in their own right. We saw some PhDs in there. We have people that are working on groundbreaking sciences and just said, you know what, this is a once-in-a-lifetime opportunity to go see a challenge. I'm going to go out there and do it. And it's funny with those guys, you know, you're having them pick up trash or
Yeah,
something like
yeah.
that, right? And then we have our contracted staff that we have on for specialty reasons out there. But everybody has been amazing spirits, great. I haven't had a single problem with my staff. It's been amazing to have that kind of support.
One of the best comments we heard all day came from your DARPA Chief of Staff, Jonathan Bennett. He said, you know, Donna's done a pretty good job for a Marine. And we're like, oh, wow, shots fired. As a true Army man, he had to just get a little something in there.
I know. So he provided some Army MPs as well.
Fantastic.
And we have a number of Army people, but no, I'm actually really glad he did that, because now it opens the door for me to get back at him a little bit.
I had to tell Todd, now Todd, you can't say things like that.
Exactly.
Only other service members.
Yes.
Yeah, we have a great rivalry. It's fun. We always make fun of each other. So.
Good people. We appreciate all your service. And look at this. Takes an Army to move a landing strip out there. Someone put down the beautiful red circles that were created today. So those are a nice improvement. And all the teams are going. We are T-minus 1 minute away from the end of this flight window, and we'll get the official word from Ann Bush, our Air Ops lead, when that time has come. She'll let us know when it goes cold, but that'll give us an opportunity now to check the leaderboard before we go as we get ready for the final flight window of the day, and then it's on to Super Sunday. And it is still Aviadrone on top. They have the highest payload to weight ratio, which has the lead. They have not hit the 4-to-1 yet, so that is not the $2.5 million that's in play. But JB, there's some great talent out there with a lot of promise. And I'm telling you what, if we don't see it today, I just have a feeling we're going to see it tomorrow.
I have a feeling we're going to see people trying their hardest to get either in the money, to move up, or to break that 4-to-1. And frankly, I would bet that we're going to see some teams who could play it safe and like go for third place, and they're going to say, screw it, I'm going for 4-to-1.
That would be awesome. Put a smile on your face, wouldn't it?
Oh, man. I mean, everybody. Like the 280 staff that we have out here, the spectators, the believers, and the doubters, right? Like it's all over the place. But if we can do this, man, what else can we do?
Yeah, there you go. Donna, thanks so much for your time. As always, Joshua Bardwell, thank you for your insight. That closes down the 4 o'clock flight window Eastern time. Come on back with us in about 30 minutes. We will have one more flight window here at the DARPA Lift Challenge here in beautiful Dayton, Ohio. We'll see you then.
With the DARPA Lift Challenge, we want to rewrite the economics of flight by creating vehicles that can carry 4 times their own weight, drastically lowering the cost of transporting heavy goods by air.
The mission impact here is substantial. Achieving this means smaller, cheaper drones can do the work of massive, expensive ones, making logistics faster and more affordable for everyone.
What we're trying to do in increasing the weight ratio is being able to find a way to be able to carry more with less. Every time you can increase your weight ratio, you can do more.
The whole point here about bringing that payload to weight ratio is really focused on bringing the cost of vertical lift aviation down. If we can be 4 times more efficient, maybe it can be 4 times less to transport something, to move cargo, to move people. That's what the DARPA Lift Challenge is looking to do. We are looking to make vertical lift aviation accessible to the common man, which will then change the way that we live and improve the lives of everyone around us. Ultimately, the Lift Challenge hopes to spark a new revolution in heavy lift, making the sky a viable and affordable highway for a new generation of air cargo in virtually every sector.
You've got to stay above 100, stay below 200. If you dip below 100, the run automatically comes to an end, and that bird better stay clear.
I probably wasn't as close as it looked.
We had an excellent flight. We have been increasing the weight over our last flight. So I think right now we are carrying one of the most payload, roughly around 180 pounds. Also, we don't show the number one ratio right now. This is because our aircraft is 55 pounds. There's other aircraft, but I think all the competition is carrying now cargo loads around 120, 130. So we are leading in that number. But of course, what counts really at the end is the metric ratio, right? So we work on this, and we will see. We have another flight slot tomorrow morning, and then we do our math, and maybe we will show some more.
Obviously, the hard deck is not in play. Seems like they're bringing it down.
Yeah,
Ooh, a little wobble there is
pretty
not
quick.
Oh, they lost the weight, and it jumped back up in the air as that weight freed itself. The pilot maintained control expertly.
I don't know.
No, that wasn't on purpose. No, sorry, that was
go.
not on purpose.
But you never know, like when you start going, how the position control stuff is going to go. So, yeah, lost too much altitude in one of the far runs, and it kind of just barely breached over there. So, had to bring it back, and then wanted to do some more tuning, and you guys saw how that went. It was coming down a little too fast, and even though I was 100% throttle, I still couldn't keep it from hitting the ground. But it didn't hit the ground that hard, because all it did is really break the straps, and then as soon as the weight is gone, that that thing has a lot of power, so just shot straight up. So, but we're all good. Everyone's safe. Everyone's all right. I think I'm gonna give it another try. I have a second drone actually, and I have another battery. We'll try to crash it again or do it successfully.
Nice and stable, and hopefully we see a touchdown right on that landing pad. Beautiful. Oh yeah.
Oh, he's going to put it right in the center. Now you're just showing off.
Oh yeah, well, you got to do it. You got to do it.
So there you go.
That looks to me like a successful run and a new leader.
New leader in the clubhouse. Avid drone out of Columbia, Maryland.
So as a lieutenant colonel in the Marine Reserves, with my history of aviation and being a pilot, this challenge is more than just a breakthrough technology. There's a phrase in military parlance that says, amateurs talk tactics, professionals talk logistics. If we can democratize logistics, if we can spread that around through the ease of vertical lift aviation, if we can make it more economical, there's a military advantage there that is almost indescribable. We don't know what the limits are or what the possibilities are because we've been so constrained in our current way of thinking. When we first invented helicopters, it opened up entirely new mission sets and capabilities. What are the new mission sets that we could open up? What are the new possibilities, whether it's offense, defense, life-saving rescue missions, disaster relief, all the different mission sets that we have, what can we do next? By making this breakthrough, we open the opportunity to the military community to rethink how they fight and act in warfare. And that, for me, is what matters most for this challenge.
Imagine crashing 1 million drones to find the perfect design. Sounds incredibly expensive, right? Now, imagine doing it without breaking a single piece of real hardware. That's the power of advanced simulation and modeling for the teams competing in the DARPA Lift Challenge. To build a drone capable of lifting 4 times its own weight, you can't rely on old-school trial and error. Every fraction of a second and every ounce of material must be optimized. Teams are testing aerodynamics, pushing materials to their breaking point, and simulating weather conditions entirely in the virtual world. The ultimate flying machine doesn't start in the sky. It starts with accurate simulation.
This has been an amazing experience so far. Everyone's kind of competing against the competition and not each other. People just laughing and having fun.
Oh! You gotta stop giggling.
What just happened out there?
We're testing the limits, so we found it.
Now you're just showing off.
The camaraderie has been amazing. Coming together day after day, how do we do this? And, you know, we've got that respectful disagreement, which is what you need for a team operating at this level. People are contributing ideas, critiquing ideas, providing feedback.
I'm glad just to be here. Like, just being able to talk to everyone and see everyone's cool drones is really amazing. You're never bored here.
I can't emphasize enough how friendly everyone is here at this competition.
This has been really a wonderful environment. People have come and talked to us about their projects and their issues, and we've gone and admired and complimented a number of those other ones.
People have been hitting us out for parts, and we're happy to share when we can.
It's really compelling just seeing everybody rolling with their own little punches, and you try and overcome it, and you find the workarounds, and you make it work, and you sort of see how that plays out for everybody in their own little story.
The MacGyver team shows a better ratio, but the battle goes on. So we will see. We're watching the others as well, but his team is very professional, doing straight flights, no vibration, professional loading, unloading. So I think they got a lot of experience.
Seems like everyone's doing really well, and everyone's going to give us a run for their money. So
DARPA is all about pushing the boundary.
We've got plenty of opportunity to raise the aviation to the next level.
We push the limits, and that's one of the exciting parts about this event. We got some amazing talent, and they're all digging in right now. I'm watching one team that's 2 spinning airplanes. It's just crazy.
I'm really excited to be here. This is kind of a dream come true, to be honest.
pretty happy to be here. We have a lot of good teams that we're competing against, and it's good to learn what other people are doing and see where we fit in this landscape. Teamwork makes the dream work, and we're doing well here.
Teamwork makes the dream work.
I would not have my summer any other way. This is what I want to do right now.
Every day is a good day so far at DARPA.
All right, let's go.
So why is now the right time to tackle this? Because we are witnessing a unique convergence of technologies. Recent breakthroughs in advanced materials, open source flight controllers, and rapid computational modeling have fundamentally lowered the barriers to entry. The cutting-edge tools that once required massive traditional research facilities are now accessible to independent innovators. The technology has caught up to the ambition, making this the perfect moment to solve this challenge.
The actual reality of what you can do with a 3D printer is astounding. You can make structures that were impossible to create 10, 20 years ago. Or you can also make structures that were only able to be created at very, very large companies with a lot of money.
Now, anyone can pay for inexpensive software to use the computer to design something that just comes off of their imagination and run some simple analysis codes. It's enough to get an idea going. Pretty quickly, you could do fluid analysis, you could do structural analysis, you could do stability and control without having an incredible depth of education.
Another aspects are power plants. So whether you're going electric with battery and motors or you're going internal combustion engine, powertrain dynamics has really exploded in the last 10 years as well. So not only the designs, the different sizes, variations, and all of that sort of stuff, but the availability of it. You can jump online, buy something, and have it at your doorstep in a week or 2 weeks. That wasn't able to be done just 10, 20 years ago. So when you have all of these factors combining, you have this ability to innovate and to change the way that we have designed, built, and flown aircraft compared to the last 50 years of aviation.
Welcome to Avalon Aero's hangar, so come on in, guys. Here's Jack, team member. He is our controls and avionics expert. This is John, lead design. I'm Alec Onessen. I do most of the manufacturing, but we all work on a little bit of everything. This is Excalibur, which is our counter-rotating coaxial system. So we have 2 rotors stacked on top of each other that spin in opposite directions, which gives us yaw control. And if you notice, we don't have a swash plate, which is essentially kind of like the transmission and steering rack of a traditional helicopter that has this configuration. So we've completely dropped the swash plate, and we use a physics-based design, and we have encoders here that read our positional inputs, and then we change the speed of our motors using Jack's very fancy software, and that kind of allows us to pitch and yaw and roll, which gives us 6 degrees of freedom with really limited mechanical complexity. So super light, very low amount of components, and pretty easy to put together. So that's kind of our design philosophy, is keep it simple.
Welcome to Dayton, Ohio. This is the birthplace of aviation. This is the home of Wilbur and Orville Wright. This is the place where they flew their first practical airplane in 1905. And now we're pleased to have you here as we take the next step in aviation development, the DARPA Lift Challenge. For the United States Army, Wright Field was the Army's Aviation Development Center all the way through World War II. At this airfield, the first fully pressurized aircraft in the United States was flown by the United States Army. This is the airfield where the first woman flew a jet aircraft in 1944 off of this field. This was the Army's development center, so fitting into the DARPA development mission, easy fit.
Being here at this museum is amazing. It is filled with design innovation from brilliant minds who have thought outside of the box. For me, this journey is personal, this competition. My grandpa was a pilot, my dad's a helicopter pilot, and then I joined the Marine Corps and became a Harrier pilot. Aviation is in my blood. I have a passion for it. I love it. This challenge is not the end for me. I'm going to keep on going, keep on pushing the limits, and hopefully helping you guys push the limits as well.
I will venture a bet that in less than 5 years, this museum will have its own hangar for drones, U.S.-made drones. And I think that the DARPA Lift Challenge will have a big impact on making that happen.
What's exciting for me is to think in 20 years, how many more designs will be around these hangars? How many will be here that were inspired by this challenge, by the things that you brought, that the teams brought to this challenge? The future is being created, and it's going to be celebrated in these hangars for decades to come.
Flight Fest going on in the distance. You see the RC planes going.
Yeah.
Just.
Wow. So the event, the DARPA Lift Challenge, is
cool.
co-located this year with one of the biggest RC flight festivals in America, Flight Fest. And we're looking off in the distance. It looks like they're doing some kind of a fighter jet fly-in. We got all these RC. Those are RC fighter jets, for the record. It can be hard to tell the difference on camera. And they are flying around, and it is just majestic. Just really makes you appreciate the beauty of flight.
RC radio control?
RC radio control, that's right.
Yesterday they had about, I don't want to say 50 or 60 of those up in the air, and they were literally doing a demolition derby.
Yep. They do a thing where everybody puts they'll have 70 aircraft in the air. They'll crash them into each other, and last man standing wins.
Oh, man.
Yeah.
That's cool stuff.
Yeah, it's pretty fun.
I've been to the Air Force Museum many times. I love it. This is the first time I've been to a Flight Fest. I love it. So we're going to split time between this and the museum depending on how my strength holds up. But I think this is fantastic. And to see so many sharp-eyed young people along with some older people, it really makes you feel great. And actually maybe a little intimidated, but it's great. I'm having a great time. I'm buying souvenirs and making memories of my GoPros. So if I end up in an old folks home, they let me have my computer and my drives, I'll be a happy creature. I can just relive all this. But it is wonderful.
When they decided to have it here, I was like, oh, I got to do that. So all this stuff combined is like a massive festival kind of deal, you know. So it's really incredible. And like he said, all these kids doing this stuff is fun to watch. if I had the kind of energy they had, I'd be doing some of that stuff too again. But the gentleman in Arkansas makes these kits, and of course you just paint them up anyway. Well, it's just a simple design with a motor back here and a battery up here, and just kind of a delta wing type plane. But they fly great. They're fun. They're tough. You can go out there and crash them up with people and still fly it some more. And, but they're called a wild hog, and it's kind of an interesting little flying rig, you know. Have you been out here when they're doing the combat? That is so much fun to watch. I mean, and they don't care. Those kids don't care to tear that stuff up and take it to a tent and fix it and bring it back and do it again. It's like, you know, we spend a little money on this stuff and go, ooh, I don't know if I want to tear that up or not, you know. It doesn't bother them one iota.
So, right now, I was in combat. I don't know if you saw it, but I was doing pretty good. I took down 3 in the last combat and 2 in the first one. And the nose got pretty much obliterated. So I'm putting it back together. Last combat, I had like a few things I had to glue back together. And this one, the entire nose was kind of destroyed, so this is taking a little bit longer. He's one of our friends. His name's Lee. We met him here a few years ago. Is this your 4th too?
I think it's my 4th. This is my 5th. This is the 4th that we've been hanging out.
Okay, this is my 4th and his 5th year. It's a lot of fun. The people here are great and really nice.
I had a monster truck just laying around in the garage. I got it for my 3rd birthday, and I decided to make it fly. Yeah, this is an old wing that we got from our neighbors last year at Flight Fest. I put ailerons on it, 3D printed a motor bracket, and a bracket to hold the tail boom. And the tail is an FT Legacy tail, scaled up 15%. And that's pretty much all I did to it. And it flew great. The first few flights weren't the best. We had to stiffen the shocks. But other than that, I mean, flew pretty good at the end. This is our 4th Flight Fest. It's just fun to be here, and it's just cool to see all the projects and just build fun stuff like this.
My favorite part about Flight Fest is building planes because I like to see like trial and error and to see which planes that I make better and better each year.
So we got these planes right here that we're working on, and it's pretty cool. It flies really good.
What's your favorite thing going on here in
the plane and the ice cream. The ice cream was so cool. The ice cream was so good, especially the cookie and cream.
The cookies
and then I just made a. Wait, no! I just made a plane. It had a propeller on it.
Okay, Yash, do you want to finish? I think he lost his... So, yeah, my husband is here and we are having great fun in Flight Fest. There's so many activities for kids. They're getting really good experience, like building stuff, and it's great. All the arrangements are really good over here.
So I just made a random thing. I don't think this works. I tried it. So you just put it in here. Yeah, this does not work. This thing does not work, but this thing does.
This kids already enrolled that we are.
Whoa.
Since the beginning of aviation, once we solved the basic problem of flight, one of the early applications of aviation was to move things and people around the world. This is a continuous evolution of what aviation originally started out to be. I can't think of a more interesting challenge. Today, when a drone can lift basically its own weight, the challenge of saying, let's see if we can get somebody to have a drone lift 4 times its own weight is a massive jump forward. This is classically what DARPA does, is to ask and say, how do we take not just the next step, but the step after that?
With aircraft, you have a lot of room to have a significant impact. A small reduction in weight has a significant impact on fuel consumption, on the amount of distance that you can travel, whereas it's not as impactful on a ship or a car. Anytime we expand the capability of a vehicle system and make it better, stronger, faster, then now you have the ability to provide more food. Someone needs blood, you can provide support medically. Someone's in trouble, you can support them from air to ground. There's just so many aspects of increasing the capability of what you lift that helps every aspect in the military.
When we first invented helicopters, it opened up entirely new mission sets and capabilities. We have a new floor of performance characteristics. What are the new mission sets that we could open up? What are the new possibilities? What can we do next? By making this breakthrough, we open the opportunity to the military community to rethink how they fight and act in warfare.
I am Vaughn Newman with the TAM Air DARPA Lift projects. We are a high school team based out of the San Francisco Bay Area in California. This is mostly a project for fun because we wanted to see if we could do it, and this is our drone that we came up with. We came up with a coaxial, counter-rotating, helicopter-style drone. We have custom-made swash plates right here, which one of our teammates designed. We've got planetary transmission, and we're running off of a Desert Aircraft 170cc two-stroke engine. We weigh about 35 pounds, give or take a couple, with gas, and we are very hopeful for our lift to weight ratio being above 4-to-1 this year. Our rotors apply to our rotor heads here and down here, and they counter rotate, and they stick out about, each one is about 4 feet in length, so we have a diameter of about 8.5 feet, including these rotor heads and clamps. The drone name is Tinkerbell, because it's pretty light, pretty dainty, and it can lift a lot of weight. So that's our name we came up with. We've had a couple of issues here and there, but we've been very resilient and have overcome everything so far, and I think we will continue to overcome every challenge thrown at us. It's a pleasure to be here also. I mean, it's so nice that DARPA hosted this for us and put on this challenge so we can go out and try to prove what was previously thought impossible possible.
Through this competition, I'm hoping to find new powertrains, new aerodynamic designs, and new combinations of things that were not thought of before. So when the next aircraft designer gets up there, instead of just saying, I'm going to do what has been done for the last couple of decades and make it slightly better, they now say, well, wait, all of these other things are possible. With these ingredients, what can I do that has never been done before? And what we're seeing out here over the next couple of days is pure innovation, unbridled, and it's just amazing to be a part of.
Scientific engineering failure is a great thing. It's the way we grow. As scientists, without making mistakes, we don't learn to understand what the fault was. So the more you make the right mistakes early and learn from them, the better you are in the long run. Success for me is inspiring the community, not just the military community, but the public on trying to come out and do something that they're willing to try that's never been done before.
What I'm looking forward to once the Lift Challenge is completed is reflecting back maybe next week, a month from now, maybe a couple years from now, and knowing that I had a small part and role in making history.
What I can't wait for is the product of that. What's going to happen in a year, 2 years, 5 years, 10 years? I can't wait to see what comes out, what industries are made because we make this breakthrough, what new capabilities and companies and organizations sprout from this challenge right here. Being here at this museum is amazing. It is filled with design innovation from brilliant minds who have thought outside of the box. DARPA has been a part of many of these designs that are on the floor, on the ceiling. It's really exciting to know that the top 3 performers out of this challenge are going to be here. They're going to be displayed. They're a breakthrough. We are making history at this challenge. For me, this is just a stamp in time, this one challenge. What's exciting for me is to think in 20 years, how many more designs will be around these hangars? How many will be here that were inspired by this challenge, by the things that you brought, that the teams brought to this challenge? What does that future look like? For me, that is more exciting than this one point in time, this one challenge, and the week of flying that we are doing. The future is being created, and it's going to be celebrated in these hangars for decades to come.
I told my wife that night it's probably one of the best experiences I've had, honestly. And it's been interesting seeing everything that could go wrong. We've been able to figure out. Really satisfied with our progress to today. We achieved more than we expected coming in.
Welcome back to the National Museum of the United States Air Force here in Dayton, Ohio. This is day 6 of the DARPA Lift Challenge. Todd Harris alongside Joshua Bardwell. This is the final flight window of Saturday, and then it's all chips on the table for tomorrow and Super Sunday as we close things out. Will someone get to the 4-to-1 payload to weight ratio and walk away with $2.5 million? We got a few more teams getting ready to take a 90-minute flight window, see if they can put something up on the board. JB, how high are your hopes, I guess, at this point that this is going to happen?
I mean, my hopes are high, and they've always been high from the beginning. Seeing somebody get so tantalizingly close and yet still not crack that 4-to-1 threshold for the payload to weight ratio that would unlock for them the full $2.5 million first prize, it's tough. It's tough. And I got to wonder when we're going to see these guys just start going for it. Just send it.
Flight line, be advised, the flight window is now open. I repeat, the flight window is now open.
All right, so it is official. We are 90 minutes away from wrapping up day number 6 on Saturday. There are already drones out on the lift area, and there is our good friend from Proto Carbon, John Brendel, who came in and spent a little time with us, gave us the whole lowdown. The only thing he didn't give us, JB, the best places to dine in Coeur d'Alene, Idaho. Well, we'll get to that later on. Gave us an idea of what they were going to try to pull off, and he's feeling pretty good about things. I mean, he shared the fact that they got it up, didn't have any strikes, and they put it back down in one piece.
I mean, it almost put a lump in my throat. I'm not even exaggerating. When I asked him, what does it feel like? Because some people would look and they say, oh, you spent the whole time out there, and at the last minute, all you did, quote unquote, is take off and land. And yet to him, to be able to just get in the air with all the adversity he's overcome to come here to the DARPA Lift Challenge, he was so moved. And it means so much to him and all the other competitors just to be here.
Other than his pilot, it's just him and his dad traveling from Coeur d'Alene, Idaho, 28 hours in all to get to Dayton to have this opportunity to compete at the DARPA Lift Challenge and put his design to the test. And we have asked all of these teams, come out here and show us your very best. What can you do? So this is the last flight window of the day. We were scheduled for 63 flights as we started the day, and I think we're getting awfully close to that. We've had a lot of great distinguished guests. We might get lucky and get Donna back out here, the program manager, but we've got another couple people that are going to join us on the set as we wrap up this final 90 minutes on Saturday, and then all eyes will be on Super Sunday. I just want to see someone write a big check. I don't know why, but I want to see someone write a big check.
I mean, I think most people would agree that even the half prizes that people have already achieved, that's half of $2.5 million, $1.5 million, and $1 million for first, second, and third place. Those are pretty big checks.
Yep. We're looking for 4-to-1 on payload to weight ratio, but Joshua, I got to ask you, because you've been in the drone industry forever and a day, 3-to-1's not too shabby.
Well, 3-to-1 is a whole lot more than the sort of standard that has existed until, well, this very event. about 1-to-1. And that 1-to-1 payload to rate ratio more or less holds true for aircraft all the way down to little racing drones, all the way up to great big cargo helicopters. For some reason, it seems like there's some constraint. And the whole point of this challenge is to say, what if we just pretended that wasn't the case and tried anyway?
So you were looking at our good friend from Protocarbon, John Brindell. He is out on the flight line right now. There is his pilot. He's going through all the final checks and specs, and he said they're going to try to get it up in the air, try to get some testing done, and then tomorrow he said, you know what, we're going to send it. We're going to try to do our very best and put ourselves, hopefully, he said, in the top 5. We're pulling for him.
Yeah,
we hope he can get it because it's a cool design, all his own.
Yeah, they had some trouble with their controls.
Right.
The aircraft was moving faster than the pilot might have intended it to. They got that sorted out, and they still have to do their safety check flights with no weight, half weight, and then they can put as much weight on there as they think they get away with. And it sounded like he's not going to waste any time taking baby steps up to the prize. It sounds like he's going to go right for something big.
Saw just a moment ago a shot of the team from Iowa State. There it is. They got the mascot. We saw them earlier today, and they pitched forward and put that thing on its head, and they are back now. So they obviously went back, got some things fixed, repaired. Psych lift out of Ames, Iowa, from Iowa State University. So we hope we get an opportunity. That camera that's bouncing up and down, that's not them agreeing with what I'm saying. That's the wind buffeting the camera and pushing it. So it gives you an idea of what they will be dealing with. The wind it's picking up 10 to 12 knots, moving. It's stiff.
Yeah, definitely. You can see that windsock there telling us how fast the wind is going. And that definitely makes things difficult for the competitors. These aircraft are right at the edge of what they're capable of doing. Most of the time, you have an aircraft, you have a vehicle, it's got plenty of extra power, plenty of extra capacity to handle all sorts of adverse conditions safely, but these guys are being encouraged to push those limits, and that means that sometimes when you get up there and the wind is blowing, you just tip right over and fall to the ground.
So we saw 2 fixed wings in the last session, and we're going to see another one here. Another squad that's with Burl Aero Alpha. They're also going to be hopefully on the line. Max Waits is back for more. Spitfire Defense is something that everyone wants to see. This is the husband and wife team. We've seen them all week long working together. Watching them take off is pretty cool.
Yeah,
they're tethered together, and it just goes.
And
well, while we have a moment before anyone goes up in the air, we'd like to welcome in Max Van Rossum from Driftless. My friend, good to see you.
Good to see you guys. Yeah.
How's your week been?
It's been awesome. It's been a whirlwind. We have had so much fun here. Lots of great flights on Tuesday, Wednesday, Thursday.
Yeah.
Today, though, was rough to fly in with all that wind. That 9 a.m. time slot that we were in, there was so much wind. And, I mean, we were in lane 2, and it was lanes 1 through 6 all went down. It was crazy this morning. So
let's actually take a look. We have a package of your drone in flight. Let's take a look at it.
Yeah.
You're going to talk us through this.
Yeah, so there's our pick right there, and actually beyond takeoff and landing, it's fully autonomous. This drone flying, so it's in mission planner. You know, we'll do those lanes, those laps right there. That's the unweighted right there, and actually we take off from the plates, the plate stack themselves right there, and you can just see that thing. It's so majestic. That's the best way to put it right there. When you hear that thing run, I mean, you can hear that roaring from literally a mile away, and that's us going down the lane right there. I believe that's a 1-to-1 ratio right there. That's us lifting. There's a 2.2 to 1 ratio right there. So it's, again, we're proving out this platform. We feel like it's a unique one, and we feel like there's a lot of opportunity with the future of this UAS design.
Yeah, it's definitely very unique. You know, I saw it and I thought what you've basically done is distilled a helicopter down to, well, the only part of it that really matters, which is the rotor. Where are your electronics? Where's all the sort of rest of the aircraft?
Yeah, so just to give you full clarity, I'm a mechanical engineer by degree, so a lot of the electrical stuff or the software stuff is kind of, it's magic to me, but it's all in that center hub. You can kind of see that blue cap on the top of that drone right there. So all of our main electronics are in that center, and the whole entire UAS rotates.
Where are you going to school, Max?
I actually graduated from UW-Platteville a couple of years ago.
Congratulations.
Thank you very much. And we're actually a startup based out of Neenah, Wisconsin.
Okay, look at this. So this is basically styrofoam.
Yeah, so it's actually a really unique process. So this is 2-part boat foam. So it's a 2-part solution. Yeah, give it a feel. It's pretty crazy. We developed our own mold, and we actually cast our own wings. We initially were doing a 12-foot long wing with our own cavity, and we just 3D printed the molds. And wow. We did 12 feet. We realized we wanted to shrink it down a little bit more, especially because that 55-pound weight limit, that is tough.
It's tough, yeah.
DARPA did a really good job making this challenge pretty tough for us. So we scaled down to 9 feet, and again, you pour out that 2-part boat foam. It takes about 45 minutes to manufacture one of these wings.
Yeah, talk about some of the trade-offs you made. We talked in this live stream before about larger wings and rotors being more efficient. What are some of the trade-offs with this large rotor?
Yeah, so I mean, the big thing with us is actually, I said it with today's flight, the wind. That is a huge thing, right? And like, it feels like we might be one of the few teams where we do better with weight than without weight. So we tried doing our unweighted flights, and it was crazy because, it's a 100-foot lane, right? 60 feet, the 20 on the ends for that yellow zone, and then the red zone. If you go out into that red zone, you have to completely redo your flight. And even just for our check flight, it was a struggle because we'd blow out into that red zone for just a second. We'd get back, and we have really good control with our drone. But again, the wind can just really carry us all around. So I would say that that's probably one of the biggest disadvantages, if you will, of this. But, it's kind of the simple concept of like, if you have a large rotor, you can spin slow and you generate the most efficient lift.
So our good friend Donna, who's the program manager, we all know who Donna is, he's talking about hockey turns, hockey stops. You come in there. How do you guys turn this when you get to the end and you make the turn to come back and go back and forth?
I mean, we've tried actually a lot of things. So yesterday we weren't actually flying here at the competition, but we did find a field to do flying and stuff. And it's basically waypoints that we have for our turnarounds. And again, this is where the software comes in, and I kind of start getting a little wishy-washy here. But we tried multiple different types of turnarounds and everything within the lanes, and it operates as a helicopter rotor. So each of these airfoils actually pitches on its own servo mechanism. So we operate the same way as a helicopter, which makes it very unique compared to a lot of these other drones at this competition.
Is this an actual combat incident right there?
That was part of the destruction.
Part of the
right
destruction.
There.
Okay.
Yeah. So Saturday, like I said, today was super windy. We did a 1-to-1 lap, and towards the end of the lap, it was basically like fireworks on the 4th of July, especially with the red, white, and blue airfoils. That's exactly what it reminded me of. It was crazy. And what was so funny too was I was actually getting interviewed by the media team, and while I was getting interviewed, I hear one of my teammates go, "Oh no, oh no, oh no," and then all of a sudden I turn around and it's just blowing up, and I just turn back to the camera. I say, "You win some, you lose most."
Well, let's talk about that because I think a lot of people watching would assume that if your aircraft crashes and is damaged, that's like the worst thing that could happen to you. What's your perspective on that?
Yeah, I mean, the crash that we had, it was total destruction. I'm not going to lie. The thing is, we could repair it in a couple of days, but it takes a couple of days to epoxy the entire frame together. Obviously, we only have one more day left of this challenge. We have a second frame, actually, a backup frame that we haven't flown at all at this competition, but we do have it ready to go. We've been kind of tuning it up and everything, and we're hopeful that we can fly tomorrow. Despite
that's the plan.
Total destruction.
Oh, awesome.
Yeah.
Well, okay, not to put you on the spot, and obviously you always have the right to change your mind.
But here it comes.
If you
Oh, boy.
We've been wondering whether people are going to kind of keep baby steps and try and improve this, or whether somebody's going to say 4-to-1, I'm going for it.
I mean, there's a chance that, if our lane coordinators allow, we'll just strap on a bunch of weight and we'll see how much we can lift. And again, this is what the whole challenge is about, pushing the limits. We've never seen drones lifting this heavy capacity, so we want to be a part of that. If we can push, we'll push.
What would the Milwaukee Brewers do?
What would the Milwaukee Brewers do?
They would send it.
They would send it. They play Moneyball, baby.
You're going yard. I say you go yard tomorrow.
Oh, yeah.
Oh, that's fantastic. Well, Max, we appreciate your time. Thank you so much. After this, and I'll get you out of here on this question.
Sure.
After this, what do? You go back to your day job, you go back to the family and do that thing, or do you start dreaming up another crazy idea of putting a drone or something up in the air?
Yeah, I mean, that's a great question. Like I said, we're a small startup. It's just 9 of us. We all actually work our day-to-day jobs. It's 6 mechanical engineers, 2 softwares, and an electrical engineer. So we have our day-to-day jobs. This project has been the last 7-8 months, just tons of nights, tons of weekends absorbed, just perfecting this craft. We knew that this was a concept that could work. And again, we're a startup. We genuinely think that this UAS platform is going to be the next wave of UAS in general. We think in 5 years, companies are going to start to shift towards platforms like this. And in the next decade, any sort of practical applications for UASs may be sort of a similar concept to what we brought here to the DARPA Lift Challenge.
So bottom line, tomorrow morning when we come on the air, I can say, folks, if you don't stick around for anything else, stick around for Driftless because they're going to send it.
I want that to happen. I want that to happen.
My man.
Appreciate
well done.
it.
Max Van Rossum from Driftless joining us here on the set on the final flight window as they try to get their drone up and going again. They got a serious incident here, but he was kind enough to bring one of the wings to us and show it off. So, Max, thank you so much. I appreciate. Yeah, that's a souvenir right there. You're not checking that on the plane, JB. Our thanks to Max Van Rossum for dropping by and sharing his insight with us. We wish them the very best, and we hope they get it done tomorrow. Pulling for them. We have no favorites in this, JB. We have no dog in the fight, but we would certainly love to see that happen because these are the kind of teams, these are the kind of stories that I think DARPA has created this whole thing for as they push the limits, try to find out what they can and cannot do. And we'll find out tomorrow. Super Sunday, the last day of competition. Can anyone go to the 4-to-1 ratio, make it all happen, and bring home the $2.5 million check, and that will go to the winner. If they do, it'll be a thing of beauty, and it'll make a lot of people happy, I think.
Yeah. I thought, aren't you impressed? Like, we've had several of these people on. They're all so positive, so eloquent, so educated. It's just a joy to meet these competitors.
Yeah, we have a lot of great people surrounding us, making us look smarter than we are. So this, again, is the husband and wife team with the fixed wings. They'll be out there. That's Proto-Carbon. They're going to spin it up. We talked to their main man who came and joined us on the set, John Brendel. He was fantastic. And we bring back our favorite analyst, Donna.
Donna, you're going to take my job.
Program manager. He's a legend. He's just enjoying coming out and being. I think he just enjoys being with us, Joshua. I think that's what it is. He's just like, man, those are the coolest kids on campus, and I think we want to hang out with them. Yeah,
you know what it is? I get to see the entire event here. If I'm not here, then I get dragged into some other type of meeting or whatever, and I don't actually get to see the action. So this is my favorite place, the best seats in the house right here.
You've spent so long planning this, so long putting all the pieces into place, and then there comes a point where it's just going, and it's a little bit out of your hands. I mean, that's got to feel great, but also maybe feel a little nervous.
You know, every day we're just hoping and praying for a great event, you know, that nothing catastrophic happens, and that, you know, the slides to the schedule get worked out, that the teams are able to make it and perform. We're always looking at the weather, of course. As you just heard from Driftless, it's drastically different for these experimental aircraft. But yeah, no, when it's all going and everything is humming, sometimes in our staff meeting, we just sit down and we say, I think that went really well. Like, whatever we did, just do that again tomorrow, and I think we'll be okay.
I want to comment on the enthusiasm that Max brought. I mean, he brings a piece of his drone here. It's busted up. He doesn't know if they're going to be able to go tomorrow, but he seemed genuinely thrilled to be here in Dayton, and they're going to try to ramp up and go tomorrow. But I think that's that kind of enthusiasm, and I think you guys have kind of caught that American can-do grit, ingenuity. Right. Bring it, send it, do what you can. So he said tomorrow he gave me a full send guarantee, Milwaukee Brewer style.
Yeah. Maybe we might be doing some other fun stuff. We'll have to see what tomorrow brings, right?
Let me ask you this, and sorry for the sports analogy, but this seems kind of like a sense of urgency. We're building to that bit of crescendo throughout the week. It's been a little more relaxed, a little more pace. People have kept their cool. Do you sense, or would you like to see more fire in the belly, as so to speak, of, hey, folks, we're running out of time, we got to go?
No, I mean, the teams that are there have that fire. The teams that showed us yesterday and are rebuilding overnight, we've tried to stay out of their hair. We've tried to just be like, all right, guys, we're not going to bother you, but we can tell they've got it. They've got that spark. They've got that, like, I almost made it. Yeah. I almost made this, you know, around the world we're going to know. People are going to know our name. People are going to know our design. Yeah. And we're going to make history. And what's interesting is we've actually worked with the museum to provide a static display.
That's cool.
And so not only do you make history with the flight, but then you get to be a part of history with all of the other legends that are around. All those aircraft that have for some reason made a mark on history and gotten a place in that museum, you get to be there.
Yeah.
And that's just amazing.
For the folks that are just tuning in and watching the action on the flight line and maybe anticipating more anxiety, more chaos, more speed at matter, they're not moving at a lightning speed out there. They're taking their time. They're very deliberate. This is not a Formula One NASCAR pit row.
No, of course, and I'm actually very thankful for that. So we've briefed them that slow is smooth, smooth is fast, right? When you rush decisions, when you rush a part change and you forget to solder a wire or screw something down appropriately, that's when you have those mistakes. And in aviation, you can't afford it. And as you can tell here, you can't afford it. So, and another part of it is these problem-solving skills. Sometimes you just don't know what is going to happen.
This is Protocarbon up in the air. And he is getting loose, as we say in the business. And it's coming down. That's a heavy landing. So John Brendel out of Coeur d'Alene, Idaho, he came, he saw, he went up higher than he did earlier in the day.
Looks like the wind got a hold of that one as well.
Yeah, Max was talking about that as well. It's that the wind for some of these aircrafts, especially with the big rotors, has been very challenging.
And that goes back to comments we made earlier in the week about the speed of the rotor and an unweighted versus a weighted. And that's exactly what happened, I think, with that one. Is that
Max said they do better with weight, with more weight on there.
So you get more speed on the rotor, which means every change in pitch of that rotor it goes around faster. It has more air going over that airflow,
look at that.
right? So yeah, he pitched up, he got a little bit of wind, and just got pushed back.
Yeah, you can see could have elected to put it down, knowing that it was not fully in control. Looks like he whipped it around here to try to get that nose down, get it moving forward. He said earlier they were having a little bit of trouble with the yaw control.
Is there no saving it at this point? I mean, is it one of those, it's in that spiral of you're not pulling this one back?
So with an aircraft that has the control response, right, you could do that. With these at this light loading, when you don't have those rotors up to the full RPM that you want, it's a little bit more difficult to be able to do that. And in this particular case, they've been trying all week. They just got up. Earlier today was the first time that we saw them get up and hover. They were canceled yesterday, so they're also pressed for time. And this is part of that we're beholden to the elements, right?
Sure.
It thunderstormed on us like crazy. They would have probably hovered yesterday, then worked on their flight controller overnight and this morning, but instead they got rolled to today, had 2 back-to-back flight windows, and didn't have enough time to be able to
You got some juice, but not that much juice.
It's just, it's you can do things, and then sometimes just time takes over and you just can't do it.
Yeah, you think about it. I mean, we pretty much lost, 4.5 hours? 4 or 5 hours yesterday?
We lost 2 windows yesterday. One of them was a full window, and then the other one had a few, like this window right now, where we only have a few people who couldn't get fit in or couldn't get their aircraft on time. And so we opened up this. This is actually a backup window for us. We haven't used it all week, and this is the time, that crunch time. Some teams, just haven't been able to make it. We want to give them a chance. So there is a team, What the Helly, that's on the flight line right now.
Yeah, he looks like he's doing the compass calibration dance.
That's probably very accurate.
Do you want to tell the audience what that is?
Go ahead.
Calibration.
Compass calibration. So the compass needs to be calibrated to the local magnetic fields. There's a lot of electronics on a plane, a lot of metal objects, and that affects the readings that the compass gets. So the compass needs to be able to subtract that out and measure the Earth's magnetic field. And what you do is you put the compass into calibration mode, and then you hold the aircraft. Well, if it's a small aircraft, you just turn it in your hands. But you basically have to rotate it 360 degrees on every axis, and then the compass sort of subtracts that out. When I see him standing out there in the field turning in a circle like that, he's not just doing a dance for fun. To me, that's what it looks like he's doing. Oh, and in fact, I remember they were asking for replacement GPS units, I believe, was this team. Yeah. Yes, so he has replaced the GPS units. And the compass is in the GPS unit. And yeah, he'll turn it on its side. He'll make a 360 turn. And it's pretty important to calibrate them somewhere where there isn't a lot of sort of ambient magnetic fields. So he's just decided to do it out here on the field, right where it's going to be flown. Maximize the odds of success. There we go, the final 360 turn on the third axis.
What's that game that kids play where they put their head on the broom and they
spin around and then they try to run to first base?
Yes.
You know, and that's kind of what it is. And then they do it when they're blindfolded too. And somebody has to at least just point them in the right direction and say, start here. That's kind of what they're doing. They spin around, and then someone stops them and says, "That's the direction you go." And now the thing the people wobble, and they're like, "All right, I'm going to make it eventually."
Is that the next DARPA challenge? No, kidding. When you were doing that, and thanks for catching that, Joshua, because I was like, "What is it? Is this a good luck dance? Is this
no.
praying to the aviation gods that he can fly?" And you think of all the technology that we have at our disposal. And this is still the best way to calibrate.
It is. It's terribly important, too, because without the compass, the aircraft doesn't know what direction it's facing. You can get that data from GPS, but GPS always assumes that you're moving in the direction you're facing. GPS doesn't know what direction you're facing, it just knows the direction you're moving. So, for example, if you get into a crosswind, well, you're facing one direction, but you're actually moving sideways and you'll get a divergence. A compass is always going to give you an accurate estimation of which direction you're facing. And, of course, that's important.
And the actual technical term for that is crabbing.
Crabbing.
Which is really funny.
Wow.
Yeah, so when you're crabbing, it means your nose is pointed in one direction, but you're actually moving in another. You're crab walking or crab flying in this particular case.
Yeah.
Have you looked at the forecast, Donna, for tomorrow? I know you're getting updates constantly. Don't care, don't want to know, just...
Man, it is what it is.
Exactly.
It is what it is at this point. We don't have any options. I didn't hear that it's going to be crazy, but I haven't checked it quite yet.
Okay.
Donna, we got a little package to show just how hard what these guys are trying to do is. Let's take a look at that and get your reaction.
So a lot of moisture, it looked like, came off that when they spun up. Was that from earlier in the morning? Or
that was the
fuel?
one that was right after the rain shower, or one of the rain showers. They might have had some left on.
Yeah, and just what they're doing, like what we're doing is hard, not just the 4-to-1 ratio, but with these novel types of craft, sometimes just getting off the ground is the real challenge.
And then you add on that they only had, like Driftless just said, 7 to 8 months to put this together on nights and weekends. Some of these have been professional companies where they have had a full staff and everything. But yeah, it is really difficult. You're taking parts, you're putting them into situations that they weren't designed for, you're pushing them, every single one of those parts, beyond what it was intended to be used for, and then you're just getting out there and trying it. And flight tests, the history of flight tests is crazy.
Yeah.
There's some movies about the breaking the sound barrier, if you've seen those.
Yeah.
Right? So those are great movies to watch and say, this is how it's always been. I run 2 other drone programs, and it's no different.
Yeah.
It's tough. It's rough. You get hard landings. You go back and you review the data. In those cases, they're normal, programs, contracted programs. You have days and weeks to be able to review that stuff and repair.
Who was the first person to break the sound barrier? Was it Chuck Yeager?
Chuck Yeager.
There we go.
There it is.
Yeah, well, maybe someday somebody's going to ask who was the first person to break the 4-to-1 payload to weight ratio. We still do not know.
We still don't
who
have
that
it.
person is.
Yep, that was the one we saw earlier with those pilot-induced oscillations.
Donna, are you aware of any craft currently made that breaks the 4-to-1? Is this literally a world first?
This is okay. So let's quantify it. So remember back when I said that the course matters.
Okay.
So
okay.
There have been craft out there that have just taken off and landed. So the one that would be interesting is the human-powered helicopter, the one that Sikorsky did. So that is probably similar, right? But they only had to lift off, hold that for, 3 minutes, I believe, and then land back down. So that is the thing here. The thing is you have to tie the 4-to-1 to that required course, and that's definitely never been done before.
Yeah. I guess it's worth also mentioning, just as for the internet commenters, lighter than air.
Oh, correct.
Lighter than air will do it, but that's
that. Yep.
Well, tell me what the disadvantages of why was that not allowed in the competition?
So one of the things is we've done lighter than air for decades, and I mean way back. I mean they were the first manned flight was hot air balloons,
right.
And And it has constantly not worked. We have seen why. The wind is one of them, right? So that big of a surface area, the wind pushes them around. The danger of helium, and then the logistics behind it. The airfields that were required were massive as well. Now, I know we have airplanes that can do the same thing, but the trade-off is an airplane flies much, much faster, right? You can go across the ocean and in a couple of hours versus days or weeks that it would take for a blimp to do it. So the payoffs there, the trade-offs that you had to do just never worked.
Yeah.
And we've tried it, right? So that's why we limited this competition to it. And we did get people, even though we put out the rules, we did get people that said, just use a balloon. Like, that's the obvious answer.
There's a reason we're not using balloons for, medevac, for, we'd use balloons for sightseeing, and that's about it.
Right. So imagine that. Imagine in a combat scenario for the military, you've got this big old blimp moving in and dropping something.
Yeah. No.
But then the flip side on the commercial, that's a great question. Why is commercial industry not using balloons either? If there was a profit and a motive and incentive there to use that technology, they would have already been on it, right? They would have already done it a long time ago. Now, I don't want to disparage the balloon industry. There's actually some really, really great use cases for balloons, and they excel at it. So the high-altitude balloons, if you want something static that's just sitting up there, they call them pseudo-satellites, right? So they're not in space, but they're acting like a satellite. That's amazing. The tourism industry, that's really fun. So balloons have their place, and they are very valuable for those types of things. What we wanted to do here was the innovation part, right? Pushing the limits of the known designs of what we are used to, instead of just saying, all right, we already figured that out in the 20s or something.
I'm wondering the last time someone tried to do something like this, or tried to do something thinking outside the box, pushing the limits of aeronautics and aviation, and I can't really think of anything in the immediate distant future or the past other than what Red Bull tried to do with that Stratos with Felix Baumgartner, where he took up in the balloon. We were talking about balloon, and then he basically free fell back to Earth. To me, that was, I watched it on a computer at home, and I was thinking to myself, this is unbelievable. That's the last time someone's kind of done a DARPA challenge, would have been something like that.
So I believe there's a company or a group of individuals that are trying to fly around the world with a solar-powered airplane. I think that's in progress. That's pretty cool. Red Bull, you're right. Red Bull does a lot of crazy aerial stunts, but not in this wide open forum like this, right? They're there for the thrills, which is amazing. They've actually done some really, really cool things.
I don't know how much for this practical application.
Right, yep. But they're pushing the limits in a different way, right?
Absolutely.
And I love Red Bull, by the way. I watch them all the time.
It's pretty cool. We know that the next challenge, or something along the lines of what DARPA is doing, is that triage situation in November that you're doing in Texas. As far as a competition or something like that, can you give us an idea of what's going on between your two ears? Give us a sneak peek of what you'd like to see, or what you'd like maybe.
Well, I'll tell you what people have asked me. So there's been some individuals that said, can we do the same thing for unmanned ground vehicles? Can we do the same thing for boats or undersea vehicles? The optics will be definitely different, right? And we'll be like, is that underwater? Or, where is it,
that would
right?
be pretty cool.
But it would be really cool, right? Get a lot of divers down there. Maybe a shark swims by when you're doing your test.
Underwater cameras. It would be ridiculous.
That would be kind of cool, right?
Yeah, that'd be good TV.
It would be great TV. But that's not my field, so,
But do you have people pitching you, like, now that they know that you put this on, your phone going to ring up on Monday,
I'm sure.
Hey, can we try this?
Last time I checked, I was like 200 emails deep. So and I actually cleared it a couple of days ago. So when I get home and take a little vacation, I'll be back at it, and we'll see what happens.
I was going to ask you, not to get too personal, but what are you doing on Monday?
I'm cleaning up.
You're going to stay here and break down?
I'm cleaning up a little bit. I'm not staying as late as the rest of the team. But, I'm going to stay here for the morning and maybe a little afternoon, and then I'm flying home in the afternoon or in the evening.
And then Tuesday, toes up.
That's funny. Some of my staff was already like, okay, we've got this for you and this for you. And I was like, can I not have a day off, please? Can I sleep in? But no, work never stops. And when you're doing a job like this, it doesn't feel like work. This is a lot of work, right? but
Yes.
it all has this really cool purpose, really cool drive, and it's worth it. So I'm actually, not too terribly mad that I might have to go in, because this is awesome, right? And to further the pursuit of this endeavor, I'm going to keep on working.
I was going to say, it's not a bad office.
No.
If you have to do something for yourself, this is not a terrible
Right?
office.
No, it's great. That's one of the things that a lot of the staff has said is like, hey, this beats a, Excel spreadsheets
At a
back in the
desk,
office.
exactly.
That's why you got so many volunteers.
That's probably
Just
right.
wanna get out of the office.
Yeah, they were like, man, I haven't seen
Have a day
the
in the
sun all summer. I'm going to be outside. It's going to be great.
All right, we'll spin forward as we continue to watch this flight window as it comes to a conclusion. We're scheduled for it to stop at about 7:30, which is under an hour from now. We'll take you back to the flight line. Obviously, if anyone goes up, if anyone's spinning or flying, we'll do that. But we're lucky enough to have the program manager for the DARPA Lift Challenge, Donna Phillips Smith, his call sign. When we look at this and look at the ramifications of what took place this week, spinning forward, give us a quick idea of what you'd like the legacy of this to be.
I think it's about the pursuit. So the pursuit of impossible, right? And to not be afraid of that, to not shy away from the risk and the effort that it takes to be able to do something that people are telling you cannot be done. And I think the amazing part is if we can spark that, if we can instill that, and we talked earlier about undersea and surface and ground and the other forms of this, if we can instill that into other communities, if we can say, hey, if aviation did it with this challenge, why can't we, right? And I was actually talking, I think I brought it up earlier, about a fire department that was here, a large fire department, and they were saying we need this as well. And they were like, we were thinking about doing a challenge, and I said, go, do it. That's awesome. Go Aero does a challenge for the medevac. So getting the word out, talking about those things, and seeing those amazing engineering endeavors. And you asked if there was a challenge before, but what actually is interesting is all the things we're missing. So actually there's a company that just put out a couple of $1,000s for anyone who can break the speed of sound with a model aircraft, with a drone. It's I forget what the amount is, but they are building, I think it's Morpheus if I'm correct, but they're building a civilian jet that breaks the speed of sound. It's fully civilian owned and operated and designed and developed. And then some college kid or high schooler, posted on the internet and said, I bet this can break the speed of sound. And that company laid it down and said, I'll pay you. There's a challenge. Anybody who can break the speed of sound with a model aircraft
as a
gets it.
as a YouTube personality and creator, I love it when someone challenges the internet to put their money where their mouth is.
Right.
They say, okay, you say you can do it. You say it's easy. Prove it.
Yeah. And oh my, if you guys saw the emails and the people talking to me earlier on, and that was actually a lot of my, nicer, but that was a lot of my responses was just like, yeah, okay, roger that. I hear that you can do, 1 billion to 1 payload to weight ratio. Obviously, I'm facetious there, but I hear you can do a crazy payload to weight ratio. I'm providing you the opportunity.
Yeah.
Come and show it.
Bring it.
Yeah.
As we can quickly spin forward to tomorrow, give us an idea. Obviously, you've already let us know that there'll be 3 flight windows, 9, 11, and 2 o'clock. So we will not have the 1600 or the 1800 flight windows tomorrow. So we'll have to squeeze all that in, and then we'll know tomorrow at roughly 3:30 Eastern time if someone has done the 4 to 1.
Right. And then we'll have the awards ceremony at about 7 o'clock, I believe, is the time. We'll be also broadcasting that, and then it's wrapped up time.
All right.
Great.
Well, we have another issue of Stump Donna.
Another edition.
Stump Donna.
Round 2 of Stump Donna. Here we go. Tell them
go.
what they won. All right, Stump Donna. This is where you got to tell us what went wrong.
Okay.
Or the design, and we're going to start things off with Burl.
Okay.
Now, to
All
me,
right.
this looks like the wing of a stealth bomber.
Right, it does. It's kind of beautiful, actually. It's a great-looking drone. Okay, so actually, if you gave the first fly day, I believe it was on Tuesday, you'll see why they're in this situation. So first time that they went up, they had a power board failure. If you remember, they came down hard and they burst into flames. They thought they were done, and then they came back and they said, we're still doing this. We're still trying. and they went to, actually, I think like a Home Depot or something. They bought some wood because their carbon fiber had burned up. But they got to a point where they couldn't do the full operation of their aircraft. They still wanted to get out there. They've got to work on the hinging mechanism to be able to actually spin.
The hinging mechanism. Yeah,
Right.
does it spin on purpose?
Correct, yes.
'Cause it's not clear to me what that's intended to do.
Yeah, that's a prop-driven rotor, just like Driftless was out here. Yeah. So what that one will do is they have that quadcopter to lift it up. Once they're safely away or above the trees in a scenario or a house or whatever it is, then they're going to start spinning, and they're going to use those props to spin the entire large rotor with that large aspect ratio around in a circle, right? So they had the power issue first, the power board issue, and then after that they had, I believe, some ESCs that burned out. Which has been, like I've said, a common problem across the board here. And so they got out there and just said, I want to see if we fixed those internals. And if we fixed those little gremlins in the system, right, then we'll go on. So I think that they're going to try and get the rotating arms, so the hinges on there, so that those motors can start spinning it around.
Okay.
Right?
Donna, what's an ESC for the audience?
Yeah, electronic speed controller. So it is the guardian, the median between the battery, which can sometimes be unpredictable, and the motor. And it also says, basically, in layman's term, it says, I need this much power from the battery, I need this much juice, and then it gives it to the controller, or to the motor.
Yeah.
And that's coming from your flight controller, whatever it is. If it's autonomous or manned or whatever, basically the human or the machine is telling that piece of gear, I need you to give this much juice to the motor. Then it tells the battery and it pulls it.
I thought ESC was that button you hit on your laptop when you got to get out of something. Just hit the ESC. So that's what I was thinking.
Escape.
The question I have for you, and this is a legitimate one, on that Burl aircraft, the cable is hanging down.
Right.
If they get up to elevation, does the weight have to be of 100 or well?
So we knew
that thing is long.
Right. So we knew that that people were using sling loads. And that people were also having these prop-driven rotors, which can be difficult to put another piece of gear on it. So we did allow them for the sling loads to separate it.
Okay.
Now we can only follow the tracker, obviously, right? So there you go. You can see the aircraft up at the top of the screen, and then the tracker floating there in the sky. And so because we can only track the tracker, we knew that. We said we will be tracking the tracker. So in this case, it's a little disadvantaged because that'll start swinging a little bit and could swing out of the box and, DQ that run.
Right.
Well, and as far as the 200-foot ceiling goes, the aircraft could theoretically be above that 200-foot ceiling while the tracker's within it.
Which is also why we have a ton of buffer. So we can go all the way up to, well, actually, the 44807 has it to 400, but here on the base we can go even higher.
Okay.
So we have the airspace to allow that kind of design, and we kept it down, well down below the actual FAA rules or the barriers that the FAA has for us.
All right, we're going to go ahead and give you credit for that one. You did not get stumped on that one. So it's Donna 1, us nothing. As we move on to the next one on this game that's sweeping America, Stump Donna. Here's the next one. Give us your take on this, and we're still kind of scratching our heads on this one. This is the Stanford Online High School guys, and I thought it was just someone brought out a coffee table and took the top off and slapped some rotors on top of it.
No, this one has had some fun names: Santa Sleigh, Park Bench, some other things. But actually, this is really novel. This is very, very interesting for the aerodynamic people out there. And so there's some other companies that you've seen that have a tail sitter. And so a tail sitter has this broad wing that is just, oriented vertically. And then what you have to do is transition. Remember the blue hang glider one, right?
Yep.
So let's use that as the example.
Happy Hellfire.
Happy Hellfire, was that it?
I think so.
So the blue hang glider, Happy Hellfire, they had that moment arm problem, remember? Where we said, okay, you have to get to a point where you start getting wind over your airfoil, where you start getting wind over that blue sail in that particular case. But that transition period is actually really difficult. And we found out with Happy Hellfire, right? These guys said, I'm not going to tilt my entire aircraft over and risk that. What I'm going to do is just have all of the winglets or those little blinds, Venetian blinds, turn into the lift as it's flying.
Okay.
So what they're doing is, as soon as they start getting some speed, they are those Venetian blinds, those blinds are providing lift. So they're instantaneously, as soon as they're moving, they're providing lift. And then as the quadcopter that's on the top, as it starts tilting to gain speed, no matter what angle it's at, it's got wings, multiple wings in those blinds that are always at the correct angle.
Wow. But they don't cantilever at all. They're fixed.
They do. No.
Oh, they do. Okay.
They move.
I thought they were fixed.
Nope. They all cantilever in there, right? And they that one's pretty cool.
It's like downforce with a wing when you're taking off, and it provides the lift on it.
Right. So a fixed wing on an airplane, right? That's why when you're taking off, you've got that really high angle. Of course, you're trying to get away from the ground. But when you're landing, you're also coming in like this because you're going slow, and you've got to get the correct amount of wind over that airfoil. In this particular case, you're able to just change your airfoil instead of really the amount, or you can do both.
All right, we're going to give you credit for that one as well. 2-0, Donna's on top. What the heli is down on the flight line, and we're going to include this into Stump Donna, but also you can tell us what went wrong on this, because it did not succeed in what they were trying to do. Again, this is what the heli on the flight line just moments ago.
All right.
And you can say, what the heli just happened?
Right.
This is the team out of San Mateo, California, and things just started... And that's not ejecting no payload.
That's interesting. Okay. No.
Now a robot's going to pull it away.
Those are starters. Those are starter motors.
Oh, okay. So
that's
just to fire up the props.
Yep.
So
that fires out the engines.
We've talked about how you have to crank start these motors.
Yeah. You wouldn't want to be out there hand cranking.
And I've said more than once, or your car has a starter motor, but that costs weight, so we have those giant props, who wants to start that by hand?
Correct.
Little string on there and just put it on a fishing reel and just reel it back in?
So we did put it in the rules. We knew how much starter motors cost, or in weight. Sorry, in weight, not in money. And so we did put it into the rules, and you saw some people leaning over their aircraft starting up the smaller props. We deemed that safe enough because they were far enough away. In a design like this, we said, there's no way. There's no way you're going to lay on your back and use a drill to start that motor. So they just came up with an ingenious release mechanism there and good old string.
Yeah. So
just pull that back.
So we've got duct tape today. We've got string.
Sometimes people overthink things.
Yes.
Sometimes you just need to go with the cheapest and simplest option.
Yeah, so they're going to have to go back out there and put it on after every attempt, right?
Correct. So when they come back down, because it's also unsafe, unless they have an automatic release mechanism for the weights.
Yep.
If they don't, then yes, they will have to stop the rotors. They'll probably have a team out there. They drop the weights. They put those starter motors back on, make sure, whatever the release mechanism is, run away and kickstart it.
So we may see some F1 pit stop action as
That's
they
true.
run out. They
That's
drop
very
the weight.
true.
They put the starter motors back on.
Yeah.
Heck yeah.
So that was that one. That
was
we almost got you.
Second.
For a second,
it got me for a second, and then I remembered. I was like, that's what that is. That's the starter motor.
So close.
Still undefeated. Still undefeated and still reigning champion, Donna. Congratulations on Stump the Don as you go a perfect 3-0 in the final flight window here of day number 6 of the DARPA Lift Challenge. We got one more day. That's coming up tomorrow. We've dubbed it Super Sunday, and it has been fantastic to have Donna on the set with us. We're going to let him bounce because he's got some things to take care of, but we always appreciate him dropping by, helping us out, answering the questions. I think we would have been stumped. I don't know about you, but I think we would have been stumped.
I'll tell you what, I only knew the answer to some of those because I went around and talked to the teams and they told me the answer.
Okay.
It's not cheating if you do your homework.
So you had the answers before it happened. So there is the look at the flight line. Pretty quiet so far. You see the clouds in the distance. We've been lucky, touch wood, that no weather has impeded today's action. We are going a little bit later today because we've had to push back. Yesterday we lost about 4.5 hours of competition, so that's why we're going a little later today. And then tomorrow we'll start at 9 o'clock Eastern time. That'll be the first flight window. Vertsol's Kevin Horn now joins us on the set, chasing off the program manager. Well done on that, Kevin.
Yeah, thanks.
Tell us what we've got here and why this is so ingenious.
Okay. This is a hybrid generator.
Okay.
There's only 2 teams that have brought hybrids from what I can understand. But there's really 3 performance technologies you can do in this space. There's a lot of people with turbines, and those are some of the helicopters that have put up some big weight. You have battery electric, and so all of your energy is stored in batteries. And then you have reciprocating engines, which is a part of this here. Most of them are turning propellers. And so you use the engine shaft power. It just creates direct thrust that you use and try to control it, whatever, with throttle. I was really excited about the opportunity to try and demonstrate some different technology. Like, we've heard of hybrids in automobiles, but I was really excited about the electric propulsion and controls that you can get, especially in a quad. I grew up racing FPV, and I've seen many of Joshua's videos. And so I wanted to have that control of electric, but I wanted to have the power and the power density from gasoline. One of the big elements is that a gallon of gas has 80 times the amount of energy that a battery does for the same weight. And so we wanted to tap into that to be able to produce a bunch of power for the mission.
Well, let's talk about that, because the liquid fuel engines, most people would say you just hook it up to a propeller. Why can't you build a quadcopter with gas engines?
It's about how you can control it. So you think of a quadcopter is based on 4 engines at the corners, and all of your control authority, the way it rolls, pitches, and yaws, comes from just moving those motors around and controlling them really fast. Electric is really good at that because I can run it from 0 to 100 and back within the scope of a second, and that gives you a lot of control authority. A gasoline engine takes time to spin up and spin down. You have controllability issues. Sometimes they don't want to run, and so they really kind of like to run at a set speed. And so you see these types of engines much more happy in a lot of the aircraft that are flying around in Flight Fest, but like big flyers kind of running at a set speed and kind of making power. They make a bunch of power for their weight, but you just really can't move them quite as quick.
Yeah, those gas engines really like to be at a certain RPM, and they do not change. I think about it in your car. You hit the gas, it doesn't just immediately speed up. It goes
right.
And that doesn't work for a multi-rotor.
Yeah.
So this is a one-off.
This is what you're looking at is a prototype that I built. I've integrated a number of components. Gasoline engine, we've got a motor, and we've got a lot of really innovative control electronics inside of it that allows this to be mounted to my quad. I can start it from a switch on my controller. I let it warm up, I run through the cycle, and then I can basically put it in a high power mode, and it starts screaming like a two-stroke.
Like a two-stroke motorcycle?
That's exactly it.
So we have basically a gasoline engine on the bottom.
Gasoline engine on the bottom.
An electric motor on the top.
Yep.
And how are they integrated?
Yeah, so we've got a speed controller here, which a bit of kind of our special sauce is inside of that. But what I'm actually doing is I'm using this as a motor generator, and so I can start it. I use the same motor to start it. And so we were talking, I think, just before I heard you mention, those starters that we're pulling away from this. I just carry mine along because I use it to get power out of the engine once it's running. And the control electronics are really, really smart. We have a lot of code and integration built into the aircraft so that I can control it. I know what's going on. And it takes kind of complicated, but 3-phase power that comes out of the engine. It converts it into very clean DC power that I put straight into batteries. And so super excited. I pulled this off my aircraft earlier, but on Tuesday of this week, we did a flight with the generator. I took my big quad off. It weighs about 55 pounds. We fill it right up with fuel to the limit. We took off. We hovered nice and stable. I pressed a switch. You see a puff of smoke come out the back. We hovered on the generator power, and
let's take a look
at it. Oh, yeah, awesome. So you see the engine, you can kind of see a little bit of puffs of smoke coming up on the ground.
So that's you starting the gas engine.
Yeah, I'm starting it here. And so we spin up the props. And and so there's a couple of tests here. Yeah.
I wish you could tell us. I wish we could have a microphone on you where you're down there and just say, guys, this is what I'm doing. I'm just going to spin it up. Don't get too excited.
It was, so this looks like it was on probably from Thursday. The days I've been here from,
this was Wednesday.
Yeah, I've flown every day this week, so they're kind of blending together. We were carrying 115 pounds here, so this was a big one.
What's the max speed on that when you tilt it down like that and give it full throttle?
This one reps, we got up to like 38 miles an hour.
Man.
And I think we just were going for kind of an initial controllability check here. And so
we've seen some of these other aircraft that are using. They're essentially, it seems like they're trying to do a gas engine multi-rotor, and we've seen them struggle with controllability. I remember commenting when we saw that you were tilting that thing around and jerking it around, and it was staying perfectly composed.
Yeah.
That goes back to that electric motor, that electric generator driving the motors.
Yeah. At the end of the day, this competition is actually about how much power you can hold on board the aircraft to run the mission. What I wanted was that control of electric with the power and energy stored that we could have with fuel. And so, super excited that it was able to put this together, test it, fly it, and show the concept. This is the second one that we've built and tested. It's much larger than the last one, and that was a bit about how we pivoted, to make the requirements of the event. But it's Saturday evening. I still have a flying aircraft, and we've been flying on batteries. And so, my good friend John from Protocarbon, I just watched his aircraft go down, but he's been super gracious to let us borrow some of his flight batteries, because we also decided we wanted to fly electric only. And that's also another advantage is I just simply take this off my aircraft. I put a big old battery on, and it's actually much easier to fly. Yeah.
What's the weight difference when you swap out?
It's a little bit lighter on electric, but I have way less power. I have way less power and range, so I have to both manage the amount of energy that I can draw out of the batteries, and we have to very carefully manage the energy in the batteries towards the end of it. Joshua will know this, but like as a battery gets low, you can pull less out of it, and we pull a lot out of it when we're flying at 175 pounds, and so the end of the flight is squirrely and wobbly, and that's why you see so many teams kind of going down towards the end. They're just running out of energy.
Yeah.
Kevin, appreciate your time. The big question is, will we see you tomorrow, and will you go for it?
We requested a sign-up, and we're anxiously waiting for the flight schedule. So, like I said, flying aircraft will be there.
All right.
Awesome.
Congratulations
Thanks,
on everything.
Yeah.
Kevin Horn from VertSolve joining us here, showing off his innovation as we are coming down to the final 35 minutes of this flight window. And just moments ago, what the heli, they decided to send this thing up again. Look at that. There's we almost stumped on it. That was so good.
Yeah.
Watch them pull off these starters. Boom, drop.
They want to get those off the landing pad, I suppose.
Oh, don't tell me it's going to hook. Oh, there we go.
They're not in the way when they come in
later.
Also, notice that those two rotors, they certainly appear like they are overlapping.
Mm-hmm.
And, of course, a disadvantage of that is that you lose a little bit of that efficiency as those rotors are sharing the same thrust column. And now we're drifting in.
Oh, what the hell?
Oh, those make impact into the ground. And it does not look like those. We've seen some of the larger, slower moving rotors survive an impact like that. Going out there with a gas can, you might ask, well, are they refueling it? No, I would say almost certainly not. My guess is that they're going to pump the gas out of the tank. It does not look like this is going to fly imminently.
So it looks like they're going to drain the fuel on that?
That's my guess. I mean, at least they would set it upright again before they fueled it, you would think.
Yeah.
Let's watch and see what they do.
So what the heli got it up in the air momentarily and then came down, and it took a hard tumble. So with just under 35 minutes to go before the day and this flight window comes to a conclusion, I just don't see them being able to fuel up, make the repairs, and then start all over again. But you know what? Could happen.
Yeah,
it could happen.
It could. Anything could happen. You know what couldn't happen?
What's that?
Anybody be disappointed to be here.
Oh, yeah.
That's a
Come on.
Lift challenge.
It's been a long day. What is this, our fifth flight window?
I've lost count.
Yeah.
I'm having so much fun.
So they'll continue to get the fuel out, and we now welcome in a very special guest. Now, it's not very often that we get the most important person most important person part of the team, but we got the mom. I mean, we've got the pilots, we've got the engineers, but you want to get the mom, and we've got Susan Commanda, and of course your team is energetic flying nuisance. Now, please tell us that nuisance part isn't named after your son, Christian.
No, for sure.
I was just wondering. It's like he's just an energetic flying nuisance, that kid.
Yeah, no, he's absolutely, they are so passionate, and I'm really proud of them because they've had some challenges and different things that haven't worked, and they're still head down. They're going to figure it out, and they've always been like that.
Yeah.
So they were friends from kindergarten, and they both grew up on farms, so they were driving tractors and fixing things since they could probably walk. So it's great. I read the two of them are fun, and they're both like, they're that crazy and passionate. They're like, they kind of are perfect for each other.
We've seen some video of the aircraft itself. It has got some unusual characteristics. Can you tell us anything about the construction of the aircraft? Let's take a look, actually. What are these red, kind of like, looks like a vase almost on there?
So those were custom connectors that they 3D printed.
Ah, okay.
That's what you guessed.
That's what I guessed, yes.
To connect the carbon fiber, because they use carbon fiber poles, and then they mounted carbon fiber on top, and then that's what the engines are actually sitting on. So that's custom.
More important question, where exactly is Claremont in New Hampshire?
It's actually right across the border from Springfield, Vermont.
Oh, okay.
So it's close.
Okay. How have you enjoyed your time here so far?
I love it. The people are great.
Yeah.
So in high school, they were on the robotics team, and it was kind of the same environment. Everybody's helping everybody. People needed, they needed some epoxy. We're giving them that, and wires, everybody's swapping, and they're really kind of asking questions. I think all the people that are competing are really interested in, like, well, what are you doing? And we're doing this, and that sounds, and it's fun. Like, I love listening to that. I think that's really great. It's a great environment.
If you want the good intel, you always go to Mom. So what's the intel for tomorrow? What's the plan? Just tell us. We won't tell anyone else.
Well, so today they had a challenge. They had everything dialed in, but it was so hot that they have a special mix of nitro fuel that they use with batteries. Like, I don't know how it works exactly, but it actually expanded and backed into the carburetor. So they're fixing that right now.
So basically flooded the carburetor.
Yeah.
Finicky liquid fuel engines.
Because we were wondering, we saw them out there and we're like, getting ready to do something, all dressed up and no place to go.
Yeah, and they had it all dialed in. It was just so hot that it just did. So they figured out how they're going to resolve that tomorrow. I think we're targeting a 2 o'clock flight. But
so maybe keep it covered with Mylar or something before they get out there, and then
so it stays cool. We actually ran to Walmart and bought a leaf blower to kind of keep it cool. I'm the parts runner. I know Dayton very well right now.
they love you and your credit cards. Like,
God.
Mom, we need this.
Yeah, and then you get a text at Walmart. I need this too. Can you go to Napa? I'm like, what is it? Send me a picture. I'm like,
that's amazing. Find it. That's amazing.
Tell us about the process of getting here. I can't help but notice we're now on the second to last day. I'm sure you would have been here the very first day and out there flying the whole time if you had all could have. What's been going on?
So they actually crated the drone and left on Saturday and drove it out here. It was 13 feet, 5 inches tall. Right. So they strapped it in. They had foam on the inside, and things stood up on the trailer. So they had a little caravan. So his dad drove the trailer because he's good at the trailers. You didn't want to wreck the drone. And then we had an RV, and then we had friends of ours, the other parents, in the truck with the golf cart and all the tools loaded for bear.
So it takes a village to win DARPA.
Oh, yeah.
It takes a village.
It certainly does.
All right, well, we wish you the very best of luck. Again, the team is energetic, flying nuisance. No shade on Christian. We wish him the very best. You must be a proud mom, especially if he walks away with $2.5 million.
Super proud. I'm just proud. What I really love about it is that they're not giving up. They run into trouble, and they're head down. They're figured it out, and they're here to the bitter end. They're like, we're going to get this thing in the air.
Good life lesson.
Yeah, very good life lesson.
You raised a good shot. Thank you so much, Susan, for being
guys.
with us. We appreciate it. Susan Commanda and their team, energetic flying nuisance. Just moments ago, we saw Sherman Aeronautics get up in the air, and it was a momentary, maybe less than 20 seconds, and then they came back down. So I don't know, JB, if that was a test situation or if they were really trying to put something together, but they are now under 30 minutes to go. And so we will see if they try to go back up again. We've had, talk about a variety of guests we've had today.
Oh, man.
We've got designers, engineers, Donna. We got Christian's mom. We got everyone popping by. So we appreciate everyone taking time, giving us a little insight. And we will continue on as we will see if they keep this flight window open until 7:30 Eastern time. We're just past 7 o'clock right now. JB, what can you get done in 30 minutes, 29 minutes on the penultimate day of the DARPA Lift Challenge?
Todd, let me ask you a question, and I know my answer. If you could get one of these teams up here who we haven't seen and get them up here to interview, does one come to mind?
Yeah, it's going to be fantastic, and I hope tomorrow that we see everything that everyone wants to do and they get an opportunity to put their very best forward. We want to take a moment while we have a chance and bring you a story that is so interesting about a pilot who ejected safely and his plane which landed safely, and you can all find this inside the beautiful National Museum of the United States Air Force.
Someone named it the Cornfield Bomber, and not being a bomber and not being in a cornfield, it's interesting that it was named that. I don't know who named it that, how it got that name. It should be the Wheatfield Fighter, but I guess it sounds a little catchier, I guess, to be the Cornfield Bomber. Take off as a flight of 4. We actually ended up as a flight of 3 because one airplane aborted. I had my wingman, which was Major Jim Lowe at the time. The other member was Tom Curtis. He was also a major. He was to be the opponent. We flew slightly north of Maelstrom. I was coming in at approximately 40,000 feet. As it turned out, my opponent was lower. We met. We got into a vertical scissors at the time. And very shortly thereafter, the aircraft went into a post-stall gyration during a high-speed rudder roll and immediately went into a left-hand turn flat spin. It remained in that spin as I was going through the maneuvers, the emergency procedures to recover. It did not recover. I finally, after being prompted by my wingman, ejected approximately at 8,000 feet or so above the ground. Immediately after I ejected, the airplane immediately went completely nose down and recovered from the spin and flew off. Flew off a number of miles away and landed by itself in a little town by the name of Big Sandy. There was about 6 inches of snow on the ground. It was in a wheat field, probably skidded some couple hundred yards or more and came to rest. It ran at idle until it basically ran out of gas. This wasn't the first time that the minute the pilot ejected, the aircraft recovered from the spin. And of course, I was surprised that was the case. I assumed it crashed, but the fact that it landed by itself was obviously a shock to everyone. There was no major structural damage. There was damage, and the airplane was sent back to McClellan Air Force Base, which is our depot. And at some point in time, I'm not sure when, it had been repaired and was returned to service. And I believe it was probably in about 1979, which would have been 9 years later. The airplane was down at Tyndall, and my wingman, when I jumped out of it, Major Lowe, was the squadron commander now at Griffiths. And he, of course, saw to it that I was assigned that airplane, and I did fly that airplane when they were down there with training with IWS again. Well, it's a unique experience, you know. I guess I'm part of a 1 in a million occurrence. I don't know that this has ever happened again, this whole scenario, but it is good to see the airplane again and to know that it's in the museum here, and this story, I guess, will live on until it happens again.
And that is inside the museum, along with another hundreds of great stories. The Memphis Belle is there. I mean, just go there. People say 2 hours plus, but it would be well worth it. Air Force One, all kinds of planes. If you love aviation, if you love aeronautics, if you love design, if you like that, that's great. That's just an amazing story. And as we went to that package, Joshua Bardwell asked me what guest I would want to be on here, and I kind of skipped over that, so I want to give you the answer. I want that guy. I want that guy on the set, because that story, for him to eject at 8,000 feet, and what could have gone wrong, JB. I mean, that plane corrected itself and then just headed off, not on autopilot, just headed off in instruction. Can you imagine if he was near a major city or something like that? What could have happened? Land in a cornfield and just belly land, and then...
Well, it just goes to show that when you're pushing the limits and you're testing stuff like this, unexpected stuff happens.
Yeah, this is Max Wakes right now, Richmond Hill, Georgia. And, who would you like to have as a guest?
You know, I have always wanted to meet, and he happens to be here. Of course, all these teams are impressive and in their own way, but I've always wanted to meet Luke Bell.
Luke Bell, their team is
father and son team who have multiple
Guinness
drone
Book of
speed
World Records.
Yeah. And
we could probably arrange that. I know people.
And we saw him this morning. Elena got to interview him. I'm a little bit jealous.
Yeah.
And I'll spend the whole interview talking about his drone speed records instead of this, and somebody will have to keep me on top.
Going back to the museum quickly, and that's where we are at the National Museum of the United States Air Force. Seen the Memphis Belle? Have you seen the movie?
Yes.
Oh, just fantastic.
Yeah, there's so much aviation history here, and
super
and
cool.
we're making aviation history here. We're going to see whichever aircraft here in a permanent display here at the museum, and it definitely deserves to be here. As far as we can tell, no one has done what we're doing here exactly.
So this is SciLift right now. The team from this is Max Waits.
Oh, they're flying! They're flying their little
Waits.
tricopter. I say little. Sorry. Yeah, it's up in the air. We saw them.
This is SciLift. I'm sorry. This is SciLift.
We saw them struggling to get in the air before they flipped over.
This is the team from Ames.
And now they are
so good. Iowa State's team up in the air with the Lucky Charm on the nose, patched up, ready to go. We saw them earlier today lift up, and then they just kind of flopped over onto the top.
Now, certainly one of the weaknesses of that design is that it's getting all of its yaw authority, that's looking left and right, all of its yaw authority from the counter torque on those two small propellers. And generally, this type of design is much weaker on the yaw axis than it is on the other axes where the propellers are actually pushing it.
So no weight on there right now, JB. It looks like they're just going up and down, checking out the hover, seeing how stable it is.
Oh, I hope they catch that. I hope they catch that. That's faster than you might like to see.
Yeah, but no harm, no foul,
no
right?
harm done. No harm done.
It wasn't pretty, but the fact that they got up, they came, they saw, and they were successful to a certain degree. So I'm
that
sure
frame very robust.
Yeah.
Certainly one of the advantages. Very robust frame.
At what point did you say this does not look like a descent?
Well, the
normal
wobble
descent.
and the speed of the descent. Mostly the speed of the descent. When you descend that fast, you have to put out a lot of energy to catch yourself at the bottom, and it's just a lot more of a precarious thing, although more impressive if you pull it off.
Yeah.
That's the kind of thing you would see a racing drone or a freestyle drone do to impress everybody. But here, this is very much a tortoise race, not a hare race.
Yeah.
Slow and steady and efficient wins the day.
Since they were so close to the takeoff and landing area, they were able to retrieve it. Again, they've got we're a little over 20 minutes before this final flight window of the penultimate day here at the DARPA Lift Challenge comes to a conclusion, and then we turn our attention to Super Sunday and the final day to see if anyone has 1 day left to hit that 4-to-1 payload to weight ratio, if they can get it done, and if they can do it under 30 minutes, and if they're the fastest and have the most highest ratio, then they walk away with $2.5 million.
That is right, but they do have to exceed that 4-to-1 payload to weight ratio.
And they have to travel 4 nautical miles, drop the weight, and travel another nautical mile. So it looks like SciLift doesn't look like it's too damaged.
Yeah, no, it looks pretty intact. I don't see any broken props, broken propellers. They're checking them. A design like this, very compact. There's not a lot of parts sticking off or hanging off, and it's quite likely that it could survive an impact like that with no meaningful damage whatsoever.
We got some dark clouds on the horizon, and if you just pan to the left at Flight Fest, look at this. It's Combat Hour.
This
My
is what we've been
favorite,
waiting
the
all day
Demolition
to
Derby.
see.
So if you were just walking around and you saw that, you might say, oh, a bunch of seagulls in the air. Some of those seagulls look fatter than others, but this is 70 RC planes. They go up, and they basically try to knock each other out of the sky.
Yeah, little radio-controlled planes, maybe 3-foot wingspan or more, made out of foam, and they crash into each other on purpose, and the rule is last one standing wins, but it's mostly just about the fun.
Now, are they using goggles on this, or is this
They
just
are
line of
not.
no
No.
goggles? Okay, because that would be a game changer, right?
Well, you'd think so, but two problems. One of them is that getting that many pilots in the air with goggles, there's just not enough radio frequencies to do it. And the other problem is, here you can see the area all around the aircraft. With the goggles, you only see what's directly in front of you. And for something like this, flying line of sight actually was more of an advantage, I would say.
It's just chaos. I mean, you look at the carnage that's on the ground and the hundreds of people that are lining the side of the course to watch this. It is a spectacle, and I can't imagine being a pilot. You just go full crazy Ivan and just start weaving through the traffic and hope you hit something and hope you don't get hit.
Yeah. And people might wonder, well, it's mighty a big coincidence that Flight Fest, one of the largest RC radio control festivals in the United States, just happens to be being held right next door to the DARPA Lift Challenge, and that is not a coincidence. DARPA, as we learned earlier from the director, I believe, is very interested in bringing the community in, and so they arranged to have Flight Fest be held here instead of its usual location.
Stephen Winchell was kind enough to join us, the director of DARPA, and gave us the inside skinny on that as they combine the two events. Been a great crowd. The weather's been good, other than yesterday afternoon when it just downpoured. Ooh, another victim.
Yeah, no. You know, when we see during this testing, we see one hit the ground and we go, oh. No, these guys love it. That's what they're here for. These planes are designed to crash and be crashed, and they love it just as much. They're here for the carnage.
What are these costing? If someone drills me and T-bones me and I drop to the terra firma, I'm not going to be too happy about it, but what am I looking at?
Well, here's the thing. You might have a couple $100, maybe a little more than that. These are very repairable. They're typically made of a expanded polypropylene foam, and so you could literally just get that plane that crashed and is in 3 pieces, get a hot glue gun, and have it back in the air again in minutes.
What do you do to practice for this? You go down to the beach and hope for the seagulls are out there and just start trying to pick off some seagulls?
I don't know. You could certainly get a friend, and you guys, a lot of times people will put streamers onto their planes and try and cut the streamer so that you're not damaging the plane. But honestly, I don't know if there's anything you can do to practice for this.
2 more just
get up there and do your best.
Well, the fans are loving this. This is basically demolition derby aviation style.
Look at all the planes on the ground.
Yeah.
You see all the litter on the ground? That's all planes that have been knocked out of the air.
So they're saying there's somewhat close to 70 that start out, and then it's full on. And I imagine those first 30 seconds, it is absolute mayhem.
Yeah, and those planes are still on the ground because much like DARPA, Flight Fest is very concerned with safety, and you got to wait until it's over. You know,
what would be your strategy?
Oh, man. So do you go hard and just try and take everybody out?
Like a bowling ball?
I don't, earlier you proposed a strategy of kind of lingering around the sidelines, but I don't think the goal here is to be the last one standing. I just think the goal here is to have a great time. And so I'm just going to try and be evasive. I'm going to try and hit people, and whatever happens, happens.
It would be like the big hawk and just circle above Pandora, and then I'm going to swoop down and wreak my havoc.
You know, Todd, this is reminding me, and I don't know if this is happening this year, but another event that Flight Fest has done is they will build a gigantic, compared to some of the aircraft we've seen in the Lift Challenge, maybe not, 15-foot wingspan airplane. And they'll put it up in the air, and all the little planes will go up.
And take shots at it?
The goal is to knock it out of the air. And, of course, that big plane, they'll knock holes in the wing.
It keeps going.
And it just keeps going until finally that one final hit takes it out, and it falls, and the whole crowd cheers. It's just a good time.
It looks like we've still got about 20, maybe 25 competitors that are still airborne or airworthy.
Yeah.
It's amazing when you see 2 come together. It's just like, man, there's some serious aggressive flyers out there. They go cutting through.
Oh, yeah. And, you'll sometimes see them take a hit and it stays in the air. They're surprisingly durable. Right up till they're not. Woo! See multiple designs out here, traditional airplanes. I see some flying wings. I see one that looks like a fighter jet. Somebody went and put a streamer on there just for fun. Maybe not for fun. One of the challenges here is just you keeping eyes on your plane, and that streamer may be helping.
There's no way to be defensive in this, right? I mean, you don't know who's going to...
I don't think so. There's too many targets. I don't think so.
Well, they're going to need their own command center if this chaos continues, and it will, and maybe we'll bring you the winner when we get down to the final plane. But we have a command center as well here, and it is, I don't say it's chaos in there, but don't step your foot in there and start just chattering about, because Ann Bush, the Air Ops lead, she doesn't mess around.
Yeah, it's intense. It's intense in there.
All staff be advised, CP is now closed for flight ops. I repeat, CP is now closed for flight ops.
Hands on 3, 8, 11, and 14 start, please.
Getting hold of ground ops at 13 and 15 to see if they're going to make their window, but everyone else should be able to.
Stand by.
Range is hot at the start of your flight today.
Copy. Ops. Range is hot. Can I have a leaderboard check, please?
Leaderboard here.
Stand by 60 seconds. Quiet NCP. 10 o'clock flight window is now open.
2 has been cleared for check, so they could fish straight into competition.
I'm showing 2, 4, and 10 online. 2 marked as unofficial loaded.
It is loaded at 112 payload weight.
2 stop left.
Copy.
Yeah, 2.14 ratio for lane 2.
Eric, confirm 3 unofficial or official.
Is labeled as official.
162 pounds.
Official 2.96, lane 3. Standing by for comp run.
Official run should be coming up to lane 11.
3.31.
182 pounds at 3.31.
Stand by for launch.
12 will be an unloaded check.
Copy. Brad, confirm prep 1 is on 2 and 3.
Prep 1's on 2 and 3, confirmed.
Copy. 11, comp run.
Yeah, we're watching it.
Eyes on 11, starting comp run. Pending success, goes to second.
Here, 11.
Launch. Launch on 2.
Launch on 2. Suit.
Prep 1.
All books.
10 crash.
Copy crash.
Crash or hard in?
Lane 10 was reported as fixable.
Lane 3 ops, confirm comp run on 3.
Lane 12 increasing altitude.
Breach. Breach on 12. Here, French breach. Launch on 3. Prep 1 to 3. Lane 4 going cold. Can I have eyes on 11?
Lane 11's descending. All right, coming in for landing on 11.
Dropping.
Lane 3s should be about complete transport.
Looks like 12 safely landing.
They're descending now.
Yeah, they're 40 feet.
Lane 12 grounded.
Lane 3's in last month.
Copy.
And 11.
Stay by 11 for landing. Comp run.
3's coming in.
Stay by.
I'll hold on.
3 top left. Coming.
11, successful landing. Run complete. All right, Brad, I want eyes on 3 descending. Competition run. Goodbye, successful landing.
That's 2 on the board in the first batch of runs. Pretty good.
All right, new third place.
We still birds in the air, lane 10.
1000 flight window is now closed.
We have a cold range. You're
Cold
clear
range.
for recovery and transport.
And of course, our thanks to Ann Bush, the Air Ops lead. And there is the scene here in Dayton. That is just a thing of beauty. It looks like an Ansel Adams painting as we come to the end of Saturday, day 6 of the DARPA Lift Challenge. Todd Harris, Joshua Bardwell with you. And what a thing of beauty.
Yeah, beautiful, beautiful weather out here.
It has been fantastic, other than yesterday afternoon when it downpoured. This is Sherman Aeronautics. They are on the ground, walked away momentarily, but now racing back out. So we'll see if they're going to try to fire up those folks from San Bernardino. Is he going to have to recalibrate?
He's doing the compass dance again.
There we go.
Still calibrating the compass. At least that's what, well, he would do all 3 axes, you would think. They damaged their GPS units there in a previous crash, and I saw reports they were asking if anybody had a spare of the exact model unit that they needed. Obviously, there's no time to order it. And the fact that they're out there now doing their compass calibration.
Someone came to the rescue?
Means somebody came to the rescue with just by chance, the exact GPS unit they needed. But we haven't seen them in the air during this flight window. So only about 10 minutes left to go in the flight window. Okay, so he'll rotate 360 degrees with the airplane held flat. And then if this is in fact the compass calibration dance, he will tilt the aircraft nose down or nose up and rotate it 360 degrees. Yes. And that is to allow the onboard compass to cancel out anything affecting the magnetic fields about the airplane and detect the Earth's magnetic field.
You're sure this is all official? This is not just aeronautics version of the hokey pokey?
No, sir. Okay. No, sir. You have to do it. The thing is, with a small aircraft, like a little handheld drone, you just hold it in your hands and you just turn it.
Right.
But with a big aircraft, just about the only thing you can do is hold it. And then, of course, with very, very big aircraft, there's other ways of going about it. There's a reason you've never seen a 747 do this dance.
Yeah. This is Sherman Aeronautics trying to get up, trying to get some testing done. Remember, it all comes to a conclusion tomorrow. The DARPA Lift Challenge. Remember we got here earlier in the week and not sure what we were seeing and expecting and how it was all going to play out. And it seemed like every day got ratcheted up a little bit
Just
more.
a little bit
more serious, a little more serious. And I'm wondering what tomorrow morning's going to bring.
Yeah, well, tomorrow being the last opportunity people have, you say, well, there's no sense bringing your stuff home. Some people are going to say, we're going to go for it. And I certainly hope we saw today multiple teams trying to crack that 4.0 ratio and ended in a crash. I'm sure hoping they come back tomorrow and try it again. You know, regardless, you know, it has been so meaningful to see when people said, what are you talking about? 3-to-1's impossible. And to see multiple teams getting over 3-to-1, and then, of course, taking home half that prize money, no small amount. The whole event has been just so rewarding for everybody.
So we are coming down to the final few moments here in this flight window, the final flight window. We did 5 today on Saturday after yesterday's afternoon sessions were washed out. And there is the scene right now there. See the tail flaps going up and down, checking that.
Yep.
Going for final pre-flight checks.
Yep, making sure that tail moves the right direction and to the full extent of its normal travel. And then if you really want to feel like you just wiggle it around and you go, oh, look, my plane's doing a little dance.
I feel like I've gotten a PhD in Drill 101 the last 4 or 5 days, so thank you, Professor.
Right up to speed, Todd. You have a new career.
There you go, yeah.
If sports ever leaves you, you can do drone
Oh, it left me a long time ago, but I'm happy to be here.
Okay, spinning up those motors. Those are electric motors, so no need for anybody to go out and do a starter.
Here we go.
And we have seen this system flying multiple times. You know, so lots of credit to them. We've seen how hard it could be.
Yeah.
Earlier today, a similar system failed to get in the air.
If this is the last flight we see today, this is going to make me very happy.
Oh, yeah.
Just to see them up and flying and be mesmerized.
Oh, yeah. So they're going to have to redo their safety check flights since they've rebuilt. So we've got low weight here. But obviously, if they want to go for some kind of a weighted trial, they're going to have to do the safety check flights first. So they still have another 5 or 6 minutes before the flight window ends to get that done. I believe right now this is 0 weight. That's just the Titan module up there that's used to track the location of the aircraft.
157 feet up right now and climbing. Get a nice view of Dayton.
Yeah, and those safety check flights, basically they just take off. They fly to a prescribed altitude. They fly out. They turn around. They come back, and they land in the prescribed location to demonstrate that the aircraft is controllable with no weight on it all. After that, they'll add half weight. It's about 55 pounds, and then they'll add. If they pass that, they go to full weight, 110 pounds or more, depending on what they want to attempt.
You know, if you walked out your door and saw this, it would be what I call a distraction drone, because you'd stand there and look at it and go, "What the what?"
Yeah. Is that?
You wouldn't say "What the hell?" You'd say "What the what?"
Well, sure. You look at that and you say, surely someone's doing that on purpose.
Yeah.
There's no way anyone did that on accident. But why?
It's an aerial tug of war.
What were they thinking? And now we know. We know that basically this is just like a helicopter rotor blade, where the most significant part, the outer part that's moving fastest, the part that's making all the thrust, we just got rid of the inside. And then what if instead of a rotor blade it was 2 airplanes? So this is not as far-fetched as it might seem at first. But don't get me wrong, it's a little bit far-fetched.
So they're there at 175 feet, traveling just about 6, make it 4, back to 2. They're kind of all over the place there. The payload is 2.4 pounds. You mentioned that's the Titan drone in the vehicle. Ooh, and it's starting to
swing.
Starting to swing, but you don't want to clip that with a plane.
No, and keep in mind that altitude is the altitude of the Titan module, which is dangling from the tether. So when we see the altitude jumping around, nevertheless, that is the official scored altitude. And if that jumping around were to cause it to go outside of the safe area...
Am I worried that that's going to swing up and hit one of the planes as it comes around?
I mean, I'm sure it's a possibility. I don't know if that tether is short enough that that's not possible. We haven't seen it jumping like this previously. That line has stayed taut enough. And you see those planes starting to go up and down.
This looks like the Flight Fest aerial combo going on. The little battle going in the sky.
Yeah.
Now it looks like they've
settling down.
Yeah.
Yeah, that weight is swinging around. Now that's only the 2.3-pound Titan tracker. You can imagine if that was more weight.
Yeah.
Well, maybe it'd be more stable though with more weight. We've talked about how sometimes these systems are more stable. They actually perform better with the weight.
I just wouldn't want to clip that because I think it would probably do some damage to my plane. Plus,
Yeah,
you'd have to probably pay Donna back for the Titan that you broke.
Well, I would guess he assumes that as a cost of doing the event.
Come on.
I would hope. We never did ask him.
You got to return your Titan the way you found it.
Yeah.
Look at this.
I'm pretty sure they've destroyed more than one Titan in the course of this.
Well, they've been up for almost 4 minutes, and this is just kind of a safety check. If it was a actual scoring run, that upper right corner, run 12, that would be lit up in green. As it stands right now, they're getting some good data off here, traveling around 7 miles an hour.
Yeah, we haven't seen them really get up to speed. We've seen them go up, fly around, and come down. It's still an open question as to what kind of speed this system could get. In order to do that, they would need to tilt their quote-unquote rotor disc, which is basically the disc that planes together are making, and they would have to pick up some speed. We're seeing a lot of jerking there, of course, and as that disc tilted, they would get closer to that dangling weight. It is really being jerked around. This test flight's going on for a little while. If all they had to do was get up in the air, demonstrate their zero weight, you'd think they might rush to get on the ground and try and do a half-weight test. Suggests that maybe this is more than just a check flight. They may be gathering data. Also, certainly some variable has changed because we've seen them fly before, and we haven't seen this sort of jerking of the dangling weight. So maybe they've changed a variable. Maybe they've added some power or something, and are trying to improve their standing.
So being framed perfectly by that big thunderhead in the distance. This, again, is Sherman Aeronautics out of California. Just a bit of a test flight, 5.5 minutes. Husband and wife team as they look like they're bringing the altitude back down. So it looks like they're coming home and might be setting it down. They were up at 175 feet of altitude. Now they're down to 50. And this is something we always like to see, the landing.
Yeah, nice safe landing. And their goal is going to be to put down in the center, or at least within that 5-foot radius ring. The key thing is that the weight itself, the Titan tracker, is what determines where they have landed down for scoring purposes. So if this is a check flight or if this was a sport
this is
run,
getting close. It keeps.
And as you see, it's going to be hard for them to set that down precisely with it dangling and jerking like that.
Well, that thing swings back and forth, and it's on the ground, so now they can put the planes down and reduce the speed, and here we go.
I mean, it definitely shows what they've accomplished, that they're able to do even that. Oh, look at that joy. Look at that celebration. Look at that celebration. That's obviously a win. That's obviously a win for them.
Smiles all the way around.
More than smiles. Oh, my gosh. Oh, my gosh. Fantastic.
Max Waits is still up in the air, so we were watching the two fixed-wing aircraft do their tug-of-war beauty. This is Max Waits out of Richmond Hill, Georgia. I don't think they have weight in that mesh basket, and it looks like they caught something, or something just took them out of the sky because they just dropped.
Yeah, I saw something come off. It might have been a propeller. Whenever you see an arm drop like that and it tumbles, that usually means that one of the motors or propellers has stopped making thrust. And you think about it, if I'm holding up the aircraft on 4 points and suddenly one of them goes away, it's going to tumble like that.
I guess if you're going to put it down on them with a heavy landing like that, hard landing, you might as well do it at the very end of the final flight window on Saturday. Let's watch it one more time.
Plenty of time to get it back together, I guess, in the middle of the night.
Oh, this could have been
a sleepless night.
This could have been. Oh, yeah, there it is.
The whole motor came off. The whole motor came off.
That wouldn't have been a good stump.
And then
he would have got
took
that
another one
easy.
off.
Yeah.
So sometimes that's just a loose screw that you failed to tighten. Sometimes you'll have like a 3D printed mount, and the plastic gives away.
Oof! Look at that. Once that goes.
Yeah. And rip the next one off as well. There's no saving that, unfortunately. And from that height, from that altitude, it's highly likely that there was some serious damage.
See the frame tumbling back to the earth, and the
Yeah,
as you said, the propellers, those are easy to replace. But yeah. So for Max Waite, their day comes to a conclusion. And Sherman Aeronautics, look at this. They're pretty happy with what happened. And look at this. Why not?
Oh, yeah.
Look at the backdrop. I mean, when are you going to get this chance to take a picture like this?
Oh,
that's
my
Christmas
gosh, they're
card
going out
material,
there.
right?
They're going out there to take a selfie with they're so proud of what they've accomplished. And I think we all are.
You don't think the only thing that would make that better?
Yeah.
Put Joshua Bardwell in there.
I would do it.
King of drones.
I would do it. That would probably be presumptuous.
Well, congratulations to them, Sherman Aeronautics. It took a while. It literally took, hour and 20 minutes for them just to get up in the air. And once they did, though, they made the very most of it. And they come back down, safely putting down the Titan, and both craft go to the ground. All right, so we have been told that the flight window has been closed. So Saturday's competition is now complete. Day 6 goes into the books, and that just leaves one more day. JB, before we say goodbye, as we get ready for tomorrow, your final thoughts on Day 6.
Final thoughts. We saw a lot of people trying to get done what they needed to get done. We didn't see a lot of motion, and tomorrow is just do or die.
No question about it, and there will be some hardware and some cold hard cash on the line. Who will take it home? We will find out. That concludes Day 6 of the DARPA Lift Challenge from Dayton, Ohio. For Joshua Bardwell and Elena Buenrostro, I'm Todd Harris. Hardware's delivered on Super Sunday here in Dayton. We'll see you then.